Hi everyone, welcome to PrepFusion. So today we are starting our new subject, that is signals and systems. So first we will be studying about signals, then we will be studying about systems. After that we will be studying about the tools that we can use on signals. So first we will be getting started with signals. Okay, so that is the first chapter, that is signal. And before starting this chapter, I just want to tell you one thing, that signal system and mathematics both are complete different subject. They are not interrelated. But in the few initial lecture of signals and systems, you may feel like that, sir, we are studying mathematics. But you need to have the patience, you need to watch the subject till the end. You will realize that it is integrated with electronics and electrical, not with mathematics. Okay, so both are complete different things. So let's get started with signals. So what is a signal? Signal is nothing but a piece of information. Let's give you by an example. So these kind of circuit you would have seen in your elementary classes, in class 11th or 12th you would have seen it. So what is there? There is a resistance R1, there is a resistance R2. Now what do? I apply a voltage signal here. If I apply a voltage signal here, I can get some voltage output here. No? This signal could be anything. It could be some DC 5 voltage. Let's just say this is 5 volt. What do I mean by that? What do I mean by that is that I am applying a 5 constant voltage. This 5 voltage was applied. This 5 voltage was always there. So I am applying this constant 5 volt voltage with respect to time t. So at all the time it was always 5 volt. So this is signal. You are applying a signal to a particular circuitry, that is R1, R2. This circuitry is there. You are applying this particular signal to this particular circuitry, and then you are receiving some output. You are receiving some output. What will be this output? This output will be, if you have basic idea of network analysis, then you know that what I can do, in both of the resistor current is same. This current and this current is same. So what I can do, I can apply the potential division. Even if you don't know, you can ignore it. Okay. Just that output will be 5 into R2 upon R1 plus R2. So this is also a signal. Basically, what is your output? Your output is this is your output. Your output is 5 into R2 upon R1 plus R2. This is your output signal. So both are the signals only. This is the input signal, this is the output signal. So what is the piece of information here? The piece of information is, to this particular circuitry, you are applying a 5 volt input. You are applying a voltage of amplitude 5 volt. So that is a information, and you are receiving a information at the output as well. Which information you are receiving? At the output you are receiving 5 into R2 upon R1 plus R2, this much voltage. So signal is nothing but a piece of information. This is just a basic definition. Okay. Now there are certain types of signal. So signals can be divided into two parts. Just one second. Continuous time signal and discrete time signal. Now continuous time signal and discrete time signal both have two parts as well. You just need to see the classification. We will understand each and every term by a certain example. Okay. So continuous time signal can be also of two part. Continuous time, continuous amplitude, continuous time, discrete amplitude. Same goes for this one. Discrete time, continuous amplitude, discrete time, discrete amplitude. So let's understand one by one. Continuous time, continuous amplitude. First we are going to study about continuous time, continuous amplitude. Continuous time and continuous amplitude. So what do I mean by that? Let's make a curve. Let's make a simple curve. So this is a signal that I am drawing, x of t versus t. So this is how I am drawing the signal. Okay. So this, let's just say this time is 0. Time is given in seconds. I just say time is given in seconds. 0, 1, 2, 4, 6. So what do you see here? Xt is defined at every time. What I mean to say is that between 0 to 1 second, xt is defined at all the time. Can you tell me the value of xt at t equals to 0? Yes. Can you tell me the value of xt at t equals to 1 second? Yes. Can you tell me the value of xt at 0.5 second? Yes. 0.5 second would be somewhere here. Can you tell me the value of xt at 0.00001 second? That would be somewhere here. So that means xt is defined at all the time. The time window from minus infinity to infinity. Minus infinity, what do I mean by minus infinity? Let's just say before this it was 0 only. Here I am defining the time from 0 to infinity. No, let's just say before this it was 0 only. and after this as well it became 0 only. Let's just say after this as well it became 0 only. So before this it was defined, after this also it is defined. You can tell the value of xt at all the time instant 0, 1, 2, 3, 4, 0 0.001, 0 0.005, at all the time instant you can define the value of xt. That means it is continuous time. So first term is clear, continuous time. Now what do I mean by continuous amplitude? So here amplitude is also continuous. Let's just say this value was 1 and this value was -1. This value was, let's just say, 2. This value was -0.5. So here it can have infinite values. What do I mean by that? Between 0 to 1, we can see that here the values are between 0 to 1. So between 0 to 1, it will have infinite values. What do I mean to say is that it can have 0.001 as well. It can have 0.5, it can have 0.7, it can have 0.007, it can have 0.150. Like after that it can have, because it is going till 2. Basically it can have infinite values. In this graph you can see that it is having infinite values between 0 to 1. That's why it is known as continuous amplitude. So in the time window as well you are having infinite values, in the amplitude as well you are having infinite values. Between 0 to 1 infinite values are there, between 1 to -1 there are infinite values. That means xt can have infinite number of values. It can have 1, -1, 2, 0.1, 0.2, 0.138, 0.158. Infinite number of values are possible. That's why it is known as continuous amplitude. So continuous time and continuous amplitude. So this was our first classification. Okay, well and good. I hope you must have understood it. Let's go to the second one, continuous time and discrete amplitude. So time is continuous. That means it should be defined for all the time. Let's just say this is 0, this is 1, this is -1, then here it would be 2, then it could be 3, 4, 5. So it is defined for all the time. At 0.5 as well you can tell some certain value, at 0.6 as well you can tell certain values, at 0.8 as well you can tell certain values. That means from 0 to infinity it is defined for all the time. From 0 to -infinity as well, or you can say from -infinity to +infinity. From here to here it is defined for all the times, right? That means it is defined for infinite time. And if it is defined for infinite time, that means it is continuous time. Now talking about the amplitude. Now I am saying that xt can have only two kind of value. One is +1, other one is -1. One is +1, other one is -1. So from here what did you get to know is that xt can have only two kind of values, 1 and -1. That's it, nothing else. So amplitude is discrete now. Amplitude is not constant. Sorry, amplitude is not continuous. You cannot say amplitude is continuous. Here between 0 to 1 it can have infinite number of values. From 0, 0.001, 0.002, 0.003, 1.2, 1.3 till 2 also it can have infinite values. So here the values are infinity. But here I am saying that I am fixing the amplitude. I can only have 1 and -1. That's it. Let's talk about this graph. Here I am saying that it can either have 0 value, or it can have 1 value, or it can have 2 value, or it can have again 0, it can have -1, 0, and let's call it 1.5. So here I am saying that xt can have 0, 1, 2, -1 and 1.5. So here also I am fixing the amplitude. I can say that xt can have only these 5 values, not more. I can fix the amplitude in this manner as well, that xt can have 0, 1, 2, 3, -1, -2, in that manner. But xt cannot have infinite number of values. Here xt was having infinite number of values. Between 0 to 1 it can have any values. But here xt cannot have infinite number of values. xt can have 10k values, xt can have 20k values, xt can have 2 lakh values, xt can have 30 lakh values, xt can have 3 crore values, but xt cannot have infinite number of values. Here xt was having 1, 2, 3, 4, 5. Here xt was having 5 kind of values. Here xt was having 2 kind of values. xt can have 10,000 values. xt can have 20,000 kind of values. xt can have 30 lakh kind of values. But xt cannot have infinite number of values. If I have made the graph like this, that means between 0 to 1 it can have any value. That means it would be infinite number of values. But now I am making the graph like this. So I can make the graph anyway. I can keep on increasing the graph like this. I can keep on increasing the graph like this. That this graph can go up to 10,000. I started from here 0, 1, 2, 3, 4. It can go up to 10,000. But still it will be fixed that your xt will have from 0 to 10,000 values only. But in this graph, it is going from 0 to 1 only, but in between it is having all kind of values. Say yes or no. Are you able to understand this point? So that's why it is known as discrete amplitude. Okay. So did you understand the meaning between continuous amplitude and discrete amplitude? We are studying about continuous time. The time is continuous in both of them, but the difference is about the amplitude. Here it was continuous amplitude, here it is discrete amplitude. Well and good. Okay. So let's just remove it off so that your notes are clear. Yeah, fine. Now the point is, how do I go from continuous amplitude to discrete amplitude? What is my target? Going from continuous amplitude to discrete amplitude. Let's just say I am given this graph. From this graph, how do I get to this graph? So that I need to see. So this process is known as quantization. What it is known as? Quantization. So now I have to do the quantization of this curve so that I reach to the discrete amplitude curve. What is this? Continuous time, you can see this is continuous time, and continuous amplitude as well, because you can see that between -8 to -4 also it can have infinite values, between -4 to 0 as well it can have infinite values, from 0 to 4 it can have infinite values. So it is continuous time and continuous amplitude. But now where I need to go? Continuous time but a discrete amplitude. So what I need to do? I need to think about the quantizer. Okay, or I need to do the quantization process. So how will I do the quantization process? So what I will do, I will get some different signal. I am calling that signal as yt. Yt is just the quantized version of this. So what I am gonna do is that I will make a circuit, and that circuit will tell that if your input is, if this particular signal is between -8 to -4, if in this particular signal, if your amplitude is between -8 to -4, then this quantizer circuit will give the output as -6 volt. What I am saying, if my applied input is between -8 volt to -4 volt, then this particular circuitry quantizer, this arrow I have made, what do you mean by this arrow? This arrow means there is a circuitry. This arrow means there will be a circuitry where xt will be applied and your output will be yt. Here there is some circuit. I don't know what is there inside the circuit, but I just know the property of the circuit. The property of this circuit is, if the applied input is between -8 to -4, it will give the output to be -6 volt. So quantizer. So this is a quantizer circuit where I am applying xt as input and I am receiving yt as output. So property of this particular circuitry is that if you give the input to be between -8 to -4, it will give the output to be -6. How it is doing so, you don't need to care about it. When we study communication system, at that time I will tell you briefly about this quantizer circuit. Otherwise you will study it in masters. But briefly I will tell you about this quantizer circuit. It is not necessary for your examination that what is there inside this block. You just need to do what this particular block is doing. And when we study about data converters in digital electronics, there also we study about this quantizer. What is this? This is just a this is just a ADC, analog to digital converter. So that we study in digital electronics as well. So no need to worry about that, what is there inside the circuit. Just you need to know one thing, that between -8 to -4, it is implementing it to -6 volt. Now it is not necessary that it will implement to -6 volt only. It depends on the circuit. Now this circuit might change it to -5 volt as well. The circuit can change it to 0 volt as well. It can change it to anything. It depends on the circuitry, how you are designing this. So the user have designed, I am assuming that the user have designed in a way that if your input is between -8 to -4 volt, then it will give the output to be -6 volt. Okay. Then it will give the output to be -6 volt. So between the time window of 0 to 1 second, between that time window of 0 to 1 second, output is -6 volt. Now between the time window of 1 to 2 second, between the time window of 1 to 2 second, your input is going from -4 to 0. Now I have designed this quantizer circuit in a manner that if my input is between -4 to 0, then it will implement it to -2 volt. I have designed this quantizer circuit in a manner that if your applied input is between -4 to 0, then it will give the output to be -2 volt. So between the time window of 1 to 2 second, between the time window of 1 to 2 second, your input is between -4 to 0 volt. That means it will give the output to -2 volt. giving the output to minus 2 volt. Say yes or no, right? So this was your continuous time and continuous amplitude. Now, if my input is between 0 volt to 4 volt, then this quantizer circuit will give the output to be 2 volt. This is how I have designed it. I am assuming that I have designed the quantizer in a manner that if my input is between 0 to 4 volt, the given output will be 2 volt. So between 2 second to 3 second, between 2 second to 3 second, between 2 second to 3 second, the input is between 0 volt to 4 volt. So output will be at plus 2 volt. Output will be at plus 2 volt. Output will be at plus 2 volt. Now between 3 second to 4 second, between 3 second to 4 second, between 3 second to 4 second. If your input is between 4 volt to 8 volt, if your input is between 4 volt to 8 volt, 4 volt to 8 volt, then output will be given at 6 volt. Output will be given at 6 volt. Output will be given at 6 volt. So this was minus 6, this was minus 2, this was plus 2, this was plus 6. Now what is happening? Suddenly the input is dropping to minus 3 volt. Suddenly the input is dropping to minus 3 volt. That means it is between minus 4 to minus 4 to 0, right? The input is dropping to minus 3 volt. That means it is there in this window. It is there between the window of minus 4 to 0. And if your input is between minus 4 to 0, where it will direct, the output will be given as minus 2 volt. Say yes or no? The input suddenly dropped to minus 3 volt and minus 3 was lying in the window of minus 4 to 0, in the window of minus 4 to 0. And I know that this quantizer circuit will implement minus 4 to 0 to minus 2 volt. This quantizer circuit will implement minus 4 to 0. If the applied input is between minus 4 to 0, it will give the output to be minus 2 volt. So that means after that, the output will be minus 2 volt. After 4 seconds, output will be minus 2 volt. So in that manner, you have discretized the inputs. Okay. So what did you understand from here? That here there was infinite values between minus 8 volt to minus 4 volt. In between there were infinite values. Minus 8 volt, minus 7.9 volt, minus 7.8 volt, minus 4.5 volt. In that manner, there were infinite number of values. But after the quantizer, you are having only one value, that is minus 6 volt. So what you have done? You have discretized the input. What you have done? You have discretized the input. That means this is your continuous time and discrete amplitude. Why discrete amplitude? Because yt can have only a certain amount of values, that is minus 6, minus 2, plus 2 and plus 6. Only these kind of values it can have. So your output is that basically this signal is discretized in amplitude. So time is continuous. It is defined at all the time. But the amplitude is discrete. Say yes or no? So if you want to go from continuous amplitude to discrete amplitude, if you want to go from continuous amplitude to discrete amplitude, then you need to follow the process of quantization, right? Continuous amplitude to discrete amplitude. That means you need to follow the process of quantization. And if I need to go from continuous time to discrete time, if I need to go from continuous time to discrete time, this is our next topic. So if I need to go from continuous time to discrete time, then I need to follow the process of sampling. Okay. What I need to follow? I need to follow the process of sampling. Now what is this sampling that we need to study? So now we need to go from continuous time to discrete time. We have studied about this continuous time, continuous amplitude, continuous time, discrete amplitude. And we have studied this process as well, that how I will go from here to here. Now the next process will be you go from here to here. Then you know that how to go from here to here already. So basically you pick any signal and you want to get discrete time. So from continuous time to you want to go to discrete time, what you will do? Sampling. And then from continuous amplitude you need to go to discrete amplitude, what you will do? Quantization. So path is clear, no? Right? If you are given one signal, let's just say I give you one particular signal, that is continuous time, continuous amplitude. So if you know both of the process, quantization and sampling, then you can go to any signal. From continuous time, continuous amplitude to you can go to continuous time, discrete amplitude as well. From continuous time continuous amplitude 2, you can go to discrete time continuous amplitude as well, and from here you can go here as well. Say yes or no. So first, now we need to study about sampling. So what is this sampling? Okay, very easy process, very simple process. Although here we did not study about the internal circuitry, that we can study in communication system and somewhat in digital electronics as well. Okay, and the actual circuitry, the actual quantizer circuit, you will study in masters. Or when we study communication system, I will give you a reference from where you can study about the quantizer circuit. Okay, now we need to study about the sampling. So I will take a break, then we will start studying about sampling. Okay, so now we will study about sampling. So from continuous time to discrete time we need to go. That means we need to follow the process of sampling. So what do we do in this sampling circuit? So this is your input signal that is applied to a sampling circuit. Let's just say there is a sampling circuit and this input is applied to a sampling circuit and you are receiving some output. The output I am showing by y of n, not y of t. The output I am showing by y of n. Why y of n? You will understand. Okay. So applied input was x of t, output is y of n, and you are applying it to sampling circuit. Okay. Now what I am saying, there is a switch in this sampling circuit. There is a switch, and this switch is getting closed after every 2n seconds. After every 2n second, where n is some integer. What do you mean by that? That after every 2 seconds, the switch is getting closed. Basically, if you put n equals to 0, that means at 0 second you will close the switch. If you put n equals to 1, that means at 2 second you will close the switch. If you put n equals to 2, that means at 4 second you will close the switch. In that manner, after every 2 second you will close the switch. Say yes or no. So then you will receive some output. So what output you will receive? So when you close the switch at t equals to 0 second, then your input was 0 only. So here you would receive output to be 0. Then you close the switch at 2 second. Then you close the switch at 2 second. So at 2 second, what was the amplitude? Let's just say the amplitude was 1 here. Here it was 2. Here it is. Let's just say it is 1.5. Then the amplitude was 3. So just as you close the switch at 2 second, n equals to 1 means just as you close the switch at 2 second, your output was 1. Your output was 1. So how would you show the output? Output was 1. So this was the amplitude of output 1. Here what I am showing, y of n. That means I need to plot the graph with respect to n. I am showing y of n. That means I need to plot the graph with respect to n. So here what value I will put? The value of n I will put. Here my n was 0. Here what was the value of n? N was 1. But n equals to 1 means 2 second. Say yes or no. Did you understand this point? A very important point. You are closing the switch after every 2 seconds. That means here n will be 1. You are showing the graph of y of n with respect to n. So n value will always be integer. So whenever you show a discrete signal, always you say that n will always be integer. But here the value of t could be anything. It could be 2 seconds, it could be 4 seconds, it could be 6 seconds, because you are closing the switch after every 2n second. Now the next switch you will close at 4 seconds. N equals to 1 you have taken, now you will take n equals to 2. That means next switch you will close at 4 seconds. So at 4 seconds your amplitude is 2. So at 4 seconds your amplitude is 2. But here what you will put? N equals to 4. Here you will put n equals to 4. No. Here you will put n equals to 2. Because n equals to 2 means 4 seconds. And at 4 seconds you are having the amplitude to be 2. Now what you will put? N equals to 3. N equals to 3 means 6 seconds. So at 6 seconds your amplitude is 1.5. So at 6 seconds your amplitude is 1.5. And 6 seconds means n equals to 3. So at n equals to 3, that means at 6 seconds you are closing the switch, and here the amplitude was 1.5, so that will be copied to the output. Now next, n equals to 4, that means at 8 seconds amplitude is 3. And now at 10 second, basically here n equals to 5 you will put, here n equals to 4 was there. Now n equals to 5 you will put, that means at 10 second you will see. So at 10 second, what is the amplitude here? Next sample I need to calculate at 10 second. First sample I calculated at 0, then at 2, then at 4, then at 6, 8. Next I will calculate at 10. But for 10 it is not even defined, right? You are given till 0 to 9 only. After 9 what is happening you don't even know. After 9 what is happening you don't even know. But you know one thing, that next sample I will take at 10 second. After that I will take the sample at 12 second. So this was 2 second. Next was taken as at 4 second. Then you will take at 6 second. Then you will take at 8 second. Then at 10 second. Next sample you will be taken at 12 second. You don't know what will be the value. You don't know what will be the value. But this is how you will be taking the samples. Now just let me know one thing. Here, what kind of signal it was? Continuous time, continuous amplitude. Because it was defined for all the time. 0, 0.1, 1, 2, it was defined for all the time. And continuous amplitude as well. It can have any value. From 0 to 1 it can have any value. From 1 to 2 it can have any value. So continuous time, continuous amplitude. But just let me know one thing. Here, if I ask you what is the value of y of n at 1 second, can you let me know the value of y of n at 1 second? At 1 second. No. Why is that so? Because you are calculating the sample after every 2 second. So at 0 second you will calculate the sample, at 2 second you will calculate the sample, at 4 second you will calculate the sample. You are not even calculating the sample at 1 second. So 1 second would have been somewhere here. And you cannot even get 1 second. Are you getting this point? After every 2 seconds you can get the value of sample. So at 1 second you cannot even define the value of y of n. So that means y of n is not defined at all the time. It is defined only at 0 second, 2 second, 4 second, 6 second, 8 second and 10 second. And after that 12 second, 14 second. So in that manner, the y of n, the time window has been discretized. That means the time can have the value of 0 second, 2 second, 4 second, 6 second and so on in that manner. But it cannot have the value of 1 second. It cannot have the value of 1.1 second. It cannot have the value of 5.5 second. Right? Here between 4 to 6 it will not be defined. It is defined at 4 second only. It is defined at 6 second only. Now you will say that, sir, these values can go up to infinity. Yes. But the point is, for continuous time means it should be defined at all the time. The meaning of continuous time is that it should be defined at all the time. It might happen that for t less than 0, it was 0. Okay. For t less than 0, it was 0. It might happen that after 9 seconds, it is 0 only. After 9 seconds, it is all 0. But still it is defined, no. From minus infinity to till plus minus infinity. From minus infinity to plus minus infinity, I can say that at every time I can tell the value of xt. If I ask you what is the value of xt at 0.01 second, then you will say that this is the value. If I ask you what is the value of xt at 1000 second, you will say that, sir, it will be 0. So at all the time xt is defined. But here, if I ask you what is the value of y of n at 3 seconds, you will say that, sir, I don't know because it is defined at 2 seconds only, at 4 seconds only. If I ask you what is the value of y of n at 4 seconds, you will say that, sir, it is 2. If I ask you what is the value of y of n at 3 seconds, you will say that, sorry, at 6 seconds, you will say that, sir, it is 1.5. But in between it is not defined. That means it is your discrete time, right? So this was continuous time, continuous amplitude. This is your discrete time. Now let's talk about the amplitude. Discrete time, let's talk about the amplitude. So let's just say I give you this signal only. Okay, forget about this signal, forget about this signal. I give you this signal only and then I ask you whether it is discrete amplitude or continuous amplitude. So what did I tell you? What you will do? That, sir, your y of n can take only this much values. Sir, y of n can take 0, 1, 2, 1.5 and 3. Only these values y of n can take. So these values are not infinity. Basically, it can take only 5 kind of values. That means, sir, it should be discrete amplitude. So you will say that, sir, discrete time, discrete amplitude. And you are not wrong here. You are not wrong. If I give you only this graph and I ask you whether it is discrete amplitude or continuous amplitude, you will say that, sir, here in the graph I can see that y of n is having 0, 1, 2, 1.5 and 3. Only 5 kind of values. That means it should be discrete amplitude. And you are not wrong in that. But if I give you this complete scenario, that from where to where I am coming. So I am coming from continuous time, continuous amplitude to discrete time. Now I don't know about the amplitude. So let me know one thing. If you need to go from continuous amplitude to discrete amplitude, what you need to do? You need to have a quantization process. Are you doing any quantization process here? No. I am not doing any quantization process here. So I cannot call it discrete amplitude. I will have to call it continuous amplitude only. But this I will be able to tell if I know from where to where I am coming. If I am coming from here to here, then I will call it is continuous amplitude only, because I know this signal. In this signal, I only applied a sampling circuit. If I apply the sampling circuit, that means only my time will be discretized. Amplitude still I will call continuous. Say yes or no. But if I only give you this signal, only this signal is given, this is not given, only this signal is given, and I ask you whether it is discrete amplitude or continuous amplitude, so you will say that sir, y of n can have only certain amount of value, 1 2 0 1 2 1.5 3. That means it should have been discrete amplitude, and you are not wrong in that. But if I tell you that I am coming from this continuous amplitude signal to this particular signal and I am only applying the sampling circuit, that means it has to be continuous amplitude only. So here I am writing discrete time continuous amplitude. Are you understanding the point? So in the examination they will never give this circuit and they will ask you what kind of signal is that. Never ever this question will be asked. Even in the interviews these kind of questions will not be asked. But if they want to frame a good question, they will certainly ask what kind of signal is that. You will say sir, it is discrete time discrete amplitude. But no, you need to tell sir, certainly it is discrete time. But for telling the amplitude, I need to know from where this signal is coming. So they will say that this signal is coming from here. That means it is coming from continuous amplitude only. So you just gave the sampling circuit. That means time will be discretized only. So still I will call it continuous amplitude. Are you getting this point? The reason for calling it discrete continuous amplitude is that like this signal could have been defined in any way, no? The input signal. Let's just say this amplitude was defined something like this. So it was, let's just say it was continuously defined. It was having infinite number of values. And your sampling time was till 2n second. So after 2n second, you can have any kind of values, no? This sample you could have calculated, these samples you have calculated. That means value could be 1, 2, 3, 4.5, 5.5, minus 1, minus 2, minus 5, minus 6. What I am saying is that this particular signal is defined somewhat like this. It is defined somewhat like this. Then it is decreasing the amplitude. Then after every 2n second, you are calculating the sample. Here luckily it was defined between 0 to 9 second only for this particular circuitry. Then we said that it is all 0, it is all 0. So you got the value to be 0, 1, 2, 1.5, 3 and 0. So you thought that only certain amount of values are there. So certainly I can call it discrete amplitude. But it is derived from a continuous amplitude only. And I am not giving any quantizer here. If I have said that I have applied some quantizer, then you could have called it discrete amplitude. So it depends whether this signal is completely alone given or they are telling that from which particular signal you are getting it. Okay. So what you will call it? Discrete time continuous amplitude. Are you getting this point? Now let's see how you will get discrete time and discrete amplitude. Okay. So you know from continuous time to go for discrete time, I need to go for the sampling process. Let's see this signal. Which signal is that? Continuous time. But discrete amplitude, because here you can see that it can have 0 value, 1 value, 0 value or 2 value or 0 value. So here your xt can have only 3 kind of values, 0, 1 and 2. So it is discrete amplitude. Now you are applying a sampling process. That means sampling process, what it will do? It will make the continuous time to discrete time and the amplitude will remain as it is. So sampling process does nothing with the amplitude. If it was continuous amplitude, here also it will be continuous amplitude only. But if it is discrete amplitude, then it will be discrete amplitude only. Are you getting this point or not? So here if this alone circuit was given, if this alone waveform was given, you could have said that sir, it might be discrete amplitude. But if they tell from where it is derived, they say that it is derived from this particular signal, then you will call it continuous amplitude only. Is that okay for you? So these kind of questions can be coming in the interview, but no one will ask you in the examination. Okay. So let's do the sampling process here. What they are saying. Let's see if this slide is clear. Okay. So this slide is clear only. So what all things you studied from this slide? One thing you studied that n value will always be integer. N value is not the time. This n doesn't show the time. This only shows that this is the first sample, this is the second sample, this is the third sample, this is the fourth sample, this is the fifth sample. So this shows the number of samples. It is not showing the time. For showing the time, you need to know that after how much seconds you are closing the switch. So at 0 second, at 2 second, at 4 second, at 6 second, at 8 second, in that manner you are closing the switch. So these are the time. But how we will show the signal? We will show the signal y of n versus n. So here I will write 0, 1, 2, 3, 4, 5, 6, 7. In that manner I will write down. So when we study about that discrete time signal, at that time you should not be having the doubt that sir, yn is integer. Yn is integer. So always n will be integer. You will never say that sir, n is half. There is no meaning of that. Because you are closing the switch after every 2 seconds. That means you will close the switch at 0 second, 2 second, 4 second, 8 second, and so on. So n has to be integer, right? N has to be integer. So that's why n is always integer. So always here I will write down n value. So now I will get again y of n versus n. Now I am closing the switch after every 2.5 second. 5 by 2 means after every 2.5 n second I am closing the switch. That means first switch I will close at 0 second, then I will close at 2.5 second, then I will close at 5 second, then I will close at 7.5 second, then I will close at 10 second. In that manner I will keep on going. So first at 0 second I am closing the switch. At 0 second what is the value? 0 only. Then I will close the switch at 2.5 second. At 2.5 second what is the value? Again 0. And at 2.5 second what is the value of n? The value of n is 1. At 2.5 second the value of n is 1, right? So this is your 2.5 second, but let's not show it again and again. I hope you already know that this is your 2.5 second. Now value of n I will put as 2. Value of n equals to 2, that means next switch I will be closing at 5 second. So at 5 second what is the value of xt? That is 1. So at 5 second the value of xt is 1. So next sample you are calculating at 5 second. So at 5 second next sample you are calculating. So this value is 1. Now n should be put as 3. N equals to 3 means at 7.5 second I am calculating the sample. So at 7.5 second what is the value? 7.5 second will be somewhere here. So at 7.5 second value is again 0. So again value will be 0. Next sample I will be calculating at n equals to 4. N equals to 4 means at 10 second I am calculating the sample. So at 10 second what is the value? 2. So at 10 second the value is 2. N equals to 4 means 10 seconds. So n equals to 5 I will put. N equals to 5 means the next value will be 12.5 seconds. So next sample I will be calculating at 12.5 second. So n equals to 5 at 12.5 second. At 12.5 this is your 12.5. So at 12.5 second again the amplitude is 0. So 0, 0, 1, 2 and 0. So this is how my output will look like. So what do you think? What kind of output it is? It is your discrete time, because it is defined for 2.5 second, then it is defined for 5 second, then it is defined for 7.5 second, then it is defined for 10 second, then 12.5 second. In that manner it is defined. So it is defined for a particular time window only. If I ask you what is the value of y of n at 2 second, will you be able to tell me? No, you will say that sir I don't know what is the value of y of n at 2 second. You only know the values at 2.5 second, 5 second, 7.5 second, 10 second and 12.5 second. In that manner you only know. So that means it is discrete time, and amplitude is also discrete, because if you see the previous signal it was discrete signal only, amplitude was discrete only. So you do not do any quantization process. What is the quantization process? This is the quantization process. So you did not do any quantization process. That's why it is your discrete time and discrete amplitude, and this was your continuous time and continuous amplitude. So this signal you would have got from some continuous time and continuous amplitude signal only. Basically there would have been some continuous time and continuous amplitude signal, right? Then what was done? It was gone through a quantizer. It was gone through a quantizer. And when it was gone through a quantizer, when it was gone through a quantizer, you got this continuous time and discrete amplitude signal. And then this signal is gone through a sampler. And when it was gone through a sampler, you got this discrete time signal. Is that okay for you? So what is the conclusion? The conclusion is, let's write down here. If you need to go from continuous amplitude to discrete amplitude, you need to go to quantizer. And if you want to go from discrete continuous time to discrete time, you need to go to sampler. Is that okay for you? Sampling means time will be discretized, and quantizer means amplitude will be discretized. A very interesting point about your whole electronics and electrical engineering. People do not even understand the difference between quantization and sampler. They think that both are the same thing. But quantization is associated with the amplitude and sampling is associated with the time. Sampling means you are discretizing the time. Quantizer means you are discretizing the amplitude. All good? Okay. Let's solve a question. This question is given. XT waveform you need to draw. Sampling frequency is 2 Hz. You need to find the discretized signal. How will you find the discretized signal? So first draw this signal XT. Okay, even if you don't know how to draw it, you will understand it. You will understand drawing all these kind of signals. But here I am just drawing it. So what is this? This is a sinusoid signal. This is a sinusoid signal. So x of t versus t I am drawing. This is a sinusoid signal. So in that manner it will keep on going. And here also. Okay. So at t equals to 0 you are having value to be 0 only. You can put t equals to 1. At t equals to 1 you are having the value to be sin pi by 2. Sin pi by 2 is equals to 1 only. At t equals to 2, this will be 2. This will be 3. This will be 4. Basically I am putting these values of t. I am just drawing the graph. At t equals to 0 you are having sin 0. At t equals to 1 you are having sin pi by 2. Sin pi by 2 means 1. At t equals to 2 sin pi. Sin pi means 0. At t equals to 3, 3 pi by 2, that means minus 1. You can put t equals to 0.5 as well. If you put t equals to 0.5, that means sin pi by 4. Sin pi by 4 means 1 by under root 2. So this will be the value of 1 by under root 2. So in that manner, this is the curve you are getting. So this will be the sinusoid curve you are getting. Now what they are saying? What is this new term? The new term they have defined is sampling frequency is 2 Hz. What they are saying? Sampling frequency is 2 Hz. What does that mean? Do you understand the difference do you understand the relation between frequency and time? Frequency is equals to 1 by t. Say yes or no. So if I write down Ts, that would be equals to 1 by Fs. So that would be equals to 1 by 2 second. So sampling frequency is equals to 2 Hz. Now sampling time is coming out to be 1 by 2 second. What does that mean? That after every half second you need to close the switch. Fs was given as 2 Hz. Ts came out to be 1 by 2 second. That means after every 1 by 2 n second, after every half second you need to close the switch. So here in this question, what was the value of Ts? 5 by 2 second. That means after every 5 by 2 second you need to close the switch. In this question, what was the value of Ts? 2 seconds. This was the value of Ts, 2 seconds. Then what would have been the value of Fs? Fs will be equals to 1 by 2 Hz. So this would have been the value of Fs. Here what would have been the value of Fs? Fs would be simply the reciprocal. So that would have been 2 by 5 Hz. So this would have been the value of Fs. So in this question, Fs value was mentioned. That was 2 Hz. That means Ts value was 1 by 2 second. That means after every half second you need to close the switch. So after every half second I will close the switch. Then I will get the discretized signal, that is equals to y of n. That will be my y of n. So y of n versus n I will draw. So first at 0 second. At 0 second I will close the switch. By the way, what this will be? This will be minus 1, right? This will be minus 2. Because the graph can go from minus infinity to plus infinity. It is not necessary that you will start from 0 only. It will go from minus infinity to plus infinity. What this will be? Minus 3. What this will be? Minus 4. So what I am saying? After every half second I need to close the switch. So at 0 second I close the switch. Then n equals to 1 I will put. That means at a half second I will close the switch. So at half second what will be the value? At half second. At sine half second. That means pi by 4. Sine pi by 4 is 1 by under root 2. So this is your n equals to 1. This is your n equals to 1. Then n equals to 2 you will put. That means at 1 second I will close the switch. So at 1 second what is the value? 1. At 1 second the value is 1. Then at 3 by 2 second what will be the value? 1 by under root 2. At 3 by 2 second the value will be 1 by under root 2. So basically this was your first sample. This will be your second sample. This is your third sample. What will be your fourth sample? Fourth sample means you need to close the switch at 2 second. You started with 0 second, then half second, then 1 second, then 3 by 2 second. Next will be 2 second. So at 2 second you need to close the switch. At 2 second the value is 0. At 2 second value is 0. This will value is 0. Sorry. So this will be your fourth sample, right? The next sample will be at 2.5 second. So at 2.5 second value will be minus 1 by under root 2 at n equals to 5. N equals to 5. Then at n equals to 6, this will be the value. Then at n equals to 7, this will be the value. At n equals to 8, this will be the value. So this was 5, 6, 7, 8. So n equals to 8 means 4 seconds. So at 4 seconds, your value is 0. Then again, it will get started like this. Again, it will get started like this. Again, it will keep on going like this. In that manner, it will keep on going. Okay. But what did I say? N is integer. What did I say? N equals to integer, where n is equals to integer. So integer means it could be negative as well. That means at minus half second, n equals to 1. N equals to 1 means at minus half second, what is your sample? At minus half second, what is your sample? It is some minus 1 by under root 2. At minus 1 second, the sample is minus 1. Then minus 1 by under root 2. Then again 0. Then what will happen? Again plus 1 by under root 2. Then plus 1. Then again plus 1 by under root 2. Then again 0. So are you getting the point? How it is going? Then again 0. Then again negative. Again negative. In that manner it will keep on going. Negative, 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 then 0. Then positive, then negative. In that manner it will go. So these samples you are getting. So this is how it will look like. What is this? This is 1 by under root 2. This value is 1. What is this? This is minus 1. And what is this value? Minus 1 by under root 2. So here what you can see, you can have only 0, 1 by under root 2, 1, 1 by under root 2, 0, minus 1 by under root 2, minus 1. So these values you are having. But will you call it discrete amplitude? No. You will still call it discrete time and continuous amplitude. Why is that so? Because you know that it is coming from continuous time and continuous amplitude. So if it is coming from continuous time and continuous amplitude, and what did you do? You just applied a sampling circuit here. You did nothing, but you just applied a sampling circuit here. So what you are doing, you are just closing the switch after every 1 by 2 seconds. So that means you are not applying any quantizer circuit here. And if you are not applying any quantizer circuit, you cannot call the amplitude is discrete. So this was your continuous time, continuous amplitude. Now you will call it discrete time and continuous amplitude. It is discretized in time. The value of n will always be integer. But the time here is, this was 1 by 2 nanosecond. So this was 1 by 2 second. This was 1 second. This was 3 by 2 second. This was 2 seconds. This was 5 by 2 second. Then this was 6 by 2 second. 7 by 2 second. 8 by 2 second. 9 by 2 second, in that manner. And here it was minus 1 by 2, minus 2 by 2, minus 3 by 2, minus 4 by 2, minus 5 by 2, in that manner it was going. So this is how I have discretized my output. Okay. But in the examination, you cannot solve by this method again and again, because you cannot expect I will draw the waveform, then I will discretize it. So how do we solve it in the examination? So what was given? Xt was given. Sine pi by 2t. Okay. Now Fs was given 2 Hertz. So what would have been your Ts? 1 by 2 second. Okay. Now you know that after every n Ts second, that means after every 1 by 2 nanosecond, 1 by 2 n second, after every 1 by 2 n second, I need to close the switch. So basically you just put t equals to 1 by 2 n second. What you need to do in this equation, you need to put t equals to 1 by 2 n second. T equals to n Ts you need to put. T equals to n Ts you need to put. And Ts value is 1 by 2. So what you will get? You will get your y of n. That would be sine pi by 2 into n Ts. 1 by 2 n. That's it. In place of t, what I have put? N Ts I have put. So what I am getting? Sine pi by 4n. Now I know that my n belongs to integer. So now I can directly draw my y of n. How will I draw my y of n? So n equals to 0 you put, sine 0 is 0. N equals to 1 you put, what you will get? N equals to 1 you put. If I put n equals to 1, what I am getting? Sine pi by 4. Sine pi by 4 is sine pi by 4. Sine pi by 4 is 1 by under root 2. Then n equals to 2 you put, n equals to 2 you put. So what is sine pi by 2? Sine pi by 2 is 1. N equals to 3 you put, n equals to 3 I put. Sine 3 pi by 4. Sine 3 pi by 4 is equals to 1 by under root 2 only. Then n equals to 4 you put, sine pi that is 0. Then n equals to 5 you put, sine 5 pi by 4 that is equals to minus 1 by under root 2. Then n equals to 6 you put, that would be sine 3 pi by 2, and sine 3 pi by 2 is equals to minus 1. Then n equals to 5, n equals to 6, n equals to 7. So at n equals to 7, what you are going to get? Minus 1 by under root 2. Then n equals to 8. In that manner you keep on going. Okay, in that manner you keep on going. 9, 10, 11, and then again 0, in that manner. Now come back here, n equals to minus 1, you put n equals to minus 1. If I put n equals to minus 1, so sine minus pi by 4, sine minus pi by 4 is equals to minus 1 by under root 2. Then you put n equals to 2, n equals to 2 means sine minus pi by 2, that is equals to minus 1. Then in that manner it will keep on going, right? In that manner it will keep on going. 0, this, then 0, then this, then this, then this, then 0, then again. In that manner it will just keep on going. So what I need to do, whenever this kind of signal is given, x of t is given, what I need to do, I just need to put t equals to nts. There fs could be mentioned, from there I can get the value of ts, from there I will get the value of nts, I will put that, then I will get the discretized signal. So my discretized signal y of n was sine pi by 4n, and now I just need to put n equals to integer, and then I will be able to draw the graph. So first, it is not necessary that I need to draw this continuous time graph. I just told you the process, that how we are coming from here to here. Now in the examination you will solve like this. Is that okay for you? Well and good. And you have also understood the value of n will always be integer. So when we start studying about discrete time signal, there I am not gonna discuss all these things. There you need to know that n has to be integer. So we have studied for roughly around 50 minutes. In these 15 minutes, we studied like literally nothing. Within 2 to 3 minutes, you will be able to revise it. This was your signal. Then we studied about types of signal: continuous time, discrete time. Now from continuous time, continuous amplitude, continuous time, discrete amplitude, discrete time, discrete amplitude, discrete time, discrete time, continuous amplitude, discrete time, discrete amplitude. If you need to go from continuous time to discrete time, then you need to follow the sampling process. If you need to go from continuous amplitude to discrete amplitude, then you need to follow the quantization process. So what is the quantization? What is the continuous time, continuous amplitude? It is defined for infinite window of time. It is having infinite number of amplitude. What is your continuous time, discrete amplitude? Here the amplitude are fixed. It can have only two amplitude, 1, -1. Here it can have 0, 1, 2, 0, -1, 1.5. Only these kind of amplitude it can have, right? Now continuous amplitude, discrete from continuous amplitude to you need to go to discrete amplitude. That means in the window of 0 to 1 second, the amplitude are between -8 to -4. So I am going through a quantizer process. That means this was having infinite number of values, but now it has mapped it to -6 volt only one value. Between -4 to 0, it was having infinite number of values, but now it has mapped it to only one value, that is -2. Okay. Now in the same manner, we are studying about sampling. Here we are going from continuous time, continuous amplitude to discrete time. Why it is continuous amplitude only? Because you are coming from continuous amplitude. If you need to discretize the amplitude, you need to go through the quantizer process. But here I am not going through the quantizer process. I am only going through the sampling process. That means only time will be discretized. What is the meaning? That you need to close the switch after a certain window of time. So you are closing the switch after every 2 seconds. So after every 2 seconds, you are calculating the sample and you are plotting it. Okay. So that is the value of TS. This is known as sampling time period. So then this kind of questions we saw here. So here sampling frequency was 2 Hz. Frequency was given, so I can get the value of sampling time period. That was 1 by 2 second. If sampling time period is 1 by 2 second, that means I can make my signal to be somewhat like this. So I will just replace the T to be NTS. That means after every half second, I am calculating the sample. So this is how I can get my y of n. So this will be my y of n, and this is how I can plot it. So if continuous amplitude to discrete amplitude I need to go, that means I need to follow the quantization process. And if I need to go from continuous time to discrete time, that means I need to follow the sampling process. Is that clear to you? Everything is clear, right? Now in this particular chapter or in this particular subject, this will be written that continuous signal is there, and they will write discrete signal. Now, what do you understand by this continuous signal? It could be, sir, continuous time, discrete amplitude. Sir, it could be continuous time, continuous amplitude. Sir, it could be discrete time, continuous amplitude. Anything could be there, no? In all these three things, there is a word continuous. Say yes or no? Right? But whenever continuous signal is written, so we will only think about time. Continuous signal is written, that means time is continuous. Now, it could be discrete amplitude, it could be continuous amplitude as well. Are you able to understand this point? In complete signal system chapter, if you read any textbook, you can study any book. In all the books, if they have written continuous signal, that means they are talking about the time. That means time is continuous. The time is continuous. Now, the amplitude could be discrete, amplitude could be continuous as well. You don't need to care about the amplitude. You just need to care about the time. And here you are studying about discrete signal. That means time is discrete. Now, amplitude could be discrete as well. Amplitude could be continuous as well. So, if the continuous signal is written, so what thing should come into your mind? That you are going to draw xt versus t. You are going to draw xt versus t. And if a discrete signal is given, that means you are going to draw xn versus n. xn versus n. Because n means the time is discrete. Because n value can only be integer. N is the number of sample. First sample, second sample, third sample, fourth sample. So n can only be integer, but t can have any kind of values. So in the complete chapter, if I am saying we are talking about continuous signal, that means we are talking about continuous in time. Amplitude could be anything, I don't care. And when I say I am talking about discrete signal, that means I am talking about discrete in time. Amplitude could be anything, I don't care about the amplitude. So here in this whole subject, we will be focusing more on the time, not on the amplitude. So our main focus will be towards the time, not on the amplitudes. Is that okay for you or not? So this was the first half that we studied. It was very easy. Within 5 minutes, you will be able to revise. Now we will study about some operations on signal. So now the next half will be looking like complete mathematics. Okay. The next half will be somewhat mathematics only. We will study about limit, continuity, differentiability. Then we will study about some operations of signal, equation of line we will see. Very basic things we are going to see. Okay. Very basic things we are going to see. Then basic operation, how to add two signal, how to multiply two signal, how to subtract two signals. Those basic things we are going to see. How to take mode of a signal. So now the next half will be almost mathematics, but that is necessary to understand the further part. So that we are going to start. I will take a break. You can also take a break, because if I speak continuously for 30 to 40 minutes, then after that I need to take a break so that I can drink some water and then we can proceed. So I usually take a break of 2 to 3 minutes. I drink some water and then I again start recording the lecture. Okay, so you can also pause the video if you want to, and within 5 to 6 minutes you can revise the complete chapter, and after that we can get started with limit, continuity and differentiability. You might have studied it in mathematics, so we are going to study about limit, continuity and differentiability. Okay, so yeah, let me pause the video. Yeah, hi guys, welcome back. So now we will start studying about limit, continuity and differentiability. But before that, let's study about a line, a straight line. So do you know what is the equation of a straight line? Yes, the equation of a straight line is y equals to mx plus c, right? This you might have studied in your high secondary classes. Y equals to mx plus c. What is m? M is the slope of the line. What is the slope of this line? What is the slope of this line? Change in y. Change in y with respect to change in x from 0 to 1. So slope of this line is minus 2. So y equals to minus 2x plus c. Now I need to find the value of this c constant. So what I can do? I know that at x equals to 1, my y is 0. So at x equals to 1, my y is 0. So from here what I am getting, that my c is equals to 2. So from here which equation I am getting? Y equals to minus 2x plus 2. So this is my equation, y equals to minus 2x plus 2, right? Or what I could have done, y equals to mx, slope is minus 2 plus c. C is the point where it cuts on y axis. C is the point where it cuts on y axis. So it is cutting on y axis at y equals to 2. So directly I could have written in this manner. Let's start writing the equation for this one. Y equals to mx plus c. What is the slope here? Slope. What will be the value of m? So m will be change in y 4 minus 3 with respect to change in x 3 minus 1, that would be 1 by 2. So here the slope is positive, right? So y equals to 1 by 2x plus c. What is c? C is the point where it cuts on y axis. So where the line is cutting on y axis, that we don't know. So here I need to assume a constant c. So how I can find? I know that at x equals to 1, my y is 3. So at x equals to 1, my y is 3. So from here, the value of c I am getting is 5 by 2. So what I am getting? Y equals to 1 by 2x plus c. C is 5 by 2. So this is my y. This is my equation of a straight line. So here you go to know that your slope was negative. Your slope was minus 2, right? And here you go to know that your slope was positive. Let's take more example. What I'm gonna do is that I'm gonna make some curve. Here I showed with respect to y and x. So here also I'm gonna do the same thing. This is your y, this is your x. So let's just say this is your one line. This is one of the line. The other line is along x axis only. One line is along y axis. One line is along y axis. The other line is somewhere like this, and one more line is somewhere like this. Then I change the color of pen. So one line is right in between. So different kind of lines I am making. Why I am doing so, you will understand. This is the other line I am making, and then this will be the other line. So I am saying that the slope of this line is 1. The slope of this line is 1. This is what I am saying. So what will be the slope of this line? Will it be greater than 1 or will it be lesser than 1? We will talk about that, but first let me know what will be the slope of this line. What will be the slope of this line? What is slope? Change in y with respect to change in x. So if I walk on this line, let's just say I am walking on this line. So my change in x is this much. I don't know what is this change, but change in x is this much. Here let's just say x was 1, here x is 2. So my change in x is 1. But what is my change in y? In y there is no graph, right? In y there is no change. Here also y was equals to 0, here also y is equals to 0. Say yes or no? Here also your y was 0, here also your y is 0. So change in y is equals to 0. And change in x, it could be anything. So what will be the slope? Slope will be 0. So here what is the slope? M equals to 0. So here your slope is 0. What will be the slope of this line? What will be the slope of this line? M equals to what? So what is the slope? Change in y with respect to change in x. So let's just say I am walking on this line. On this line my y is changing by this much amount. So there is some change in y. How much your x is changing? On this particular line, here also x was 0, here also x is 0. So x is changing by 0 only. So how much is the slope? M equals to infinity. So this is the maximum slope. This is the maximum slope. This is the maximum slope and this is the minimum slope. So if you walk in this direction, basically this is one of the curve, then second curve, then third curve, then fourth curve, and then fifth curve. So if you are walking in this direction, that means your value of slope is increasing. So here if the slope was 0, here if the slope was 1, it could be somewhere in between. It could be any value, but it has to be between 0 to 1. So what I am saying, the slope will be between 0 to 1. Or it could be any value, a random value I am putting. Let's just say it is 1 by 3. I am not sure, it could be any value. It could be somewhere between 0 to 1. And what about this one? It could be somewhere between 1 to infinity. Let's just say I am saying m equals to 3. Say yes or no. Did you understand this point? Right? Let's talk about these green curves now. So what is the slope here? What is the slope here? M equals to 0 only. What is the slope here? Because this is the same line only, no? So for the complete line, the slope is 1 by 3 only. For the complete line. What is the slope here? For this complete line, the slope is 1. For this complete line, the slope is 3. And for this complete line, the slope is equals to infinity. What about this line now? What about this line? This is m equals to 0, this is m equals to infinity. You know that this is a negative slope. Now I am saying that this is m equals to minus 1. Why I am saying minus 1? Because I know that this is a negative slope. If the curve is like this, that means the slope will be negative. Here you can see the curve is like this, the slope is negative. If the curve is like this, the slope will be positive. Why is that so? Because here if x increases, If my x is going from 0 to 1, then value of y is decreasing. Y is coming from 2 to 0. If x is increasing, then y is decreasing. That means slope is negative. Here the slope is positive. Now here also the same thing is happening. If x is increasing, if we are going from here to here, if x is increasing, then y is decreasing. So slope is negative, that is -1. You let me know what will be the magnitude of this slope. It would be -3 or it would be -1/3. Which one of them will be correct? Look, this is going towards infinity. So if we go in this direction, my magnitude of slope is increasing. If I am going in this direction, if I am going in this direction, then my magnitude of slope is increasing. Say yes or no? Because I am going from 0 to infinity. In between there is -1. So this has to be -1/3 and this has to be -3. Because magnitude of slope should increase. Negative sign just shows that if you increase the value of x, y will decrease. This is the point of negative sign. Negative sign just shows that if you increase the value of y, if you increase the value of x, y will decrease. That's it. But if we talk about the magnitude, here the slope was 0, then it would be 1/3, 1, 3 and towards the infinity. That's it. Okay. So basically, if your curve is near to y-axis, like if your curve is parallel to y-axis, if your line is parallel to y-axis, that means the slope is infinity. If it is parallel to x-axis, that means the slope is 0. If your line is parallel to x-axis, the slope is 0. If your line is parallel to y-axis, the slope is infinity. Say yes or no. And if it is there in between, then it can go from 0 to infinity anywhere. Right? So if this is -1, then this line is already the same. So y is equals to -1/3. So here you can tell that, sir, this line is near to x-axis, so value is lower. Sir, this line is right in between, so I am calling that the slope is -1. Sir, this line is near to y-axis, that means the slope is higher, that is -3. So for this line, the slope is -3. Are you able to understand the concept of slope now? Okay. So you surely would have understood the concept of slope. So here also, if I am going in this manner, then my mode of m is increasing. And here also, if I am going in this manner, then my mode of m is increasing. You don't need to mug up anything, okay? And if I am going in this manner, that means if I go towards y-axis, if I am going towards the y-axis, that means my slope will increase. Okay, going towards y-axis, slope will increase. Let's solve this question. What they are saying? This is the line. The line is having a slope of 3. The line is having a slope of 3. You need to tell me the value of x of 3. That means what I need to tell, when I put t equals to 3 here, what value I will get? This is what I need to tell. So what I can do, I can write the equation of the line. What will be the equation? Y. Here what is y? Y is xt equals to mx plus c. What is the slope? 3. T plus c. Right? Now the value of c I don't know. So for that what I can do? At t equals to 1, my xt is equals to 2. xt is equals to 2 at t equals to 1. So what I am getting? C equals to -1 I am getting. So from there what I am getting? xt equals to 3t minus 1. Right? And if I put t equals to 3, t equals to 3 I can put, or I can say x equals to 3. So what I am getting? 9 minus 1, that is equals to 8. So that's the answer. But now I will solve it with another method. What do I know? I know the slope is 3. I know that slope is 3. What they are saying, what I need to find? x3 I need to find. That means I need to reach here. T equals to 3 I need to reach here. The slope is 3. What does the slope say? Slope is change in y divided by change in x. So that means if the change in x is 1 unit, if the change in x is 1 unit, then the change in y will be, if the change in x is 1 unit, then the change in y will be 3 unit. This is the meaning of slope. Because if I put delta x equals to 1, then the change in y will be 3 unit. If the change in x equals to 2 unit, if you need to go from 1 to 3, that means you need to change in x by 2 unit. So if the change in x is equals to 2 unit, then the change in y will be equals to 6 unit. So from 2, your change will be equals to 6 unit. So what will be the value of x at 3? When your t was 1, the value was 2. But now your t is becoming 3. That means the change in t is equals to 2 unit. So the change in y will be equals to 6 unit. So answer will be 8. So this is how I'm going to solve it. Okay. Again and again I will be using the same thing. So there you should not be confused that how I am writing it down. I will just say that slope is 3, change is 2, so here the change will be 6. So 2 plus 6, 8. So there I am not going to write down any equation or anything like that. Directly I will say that at 3 I will get the amplitude of 8. Try the same thing with this particular question. First write down the equation and then find the value of x of 5. Then intuitively you find the value of x of 5. Intuitively means by using the concept of slope. Okay. So first let's write down the equation. What will be the equation? Y equals to slope is minus 2 plus c. C value I don't know. So if I put t equals to 3, my xt will be 2. If I put t equals to 3, so c will be equals to 8. So from here what I am getting? Xt equals to minus 2t plus 8. And I can verify it as well, because if I put t equals to 3 here, so what I am getting? X of 2 only. So this is the equation. What I need to do? X of 5 I need to get. So if I put 5 here, so minus 10 plus 8. So x of 5 equals to minus 2. So this is the answer. Well and good. Okay. Now let's try finding it out by the intuition. So what we are doing? From 3 to 5 I need to go. So if the value of t is increasing by 2, if the value of t is increasing by 2, then xt should decrease by minus 4. Look, if t increases by 1, then xt should decrease by minus 2, because the slope is negative. So if t is increasing by 2, then xt should decrease by minus 4. So initially it was at 2. X of 3 was 2. So what will be x of 5? From 3 to 5 you are going. That means you need to decrease by minus 4. So 2 minus 4, that would be equals to minus 2. So that's the answer. There you go. So what I'm gonna do is that I will just see the curve. What I will say, okay, 3 to 5 I need to go. That means t will increase by 2. So this should also decrease by minus 4. So 2 minus 4, that means at minus 2 I will reach. So directly just by looking at the curve, I can tell the value of x of 5 without even writing down the equation. Okay, so that's the meaning of slope. I hope you would have understood this point as well, that how the slope increases, decreases. I hope you would have understood this point as well, that how I am going to utilize the concept of slope in finding out the values. Is that okay for you? And positive slope, negative slope, that also you must have understood. That if it is like this, then it is positive slope. If the curve is like this, then it is negative slope. Say yes or no. All good. Let's study the concept of differentiability, continuity and limit now. Okay. So points are there 0, 1, 2, 3. So at these points we need to tell whether the curve is differentiable or it is continuous or what is the value of limit. So first let's understand the meaning of limit. So what do you mean by limit? So if I am writing down something like this, that limit t tends to 0 minus x of t will be what? That means you need to come to 0. You need to come, t should come to 0. But you should approach it from the left hand side. 0 minus. If minus is written, that means you need to approach from here. And if plus is written, if I had write down t equals to 0 plus x of t. So if plus was written, that means you need to approach from here. Okay. Plus means you will be coming from right hand side. Minus means you will be coming from left hand side. So what you need to do, you need to tell me the value of x of t at 0, but just before the 0. Just before the 0, that means here. So what is the value? 0 only. And just after the 0, just after the 0, it is also 0 only. Say yes or no. Just before the 0 and just after the 0, it is 0 only. Did you understand this point or not? This is the concept of limit. How did I write down these things? Did you understand this or not? Just before the 0, what is the value? 0. Just after the 0, it is somewhat greater than 0, or you can say it is 0 only. What about limit t tending to 1 minus x of t? That means you need to approach to 1, but from the left hand side. So just before 1, what is the value? Nearly around 1 only. And just after 1, what is the value? Just after 1, what is the value? It is also 1 only. Just after the 1, it is also 1 only. Right? Let's talk at the point 2. limit t tending to 0 minus x of t. So now this will be interesting. Just before the 2, what is the value? Just before 2, nearly around 0, right? But if I ask you, just after 2, what is the value of xt? Just after 2, just after 2, the value of xt becomes 1. At 2, you are having this line. Before 2, it was nearly around 0. But just after 2, just as you go here, just after 2, the value becomes 1. So here, before 2 and after 2, the values are not same. Did you see this thing? Right? So this is how we find the limit. So let's check for the last one. What do you think? What will be the answer for just before 3 and just after 3? What do you think? The answer will be same only. Why is that so? Because just before 3, this is the value, that is 1 only, and just after 3, that is also 1. Okay. Now the question will be, the graph is continuous at t equals to 0 or not? What I am saying, at t equals to 0, the graph is continuous or not? The curve is continuous or not? So what you will do, sir, I will calculate the value just before t equals to 0 and just after t equals to 0. If both of the values are same, that means it is continuous. So at t equals to 0, what I will write down, at t equals to 0, my curve is continuous. At t equals to 0, my curve is continuous. It is continuous. If I ask you at t equals to 1, if your curve is continuous or not. So what you will do, that sir, I will see just before 1. Just before 1, what is the value? It is nearly around 1. Just after the 1, what is the value? Nearly around 1 only. So that means at t equals to 1, it is continuous. Okay. At t equals to 2, if I am asking. So what you will do? Sir, just before 2, I am getting the value to be 0. Just after 2, I am getting the value to be 1. So it is not continuous. Not continuous. At t equals to 3, if I am asking. Just before 3, the value is 1. Just after 3, the value is 1. So that means it is continuous. So you understood the meaning of limit as well. You understood the meaning of continuity as well. What do you mean by differentiability? Differentiability means slope. Okay. Differentiability means just the slope. So just before t equals to 0, just before t equals to 0, what is the slope here? 0. Just after t equals to 0, the slope is positive. What I mean to say is that limit t tending to 0 minus, here I am gonna write down x dash t. What is the meaning of x dash t? X dash t. What is the meaning of that? That means differentiation. And what is the meaning of differentiation? Sorry. What is the meaning of differentiation? The meaning of differentiation is equals to slope only. Basically, if I differentiate this curve, mt plus c, if I differentiate this curve, what I am getting? Slope only, right? If you differentiate this curve, what do you get? Differentiation of t will be 1, differentiation of c will be 0. So you are getting the slope only. So differentiability is defined with respect to slope. That means you will approach x dash t for t just before 0 and for t just after 0. So what do you see here? The slope just before 0, the slope just before 0 is 0, because for this particular curve, what is the slope? 0. So here what is the slope? Here the slope is 0. For this particular curve, what is the slope? Here the slope is 1, right? Here the slope is 1. So I am writing down like this. Here what is the slope? Slope is 1. Here what is the slope? Slope is minus 1 here, because 1, 1, slope is minus 1. And here what is the slope? Slope equals to minus 1. And here what is the slope? Here the slope is equals to 0. Here slope was 0, here slope is 1, here minus 1, and here it is 0. Let's see the differentiability at t equals to 0. What I am checking? I am checking differentiability. Differentiability at t equals to 0. Okay, this is the first lecture. It might seem like that it is mostly mathematics only, but first lecture will be about mathematics. But after that, the things will change. Okay. So it might feel like that, sir, we have already studied all these things. So you can quickly see all these things and then just kind of you can quickly see it and then you can ignore it if you have already studied. But there would be a lot of guys who don't even know what do you mean by differentiability, what is the meaning of continuity, or what is the meaning of limit. So these terms I will be again and again using in my lectures. I will say that at t equals to 0, the step function is not differentiable. The step function is not continuous. So there people will be thinking what he is saying. What do you mean by continuous? What do you mean by differentiable? So there I will be using again and again, I will be using these terms. So that's why I just want to introduce all the terms in the first lecture only. Whatever the term that I am going to use, all the terms I am introducing in the first lecture itself. Okay, so that was the target. Yeah. So what we are seeing that differentiability at t equals to 0. So I will see the curve. I will see the slope. Slope just before t equals to 0 was 0. And slope just after that is 1. So both are not equal. Both are equal? No. So that means it is non-differentiable. Non-differentiable. What about at t equals to 1? What about the differentiability at t equals to 1? So I can approach from 1 minus. So just before 1, what is the slope? Plus 1. And just after 1, what is the slope? Just after 1, what is the slope? Just after 1, the slope is minus 1. Here you are, just before 1, the slope is 1. Just after 1, the slope is minus 1. Just after 1, the slope is minus 1. Is it differentiable? Absolutely not. Non-differentiable. Okay. Let's check at 2. So at 2, what you will say? At 2, I need to check. So just before 2, what is the slope? Minus 1. So here, if I write down in this manner, what I am saying, that I write down x dash 2 minus. Did you understand the meaning of this? X dash 2 minus is equals to limit I am going towards 2 from the left hand side xt. So this can be written as x dash t. So this can be written as x dash 2 minus. So slope just before 2. The slope just before 2 is minus 1. And the slope after 2. The slope after 2. Slope after 2. That is equals to 0. Slope just before 2 was minus 1. Slope after 2 was 0. So this is how I can write down. X dash means slope at 2 plus just after 2. So again you can see that both are not again equal. So that means again non-differentiable. Okay. Now slope at 3 minus, slope at 3 plus. Just before 3 the slope was 0. Just after 3 the slope is 0. That means yes, this is differentiable. Just before 3 the slope is 0, just after 3 the slope is 0. That means yes, this is differentiable. So did you understand the meaning of differentiability, continuity and limit? This is not the complete mathematics we are teaching here, just the only basics that you need to know. So that basics we are teaching here. What is the meaning of limit, continuity and differentiability, that we have studied. Also we have studied about the straight line as well. All good. Let's go on to the basics operation on signal. So we just need to add two signal. One of the signal is x1t equals to 4. x1t equals to 4. How it will look like? That for every value of t, your graph is equals to 4. Plus x2t is equals to 2. That means for every value of t, your graph is equals to 2. And then I need to add both of them. So if I do x1t plus x2t, I am calling it as xt. So what I will get? x1t is 4 plus 2. I will get 6. Do I have the page? Yes. So here what I need to do? 4 plus 2. What I will get? 6. So what I am getting? 6. Right? So my yt is equals to 6. But what I could have done? If I had to add these two graphs, if without even writing down these equation, I am just giving these two graphs, 4 and 2. So if I am adding these two graphs, both are some constant value. So constant value will be added. 4 plus 2, 6. Or what you can say, that this graph is shifted upward by 4. What I am saying is that in this particular graph, I am adding this particular graph. In this graph, in x2t, I am adding x1t. So what I will say, sir, this is a DC value of 4. So this DC value is being added in this 2. So this graph is shifted upward by 4. So what do you get? 6. Or what I could have said, that in this particular graph, in x1t, I am adding x2t. What I am saying, in x1t, I am adding x2t. So that means here, this will be shifted upward by 2. So 4 is shifted upward by plus 2. So where it will reach? Plus 6. Or I could have said that 2 is shifted upward by plus 4. So where it will reach? At 6 only. So whenever you add a DC value to a graph, the graph shifts upward. Say yes or no. Whenever you add a DC value to the graph shifts upward, no matter whatever the graph is. So if I ask you to do this thing, 2t plus 2, can you draw the graph of x equals to 2t? Yes. Y equals to mx. So this will be the graph of x equals to 2t. And then you need to add 2. So what will happen? This graph will shift upward by 2. So here you are having this graph will shift upward by 2. So at t equals to 0, you are having the value of 0, but it is shifted upward. So now you will have the value to be 2. The slope did not change. Here the slope was 2. Y equals to mx. Here the slope is 2. Here the slope is equals to 2. So here also the slope is 2 only. Slope did not change. Here what was the slope? Slope was 0. So slope 0, slope 2. Here what was the slope? Slope was 0 only. In these as well, what was the slope? Slope was 0 only. Here also the slope was 0 only. So slope did not change. Slope 0, slope 2. Here also the slope will be 2 only. But graph got shifted upward. Or what you could have done? 2t plus 2. Because yt is equals to x1t plus x2t, no? So 2t plus 2. So can you draw the graph of 2t plus 2? Yes. This is how it will look like. Where 2 is the slope is 2. And on y-axis, it will cut at 2. On y-axis, it is cutting at 2. Now, if I ask you to find this value, can you find out? Say yes or no. This is the value of t, right? This is 0. So what do you think what this value should be? What is our slope? Our slope is 2. So this value has to be minus 1. Say yes or no. Because if my change in t is 1, if I am increasing the value of t by 1, then my y should increase by 2. Is it increasing? Yes. If I increase the value of t by 1, then my y should increase by 2. Is it increasing? Yes, it is increasing. So this has to be minus 1. Or you can put it here as well. If I put t equals to minus 1, my y should be 0. Am I getting y equals to 0? Yes. If I put t equals to minus 1, here, what I am getting? 0 only. So yes, I am getting 0. And meaning of slope is also verified here. Also, the other thing what I got to know is that the graph will be shifted upward, and that is also being shifted upward, right? Let's go to the next one. What I need to add? 2t plus 3t. So what will be the graph of 2t? Let's just say this is the graph of 2t. This is your 2t. And what will be the graph of 3t? This will be the graph of 3t. Okay. So let me know one thing. What is the slope here? Slope was 2. And what is the slope here? Slope was 3. If you do x1t plus x2t, what you will get? Yt equals to 5t. Right? 2t plus 3t. Basically, yt is equals to 2t plus 3t. 2t plus 3t. So what I am getting? 5t. So what is the slope of the resultant graph? That is 5. Here the slope was 2, slope was 3. Both slopes are added. What you are getting? Slope equals to 5. What will be the slope here? Slope will be 5. So new point. What is the new conclusion? The slopes are always added. When you add two graphs, the slope will always be added. Here the slope was 2, here the slope was 3. Added become 5. Here the slope was 0, slope was 2. Added, it became 2. Here the slope was 0. Here also the slope was 0. Added, the slope was 0 only. 0 plus 0, 0. 0 plus 2, 2. 2 plus 3, slope is 5. So when you add two graphs, the slope will always be added. Is that okay for you or not? Okay. So slopes are always added. 2t minus 3 minus 3t plus 1. 2t minus 3 minus 3t plus 1. So first make the graph of 2t minus 3. The slope is positive and it will cut on y-axis at minus 3. So this is how the graph will go. Here the slope is 2. Slope is 2 and it will cut on y-axis at minus 3. Here the slope is minus 3t and it will cut on y-axis at 1. So slope is minus 3. That means negative. So this is how the curve will go and it will cut here. Slope is minus 3. Now one thing I know, when I add both of them, the slope will be added. When I add both of them, the slope will be added. So the new graph will have a slope of minus 1. The new graph will have a slope of minus 1. And at t equals to 0, what value it will have? This is having a value of minus 3 and this is having a value of plus 1. That means at t equals to 0, it will have a value of minus 2. At t equals to 0, this is having a value of minus 3 and this is having a value of 1. That means at t equals to 0, this will have a value of minus 2. And the slope is minus 1. That means graph will be somewhat like this. Slope is minus 1. So graph will be somewhat like this. There you go. With the slope of minus 1. Slope of minus 1. Are we getting the same thing? We can check out as well. How we can check out? What we need to do? Our yt is just the addition of both of the graph. So 2t minus 3 plus minus 3t plus 1. 2t minus 3 plus minus 3t plus 1. So what I am getting? This was minus 2. Let me write it down in a good manner. This was minus 2 here. So what I am getting? 2t minus 3t, that is minus t minus 2. So yt is equals to minus t minus 2. That means the slope is minus 1. Yes, the slope is minus 1. And it should cut on y-axis at minus 2. It should cut on y-axis at minus 2. So did you understand the point that how we are adding up the graphs? How do we add up the graph? So if these curves are given, I can directly add these curves. What do I need to remember? The slope will always be added. 2 minus 3, slope will be minus 1. And at a certain point, I can get the value. This guy is saying that value should be minus 3. This guy is saying that value should be plus 1. So minus 3 plus 1, at 0, I will get minus 2. Then I can draw the curve. There you go. What will be this value? What do you think? What is the slope here? 1. Sorry, the slope is minus 1. So what should be this value? This value has to be minus 2. Why is that so? Because if I from here to here I am going. If I change the value of y by 2, if I change the value of t by 2, sorry, if my value of t changes by the factor of 2, then the value of y should also change by the factor of 2 as well. Because the slope is 1, no? So if x changes by the factor of, if t changes by the factor of 2, that means the value of yt should also change by the factor of 2 only. So if this is 2, if this window is 2, then this window should also be 2. That's why 2 divided by 2, slope will be 1. So this value will be minus 2 only. Or you can check as well, if you put t equals to minus 2, at that point yt should be 0. If I put t equals to minus 2, if I put t equals to minus 2, that means my y should be 0. Are we getting the same thing? Yes, we are getting the same thing. Say yes or no. Okay. So these are the points you can make. Now there will be one term I will be again and again using. I will be using these terms, sudden change and linear change. What do I mean by that? So basically this will be a curve. Basically the scene will be somewhat like this, that this is your yt and this is your t. This is your yt, this is your t. So and this will be a certain value of t. Let's just say this is t equals to 1. So I will say that at t equals to 1, am I having a sudden change? Yes. Basically at t equals to 1, just before t you are having this value, just after t the value has changed. So there is a sudden jump in the amplitude. You are on this line, okay, you are going like this, and suddenly your curve became like this. You are here. Suddenly at t equals to 1, there was a sudden jump. You are getting, in test series, you are getting 20 marks. Suddenly you got 50 marks. So there is a sudden change at t equals to 1. So this is the point of sudden change. This is the point of a sudden change. But is there any linear change? What do I mean by linear change? That means if the slope is changing or not. Linear change you can say, or you can say slope change also. Here you can write down slope change. So is there any slope change? No. Previously also there was slope 0. Here also the slope is 0 only. So there is no slope change. Here let's talk about this point. Is there any sudden change? No, there is no sudden change. You are having this marks, and your marks are increasing in this manner only. Previously you were having 20 marks. Slowly your marks are increasing, 21, 22, 23, 24, in that manner it is increasing. So there is no sudden jump. But certainly there is a linear change, or you can say slope change. At this point there is a slope change because here the slope was 0. Now the slope is something value I don't know, but this is a positive slope. So certainly the slope has changed, right? So here what do you see? Slope change. Look, these terms I will be using again and again. That's why we are studying it. Okay, these are not any standard term. If you want to study from me, then that means you need to study these terms because I will be using it again and again. And there is some reason behind all these terms. Okay, there is some reason. That's why we are studying it. When you study the complete chapter, you will realize why I taught all these things. Right now, you are not able to relate it, that why we are studying it. But later on in this chapter, you will be able to relate that why we studied all these things. These things we are studying just to make the things easier. Okay, just to make the things easier, we are studying all these things. What about this point? At this point, is there any slope change or is there any sudden change? What do you think? So, is there any sudden change? No, there is no sudden jump. The values are changing smoothly only. But there is a slope change because here the slope was some positive value, but now the slope became 0. So here there is slope change. What about this point? So you are here like this, slope was 1. Suddenly the amplitude increased. Here just before this point you are getting 20 marks. Just after this point you are getting 50 marks. Right? Here also same thing happened. Just before that you are getting 20. After that you are suddenly getting 50. Here you are 20. Suddenly after that you are getting 20. So here you are having a sudden change. But is there any slope change? Is there any slope change? No. Before that as well slope was 1. After that as well the slope is 1 only. Slope did not change. Let's just say this was t equals to 1. So for t less than 1 the slope was 1. For t greater than 1 as well the slope is 1 only. So slope did not change here. So there is no slope change. Only sudden change is there. Only this sudden change is there. Only this sudden change is there. What about this point? What about this point? At this point what do you see? At this point, do you see the slope change? Do you see the sudden change, or do you see the both? Before this, what was the slope? Some positive value. Here, what is the slope? Slope is 0. Here, what is the slope? Slope is some negative value. Here, what is the slope? Slope is equals to 0. So let's talk about this point. Just after this point, slope is 0. Just before this point, slope is some positive value. That means certainly here there is slope change. And certainly there is a sudden jump as well. There is a sudden jump as well. Here you are getting this much marks, suddenly you are getting this much marks. Certainly there is sudden change as well. Slope change and sudden change. What about this point? Those who have already studied this chapter, they would be able to understand why we are studying all these things. Because sudden change will be your unit step function, slope change will be your ramp input. Okay, ramp function. So ramp function and unit step function both will be interrelated here. Those who haven't studied, they will be studying in the upcoming lectures. So you will be able to relate why we are spending time here. Okay. What about at this point? Was there any sudden jump? No, there was no sudden jump. Here you are getting 20 marks. After that also you are getting somewhat 20.5 marks. So there is no sudden change. There is no sudden change. But certainly there is a slope change. Here the slope was 0. Next the slope is negative. So at this point there is slope change. What about this point? Is there any sudden change? Yes. Just after this point, the value is this. Just before this point, the value is this. Previously, you were getting 50 marks. Just after that, you are getting 20 marks. So certainly there is a sudden change. You can see by this arrow as well. There is a sudden change. So at this point, certainly there is a sudden change. Is there any slope change as well? Yes, there is slope change as well. Why slope change? Sudden change plus slope change. Because just before this point, the slope was negative. Just after this point, the slope is 0. So sudden change plus slope change, both things are there at this particular point. So is that clear to you? What is the meaning of sudden change and what is the meaning of slope change? Both are clear? Well and good. Okay. Let's get back to our topic, and now you need to add both of the graphs. How will you add these two graphs? So first example I will solve, next you will solve on your own. So I need to add both of the graphs. So what I will see, I will mark those points where there is any change. It could be sudden change as well, it could be slope change as well. So here what do you see? There is a slope change. Here also you can see slope change. Here you can see there is a sudden change, right? Or slope change as well. I just need to mark the point where the graph is changing. Here graph is changing. At this point as well there is a slope change. At this point as well there is a slope change. At this point as well there is a sudden change as well. There is a slope change as well. So what all are those points? 0, 1, 2, 3. Here also the same points are there, 0, 1, 2, 3. So in the final graph, I need to add both of the graphs. So what I am saying, this is equals to yt. Okay, this is your x1t, this is your x2t, it is equals to yt. So I am drawing yt. So what I am gonna do, I am gonna mark all the points where there is a change. So change is there at 0, at 1, at 2, 0, 1, 2, 3. So these are the points of change. So now we will be getting started. So at 0, what is the value? This guy is saying that value is 0 and this guy is saying that value is 2. At t equals to 0, this guy is saying that value should be 2 and this guy is saying that value should be 0. And before that as well, this guy is saying that value should be 2 and this guy is saying that value should be 0. So before 0, the value would be 2 only, because 2 plus 0 will be 2 only, right? 2 plus 0 will be 2 only. Now at 1, what this guy is saying, the value should be 1, and what this guy is saying, the value should be 0. So 1 plus 0, the value should be 1 only. So at 1, the value should be 1. Are you getting this point? At 1, this guy is saying that value should be 1 and this guy is saying that value should be 0. At 2, this guy is saying that value should be 2 and this guy is saying that value should be 1. So 2 plus 1, value should be 3. So at 2, value should be 3. And at 3, what this guy is saying? This guy is saying that value should be 0. Oh, wait a second. At 2, this guy is saying that value should be 2. But at 2, this guy is saying that first it is saying that it should be 2 and immediately after that, value should be 2. What I mean to say is that at t equals to 2, this curve is saying that value should be 1, but suddenly it should be changing to 2. Are you getting this point? Did you understand this point? At t equals to 2, this curve is saying that value is 1, but suddenly it should change to 2. So previously the value would be 1 plus 2, 3, but suddenly it's here the value is 1 plus 2, that is equals to 3, but suddenly it should change to, from 3 to, it should change to 2 plus 2, 4. Previously it was 2 plus 1, then suddenly it should change to 2 plus 2, 4. So at t equals to 2, in the final curve, at t equals to 2, only you will go from t equals to 3 to t equals to 4. Are you understanding this point? At t equals to 2, there was a sudden jump. So previously it was saying that value should be 1 and this was saying that value should be 2. So 2 plus 1, 3. Then it was saying that immediately it should change to 2. So 2 plus 2, it should be 4. Now at point 3, this curve is saying that first my value should be 2. So 2 plus 0 should be equals to 2. So at value at 3 should be equals to 2. Are you able to understand this point? At t equals to 3, this curve is saying that previously my value should be 2 and this curve is saying that your value should be 0. So 2 plus 0 should be equals to 2. But at this point only, this curve is saying that at the very next moment my value is becoming minus 2. At the very next moment my value is becoming minus 2, and this is saying that at the very next moment my value is 0 only. So 0 plus minus 2, that should be minus 2. So at the very next moment your value should be minus 2. Say yes or no. So this is how the curve will go. From 2 to 1, then from 1 to 3, then there is a sudden jump, then from 4 to 2, then there is a sudden jump. Now after that, what will be the scene? After that, here what is the slope? I don't know. There is some negative slope. Or you can calculate the slope as well. What will be the slope here? Just let me know what is the slope. So what is the slope of this line? Negative slope it will be. The change in x is equals to 1. So what is the change in y? From 2 to 0. Change in y is 2. The change in x is 1. And slope is negative. The slope is minus 2. Did you understand this point? The slope is negative, I know. Right? The slope is negative, I know. What I can see, the value of y is going from 2 to 0. And the value of x is going from 2 to 3. So what you are getting? The slope is minus 2. So here the slope is minus 2. So after this, here the slope is minus 2. So this slope is minus 2. After the point 3, the slope is minus 2. And what is the slope here? Here the slope is 0. And what did I tell you? The slope should be added. So minus 2 plus 0. After that, the curve will decrease by the slope of minus 2. by the slope of minus 2. So here I can write down the slope will be minus 2. So this is how the final curve will look like. More things you can study from here. What is that? What is the slope here? M equals to 1. And what is the slope here? Now you should be able to write down the slope. 2 by 1 minus 2, because this is the curve, right? Slope is minus 2. So when you add both of the slope, between 0 to 1, the curve is having minus 2 slope. Between 0 to 1, this curve is having plus 1 slope. So plus 1 minus 2, the slope should be minus 1. In the resultant graph, when I am adding both of them, so in the resultant graph between 0 to 1, the slope should be minus 1. Are we getting the same thing? Between 0 to 1, I am saying that the slope is minus 1. Can you calculate whether the slope is minus 1 or not? Yes, I can calculate. How I can calculate? The change in y, it is going from 2 to 1 divided by change in x, 0 to 1. What is the slope? Minus 1 only. Yes, the slope is minus 1. And what did I say? When you add both two graphs, the slopes are always added. Here what is the slope? Slope is 0. And here what is the slope? Slope is 2. Here the slope is 2. 2 divided by 1, the slope is 2. Here what is the slope? Slope is 0. So in the resultant graph, the slope should be 2. Are we getting the slope to be 2 here? Let's check that out. So change in y, 3 minus 1, 2. Change in x, 2 minus 1. So what is the slope? Slope is equal to 2 only. So here also the slope is 2. So what did I say? I always said that slope should be added. Are the slopes added? Yes. Now here there is a sudden change. And here there is a linear change. Or you can say here there is a slope change. So there is a sudden change. So in the resultant curve as well, you can see a sudden change. So at t equals to 2, you are seeing a sudden change. So in the resultant curve as well, there is a sudden change at t equals to 2. At t equals to 3, in the curve you can see there is a sudden change. So in the resultant curve as well, there is a sudden change at t equals to 3. So sudden change is resulting in sudden change only, right? And slopes are always added. In that manner you need to see. Here what was the slope? Minus 2. Here what was the slope? 0. So between 2 to 3, the slope is 0. Between 2 to 3, the slope is minus 2. So in the resultant graph, between 2 to 3, the slope should be minus 2. Here the slope was minus 2 and here the slope is 0. So in the resultant graph, the slope should be minus 2. Are we getting the same slope? Let's check that out. How we will check? So here, what will be the slope? So change in y, 4 minus 2, divided by change in x, 2 minus 3. So slope is minus 2 only. Yes, slope is minus 2. So slopes are always added. And here as well, the slope will be minus 2. After that, slope is minus 2. Here the slope is 0. So this slope will be minus 2 as well. So this is how my resultant graph will look like. Although better than showing the values like this, I should have shown the values on the axis. So this is how I should have shown the values. This is how I should have shown the values, right? So this is 2, this is 3, this is 4, and this was minus 2. I don't remember, this was minus 2. Minus 2 plus 0, yeah, this was minus 2. So this is how I should have shown it. So this is the resultant graph. This was an easy case because the changing point was same. Here also the change was at 1 only. Here also the change was at 2 only. Here also the change was at 3 only. But what if the graphs are like this? What if the graphs are like this? So try doing it on your own. Here the change is at 2 only. But here the change is at 0. Change is at 1 as well. Change is at 2 as well. There is no change at 3. Okay. There is no change at 3, right? Neither there is a slope change, neither there is a sudden change. But here there is a change. Slope change is there. Here also there is a slope change. Here there is a sudden change. Slope change is also there. So change is at 2, 0, 1, 2 and 3. So in the resultant graph, what all points you need to plot? 0, 1 and 2. 3 also you can plot, but there is no change at 3. Here also there is no change at 3. So let's keep 3 as it is. So these are the changes. So try thinking about it. Try drawing the final curve. You would be able to do if you just keep your concentration high here. Just think about it and you will be able to draw the resultant graph for sure. Okay. So I will take a pause. Then I will come back and you try making the resultant graph. Just remember two things. Slopes are always added. And if there is a sudden change in the resultant graph as well, there will be a sudden change. That's it. Then you will be able to certainly draw the resultant graph. Okay then? Yeah, so I will take a pause and then I will come. Yeah, so did you guys try it? We need to add both of the graphs. So we know that our changing point are 0, 1, 2. Now the catch here is that at 1, I don't know the value here. I know the value at 0. At 0, this guy is saying 2 should be there. This guy is saying 0 should be there. So 2 plus 0, it would be 2. So here it would be 2. No doubt about that. At 1, this guy is saying that it should be 0. But at 1, what is the value here? I don't know that. At t equals to 1, what is the value here? I don't know that. So one thing is that I can find the value because I know the slope. So that I can do. Or without even finding the value, how I will do it. So one thing I know that slopes are always added. So between 0 to 1, this curve is there. What is the slope of this curve? You should be able to tell me. Slope will be positive 3 divided by 2. Value of y is changing by 3, value of x is changing by 2. So slope is 3 by 2. And what is the slope here? If you look closely, what is the slope here? Slope here is, slope will be negative because the curve is like this. Slope will be negative. So value of y is changing by 2 and value of x is changing by 1. So slope will be minus 2. So slopes will be added. So here this is saying that 3 by 2 and this is saying that minus 2. So 3 by 2 minus 2. So total slope here should be minus 1 by 2. So at 1, basically you will start from here. For t less than 0, this was 0 and this was this curve. So basically this curve plus 0 will be the answer, this curve only. For t less than 0, only this curve will come into action because this was 0 only. Now for 0 to 1, plus 3 by 2 minus 2, that means the slope will be minus 1 by 2. Minus 1 by 2 means curve should come like this. Curve should come like this. Curve can go either like this or it can come like this. So it has to come down. Why is that so? Because the slope is minus 1 by 2. Here the slope is minus 1 by 2. That means if my t increases, y should decrease. This shows that slope is minus 1 by 2. Now let me know what should be the value at 1. What should be the final value at 1? What do you think? What should be the value here? What is the slope? Slope is minus 1 by 2. That means if your t increases by 1, then your y should decrease by minus 1 by 2. If your t increases by 1, then y should decrease by minus 1 by 2. That means 2 minus 1 by 2. So the value here should be 3 by 2. So at this point, I should get 3 by 2. Say yes or no. Now let's check if you are getting 3 by 2 only or not. Let's check that. How will you check? So what this guy is saying? This guy is saying that at t equals to 1, value should be 0. And what this guy is saying? At t equals to 1, what should be the value? What is the slope here? 3 by 2. Slope is 3 by 2. That means if the change in t is, is 1, then the change in xt would be 3 by 2. The slope is 3 by 2. That means if t changes by 1, that means xt would be changing by 3 by 2. So at 1, what is the value? 3 by 2 only. So at 1, this guy is saying that value should be 3 by 2 and this guy is saying that value should be 0. So 3 by 2 plus 0. 3 by 2 plus 0 should be equals to 3 by 2 only. So both ways I can check. First way could have been that I find the value here and then I simply add 3 by 2 plus 0. I would have got here. Then I would have just made this graph. Or the other way could have been, I know that the slope is 3 by 2 here, the slope is minus 2. So when I add both of the curves, slope will always be added. So 3 by 2 minus 2, minus 1 by 2. And minus 1 by 2 means I will go down. And if I am coming down with the slope of minus 1 by 2, then certainly I can find this point. Now at 1 only, what do you see? At 1 only you can see that there is a jump. There is a jump of 2. So at 1, this guy is saying that first it should be 3 by 2 plus 0. First it should be 3 by 2 plus 0. And then it should be 3 by 2 plus 2. So there is a jump of 2. 3 by 2 plus 2. Initially it was saying it should be 0. Then it is saying that it should be 2. So 3 by 2 plus 2. What that would be? 7 by 2. Right? It should be 7 by 2. So from here it will take a jump to 7 by 2. From here it will take a jump to 7 by 2. Right? So this jump it has taken at 1 itself. So this is how I could have solved it. Now between 1 to 2, between 1 to 2. So what is the slope? 3 by 2. And here what is the value? 2 only. So let's drop it here. Directly we will go at 2. Directly we will go at 2. So at 2, what value I am expecting? At 2, this guy is saying that value should be 2. And at 2, this guy is saying that value should be first 3 and then it should be 4. At 2, this guy is saying that value should be 2, and this guy is saying that first value should be 3, that means 2 plus 3, 5, and then again it is saying that value should be 2 plus 4, 6. That means from 5 to 6 there will be a jump. So here what was this? This was 3.5. So 5 will be somewhere here. So at 2, value should be 5, and then it should take a jump to 6. And how will you make the curve? This is how you will make the curve. So from 5 to 6, it should take a jump. I hope you are getting the point. At 2, I can define the values. No, at 2, this guy is saying that value should be 2, and at 2, this guy is saying that value should be 3. So 2 plus 3, 5. And at the same point, this guy is saying that value should be 2. At the same point, this guy is saying that value should be 4. So 2 plus 4, 6. So from 5 to 6, it should take the jump. So now, how should the graph go between 1 and 2? This is how the graph should go. So I need to add the lines. So better showing the values 5 and 6 here, I should show it on the graph. So on the graph, it would be like this, that this value is 5 and this value is 6. Okay, I am not showing here. And can I tell the slope of this curve? What do you think? What will be the slope of this curve? Between 1 and 2, what should be the slope? Between 1 and 2, here the slope is 3 by 2. And between 1 and 2, here the slope is 0. So slope should be, this resultant slope should be 3 by 2. Are we getting the same slope? Let's check that out. So how much change is there in y? The change in y is 5 minus 7 by 2. And how much change is there in x? That is 1. So what is the slope? How much change is there in y? That is 5 minus 7 by 2. And how much change is there in x? That is 2 minus 1, that is 1 only. So how much you are getting? 3 by 2 only. Are you getting the same slope? Yes. At 2, there is a sudden jump. At 2, there is a sudden jump here. So in the resultant as well, there is a sudden jump. At 1 also, there was a sudden jump. So in the resultant as well, there is a sudden jump. Now after 2, what is happening? After 2. After 2, this guy is saying that the slope is 1. How the slope is 1? You can check. The slope is 1 like this. Right? And this guy is saying that the slope is 0. So what should be the resultant slope? Resultant slope should be 1 only. So what I am going to do is that I am going to take this graph down. Because after that, my slope should be 1. So this is how the curve will go. So it will keep on going like this. Because after 3, after, oh sorry, yeah, after 2. After 2, this guy is saying that slope should be 0. And after 2, this guy is saying that slope should be 1. So slope will always be 1. So here the slope will always be 1. Okay. And here what was the slope? That I already wrote down. 3 by 2 minus 2. So slope was minus 1 by 2. So minus 1 by 2, then sudden jump, then slope 3 by 2, then sudden jump, and then finally the slope is 1. So this is how the curve is going. And here I don't know what is the slope. Here I don't know what is the slope because they did not give in the question. They did not give this slope, so that I cannot determine. So this is how the final curve will go. So it will keep on going like this. This 3 was given just to confuse you. At 3 there is no transition. Neither there is sudden change, neither there is any slope change. So at 3 there is no transition. I just gave you to confuse you or just to let you know that what will be the slope of this line. The slope of this line will be 1. So this is why it was given, nothing else. Okay. So 1 plus 0, the slope will be 1 only. So this is the resultant curve. So this is how you should be able to make the curve. Okay, and certainly we will study all these topics again when we study about step function and ramp function in the next lecture itself. From next to next lecture, we are going to study about all this again. But these are some of the points which are usually missed by a lot of students because we don't usually study it. Sometimes we missed all these points, right? But now in the first lecture itself, we are covering all these basics so that when we go into the chapter, we will feel confident. This is not anything related to signal system. This is just the mathematics we are studying because first lecture is always the base. First lecture might go for 2.5 hours or it can go for 3 hours as well. But that will be the base of the whole chapter, right? So we are building up our base so that in the next lectures we don't feel any problem. Now what we are going to do, we are going to do the multiplication. So 3t should be multiplied with 5. What you are going to get? 15t. Okay. So 3t, here the slope was 3. It was multiplied with the constant value, that was 5. So final slope became 15. No conclusion, we are not drawing any conclusion from here. No conclusion have been made from this particular curve. What I am saying, no conclusion we have made from here. Just I drew the graph with the slope of 15, nothing else. Okay. Now if I multiply with minus 1, what will happen? My slope is 5t. Sorry, my slope is 5, my curve is 5t. This is my curve, 5t. Slope is 5. And I am multiplying with minus 1. I am multiplying with minus 1. So now what will happen? What will be my resultant answer? Minus 5t. So resultant answer would be somewhat like this. This will be the resultant answer because slope is negative and it should cut y-axis on 0. Right? It should cut y-axis on 0. So this will be the curve minus 5t. The slope is negative. Say yes or no. But how will you come from here to here? Basically what you are doing, you are just taking the negative of this curve. Your yt is equals to minus of xt, minus of x1t. Say yes or no. You are just taking the negative of this curve. So what will happen if you are taking the negative? So whatever the positive value was there, that became negative. And whatever the negative value was there, that became positive. The magnitude did not change. Let's just say here the magnitude was 5. Now the magnitude became, sorry, here actual value was minus 5. Now this has become plus 5. And here actual value was 5. This has become minus 5. So magnitude, here magnitude was 5, here also magnitude was 5, here also magnitude is 5, here also magnitude is 5. Magnitude is not changing. What is changing? The sign is changing. Positive value becomes negative value becomes positive value. That means if you are multiplying with minus 1, if you are multiplying any function with minus 1, or you can say if you are taking the negative of the function, that means you need to take mirror image about t-axis. Mirror image about x-axis you can say, or t-axis you can say. So I am just taking the mirror image. What will be the mirror image of this? This point should come here, 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 this point should come. What do you mean by mirror image? Let's just say you are standing. So what is the mirror image? Reflection of this image will become here, reflection of this image will become here, reflection of this image will become here, the reflection of this image will become here. So that will be your face. Now reflection of this, like this, reflection of this guy, that is away from you, so this will also be away from the screen. This is near to you, so this point and this point are same, this point and this point are same. Straight line will be straight line. What about this point? This is away from the mirror, so here it will be made away from the mirror. So same thing is happening here. You are just taking the mirror image about t-axis. What you are doing, you are taking the mirror image about t-axis. So the point which was near to origin, that will be near to origin, which is away from the origin, it will be away from the origin. So you just need to take a mirror image. Just take the mirror image of this here, take the mirror image of this here. So if I am just multiplying with minus 1, that means I am just taking the mirror image about t-axis, and this you don't need to mug up. What you will think? Initially I was having x1t, now I am having minus x1t. So that means whatever the positive value was I was having, that will become negative, and whatever the negative value I was having, it will become positive. That's it. Okay? Well and good. Very easy. Now let's take another example which will be more interesting for you. So let's remove it off so that you get good notes. So this will also be removed. So let's take another example. You need to get minus of xt from this particular given curve. Xt is given, you need to tell minus of xt. How will you do? What you will think? Okay sir, minus sign is there. So positive value will become negative value will become positive value. And this is the line which will remain as it is. So what will happen? This is the negative value, this will become positive value. Or let's start from here. Let's start from right here. So this value will become all positive, and this positive value will become negative. So how it will look like? You just need to take the mirror image. What I am doing, I am just taking the mirror image. So let me show you by taking the points as it is. So this is how I will start. Just 1 second. Another reflection I will take here. Yeah. So this is how the mirror image will look like. This positive value will be negative. Now this negative value will be positive now. This negative value will be positive. All the negative values will be positive. So let's make the curve like this. All the negative value will be positive. This is also a negative value. This will be positive, and all these positive value will be negative. right? So how the curve would be going? So negative value becomes positive and positive value becomes negative, right? Now what will happen? This transition is like from upper side you are coming to downward side. So from downward side you will go to upper side now. And this is the negative value, it will become positive now. So there you go. This is your minus of xt. Are you able to understand this point? Just about t axis I am taking the mirror image, nothing else. I will just place a mirror here and I will see how it will look like. So this value will be like this. Then this is coming downward, right? From positive value, from let's just say this was 1 and this is minus 1. So from 1 to minus 1 it is coming. So it will go from minus 1 to plus 1. Minus 1 to plus 1. Here you can see minus 1 to plus 1 it is going. Here also you can see the same thing, right? So the same thing is happening. Just you are taking the mirror image. Negative value or positive value negative value. That's it. So this is the meaning of multiplying with minus 1. Now we will move to the most interesting part, and here you need to pick your whole attention, because in the last 2.5 hours whatever you might have studied, you would have already studied it. In last 2 hours whatever that we have studied, there might be some guys who would have already studied all those concepts, but now this is something new. What you need to multiply? You need to multiply t with sine pi by 2t. Okay, so there have been a lot of guys who would know everything that I taught in the last 2 hours, because if you are someone who is dropper, then you would have already studied all these things. Basically most of the things you would have already studied, but now this kind of things you need to study. You need to multiply t with sine pi by 2t. Try doing it on your own first. How will you multiply? This is the graph of t and this is the graph of sine pi by 2t, right? Here what will be the value? Values I can mark up. Values will be plus 1 and minus 1, right? So now just let me know one thing. At t equals to 0, this guy is saying that value should be 0, and this guy also saying that value is 0. At t equals to 0, this is saying that value is 0, and this is also saying that value is 0. So 0 into 0, 0 into 0 will be 0 only. What is your yt? Yt is t into sine pi by 2t. So at t equals to 0, value should be 0 only. All good. Now at t equals to 1, this guy is saying that value is 1, and at t equals to 1, this guy is also saying that value is 1. At t equals to 1, value will be 1 only. So 1 into 1, it will be 1 only. Resultantly, what will be the value of y of 1? So this guy is saying that value should be 1, and this guy is saying that value will be 1. So it would be 1 only. But let's talk about at 1 by 2. At 1 by 2, if you put t equals to 1 by 2 in this function, so what it will say? At 1 by 2 I am asking. If you put 1 by 2 in this function, what this will say? The value should be 1 by under root 2. Because if I put t equals to 1 by 2, it will be sine pi by 4. Sine pi by 4 is 1 by under root 2. And what this will say? If I put 1 by 2 here, the value should be 1 by 2. So 1 by under root 2 into 1 by 2. That would be 1 by 2 root 2. So resultant value is lesser than this guy, no? What I am saying, here the magnitude was 1 by under root 2. So resultant value, this resultant value after the multiplication, so 1 by under root 2 into 0.5. That means resultant value is lesser than 1 by under root 2. So basically this graph goes downward. Say yes or no. Are you able to understand this point? What did I just say? We will take more examples. Let's take more example. Let's talk about at t equals to 3. So at t equals to 3, what this curve will say? At t equals to 3, this will say that my value is 3. What I am finding? I am finding y of 3. So this curve will say that my value should be 3. And what this curve will say? At t equals to 3, value should be minus 1. So what is your y of 3? Minus 3. That means this negative value remains negative only, but the amplitude increases by minus 3. Here the amplitude was minus 1, but in the resultant, the amplitude is increasing to minus 3. Say yes or no. Are you able to understand this point? What about at 5? At 5, this guy will say that, my magnitude should be 5. Basically, y of 5 I need to write down. So this guy is saying that 5 should be multiplied with, here what is the value of function? At 5, the function is 1. Basically, if you put 5 here, so the function is 1. So 5 into 1 should be 5. So in the resultant, y of 5 is coming out to be 5. Basically, this sinusoid function is being multiplied with certain values. At 5, this value will be multiplied with 5. At 4.5, this value, whatever the value is there, it will be multiplied with 4.5. At 4, this value will be multiplied with 4. Although 0 multiplied with 4 will be 0 only. At 3, this value will be multiplied with 3 only, because t of 3 is 3. You are multiplying t into sin pi by 2t. So at 3 you are having 1, and that will be multiplied with t. That means this value will be multiplied with 3. Say yes or no. So all the values after this, here 7, whatever the value is there, minus 1, this will be multiplied with 7 only, because what you are doing, t into sin pi by 2t. That means 7 into 7 pi by 2, 7. And this value is minus 1. So what you are going to get, minus 7. So just as you move along that t-axis, all these values are being multiplied with the t itself. That means eventually it will keep on increasing. That means at 9 what will happen? At 9 what will happen? So whatever the value you are getting in sinusoid function will be multiplied with 9. So sin 9 pi by 2 will be multiplied with 9. So that means amplitude will increase more, then it will keep on increasing in this manner. So are you able to relate that on this direction what kind of curve you will be getting? What kind of curve you will be getting? And another thing to note is that negative value remains negative only and positive value remains positive only. So on this kind of curve, on this side of the curve, this kind of curve you will be getting. Here, this kind of curve you will be getting, because the amplitude will just keep on increasing. Say yes or no. Say yes or no. We started with 0 here. This is our 0. This was our 1. Sorry, not 1. At 2. At 2 you are having 0 again. So this was 2. Then this would have been 4. This would have been 6. This would have been 8. This would have been 10. This would have been 12. So at 5, at y equals to 5, what you are expecting? Sorry, at t equals to 5, at t equals to 5, what value you are expecting? At t equals to 5, this will be 5 only, and at t equals to 5, this was 1. So 5 into 1, you are expecting the value to be 5. So yes, it is 5 only. At t equals to 5, you will get the value to be 5. At t equals to 7, you are expecting the value to be minus 7. Yes, you are getting minus 7 only. At t equals to 9, you will be getting the value to be plus 9. At t equals to 11, you will be getting the value to be minus 11. So in that manner, the amplitude will keep on increasing. So this side of curve will be looking something like this. Say yes or no. Although this line will not be there, this dotted line I just made to make sure that my curve will be somewhere in between. Are you getting this point or not? A very good point, right? So let me first remove all these off. Then we will think about the other side. Okay. Yeah, so now we need to think about the other side. So at the other side, what is happening? So what do you think what is happening at the other side? At the other side, let's take at t equals to minus 1. What is the value? Minus 1 only. But here at t equals to minus 1, what is the value? Minus 1. So basically, y of minus 1, what that would be? T is minus 1 into, here the value is minus 1. So what it will become? Plus 1. Basically, this side of value is being multiplied with negative. That means whatever the negative was there, that will become positive, and whatever the positive was there, that will become negative with the increasing amplitude. Why increasing amplitude? Because the value of t is also increasing here. What I said, since it is being multiplied with negative, that means negative will become positive and positive will become negative with the increasing amplitude. The same thing will happen here as well. Increasing amplitude. Why increasing amplitude? Because this guy is also increasing its amplitude. Here also, this is also increasing its amplitude, no? Minus 1, minus 2, minus 3, minus 4, minus 5, minus 6. So in that manner, it will keep on increasing. But negative value will become positive and positive value will become negative. 0 will remain there as it is. So how I will make it? 0, and then what I was having? Negative cycle. But this negative cycle will become positive cycle. So this is how I will make it. So simply the same graph I will get here. Ditto same graph. Although it is very tough to make in the writing pad. Okay. क्या करें यार? Same kind of curve you are getting. So this is how you will get the curve. So this point will be minus 2. Then this is minus 4. Because at minus 4 you will get the next 0. Minus 2, minus 4. In that manner we will keep on going. So ditto the same graph we will get, just the negative thing will become positive and positive thing will become negative, and amplitude will keep on increasing. So now what is the conclusion we can make? If you need to multiply any sinusoid or cosinusoid with any function, so first you will draw the function. First what you are going to do, you are going to draw the function, and then you will take the mirror image of the function about t-axis. What did I do? First I will draw the function. This is the function I have drawn. Then I will take its mirror image. So mirror image of this will be like this. The mirror image of this will be like this. And then in between, I will draw the sinusoid. In between, I will draw the sinusoid. The important thing to note is that you need to see whether it will be starting with positive cycle or negative cycle. That you need to think. And how will you think? By these values you will think. We will take more example, it will be more clear to you. We will take more example. Let's try this example. Okay. The point that I said in the end, that will be more clear to you with this example now. Now you are multiplying with mod of t. So how the graph of mod of t will look like? I hope you know how to draw the graph of mod of t. That means if you take the value of t to be positive, then it will be like simple t graph. But if you take the value of t to be negative, still the answer will be positive. What is the meaning of mod? Let's just say t equals to -1 I take. So what will be the value of xt? That will be +1 only. If I take t equals to -2, the value of xt will be +2 only. Basically here t equals to -1, it will give the value to be 1. T equals to -2, it will give the value to be 2. At t equals to 1 as well, it will give the value to be 1. And at t equals to 2 as well, it will give the value to be 2 only. So this is how the curve will go. So this is the graph of mod of t, and that you need to multiply with sin pi by 2t. Okay, so let's get started. So this graph multiplied with this graph, have we seen it? Yes. This particular graph multiplied with this particular graph, the same thing we have seen it. This graph multiplied with this graph. What did we show there? 0 will be multiplied with 0, 1 will be multiplied with 1, 2 will be multiplied with, at y equals to 2 will be multiplied with 0, 3. Here at 3 you will get the value to be 3. So 3 will be multiplied with -1. This is +1 and this is -1. So 3 will be multiplied with -1. So in the negative cycle the value will increase. Here at 5, this will be multiplied with 5 only. So at positive cycle value will increase. So in negative value will keep on increasing, at positive as well the value will keep on increasing. So we have already seen this kind of cycle, but we need to add a page. Where we are? Here we are. So for resultant, this is how I will draw the resultant. So here I know how the curve will go. The same way it will keep on going. 0 will remain at 0. In that manner it will keep on going. It will keep on increasing like this. Okay. This point is 0. What this point will be? 2. This point will be 4, 6, 8, 10. You can verify. At 5 you are getting more amplitude. At 1 you expected the magnitude to be more. At 3 also you expected the magnitude to be -3. So this is the same thing you are getting. Now what will happen towards this side, this particular side, towards the negative side? Now we will analyze for this particular cycle. So here this curve is multiplied with the positive value only. That means negative will remain negative only and positive will remain positive only. Are you getting this point? Here -1 will be multiplied with 1. Previously in this case -1 was multiplied with -1. So -1 into -1 it was becoming +1. So that's why the negative cycle became positive and positive cycle became negative. But here in this case this is not going to happen. Why is that so? Because -1 will be multiplied with 1 only. So this will be -1 only. 2 will be multiplied with 0. At -2 the amplitude is 2. Here amplitude is 0. So 2 into 0 will be 0 only. At -3 it will be multiplied with 3. So at -3 it will be multiplied with 3. So 1 into 3 will be 3, right? So amplitude will keep on increasing. But here negative cycle will not become positive and positive cycle will not become negative in this manner. It will not happen. So negative will be negative only and positive will be positive only. So how you will start here? how you will start here. So this is how I'm gonna start. Negative will be negative. So first cycle is negative here. So here also the cycle will be negative only. So with the negative only I will start. So this is the important point to notice here. Okay, a very, very important point. Usually I have seen students blindly they will make the curve and then they will say that sir in between I need to draw the sinusoid. But you need to see the cycle. No, this is positive, this is negative. Okay, so it will depend on the curve with which you are multiplying. So here you are multiplying with mode of t, not with t. So if you are multiplying with mode of t, you need to take care of this thing. Okay, and when we study even odd function, it will become very easy for you. Because what kind of function is that? This is a odd function. And what kind of function is that? This is a even function. Those who know it, they will be able to relate. So in even function, you just need to take one photocopy. You just need to take one mirror image. But in odd function, you need to take two mirror images. First mirror image you will take like this, and then other one you will take along with the x-axis. So if you take two mirror image, you are getting the same structure. That means this is the odd function. So if you are able to make this particular diagram, then just by looking at the curve only, you will be able to make this particular diagram as well. When we study even odd function, at that time I will tell you in detail. As of now, you don't need to worry about that. So this is the curve of y of t. Are you able to understand this? Are you able to relate? Are you able to enjoy this thing? Right? I hope you are understanding. So better than remembering any method here that you take the mirror image. So better than remembering the method, you just apply your aptitude here. You just apply your brain that what is actually happening. 3 is multiplied with 3, so amplitude will keep on increasing. In that manner, you can just think in the examination. It will not take much time. So don't remember any method for this one. Just you remember that what was the process. So here you need to multiply e to the power minus t with this same sinusoid function. So what you are multiplying? Your y of t is e to the power minus t into sine pi by 2t. So first draw the graph of e to the power minus t. At t equals to 0, value will be 1. At t equals to infinity, e to the power infinity, that is equals to 0. And at t equals to minus infinity, e to the power infinity, that would be equals to infinity. So it will start from infinity till the 0. So this is how it will go. So this is the curve of e to the power minus t. If you put t equals to minus infinity, that means e to the power infinity, that will be equals to infinity only. And if you put t equals to 0, at t equals to 0, value will be 1. And at t equals to plus infinity, the value will be 0. So it will start from plus infinity and it will go towards 0. So this is the graph of e to the power minus t. Okay. This is the graph of e to the power minus t. Now this graph will be multiplied with this particular curve. What this is having? Value 1, minus 1. Value minus 1, value plus 1. Now let's analyze this particular cycle. So what is happening? Here the value is always positive, but the value is always decreasing. From 1 to this value will decrease only. From 1 to it will go towards 0. But value is always positive, so there will be no sign change. That means positive will become positive only, negative will be negative only. Positive will be positive, negative will be negative only. Right? Because here the value is positive. So if positive is multiplied with anything, that means positive cycle will remain positive cycle only and negative cycle will remain negative cycle only. But the thing is, amplitude will keep on decreasing. Right? Here 1 will be multiplied with this much value. Amplitude will decrease. Minus 1 will multiply with this much value. Amplitude will decrease more. This plus 1 will be multiplied with this much value. Amplitude will decrease more. In this manner, it will keep on going and amplitude will keep on decreasing. At infinity, amplitude becomes 0. And anything multiplied with 0 will be 0 only. So amplitude will just keep on decreasing. It will start like this and it will just keep on decreasing. It will just keep on decreasing. So negative value will be negative only, but reduced amplitude. Are you getting this point? Basically, let's just take the example. What I am saying, at t equals to 3, what will be the value here? E to the power minus 3. And at t equals to 3, what is the value here? Minus 1. So what will be your y of 3? That will be e to the power minus 3 into minus 1. E to the power minus 3 is a positive value, right? This is a positive value and this is a negative value. So final answer is e to the power minus 3, which is a negative value only. So in negative direction, your amplitude is decreased. Basically, e to the power minus 3 will be multiplied with minus 1. So what I am going to do? Again, I am going to take the mirror image here. I just took the mirror image of this much curve, and in between this much of curve, I will make my sinusoid. Actually, amplitude should keep on decreasing. So this mirror image I did not take in a good manner. So this is this fine. This seems like correct. So this is how it will keep on decreasing. Are you able to understand this point? E to the power minus 3 is multiplied with minus 1. So this value I am gonna get. So amplitude will just keep on decreasing. Say yes or no, right? And what will happen to this side? This is also positive, but amplitude will keep on increasing. So again, here also I need to take the mirror image. So this mirror image I will take, and in between I will draw the sinusoid. But here negative cycle will be negative cycle only. So it will start like this. Negative cycle is negative cycle only, and here it keeps on increasing. Then from here it will keep on decreasing. In that manner the curve will go. Okay. So I will draw it on the next page. I hope it is clear to you. In the examination, it should not be taking much time. You just know that I need to take the mirror image, but then I need to think what is happening with the amplitude. Here e to the power minus t was positive. So positive cycle will remain positive only, and negative cycle will remain negative only. With respect to this curve, the amplitude will keep on going. So this is saying that amplitude should keep on decreasing. So starting from positive cycle, it should keep on decreasing. So yes, it will keep on decreasing, and eventually it will go towards 0 in that manner. And what about this one? Here the amplitude will keep on increasing, but negative cycle will remain negative only, and positive cycle will remain positive only. So negative will remain negative only, and positive will remain positive only. So this is how it will look like. Okay. Although it will look like a bit better, but I did not draw it in a good manner. You can draw it if you want to, otherwise this curve is fine as well. So this is how you will multiply the functions. Is that clear to you? I hope you are enjoying it, and I hope you have studied something new now, right? So this was something new. So this is how you need to draw the graph. You need to think in the examination. Again, I am saying don't remember the method that you take the mirror image and in between you draw the curve. No, think in the examination which two functions you are multiplying. Okay, these two functions you are multiplying, then think, how will I think in the examination? Okay, this value is being multiplied, then this value is being multiplied with this value. 3 is multiplied with 1, that means amplitude is increasing. After that it will keep on increasing, and here negative cycle will remain negative only, and amplitude will keep on increasing. So this is how it should go. What was the difference in these two? Here the negative cycle became positive and positive became negative, but this is not happening here. And then this curve was everything new. Here it was from starting from here, it just keeps on decreasing. That means positive will remain positive, negative will remain negative only. But from increasing amplitude to decreasing amplitude it will go. From increasing to decreasing it will go. Say yes or no, right? So that's it. That's it about the multiplication. We can do more. Multiply these two curves. So think about it. How will you multiply? So from 0 to 1, you are having 1. That means this particular cycle will be multiplied with 1. This particular values will be multiplied with 1. That means it will remain as it is. Anything multiplied with 1 is the same value. 5 into 1 is 5 only. So here 1 into 1 will be 1. 1 by under root 2 into 1 will be 1 by under root 2. So anything multiplied with 1 will be the same value. And before that it was all 0. So anything multiplied with 0, 0 will be multiplied with this curve. So anything multiplied with 0 will be 0 only. So what will be the resultant? Before this everything will be 0. Before this everything will be 0. Now from 0 to 1, anything multiplied with 1 will be the same. So from 0 to 1 the curve will remain same. Now from 1 to 2, what is this value? Minus 1. Anything multiplied with minus 1, that means you need to take the mirror image. Negative value will become positive value. Positive value will become negative value. But here all the values are negative only. All these values are negative. So all these negative value will become positive value, right? All these negative value will become positive value. So anything multiplied with negative value means all the negative value will become positive value, because it is being multiplied with minus 1. Now between 2 to 3, anything multiplied with 2 to 3, anything multiplied with 0 will become 0 only. So anything multiplied with 0 will become 0 only, because between 2 to 3 you are multiplying with 0. 0 into anything will be 0 only. From 3 afterwards, like more curve is not given, but you are just multiplying with 1. You are just multiplying it with 1. So if you are multiplying anything with 1, that means negative value will remain negative only. Nothing will change. Multiplying with 1. So 1 means the same value you are going to get. Negative means negative value will remain negative only. So here negative value will remain negative only. After that the curve is not given. So till this point only I will define it. That's it. So will you be able to think in the examination? I don't think it is very tough. Simply 1 into this curve, same curve. Minus 1 into this curve, just the mirror image. 0 into this curve, 0. 1 into this curve, the same curve. So if you are multiplying with 1, the same curve you will get. If you are multiplying with minus 1, that means negative value will become positive and positive will become negative. So you just need to take the mirror image. Multiplying with 0, anything multiplied with 0 will be 0. 1, the same curve. The same curve. So this is how you will be getting. Okay. So this is the final curve. Now the final thing of this lecture, that is, now this is not the final thing. This is the second last thing. Subtraction. How will you do the subtraction? So can I write it down in this manner? What I need to do, x1t minus x2t. So x1t plus minus of x2t. x1t plus minus of x2t. So do you know how to get minus of x2t? Yes. How do you know? Here we have seen it, no? How to get the negative. From xt2, how do you get minus of x of t? Just take the mirror image about t axis. Positive, negative value becomes positive, positive value becomes negative. So what do you know? You know how to get minus of x2t and you know how to do the addition. So do you know how to do this process? Yes. So x1t will be given, x2t will be given. Your first task would be to get minus of x2t and then just add both of the curves. That's it. Okay, not tough. We are not taking an example, but you can take the example on your own and you will be able to solve it. Without any doubt, you will be able to solve it. These kind of questions I can frame in the test series as well. That add two curves, add any curve, these kind of things I can frame in the test series. But these are very simple. Just you take the negation, that means take the mirror image and then just add both of the curves. And adding both of the curves, we have seen 4 to 5 examples. You will be able to add the curves for sure. So this was about the subtraction. How to take the mode of any function? Xt is given, you need to take mode of xt. Xt is given, you need to take mode of xt. So how will you take the mode? So what is the meaning of mode? Mode of minus 5 is equals to 5 and mode of 5 is equals to 5. So for positive value, there is no meaning of the mode. For positive value, there is no meaning of the mode. So here, let's just say this value is 1, okay? And this value is minus 1. This is what I am saying. This value is 1, this value is minus 1. So here the value is increasing from 0 to 1. All values are positive. So positive value will remain positive only. Positive values will remain positive only. So between 0 to 1, values are increasing from 0 to 1 only. What about the negative values now? Here the value became minus 1. So now what you are doing? You are drawing the mode of xt. Mode of xt. Not this graph. You are not drawing this graph. You are drawing mode of xt. That means if a value of xt was negative, you will make that positive. So here value of xt was minus 1. So minus 1 mode will be 1 only. So this negative value became positive. Now at 2, what do you see? At 2. So at 2, this is the negative value. So negative value, all these negative value will become positive. So this is at 3. Now at 3, what do you see? Again there is a sudden jump and you will reach to 1. So at 3 there is a sudden jump, you will reach to 1. Because these are the positive values, so positive will remain positive only. Positive will remain positive only. Okay. Now what about this guy? This is the negative values. No? These are the negative values. So if you multiply with, these are the negative values. If you take the mode, so negative value will become positive value. So this was the negative value. All the negative value should be positive. That means at t equals to 0 plus, you are having somewhat minus 1. So here it will become plus 1. And at minus 1, you are having 0. So this will be 0. So this is how the curve will go. Basically, you are taking the mode. That means again, you are taking the mirror image. Nothing else. What is the meaning of like minus 5? Mode of minus 5. What you are doing? You are multiplying minus sign to minus 5. Then you are getting plus 5. No? So for all the negative curve, I am multiplying with minus 1. And what is the meaning of minus 1? Negative value becomes positive. And with the positive curve, what I am doing? What is the value of mode of 5? You are multiplying with 1 only. 1 into 5 is 5 only. And what was mode of minus 5? You are multiplying with minus 5, minus 1. So minus 1 into minus 5, that will be plus 5 only. So all the negative values are multiplied with minus 1. That means negative value will become positive. So this minus 1 will become plus 1. This 0 will become plus 0 only. Here what was the value? Let's just say it was minus 0.5. So minus 0.5 will become plus 0.5. Are you getting this point? Okay. And this is the positive value which will remain positive only. And there you go. So what is the conclusion that you have made from here? That if you are taking the mode, mode means simply the mirror image. What is the meaning of mode? Mode means simply the mirror image. So whatever that you see downward, that will come upward. Whatever you see downward, that will come upward with the mirror image. So for this particular curve, you need to take mirror image. For this particular curve, you need to take mirror image. Okay. So this is the end of our first lecture. Here mostly we studied mathematics only. Okay. This was purely mathematics only. First we studied about that continuous time, discrete time. That was a good thing. Then we moved to mathematics. So but that was necessary. Now we will dive into signals. We will see the type of signals. Step signal we will see, ramp signal we will see, impulse signal we will see. So these kind of signals we are going to see. And now a bit of electronics and electrical engineering will start. Till now we were studying mathematics only, but again there is a huge role of mathematics, but still signal system is not mathematics. It is far away from the mathematics. Okay, signal system is completely different from mathematics. So as of now we just show the basic mathematics of signal systems. In the next lecture we will get started with unit step signal. Okay, thank you very much. Yeah, hi everyone, welcome back. So what we were studying about basics of signal. Now we will start studying about some standard signals, like step signal would be there, ramp signal will be there, impulse signal will be there, doublet signal will be there. So all these signals we will study one by one. So in this video we are going to study about unit step signal. What do you mean by unit? Unit means amplitude is 1. Okay, unit means amplitude is 1. And what do you mean by step signal? So let's understand by a circuit. So very basics of network analysis, you know, right? Very basics. This is a switch, this is a resistor, and this is a 1 volt battery. Okay. Now this switch was open for t less than 0. It was open for t less than 0. What is the meaning of this sign? That switch is getting closed at t equals to 0. That means it was open before that. For t less than 0, this was the condition. This was the condition. The switch was open. This was the condition. Now let me know one thing. If this switch was open, then what will be the current through this resistor? 0 ampere. If the current through the resistor is 0 ampere, then what will be the V0 value? 0 only, right? Because if there is 0 current, that means there will be 0 voltage drop. So V0 value will be 0. So for t less than 0, your V0 value was 0. What I am drawing? I am drawing V0 graph, which is a function of time. So V0 t versus t I am drawing. So for t less than 0, your V0 was 0. Now just as you close the switch, then what will happen? This will be a simple line, just as I have closed the switch. And what is the voltage here? 1 volt. So just as I have closed the switch, this 1 volt will reach to V0. So now what will be the value of V0? V0 will be 1, right? V0 will be 1. But what I am saying that these wires are having some delay. What I am saying, these wires are having some delay. So just as I close the switch, V0 will be 1 volt, but it will take some time to be 1 volt. What I am saying, that I know that V0 will be 1 volt, but it will take some time to reach to 1 volt. That from 0 to it is reaching slowly to 1 volt. This is what I am saying. Okay. From 0 to slowly it is reaching to 1 volt. So how much time it is taking? It is taking delta time. You can call it time or you can call it delay as well. So there is a delay of delta time. Why there is a delay? Because I am saying that this 1 volt will take some time to reach to V0. Right? Ideally this delay should be 0, because these wires ideally should not have any delay. Just as I close the switch, 1 volt should reach there. So ideally this delta should be tending to 0. So if this delta is tending to 0, then what kind of graph you will be getting? If your delta tends to 0, then before t less than 0, voltage was 0 only. And just as you close the switch, what was your V naught? 1 volt. Just as I close the switch, my V naught became 1 volt. So this kind of graph you will be getting, right? Right. So this is known as unit step signal. Okay. This is known as unit step signal. Okay. And we show it by, we denote it by UT. How do I show it? UT. Unit step signal is shown by UT. U of t. That means it is 1 for t greater than 0 and it is 0 for t less than 0. Now you will be saying, sir, what about at t equals to 0? So did I teach you limit? I taught you about limit, right? I taught you about continuity as well. So if you say, if you ask me, limit t tending to 0 minus ut, what will be the value? I need to go to 0, but from left hand side. From 0 minus, I need to go to 0. So what is the value? 0. And what is limit t tending to 0 plus ut? What is that? I need to go to 0, but from right hand side, from here. So what is this? 1, right? So now tell me, at t equals to 0, ut is continuous or not? At t equals to 0, ut is not continuous. At t equals to 0, ut is not continuous. So if someone asks you what is the value of step signal at t equals to 0, you cannot define it. For t greater than 0, it is 1. For t less than 0, it is 0 only. But at t equals to 0, undefined. This is strictly written in our book. Which book? In OpenIM it is written. Okay. So I have seen a lot of places people will say that you take the average of 0 and 1. What you are going to get? 1 by 2. So at t equals to 0, your steps signal value is 1 by 2. But that doesn't make any sense. Okay, that doesn't make any sense. At t equals to 0, it is undefined. It is not 1 by 2 or it is anything. It is undefined at t equals to 0. So this is our step signal. Understood? Very simple thing. For t greater than 0, it is 1. For t less than 0, it is 0. Now you need to draw these graphs. So we will study one by one. We need to draw all these graphs and we will make interesting conclusion out of it. Okay, so first let's get started. First I need to draw the graph of 5 ut. Charger, तभी मैं सोचूं. The screen was lagging. And now it will not lag if it was lagging before. So x1t is 5 ut. This is what I need to draw. I know what is the definition of ut. I only know the definition of ut, that for t greater than 0, it will be 1, and for less than 0, it will be 0. But now what I have done, I have multiplied by 5. Do you remember, if you multiply any function with a constant number, what will happen? The whole function will be multiplied with 5. So previously, what was the graph of ut? If I ask you to draw the graph of ut, then how you used to draw it? That, sir, before this it was 0, but after this it will become 1. But now I am multiplying the complete function with 5. I am multiplying the complete function with 5. So this will be my x1t. So what you will call it? This is a step signal only, but this is not unit step signal. Okay. This is a step signal, but not unit step signal, because it have an amplitude of 5. So this is a step signal only, but not a unit step signal. So here, this is how I was defining it. So if I multiply by 5, so here also it should be multiplied with 5. That means amplitude will be 5 for t greater than 0, and for t less than 0, amplitude will be 0. So yes or no? Let's see the next one. The next one could be x2t, that is 5u of minus t, right? 5u of minus t. So how will you define u of minus t? One thing I know, that whatever that is written inside, how did I define ut? Ut I defined as that it will be 1 for whatever that is written inside greater than 0, and it will be 0 whatever that is written inside for t less than 0. So whatever that is written inside of u, that means if your minus t is greater than 0, then it will be 1. What do you mean by minus t greater than 0? That means t should be less than 0, right? Minus t is greater than 0. If you multiply by minus on both of the sides, then inequality sign will be changed. So t should be less than minus 0, or minus 0 is equals to plus 0 only. So t should be less than 0. So from here what you are getting? From here what I understand is that it will be 1 for t less than 0, right? So this is what I am getting. What is the second thing? That whatever that is written inside, if that is less than 0, then your value will be 0. So from here what do I understand? That if my t is greater than 0, then it would be 0. Just opposite thing has happened. How do you need to define it? Whatever that is written inside, if that is greater than 0, that means your value will be 1. Here it is 5. So what I am gonna do? I will multiply the amplitude with 5 only. I am multiplying with amplitude 5. And 0 multiplied with 5 will be 0 only, 0 multiplied with 5 will be 0 only. So what we are doing, if minus t is greater than 0, then you will get the value to be 5. That means if t less than 0, then value is 5. If t greater than 0, then value is 0. So if I draw the diagram, then how it will look like? Here amplitude is 5 only. Amplitude is 5 only. For t less than 0, amplitude is 5 only. But after that, the amplitude will become 0. Right? Amplitude is becoming 0. So this is 5 u of minus t. Now just make a conclusion out of these two diagrams. What kind of conclusion you can make? Function is similar. Like if I see 5 u of t, u of minus t. So if I just add a sign, I add a negative sign in time domain. If I add a negative sign in time domain, then what happens? The waveform gets inverted. Not inverted, I would say. The waveform will be having its mirror image about y-axis, or you can say x1t axis. So you just need to take a mirror image. Okay. So this is getting a mirror image about y-axis. Okay. About y-axis, I need to get a mirror image. So like in the examination, you are not going to define the function like this. You will just say, okay, phi for ut will be something like this. Then phi for minus u of minus t means just I need to take the mirror image. That's it. Okay. Or we will write down the conclusion as well. We will see the conclusion, and after that you will be having good enough practice. But for now we will understand it one by one. So x3 of t 3 into u of t minus 2. So try writing down on your own and try making the waveform on your own. So x3t is 3u of t minus 2. So how will I define it? 3u of t minus 2. That amplitude will be 3. Amplitude will be 3 for whatever that is written inside, that should be greater than 0. Whatever that is written inside, that should be greater than 0. That means if your t is greater than 2, then your amplitude will be 3. Amplitude will be 0 for whatever that is written inside, that should be less than 0. That means if t is less than 2. So if t is greater than 2, that means if t is greater than 2, then amplitude will be 3. If t is less than 2, then amplitude will be 0. So what kind of waveform you will get? Here I can draw the waveform. Till 2 it will be 0. After that amplitude is 3. Let's make the amplitude to be 5. Okay. Let's make it 5. Why should we change the amplitude? Let's make it 5 only. Everywhere let's keep it 5. So now this has become 5 here. This is the graph of x3t. What I am getting? 5. And this is u2. So what do you understand from here? From u of t, from this particular graph, from u of t, from 5 u of t, you need to go to 5 u of t minus 2. Then what did you do? You saw that there is a negative sign, minus 2 is there. So if there is a minus sign, that means you will do the right shift. If there is a minus sign, that means you will do the right shift. That means you will be moving towards the positive axis. This is the positive axis, no? And this is the negative axis, right? So if there is a negative sign, that means you will be moving towards the positive axis. Negative sign, you will be moving towards the positive axis. If there is positive sign, that means you will be moving towards the negative axis. Opposite you need to do. So you saw there is a negative sign. That means I will do the right shift. So your function is shifted right by 2. So this is what happened here, right? Now try making the next one. D x4t, that is 5u of t plus 2. 5u of t plus 2. So can you define it on your own? Certainly I can define it. So 5u of t plus 2. So it will be 5 for whatever that is written inside that is greater than 0, or you can call it if your t is greater than minus 2, and it will be 0 for whatever that is written inside that is less than 0, or you can say if t is less than minus 2. So for t less than minus 2, what is the scene? For t less than minus 2, everything is 0, but after that everything is 1. This is your minus 2, but after that everything is not 1, it is 5 because amplitude is 5 here. So this is the graph of x4t. So what did you see here? Here the sign was u of t plus 2. If there was a sign of plus, that means you need to do the left shift. That means you will be moving towards the negative axis. So from u of t, if you are coming to u of t plus 2, that means you are moving towards the left hand side, right? Now try relating one thing, that from x3t2 you need to come to x4t. From x3t2 you need to come to x4t. Yeah, sorry for the interruption. So what I was saying that I need to come to x4t from x3t. Okay, I need to come to x4t from x3t. This is what I was saying, right? So let's just say I am given the graph of x3t. So what is my x3t? x3t is 5u of t minus 2. Now I need to make it x4t. I need to make it look like x4t. So what I can do? What I can do is that, can I put in place of t, can I put t plus 4? In place of t, I am putting t plus 4. So what I am getting? 5u t plus 4 minus 2. So yes or no? In place of t, I just have put t plus 4. So what I am getting here? 5u of t plus 2. And what is that equivalent to? x4t. Say yes or no? Is this relation clear? What did I do? In place of t, I just put t plus 4. If I put t plus 4 here, what I am getting? x4t I am getting. Basically, if I put t plus 4 here, so I am getting 5u of t plus 2, that is equals to x4t only. So what we are getting here, that your x4t is equivalent to x3t plus 4. Now what did I tell you? If you are given the graph of ut and you need to get to u of t plus 4, what you are going to do? Plus 4. Plus 4 means you need to left shift. You need to left shift by 4. You need to left shift by 4. So the graph of u of t was something like this. I need to left shift. That means from minus 4 I will start. Same thing is happening here. You are given the graph of x3t. You are given the graph of x3t and you need to go to x3t plus 4. That means you need to do the left shift by 4. So minus 2 left shift by 4. That means plus 2 left shift by 4. That means you will be starting with minus 2. Are you getting the same thing? Yes. So I can come from u of t as well. I can come from u of t minus 2 as well. From anywhere I can come. And later on in this lecture only you will realize that you can come from u of minus t as well. So that also we will see. How you will come from u of minus t. But as of now, from u of t I am coming to x4 of t. From u of t I am coming to u of t minus 2 as well. For u of t plus 2 as well. And from u of t minus 2 as well, I can come to u of t plus 2. I just need to see what kind of shift is there. From u of t minus 2, if I need u of t plus 2, that means I need to add 4. From u of t minus 2, if I need to go to u of t plus 2, that means I need to add 4. And adding 4 means going backward. And this is the relation that we are having. So from this relation as well, you can verify your analysis. That if x3t graph is given, if x3t graph is given and I need to make x3t plus 4 left shift. Very simple, right? So slowly you will be building up the practice with that, because we are proving the things one by one. So slowly the practice will be built up. Don't care about it. Okay, don't feel like that, sir, how we will be able to remember all these things. We will solve the problems, your practice will be built up, then you will be able to remember. Okay, this is like mathematics only. Next, u of 3t. U of 3t. So a, b, c, d, e. x5t is equals to u of 3t. U of 3t. Here there is no multiplication about with any factor. So that means it will be 1. For whatever that is written inside, if that is greater than 0, it will be 0. For whatever that is written inside, that should be less than 0. So what you are getting here, 3t greater than 0, that means t should be greater than 0 only. And here t should be less than 0 only. So what kind of graph you are getting? The same graph as ut. Say yes or no. You are getting the same graph. Nothing different has happened, right? The graph is ditto the same. Similar graph is there. It is 3 for t greater than 0. Not 3, sorry, 1, 1. Really sorry. U of 3t it was. So it was 1 for t greater than 0. So what you can see here, that your u of 3t is equals to u of t. So what is the conclusion you have made from here? That step signal u, this u can eat up a constant value. It is not always true. Can I write down x of 3t is equals to x of t? No. This is not always true. Why this is not always true? Because x could be anything. But in place of x, if there is u, that means this u has ability to eat up any constant value. So u will eat up any constant value, that is 3. So u can eat up this 3. So what you are getting? U of t. So u of 3t is equals to u of t. So this is also an interesting conclusion that we need to take care. EF. Next is, I guess, u of minus 4t. U of minus 4t. So write down in the definition on your own that it would be 1 for whatever that is written inside, if that is greater than 0, or you can say if t less than 0. Minus 4t should be greater than 0. So what I need to do, if I divide by minus 4, if I am dividing by minus 4 on both of the side, then sign will be interchanged. Sorry, divided by minus 4. If I am dividing by minus 4 on both of the sides, then the sign will be interchanged. So t should be less than 0. So if t is less than 0, then amplitude is 1. Or you can say if it is 0, it will be 0 if the whatever that is written inside, if that is less than 0, then it would be 0. So what you are getting? T greater than 0. So for t greater than 0, it will be 0. For t less than 0, it will be 1. So what kind of graph you are getting? What kind of graph you are getting? So this kind of graph I am getting. This is your u of minus 4t. Now this graph is equivalent to u of minus 4t. This graph is equivalent to u of minus t. So from here what you are getting to know, that this u has the ability of eating up 4. This u has the ability of eating up the constant value, but this u cannot eat up the negative sign, right? The negative sign is still coming. So this u cannot eat up the negative sign. It can eat up the constant value. It can eat up this 3. It can eat up this 4, but it cannot eat up the negative sign. So negative sign will be there as it is. Okay. So this is the conclusion we are making from here. Slowly all the conclusion we will be understanding, everything will be clear to you. Okay. No need to worry about anything. Next we need to draw u 2t plus 2. Okay. You can define it on your own and start making the waveform. Whatever the function is, I कौन सा आ गया 7. U of 2t plus 2. So how will I define it? U of 2t plus 2. So whatever that is written inside, if that is greater than 0, 2t plus 2 is greater than 0. What does that mean? I hope you know how to solve this equation. T should be greater than minus 1. So if t is greater than minus 1, if t is greater than minus 1, then it would be 1. Otherwise, if t is less than minus 1, it would be 0. Or you can solve the equation like simply 2t plus 2 is less than 0. So what you will be getting? if t is less than minus 1. So if t is less than minus 1, sorry, greater than minus 1, then it is 1, otherwise it is 0. So breakpoint is at minus 1. So where will be the breakpoint? This will be the breakpoint. The breakpoint is minus 1. And for greater than that it is 1, for less than that it is 0. So this was the graph of x7t. Okay. Now I will draw the same graph, but how I will go? First I will draw the graph of ut. Okay. Then I will move from here. First I need to get the graph of ut. Ut graph I know. Then next I will move from here. First thing what you are doing? You are adding 2. First thing you are doing is you are adding 2. Then what is the next thing you are doing? You are multiplying with this time domain. You are multiplying this time with 2. You are multiplying this time with 2. Then you will be reaching here, right? So first what I need to do? I need to draw this graph ut. Do you know how to draw the graph of ut? Yes, very simple. How the graph of ut will look like? This is how the graph of ut will look like. That for less than 0 it is 0. After that it is 1. Okay. What is the next step? U of t plus 2. Plus 2. Plus 2 means left shift. Plus sign means left shift. So what will be the left shift? For left shift, where I need to do? Where I need to go? Left shift means I need to go to minus 2. Left shifted by 2. Okay. So this is the next thing I have done. Now if it is multiplied with 2, if it is multiplied with 2, so what I am gonna do? My time domain, my time function, here you are having minus 2, no? Now your time is multiplying with 2. There is a scaling in time domain. There is a scaling in time domain by the factor of 2. So here I will divide by the factor of 2. Are you getting this point? Here also we did the same thing. U of t, I know this will be the graph, right? U of t. U of t, this will be the graph. Here, U of t graph I know, I need to draw the U of 2t graph. So I need to do the scaling in time domain. I need to do the scaling in time domain. So this is being multiplied with 2, so I need to divide by 2. Say yes or no? So 0 is divided by 2, that would be 0 only. So that's why here you could not see the effect. But I know that this will be my final answer. Right? I have drawn till u of t plus 2. I need to go to u of 2t plus 2. So step by step I am going. I am starting from here. First t plus 2. Okay, t plus 2 means shifting here. Now it is multiplied with 2. In time domain, if it is multiplied with 2, then here it will be divided by 2. On the time axis, it will be divided by 2. Are you getting this point? So in the next step, I need to divide it by 2. Did you understand this point? Step by step I am going. Here also I did the same thing actually. From u of t I needed to go to u of 2t or 3t. U of 3t. So I am dividing this axis by 3 as well. But 0 divided by 3 would be 0 only. But here you can see the effect because it is minus 2. At minus 2, basically here this 1 was this axis. If this is 1, so this is also being divided by 3. But that effect is not visible. Only the breakpoint is visible, no? Only this breakpoint is visible. Say yes or no? What is the breakpoint? Breakpoint means where the graph is changing. So your graph is changing at t equals to 0. But here your graph is changing at t equals to minus 2. So now if you are scaling in time domain, that means if you are multiplying with 2, so here you need to divide by 2. So if I divide by 2, what I am getting? So if I divide by 2, I am getting it to be minus 1. Say yes or no? So here this will be minus 1. Because I need to divide by 2. We will solve more examples. It will be more clear to you. Okay. So let's remove off all these things. Now what other things I could have done here? What do I know? That this u can eat up any constant value. What is written there? U of 2t plus 2 is written, right? U can eat up any constant value. So can I write it down in this manner? U of 2 t plus 1. U of 2 into t plus 1. and I know that u can eat up the constant value. So what you are getting? U of t plus 1. If u of t is given, can you draw the graph of u of t plus 1? Yes. I know this is my ut. What will be my graph of u of t plus 1? T plus 1. Plus 1 means shifted left side. So it will be starting from minus 1 only. Are we getting the same thing? Yes. Are we getting the same thing? Yes. So u of t plus 1. This graph is same as these two graphs. Say yes or no? Basically, it can eat up a constant value. So I just took a constant aside. 2 I am taking aside. So it just eat up this 2. So u of t plus 1 we are getting the same graph. So multiple ways are there. Are you getting this point? This is very important that you need to get started from backward side. First target is to do the plus 2. Plus 2 means shifted backward. Then in time domain it is multiplied with 2. That means it will be scaled by 2 here. Are you getting these points? We will solve more example. No need to worry. Try the next one on your own. U of minus 2t plus 2. U of minus 2t plus 2. 7. कहाँ गया भाई? 8, 9, 10, 11. X 8t. U of minus 2t plus 2. Again the same thing, u of minus 2t plus 2. First we are doing it by the basic definition, then we will solve by the method. It will be 1 for whatever that is written inside, if that is greater than 0. So how will you solve this inequality? Minus 2t plus 2 is greater than 0. So minus 2t is greater than minus 2. So now I need to divide by minus 2 on both of the sides, right? If I am dividing by the negative number, that means your t should be less than 1. So if my t is less than 1, if my t is less than 1, that means it will be 1, otherwise it will be 0. Right? So you can draw the graph. Okay, sorry. For less than 1 it is 1 actually. For less than 1 it is 1. And after that it is 0. So this is the graph. Now what is the other way? Let's check the other way. So u of minus 2t plus 2 I need to get. So from where I will start? Let's just say I am starting from u of t. I am starting from u of t. Okay. So what is, from where I will start? From here. So what is the first step? The first step is u of t plus 2. So graph of ut I already know. What will be the graph of u of t plus 2? This will be the graph of u of t plus 2. Plus 2 means shifted backward. Plus 2 means shifted backward. So this will be the graph of u of t plus 2. Say yes or no? Shifted backward, or you can say shifted towards the left hand side. U of t plus 2. Now the next thing is multiplied with 2. Time function is, not time function. Time is, t is multiplied with 2. That means in the time axis you will be dividing by 2. Right? In the time axis I am dividing by 2. So if I divide by 2, what does that mean? That this will become minus 1. This will become minus 1. Amplitude is 1 only. Now what is the next step? The next step is this time axis is multiplied with minus sign. This time axis is multiplied with minus sign. And in the first slide here, what did I tell you? From u of t, if you are going to u of minus t, then what you need to do? You just need to take the mirror image. So next step is this time function is multiplied with the minus sign. So what I need to do? Now I need to take the mirror image. So whatever the function this is having, I just need to take its mirror image about this real x, about this y axis. So what will be the mirror image? This minus 1 will be plus 1. It is from here it is greater than 0. Basically mirror image you need to take, right? You need to place a mirror here. So this line will come here, and this line that is going this side, this line will be coming towards this side. Opposite, just the opposite thing will be happening, right? I hope you can see this. So for t less than minus 1 it was 0. Now for t greater than 1 it will be 0. For t greater than 1, it will be 0, and for t less than 1, it will be 1. Are you getting the point that how I am taking the mirror image? Right? So this is u of minus 2t plus 2. Say yes or no. So are we getting the same graph? Yes. Now what could be the other way of solving this problem? So what is given? U of minus 2t plus 2. Now I want to take common something from here. So what will I take common? 2 or minus 2? Think about it and let me know. Will I take minus 2 common or will I take 2 common? I can take both of them common. Let's just say I take minus 2 common. So what I will be getting? Minus 2 into t minus 1 here. Say yes or no. Right? Minus 2 I took common, so it will be t minus 1. So now this u can eat up this minus 2. No, u will eat up only 2 because there is an importance of minus sign, right? U of t and u of minus t both are different. U of t and u of minus t both are different. This u cannot eat up this minus sign. So u will not be able to eat up the minus sign, but u can eat up this constant number, that is 2. So u will eat up this constant number. So what I will be left with? U of minus t minus 1, or you can say it will be u of minus t plus 1. Now can I draw the graph of u of minus t plus 1? Yes. What is the graph of u of t? This is the graph of u of t. From where I will start? From here I will start. This is the graph of u of t. First, what is the first step? U of t plus 1. So first step is plus 1. That means I will be shifting towards the negative side. So this will be u of t plus 1. Now what is the scene? I need to take the negative sign. The time is multiplied with the negative. That means I will be doing the shift, or I will be doing the mirror image. So what will be the mirror image? This will be the mirror image. Mirror image of this guy will be something like this, right? So this will be the mirror image. So from here you are getting this particular diagram, and this particular diagram is same as this diagram, right? So there are n number of ways. Here I just reduce to, then I go to know that u of minus t plus 1. So I need to start from here. I need to start from the right hand side. So I'm starting from right hand side, u of t plus 1 shifted backward, and then negative sign is there. In time domain there is a negative sign. So the function or the graph will be just the mirror image about y-axis. So the mirror image will be something like this. There you go. Okay, very easy thing, very straightforward. So the graph of my u of minus t plus 1 you can draw, and it will be same like this, and it will be same like this. So there are multiple ways. This was the only conclusion. Now what is the next one? U of minus t plus 2, u of 2t minus 3. Very simple, you can do it on your own. Try it with multiple methods. Okay, try it with the multiple method. J is at 10, right? A B C D G H I, it should be I, not J. So u of 2t minus 3, right? Or 3t minus 2, 2t minus 3, then minus 2t minus 3. Okay, very simple, you can do it on your own. 2t minus 3. What could be the other way of writing it down? U of 2 I can take common, and 2 will be eaten up by u. So what you will be left with? U of t minus 3 by 2. Can you draw the graph of u of t minus 3 by 2? Yes, you can define it. That if t is greater than 3 by 2, then it will be 1. If t is less than 3 by 2, then it will be 0. So this is how I will be getting the graph. Say yes or no. Or what is the other way? You solve by this, that you start from here. So I need to go to u of 2t minus 3. So I am given u of t. What will be the first step? U of t minus 3. What will be the second step? U of 2t minus 3. Say yes or no. Right? So u of t graph do I know? Yes, surely I know the graph of u of t. U of t minus 3, do I know the graph? Yes, u of t minus 3. What will be the graph of u of t minus 3? There is a minus sign. Minus sign means I will be shifting it towards the positive axis, right? Or you can say I will be shifting towards the right hand side. Right, left are very confusing actually. We usually call it right shift, left shift, but just remember in your mind that plus means towards the negative hand side, and minus means towards the positive hand side. So u of t minus 3. Then time domain is multiplied with 2. So it will be divided by 2. Time domain is multiplied with 2. So on the time axis, it will be divided by 2. Very simple thing. Say yes or no. Now let's make it in a good manner, because this is the final graph. So this is the actual graph, but it was a time taking process. Although in the examination within 2 to 10 seconds you will be able to do it, or directly from here also you will be able to make it. That's how 2 goes outward, t minus 3 by 2, then this will be the graph. Say yes or no. Agreeing to this point? And don't feel like that, sir, how you will be remembering it. You will be remembering it, no doubt about that. Ij x tan t u of minus 2t minus 3, right? So what you can take common? You can take only 2 common. So what you will be getting? U of minus t minus 3 by 2, right? You will be taking 2 common, u of minus t minus 3 by 2. So can you draw the graph now? U of minus t minus 3, u of minus t minus 3 by 2. Or you can draw from here as well. So let's just start from here. I will draw the graph looking at this particular expression. So from where I need to start? From here I need to start. So what will be the first step? U of t. Then what will be the next step? U of t minus 3. Then what will be the next step? It is multiplied with 2. So 2t minus 3. And what will be the next step? The time domain will be mirror imaged, right? Or you can say multiply with minus 2. So let's get started. What will be your u of t? This will be your of u. This will be your u of t. This is your t equals to 0. What will be your u of t minus 3? Minus sign. That means shifted towards the positive hand side. Shifted towards positive side here. So this is your u of t minus 3. What is the next step? Time domain is multiplied with 2. So here it will be divided by 2. And what is the final step? Final step means mirror image. So this 3 by 2 will become minus 3 by 2. Say yes or no? Mirror image. Basically, if I show this diagram, how this diagram will be looking like? This is how it will be looking like, right? U of 2t minus 3 you have already drawn. So now u of minus 2t minus 3, that means you just need to take the mirror image. So I will just take the mirror image. So this plus 3 by 2 will become minus 3 by 2. Mirror image about y axis. So this is how it will be looking like. Say yes or no. So this is minus 3 by 2. This is 1. Say yes or no. Or what could be the other way? U of minus t minus 3 by 2. So you can draw it in this manner as well. How will you draw it? Again start from here. U of minus t minus 3 by 2. So if I take this into action. So first what I need to do? I have u of t. Then I need to draw u of t minus 3 by 2. Then I need to draw u of minus t minus 3 by 2. Say yes or no. Starting with u of t. Then u of t minus 3 by 2. What will be u of t minus 3 by 2? T minus 3 by 2. That means it will be shifted here. This is u of t minus 3 by 2. Right? What will be the next step? Next step is time is multiplied with minus 1. Only the time domain is multiplied with minus 1. That means you need to take the mirror image. So if I take the mirror image, what I will be getting? This only I will be getting. If I take the mirror image of this guy, mirror image of this guy, only the same thing I will be getting. So n number of ways are there, multiple ways are there. Only you need to remember one thing, that sir, I will be starting with the right hand side. So from here I will be starting u of t, I am having t minus 3, that means go ahead. Or you can see I need to shift towards the positive hand side. If I am shifting towards the positive hand side, then after that time domain is multiplied with 2, that means it will be divided by 2 on the time axis. So divided by 2, and then negative sign is there, that means you need to take the mirror image. So taken the mirror image, there you go. So this was your x tan t. Okay. JK. ABCD में गड़बड़ हो गई है यहाँ पे. I forgot the H. My own name Himanshu has been forgot. मेरे साथ ऐसा ही होता है, फिर भूल जाते हैं लोग. Okay, you try this one. U of t by 2 plus 3. U of t by 2 plus 3. बोलता कोई नहीं है वैसे, याद रहता हूँ सबको. So u of t plus 3 and then in the time domain you need to divide by 2, right? So this was only, no, t by 2 plus 3. Yeah, okay, fine. So u of t I already have, or you can define the function as well. Basically you can define the function as well, no? That how it will be defined, that it will be 1 for whatever that is written inside t by 2 plus 3 is greater than 0, or what you can say that t is greater than minus 6. So you can define in this manner as well, that if t is greater than minus 6, then it will be 1, otherwise it will be 0, right? So in that manner you can also draw from here what you are getting to know, that how the graph will look like. If t is greater than minus 6, sorry, it is minus 6. If t is greater than minus 6, then it is 1, otherwise it is 0. So u of t I already know. U of t plus 3, u of t plus 3. What is the meaning of u of t plus 3? Here it was t equals to 0. So breakpoint will be shifted backward, right? T plus 3. That means it will be moving towards the negative side, or towards the left hand side, you can say. Left, right, it will be confusing. So just remember plus 3. Okay, plus sign is there. That means I will be not be moving towards positive side. I will be moving towards the negative side. So u of t minus 3. Sorry, u of t plus 3. Now what is happening? You are multiplying the time domain with 1 by 2. That means on time axis, it will be multiplied with 2. You can say that I am dividing my time domain with 2. I am dividing my time domain with 2. So on the axis, it will be multiplied with 2. Here what was happening? Here it was being multiplied with 2. So here it was divided. Now it is divided by 2. So now it will be multiplied. Right? So now what will happen? What will be the final diagram? The final diagram will look something like this. Now this minus 3 will be multiplied with 2. So it will become minus 6. So for greater than minus 6, it is 1. Otherwise, it is 0. So this is your x11t. L. U of minus t by 4 minus 3. U of minus t by 4 minus 3. So first way you can define it in this manner. Okay, you can define it on your own and you can draw the graph. What is the other way? Other way, get started with u of t. What is the next step? U of t minus 3. What is the next step? U of t by 4 minus 3. And what is the final step? U of minus t by 4 minus 3. So what is u of t? This is your u of t. What is your u of t minus 3? Minus sign, that means I will be shifting towards positive hand side. T by 4. T by 4. That means it will be multiplied with 4. Divided by 4. Here time domain is divided by 4. So it will be multiplied with 4. So what it will become? T equals to 12. Now what is there? Negative sign is there. Time domain is multiplied with negative sign. That means what you need to do? You need to take the mirror image. So I am taking the mirror image now. This is how my graph will look like. The plus 12 will become minus 12. Right? Whatever that was on positive hand side, that will become like on the negative hand side. Say yes or no. Well and good. Or you can define it as well. How I will define it? That it will be 1 if your minus t by 4 minus 3 is greater than 0. Or you can say if t is less than minus 12. T less than, you can solve the inequality. Very simple. Or otherwise it will be 0. Or you can say if t is greater than minus 12, it will be 0. So this is how I can define it. Well and good. I guess now we are left with the final one. That is u of t by 3 plus 4. I don't know why did I write it down. You can do it on your own, right? U of t by 3 plus 4. How will the graph look like? U of t by 3 plus 4. Ut. Sorry. First you need to draw ut. Then u of t plus 4. Plus 4 means I will be shifting here. So here it will be minus 4. Right? U of t plus 4. I will be shifting towards the negative hand side. Now divided by 3, that means into multiply with 3. Right? And what could be the other way? Let's solve it using the other way. Let's solve it using the other way. That is by taking the common. My function is u of t by 3 plus 4. So what common I can take? 1 by 3 common I can take, right? So it will be t plus 12. Say yes or no. And now this can eat up any constant value. So u of t plus 12. And what is the meaning of u of t plus 12? That means it will be starting from minus 12, right? Now one habit you would have certainly built up, that if u is written, if a step signal is there and I ask you draw the graph of u of t plus 3 by 2. So what you will see that, sir, when this becomes 0, t plus 3 by 2, it is becoming at minus 3 by 2. This is becoming 0 at t equals to minus 3 by 2. So that means before minus 3 by 2 it will be 0, after that it will be 1. So this is how you can keep in mind. Say yes or no. Okay, so, surely we will write down these conclusion as well, but later on. But as of now, you must have seen everything. As of now, you must have understood everything what we are doing in these kind of graphs. Say yes or no. So we have built up a process that how to draw the graph, and these process will be applicable for any kind of graph. Let's just say this kind of graph is given, xt is given, you need to draw. First question is you need to draw x of 3t. And second you need to draw x of minus 2t plus 1. So it will be applicable everywhere. But can you do this thing that, sir, I can take or this x can eat up this 3? No, this is only applicable for ut, that u of 3t will be equals to u of t. But you cannot say that x of 3t will be equals to x of t. Say yes or no. This is not equal. This was only the property of a unit step signal. This was only the property of u. U can eat up 3. But a random x cannot eat up 3. So what is the way? From x of t, you are going towards x of 3t. So what you will do? Divide the time axis by 3. Say yes or no. Divide the time axis by 3. So this will be the graph of x of 3t. Say yes or no. Right? So what I am gonna do? I am gonna just copy this particular diagram. यार नहीं होगा ये सही से कॉपी यार. क्या हो गया ये? Wait a second, guys. What was there? I guess this triangular structure was there, right? This was the diagram. Okay, so let's draw it again because we are left with no other option. So just the thing is, what will be the different part? The different part would be that in x of 3t everything will be divided by 3. 0 divided by 3 will be 0 only, no? 1 divided by 3, 2 divided by 3, and then 3 divided by 3 will be 1. So before this everything is 0. By 3. There you go. Right. Now next you need to draw x of minus 2t plus 1. X of minus 2t plus 1. So from where I need to start? From here I need to start. So from x of t, what will be the first target? X of t plus 1. Then x of 2t plus 1. And then the mirror image. Say yes or no. So one by one I will have to draw everything. But from here to here I can directly go, no? What I will do, first I am drawing x of t plus 1, x of t plus 1. So can I draw x of t plus 1? Yes. What will happen here? X of t plus 1. Plus 1 means everything will be shifted towards the negative hand side. That means everything will be shifted towards the left hand side. Right? So this was the waveform. There is a box kind of structure. Box kind of structure. Then there is 0 and then there is triangular kind of structure. So everything will be shifted by 1. So this 1 will be coming here. This 0 will be coming to minus 1 and this minus 2 will be coming to minus 3. So now this box will be between minus 3 to minus 2. Say yes or no? The 0 was there between minus 1 to 0, but now this 0 will be there between minus 2 to minus 1. This triangular structure was there between 0 to 1, but now this will be between minus 1 to 0. Right? Then after that again there was 0 between 1 to 2, but now this 0 will be there between 0 to 1. And then between 2 to 3 there was a box. Now between 1 to 2 there will be a box. Say yes or no? Everything is 0 here. Right? So this will be the structure of x of t plus 1. X of t plus 1. Now from here I need to make x of 2t plus 1. That means this time domain, this time axis should be divided by 2. This should be divided by 2. Say yes or no? If I need to make it x of 2t plus 1. Time domain is multiplied with 2. That means time axis should be divided by 2. So this will be my 2t plus 1. So what I can write down 2 by 2. That would be 1 minus 1 by 2 minus 2 by 2. This will also be just a second guys. So this will also be 1 only. Yeah. So next thing, minus sign is there. That means everything will be inverted. So everything will be inverted. So now inversion, basically this plus 1 by 2 will become minus 1 by 2, minus plus 1 will become minus 1. So here this plus 1 by 2 is becoming minus 1 by 2. Plus 1 is becoming minus 1. So between 1 by 2 to 1 there was a box. So here there will be a box. After 1 everything was 0. So now after minus 1 everything will be 0. Between 0 to 1 by 2 there was a box. So now between 0 to minus 1 by 2 there will be, now sorry, between 0 to 1 by 2 there was blank. So now this will be blank. So just mirror image I am taking. This was between 0 to 1 by 2, 0 to minus 1 by 2. So now it will become minus 1 by 2 will become plus 1 by 2. So between 0 to 1 by 2 this will be the same. Then between minus 1 by 2 to minus 1 it was all blank. So now between 1 by 2 to 1 it will be all blank. From 1 minus 1 to 3 by 2. So this minus 1 will become plus 1, minus 3 by 2 will become plus 3 by 2. So between 1 to 3 by 2 there will be this box. And then everything is 0. There you go. Okay. So this will be the final graph of x of minus 2t plus 1. Say yes or no. Right. Okay. Well and good. So this is how we can do it. Let's see the next one. Okay. X of minus 2t minus 1. So what will be the procedure? You can do it on your own. The diagram is very complex. It will take a lot of time to make me to draw the diagram again and again. So first thing is x of t. Next what you are going to do? Need to start from here. X of t minus 1. Then x of 2t minus 1. And then the negative sign. Say yes or no. Right? X of t minus 1. Then time domain is multiplied with 2 and then there is a mirror image. So start doing t minus 1. What is the meaning of minus 1? Meaning of minus 1 is that it will be shifted towards right hand side. Minus 1 means it will be shifted towards right hand side. So minus 1 will be going towards 0 actually. This minus 2 will be going towards minus 1. Minus 2 will be going towards minus 1. minus 2 will be going towards minus 1, and minus 1 will be going towards 0. So this will be the scene, right? Now this minus 1 will be going to 0, and this 0 will be going to plus 1. So now there is a triangle. Then at 0, whatever that was happening, that will be happening at 1. So basically the waveform is shifted, nothing else. Waveform is being shifted, so you can shift the waveform very easily. But I will have to draw the diagram again. So this is your x of t minus 1. Minus 1, 0, 1, 2, 3, 4, and 5. Now what will be x of 2t minus 1? 2t minus 1. Basically here time domain is multiplied with 2. बहुत लैग कर रहा है यार स्क्रीन. Yeah, hi guys, welcome back. Actually, sorry for the interruption. In between, the screen went off. Okay, so I had to rewrite all these things. So yeah, sorry for that interruption. So what we were doing, we were drawing this particular waveform. So we have drawn x of t minus 1 because from where I need to start. Here I need to start. So x of t, then x of t minus 1, then I need to do x of 2t minus 1. So the time domain is multiplied with 2. Time domain is, if the time domain is multiplied with 2, that means time axis will be divided by 2. Time axis will be divided by 2, right? So this time axis 2 by 2 will be 1, 4 by 2 will be 2, this will be 1, and this will be 2. This is 2t minus 1. Now what is the next step? Next step is the negative sign. That means now it will be inverted. So this thing will come here and this thing will go there. So now I need to make the inverted waveform. So basically this waveform, the thing is plus 1 by 2 will become minus 1 by 2, plus 1 will become minus 1. So here it will go from 0 to minus 5 by 2. From 0 to 0 to, then here minus 1 by 2, minus 1, minus 3 by 2, minus 2, and minus 5 by 2. And here it will go 1 by 2 only, right? So opposite waveform I just need to draw. Then between 1 by 2, minus 1 by 2 to 1, it will be a simple line just like this, and then this kind of increasing waveform. Then at 2 it is getting over, right? At 2 what is happening? Okay. From 1 to 3 by 2 only. Sorry. 1 to 3 by 2. Okay, so this went wrong. This is actually minus 1, this is minus 3 by 2. And from 1 to 3 by 2 only, and then it is coming down at 3 by 2. Coming down at 3 by 2. Then till 2. And after that, this kind of waveform is there. Just I am doing nothing, I am just doing the inversion, nothing else, right? This waveform has come the other side. Yeah, so nothing will change, just other side waveform we will get. And here there you go. So this will be the waveform of x of minus 2t minus 1. Very simple. Say yes or no, right? Okay, so it was very simple. So this is how we need to draw any kind of waveform. Xt is given, we can draw any kind of waveform. Now you just answer these things. So how I can reduce it? I know that 2 will be coming common. U of 2 will be coming common. T plus 3 by 2. and this u can this eat up this 2. So what we will be left with? T plus 3 by 2. Here also 2 will be coming common. So what we will be left with? T minus 3 by 2. Here also only 2 will be coming common, right? Minus sign cannot come. Minus sign cannot come common. So how will you remember these things? So only you will remember this thing that, sir, these two are not equal. One is ut like this, u of minus t is like this. Both are not equal. So there is an importance of minus sign. And what next you will remember that, sir, u of t would be equals to u of 2t. So u of t waveform will be like this only, u of 2t waveform will be like this only. Both are same. That means you can eat up any constant value. So these two things you need to keep in mind. That's it. And you will be able to answer all these kind of problems. Okay, these will be used somewhere. Where it will be used in the further lecture, you will realize it. So that's why we are focusing more on this. Somewhere I will be using it. Okay, here 2 will be coming common only, and here also 3 will be coming common only. Minus sign will be there as it is. So minus sign I cannot take common. I can take common, but nothing will happen to minus sign because minus sign will remain there as it is. Okay. So these lectures are very simple only. So if we revise what all things we are doing, we are just making the waveform, that how these waveforms should be going. First we studied about the step function, then we saw the waveform, and then we learned that how to draw any kind of waveform from x of t to any these kind of waveform, how to draw it. So always start from the left, and minus sign is there, that means I will be shifting towards the positive hand side. If a plus sign is there, I will be shifting towards the negative hand side. Then scaling in time domain is being multiplied. So here time axis will be divided. Negative sign is there, that means inversion you need to take, or mirror image you need to take about y axis. There you go. So these kind of things we have seen, and also here we have seen that in u only, when there is u, we can take any constant value common, and this is how it will be reduced. You can make this waveform as well, you can make this waveform as well. Both waveforms will be same only. Well and good. Okay. So you draw these waveforms. What is the next question? The question is you need to draw these waveform ut, u of minus t, u of minus t plus 2, u of minus t minus 2, u of t minus 2, u of t plus 2. So quickly you can draw everything, right? So on this side I am drawing only the plus one, like I am drawing u of t. This is my u of t. This is u of t. U of t minus 2. So you can draw u of t minus 2, just it will be shifted ahead by 2. This is your u of t minus 2. Then u of t plus 2, u of t plus 2. So it will be shifted backward, right? Backward by 2. Why we are doing so, you will realize it. Some conclusion I need to make. Now u of minus t. So u of minus t, simply the mirror image of this one, u of minus t. Now u of minus t plus 2. So you can draw it from u of t. First you will draw u of t plus 2, right? And then you will take the inversion. So you can draw it on your own. This kind of waveform you will get, u of minus t plus 2. And then there is u of minus t minus 2. So this kind of waveform we will get. You can draw it on your own. You need to start from u of t only. So if you need to draw this one, what you will do? From u of t to u of t minus 2, and then u of minus t minus 2, right? So in that manner you need to draw. You will be able to draw it. No need to worry about that. But we are going to make some interesting conclusion out of it. That's the thing. So this was your u of minus t plus 2, u of minus t minus 2, right? So now what you can see, wherever there is plus t, here u of plus t minus 1 plus t plus 2, right? So here you are getting plus t, and in all these waveform you are getting minus t plus 0, minus t plus 2, minus t minus 2. So there is minus here, minus t here. So for all these waveform where you are getting plus t, the function is looking towards the right hand side. This is looking towards the right hand side. Say yes or no. It is looking towards the right hand side. Looking towards the right hand side means for left hand side it is 0, and finally it is going to 1 towards the right hand side. Say yes or no. And whenever there is minus t, it is looking towards the left hand side. Whenever there is minus t, it is looking towards the left hand side. Plus t looking towards the right hand side, minus t looking towards the left hand side. Say yes or no. And where is the breakpoint? What do I mean by breakpoint? This is the breakpoint. This is the breakpoint. This is also a breakpoint. These are the breakpoint. So where is the breakpoint? The breakpoint is there when the inside thing becomes 0. When minus t t minus 2 becomes 0. What you are getting? T equals to minus 2. So breakpoint is at minus 2. So if I randomly ask you that what will be the waveform of u of minus 2t plus 3. So do you need to think too much? What you will think? Okay, sir, there is minus t there, minus t is there. In place of u, there is minus t there. Minus t means it will be looking towards the left hand side. Now, where will be the breakpoint? Breakpoint will be at 3 by 2. Because if this goes 0, that means breakpoint will be at 3 by 2. So this kind of waveform I will be getting. There you go. So very quickly you can draw the waveform of step signals. What you need to think? Only two things you will be keeping in mind. U of t or u of minus t. If there is minus t, minus t, looking towards the left hand side. And then there is a breakpoint. And breakpoint, how will you get to know? Breakpoint you will get to know by taking inside thing equals to 0. There you go. So this is the first conclusion that we are making from here. Now the second conclusion. This is very, very important and very interesting as well. Let's make u of minus t plus 2. We need to draw u of minus t plus 2. So how do I draw it? I told you that u of t, then u of t plus 2, always start from here, and then u of minus t plus 2. But what if I would have done something like this? That I started from here. U of minus t, I am starting from u of minus t. That is wrong, right? You cannot start from u of minus t. I told you, you need to start from left hand side. So if I am starting from u of minus t, so that is wrong. So this is the first mistake I am doing, that I am starting from u of minus t. So this is the first mistake I have done. Now the next mistake what I will do? Plus 2. What is the meaning of plus 2? Plus 2 means you should shift towards the negative hand side, right? Plus 2, here it was plus 2. That means you are shifting towards the negative hand side. If it was minus 2, that means you are shifting towards the positive hand side. So this is the first mistake I have done. Now another mistake I will do, that is I will be shifting towards the right hand side because of the plus sign. So what I am gonna do, I am shifting towards the right hand side. So what I am getting? Yes, the same waveform I am getting. Basically, mistake to mistake got cancelled out. What was the first mistake? That you are starting from here. You are starting from u of minus t. So that was the first mistake, that I started from u of minus t. What is the other mistake? Ideally, you should have shifted for plus 2, you should have shifted towards the left hand side, but you are shifting towards the right hand side. So you are getting the correct waveform. So mistake to mistake got cancelled. This is just a trick. Okay, two mistakes we are going to do. Let me write it on the next page. Okay, two mistakes we are going to do. U of t, u of minus t. Sorry, u of minus t plus 2. First I will draw the waveform of u of minus t, and the another mistake I am gonna do. So I need to draw this waveform u of minus t plus 2. So what I am gonna do? First I will draw u of minus t. So first mistake is this, that you are starting from the left hand side. So this is the first mistake. Then what is the other mistake? Other mistake, that for plus sign, you expect that it should be shifted towards left hand side, but now you will be shifting it towards right hand side. So you are getting the correct waveform actually. So in the examination, you don't need to think, okay, let's just say if x of t is given and you need to draw x of minus t plus 2. So either you can start from here, but if you have the good enough concentration, so what you will do, x of minus t and then plus 2. So I will take the mirror image and then shift. Mirror image and then shift. Are you getting this point? We will solve this kind of problem. Let's just say I need to draw u of minus t minus 2. So what I'm gonna do? Sir, first mirror image u of t is like this. Then mirror image, sir, u of minus t, and then sir minus sign is there. That means I should be shifting towards positive hand side, but I will be shifting towards left hand side. There you go. So sir, I know that u of t will be somewhat like this, but I need to make u of minus t, so it will be somewhat like this. Since minus sign is there, so I'll be shifting here, u of minus t minus 2. Or what could be the other way of thinking it? That's why u of minus t minus 2. That means at t equals to minus 2, I will be having my breakpoint. And since there is minus t there, that means it will be looking towards left hand side. There you go. So in 2 minutes, you can make the waveform. So in the examination, if xt is given and they ask you to draw the waveform x of minus t plus 2 and x of minus t minus 2. There are two ways. You can start from here. This thing you can do. Or what is the other way? You start from the beginning. What is the one thing you notice there? That there is no scaling in the time domain. So this trick will not work if there is a scaling in time domain. If there is some scaling in the time domain, then I would recommend you start from the left hand side only. Okay, if there is scaling in the time domain. But if there is no scaling in the time domain, x of minus t plus 2, x of minus t minus 2, x of minus t plus 10, if these kind of waveforms are given, then what you can do, First, you start from here. This is the first mistake we are doing, and another mistake we will do. So x of minus t plus 2. So what kind of waveform you will get? X of minus t plus 2. First, I need to take the mirror image. What will be the mirror image? This plus 3 will come to minus 3, and plus 5 will come to minus 5, and in between there will be a box. Rest all will be 0. Now there is x of minus t plus 2. Plus 2 means I should be shifting towards left hand side, but I need to do the mistake. So I will be shifting towards the right hand side. So minus 3 will be shifted with plus 2. This will also be shifted with plus 2. So this will become minus 3. This will become minus 1. So there will be a box between minus 3 to minus 1. Say yes or no. So this is just a quicker way of doing the things. Okay, nothing else. Just a quicker way. Otherwise, you can remember that formula as well, that I will be starting from the right hand side and I will be doing my analysis. Or this is just a quicker way, because if you have enough practice, these kind of quick way will help you in the examination. Right? If you have these kind of practice, then in the examination you will be solving the problems in a quick manner. Okay, so that's why I am teaching all these things. Now x of minus t minus 2. So same thing I will do, x of minus t. Now minus 2. That means it will be going ahead. So plus 3 will become minus 3, plus 5 will become minus 5, and then minus 2. Then minus 2. So between minus 5 to minus 7, there will be a box. Right? So between minus 5 to minus 7, there will be a box. So this is nothing but simply a trick to solve the problem in a quick manner, nothing else. Otherwise, the method that I told you, that you get started from the left hand side, sorry, right hand side only, that you can do. But if you are starting from the left hand side, then also you can make the waveform. But you need to keep these kind of things in the mind. When you have the enough practice, you will be able to understand all these kind of things. Okay. So minus 7 to minus 5. In between there is 1. Well and good. Okay, then let's move to the next one. Now what we need to study? We need to study adding the step signals. I need to add u of t plus u of t minus 2 plus u of t plus 3 minus u of t minus 4 minus u of t minus 2. So this is the first example, then I will take this example. So here all these are positive sign, no? U of t is positive, u of t is positive, u of t is positive, here also t is positive. This doesn't matter. This is a negative amplitude. I am talking about only t. Let's just say I ask you to draw the waveform of u of t minus 4. So you know that, sir, breakpoint will be at 4, and since it is u of t, that means it will be looking towards the right hand side. So sir, this will be u of t minus 4. But if I say there is a negative sign, so what will happen? It will again be looking at the right hand side only, but this positive amplitude will become negative amplitude. That's it. Right? This amplitude will become minus 1. So the things remain same. But if it is minus t, then it will be looking towards the opposite side. U of minus t minus 4. So now it will be looking towards the opposite side. Now the waveform will be different. But in the first example, we are having all the waveforms which are looking towards the right hand side only. So let's get started. We need to draw u of t first, then u of t minus 2. So this will be my u of t. U of t. Then u of t minus 2. U of t minus 2. Then u of t plus 3. T plus 3. Plus 3 means it will be starting from here, because breakpoint will be at minus 3. U of t plus 3. Then u of t minus 4, but there is a negative sign. So t minus 4, that means there is a negative sign here, no? So amplitude will be minus 1 now. Amplitude will be minus 1. 4, it was minus 3, it was 2. And the next one is t plus 2. T plus 2. So it will be looking towards the right hand side only, but there is a negative sign. So breakpoint will be at minus 2. Breakpoint will be at minus 2. And there you go. Now I need to add all these functions. What I need to do? I need to add all these functions. So what will be my final answer if I need to add all of them? इस पेज में आ तो जाएगा क्या सब? So what do you think, from where I should start adding? I will be adding from minus infinity. Why is that so? I will be starting my journey from the minus infinity. Because if I start from plus infinity, so at plus infinity, this will also be there, no? Because this waveform is going till infinity. Say yes or no? This is also going till infinity. This is also going till infinity. This is also going till infinity. So at infinity, everything is existing. This also exists, this also exists, this also exists, this also exists, and this also exists. But at minus infinity, this also does not exist, this also doesn't exist, this also doesn't exist, this also doesn't exist, and this also doesn't exist. Which waveform will start existing for the first time? This waveform. Say yes or no? Because at minus 3 you will get that there will be first jump. Before minus 3 everything is 0. So let's just say this point is minus 3. So before minus 3 everything is 0, right? Before minus 3 everything is 0. At minus 3 you see that there is only 1. This guy is also 0, this guy is 0, this guy is 0, this guy is 0, this guy is 0. Between minus 3 to minus 2 everything is 0, only this guy is 1. So between minus 3 to minus 2 you are getting 1. Say yes or no? I will certainly tell you a method, but first first understand what is actually happening here. But there is a method as well, that this is how you can draw it very quickly in the examination. Now between minus 2 to minus 1, between minus 2 to minus 1, because why I should look at minus 1? I will look at 0 only. Why I am looking at 0? Because at minus 1 there is no breakpoint. At minus 1 this graph is not changing, this graph is also not changing, this graph is also not changing, this graph is also not changing, and this graph is also not changing. The graph is changing at minus 2 and then at 0. So I will look between minus 2 to 0. So between minus 2 to 0, this guy is 0. Between minus 2 to 0, this guy is also 0. Both are 0. Between minus 2 to 0, this guy is 1. Between minus 2 to 0, this guy is also 0. Now between minus 2 to 0, this guy is minus 1. So 0 plus 0 plus 0 minus 1 plus 1, what it will be? 0 only. So between minus 2 to 0, everything will be 0. Why I am getting 0? Because 0 plus 0 plus 1 plus 0 minus 1. So every answer will be 0 only. Now let's talk about, what I will talk about, between 0 to 1 or 0 to 2. I will be talking about between 0 to 2. Why is that so? Because breakpoint is at 2. Here breakpoint was at minus 3. Here the breakpoint is at plus 4, and here the breakpoint was at minus 2. So I am talking at minus 3, minus 2, then breakpoint is at 0, then next breakpoint will be at 2, and next breakpoint will be at 4. So only these points I will be talking about. So now between 0 to 2, this guy is 1, this guy is 0. Between 0 to 2, this guy is 1, 0, this guy is again 1, this guy is 0, and this guy is minus 1. So 1 plus 0 plus 1, 0 minus 1. What it would be? Plus 1 only. 2 minus 1 would be plus 1. So between 0 to 2, it will be plus 1. Now between 2 to 4, let's see between 2 to 4. Plus 1, plus 1, plus 1, 3, 0, and then minus 1. So it would be 2. So between 2 to 4, it would be 2. Right? Between 2 to 4, it would be 2. And after 4, there is no breakpoint. So after 4, this is 1, this is 1, this is 1. 3, minus 1, minus 1. So 1 plus 1 plus 1, minus 1, minus 1. What I will be getting? 2. So this is the addition. But in the examination, certainly we are not going to follow this process. But you are understanding something, that how this process is followed. Right? So we will make conclusion out of it. That's why I did all these kind of waveforms. Okay, so let's write down the conclusion. Do I have the page? Yes. So now I will again write down the problem. What was the x of t? That was, better writing it down, I can just copy it, no? So what will be the first step I will be noticing in the examination? First step I will be noticing in the examination is that everything is plus t. Plus t means all the waveforms will be looking towards the right hand side. All the waveforms will be looking towards the right hand side. So that means I need to start from minus infinity. Say yes or no? Because at minus infinity, everything is 0. All these waveforms are 0 at minus infinity. If all these are 0 at minus infinity, so now I need to look at the breakpoints. This guy will be having its breakpoint at 0, this at 2, this at minus 3, this at plus 4, and this at minus 2. Now I need to see, I will be starting my journey from minus infinity. So where the first breakpoint will come? The first breakpoint will come at minus 3. So now I will write down my xt in this manner that my breakpoint should be in the increasing order. That my first breakpoint will be coming at minus 3, right? The next breakpoint will be coming at minus 2. Next breakpoint will be coming at 0. Next breakpoint will be coming at 2. And the final breakpoint will be coming at 4. So this is how I will adjust my input. Why I have adjusted the input in this manner? Because I know that my journey will be starting from minus infinity. Why it will be starting from minus infinity? Because it is plus t. What is the meaning of plus t? Plus t means at minus infinity everything will be 0. At minus infinity everything will be 0. So 0 plus 0 plus 0 plus 0 0 everything will be 0 only. So now I am starting my journey. I am going on this waveform from minus infinity. I know that everything is 0 0 0 only. First breakpoint I get at minus 3. So now my target is to get my breakpoints in the increasing order. So from minus 3, minus 2, 0, plus 2 and minus 4. Now I can draw my waveform. How I will draw the waveform? How I will draw the waveform? So I know that my first breakpoint is at minus 3. So I know before minus 3 everything will be 0. Everything will be 0. Before minus 3 everything is 0. Then I know that at minus 3 what I will get? Suddenly I will get plus 1. Because it is plus 1 here, no? Amplitude is plus 1. So at minus 3 suddenly I will get plus 1. So suddenly I have got plus 1. There you go. At minus 3 suddenly I have got plus 1. There is a jump of plus 1. At minus 2 what happened? Already I was having plus 1. But at minus 2 I got minus 1. Already I was having plus 1. At minus 2 I got minus 1. That means plus 1 was already there. Now minus 1 will also be added. That means it will make it 0. So at minus 2 I will be getting 0. Now next jump will be at 0. Next jump will be at 0. So at 0 I am getting that again I am getting plus 1. Again I am getting plus 1. I was already having plus 1 and minus 1. Plus 1 and minus 1 equivalently was 0. Now what I am having? Plus 1, minus 1 and plus 1. So again it will be 1. Now where is my next breakpoint? My next breakpoint is at 2. And at 2 what I am getting? Again I am getting plus 1. So at 2 again I am getting plus 1. Already I was having plus 1. Already I was having plus 1 because plus 1 minus 1 plus 1 that was 1 only. So already I was having plus 1. Here again I am getting plus 1. So again it will be, again there will be a jump. So I will be reaching at 2. Where will be my next breakpoint? My next breakpoint will be at 4. So at 4 what we are getting? Minus 1. So already I was having plus 2. Now minus 1 is also added. So what I will be left with? Plus 1. Because plus 2 minus 1 will be 1 only. So are you getting this point? I just need to see the jump. Started from here, jump of plus 1, then jump of minus 1. Jump of minus 1, or you can say decay of minus 1. So jump of plus 1, then decay of minus 1, then jump of plus 1, then jump of again plus 1, and then decay of minus 1. So this is how you will make the waveform. Within seconds you will be able to make the waveform. You don't need to do this process in the examination. But first we need to study this, then only we will be able to understand that why we are doing so, right? So this was your x1 t. So this is how I will be drawing in the examination. Why I am starting from minus infinity, why all these things are happening, that reasoning is also clear to you. You don't need to mug up anything, right? Now the second one, you need to draw this waveform x of minus t plus 2. Minus t plus 2. Okay. Minus t plus 2. So let's see how minus t plus 2 should look like. What is the meaning of minus t? It will be looking towards minus infinity, right? It will be looking here. So minus t plus 2. Minus t plus 2. What will be the breakpoint? Plus 2 only, right? U of minus t plus 2. So breakpoint will be at 2, and this is how the waveform will be looking like. Minus t plus 2, minus t plus 4, minus t plus 4. What is next? Minus t minus 3, minus t minus 3, minus t minus 3. minus t minus 3. So what will be the breakpoint? Breakpoint will be minus 3. So where it will be looking? It will be looking towards here only. Minus t minus 3. Minus t minus 3. So breakpoint is at minus 3 only. And minus of u of minus t minus 3. Right? So it will be looking towards minus infinity only, and this is how the waveform will go. Minus t minus 3. This was minus 3, this was plus 4, this was plus 2 only. Next is minus t plus 2. Minus t plus 2, but the amplitude is negative. Minus t plus 2. Minus t plus 2. Amplitude is negative. Amplitude is minus 1. Next is u of minus t. Now what do you think, from where I should start adding? Should I start from plus infinity or minus infinity? Because if I start from minus infinity, I know that at minus infinity everything is 1. At minus infinity everything is 1. This is minus 1 actually, but at minus infinity everything exists. Minus 1, this was minus 1, this is also minus 1. So I cannot start from minus infinity. So from where I will start? I will start from plus infinity, because at plus infinity what do you see? Everything is 0. And where will be your first breakpoint? Your first breakpoint will be at 4. Say yes or no. So in that manner I need to add it up. So same thing we are doing. Why I took two different examples? The reason was, if I take two different examples, then I will get to know how I will start from plus infinity, or whether I should start from plus infinity or from minus infinity. So here I got to know that I should start from here, because before 4, or you can say after 4, everything is 0. After 4, everything is 0. Now what is the next breakpoint? Next breakpoint is at 2. Next breakpoint is at 2. Wait a second, did I do something wrong here? Minus t plus 2, minus t plus 2. Okay. Okay. Minus t plus 2. So next breakpoint is at 2. So between 2 to 4, this is 1, all are 0. Between 2 to 4, this is 1, all are 0. So between 2 to 4, you are getting 1. Now the next breakpoint is at 2. And after that, the breakpoint is at 0. Now between 2 to 0, this guy is 1, this guy is 1, this guy is 0, this guy is minus 1, and this guy is 0. 1 plus 1 minus 1. What you will be left with? 1 only. Are you getting this point? This guy is plus 1, this guy is plus 1. What you are getting? Plus 2. But this guy is minus 1, no? Between minus 2 to 0. So plus 2 minus 1 will be 1 only. Right? Now between 0 to, where is the next breakpoint? The next breakpoint is at minus 3. Right? Yeah, the next breakpoint is at minus 3. So between 0 to minus 3, this guy is 1, this guy is 1, this guy is 0, this guy is minus 1, and this guy is minus 1. So 2 plus 0, 2, minus 1, minus 1. So 2 minus 2 will be 0. So between 0 to minus 3, everything is 0. Now after minus 3, this guy is 1. After minus 3, because after minus 3 there is no breakpoint. So this guy is 1, 1, minus 1, minus 1, 0, and this will be totally minus 1. So this is how the waveform will look like. You just need to add them up. If I am adding them up, this is what I am getting to know. 2 minus 1 will be plus 1, plus 1 minus 1 will be 0, and this is minus 1. So yeah, this is the waveform. This is your x2t. Plus 1, minus 1. Are you understanding this point? So this is what is happening. And how will you do it quickly in the examination? So that certainly I am going to tell. And you can also think of it. Because in the examination, first thing what you are going to see, the first thing I am going to see is that, sir, everything is minus t. That means all the waveforms will be existing at minus infinity. All the waveform will be looking towards the left hand side. All the waveforms will be looking towards the left hand side. And if all of them are looking towards the left hand side, what does that mean? That I should start my journey from plus infinity, not from minus infinity. So here I can see that everything is minus t. If everything is minus t, what does that mean? If everything is minus t, that means that all will be looking towards minus infinity, or you can say at plus infinity everything will be 0. If it is minus t, that means at plus infinity everything will be 0. Then I need to see the breakpoint. Breakpoint at 2, breakpoint at 4, breakpoint at minus 3, breakpoint at 2, breakpoint at 0. So how I should adjust my breakpoint? Should I go from in the increasing order or should I go in the decreasing order? I should go in the decreasing order because I know that at plus infinity everything is 0. So if I start from plus infinity, so first breakpoint I will get at plus 4. So I should adjust my breakpoint in a manner that it should be in the decreasing order. So u of minus t plus 4 plus u of minus t plus 2 minus u of minus t minus plus 2. Just 1 second. Yeah, and next one at u of minus t and the next one u of minus t minus 3. So this is how I have adjusted my breakpoints. So breakpoint at 4, breakpoint at 2, breakpoint at 2, breakpoint at 0 and breakpoint at minus 3. So now I need to draw the waveform. So where I will be starting from? I will be starting from plus infinity, right? So this is 4. Next breakpoint is 2. Next breakpoint is 4, 2, 0 and minus 3. Before 4 everything is 0. At 4 what you are getting? Plus 1. At 4 what you are getting? Plus 1. At 2 what you are getting? Here you are getting plus 1. At 2 there are two things. Plus 1 is also there and minus 1 is also there, right? Plus 1 is also there and minus 1 is also there. So at 2 there is no effect. This will be there as it is. Here at 0 what you are getting? Again you are getting minus 1. So already you are having plus 1. So plus 1 minus 1 will be 0. It will be making it 0. And at 3 what you are having? Minus 1. Because already you are having 0, now another minus 1 is there. So this will be the waveform. This will be the final waveform. Okay, so this is how I will be drawing the waveform. So I will see whether all are plus t or whether all are minus t. Here all were plus t and here all were minus t. So then I will be thinking in the examination. But what if in the examination some are plus t and some are minus t? So I will draw this waveform separately. Then I will draw this waveform separately. And then I will add both of them. Are you getting this point? Some are plus t and some are minus t. So first I will draw this waveform. Can I draw this waveform? Yes. Surely I can draw this waveform. Breakpoint I can see. From where I will start my journey? I will start my journey from minus infinity. Why is that so? Because I am drawing plus t. Plus t means plus t. Okay, it will be looking towards the right hand side. That means at minus infinity everything will be 0. So I will be starting my journey from minus infinity. So now I need to say the breakpoints. So breakpoint I will be writing in the increasing order. So all these things you don't need to mug up. When you see the questions, it will be coming into your mind its own, right? It should be coming in your mind on its own. 0, then there is a jump. So this is 0 and jump will be at 1, right? 0 and then there is a, sorry, at u of t you have a jump of 1, right? At u of t you have a jump of 1. Then at u of t minus 1 another jump will be there. So another jump is there, right? 1 plus 1 it will be 2 only. So this waveform I have drawn and another waveform. So here the breakpoint is at 2 and here the breakpoint is at minus 1. So u of minus t, that means it will be looking towards the minus infinity. So at plus infinity everything will be 0. So I will start my journey from plus infinity. If I am starting my journey from plus infinity, so I am coming. So first I will get the maximum value. That means first breakpoint I will get of 2. So I will get the breakpoint of 2. Then I will get the breakpoint of minus 1. So before 2 everything will be 0. Before 2 everything will be 0. Then at 2 I am having a jump of plus 1. At 2 I am having a jump of plus 1. Then at minus 1 I am again having a jump of plus 1, right? At minus 1 again I am having a jump of plus 1. Now I need to add both of the graphs. So can you add both of the graphs? Certainly you can add both of the graphs. This is 1, this is 1. So in both of the graphs you can see the breakpoints are at 0, 1, minus 1 and 2. Say yes or no. 0, 0, 1, minus 1 and 2. So in the final diagram, I will have the breakpoints 0, this is 0, this is 1, this is minus 1 and this is plus 2, and this is the final diagram of x of t. Okay, so now you can start your journey from anywhere, wherever you need to start from, because at minus infinity as well this is existing, at plus infinity as well this is existing. Basically at plus infinity this guy exists, and at minus infinity this guy exists. So from anywhere you can start your journey. So let's start from minus infinity. Okay, so between minus infinity to minus 1, between minus infinity to minus 1, so here everything is 0 between minus infinity to minus 1, and here between minus infinity to minus 1 everything is plus 1. So between minus infinity to minus 1 everything is plus 1. Now between minus 1 to 0 this waveform is 0, between minus 1 to 0, sorry, it is not plus 1, it is plus 2, really sorry, this is actually plus 2, sorry, what I am doing, really sorry for this mistake. Actually 1 plus 1 this will be plus 2, no, there will be a jump of 1, so this is plus 2. So between minus infinity to minus 1 everything is plus 2. Between minus 1 to 0 this guy is 1, this guy is 0, so 1 plus 0 will be 1 only. Between 0 to 1 this guy is 1 and this guy is also 1, so 1 plus 1 will be 2. And between 1 to 2, between 1 to 2 this guy is 1 and this guy is 2, between 1 to 2 this guy is 1 and this guy is 2, so 1 plus 2 will be 3. Now from 2 to infinity, this guy is 2 and this guy is 0, so 2 plus 0 will be 2. There you go, this will be the final waveform. So 2, 1, 2, 3 and 2. Or you can start from minus infinity as well. Between minus infinity to plus 2, minus infinity to plus 2 everything is 2. Between 2 to 0 this guy is 1, between 2 to 1 this guy is 2, so 2 plus 1 3. Between 1 to 0 this guy is 1, between 1 to 0 this guy is 1, 1 plus 1 2. Between 0 to minus 1 this guy is 1 and this guy is 0, so this will be 1. Between minus 1 to infinity this guy is 2, this guy is 0, so it will be plus 2. So very easily you can add them up, right? Say yes or no. Now let's come to another interesting point, that is, if this waveform is given, okay, if this waveform is given, how will you write down, if this waveform is given, how will you write down x1 of t? Basically now waveform is given, now I need to write down x1 of t. So what do you think, how will I write down x1 of t? What do I know? That my complete waveform, this waveform is looking towards plus infinity. Say yes or no. Basically this is looking towards plus infinity, no, because at minus infinity it is 0, at minus infinity it is all 0. So there is very high chance that it would have been made from u of t. Why is that so? Why I am saying that it should have been made from u of t? Because u of t is the function which is 0 at minus infinity. U of t minus 2 you can say, u of t plus 2 you can say, everything will be 0 at minus infinity. And here everything is 0 at minus infinity. What does that mean? That certainly there is very high chance that it would have been made from u of t. And where is the first jump? First jump is at minus 3. That means certainly there would have been u of t plus 3. You just need to see the jump. Where is the breakpoint? Breakpoint is at minus 3. That means now where I am going in this direction. I am working in this direction. So if I am working in this direction, that means I need to write down everything in terms of u of t. U of plus t I am writing down, not u of minus t. Why I am writing everything in terms of u of plus t? Because I am moving towards here. I am moving in this direction, right? So now I will write down everything in terms of u of t. So here there is a jump of 1. So u of t plus 3. What is the breakpoint? Breakpoint is at minus 3. That means it should have been u of t plus 3. There is a jump of 1. Then at minus 2 there is a decrease of 1. Right? There is a decrease of 1. Now at 0 there is a jump of 1. And why I am writing u of t? Because breakpoint is at 0. Now breakpoint is at plus 2 and there is a jump of again 1. So u of t minus 2. Now breakpoint is at plus 4 and there is a decrement of 1. That means minus of u of t minus 4. There you go. This will be your x1t. After that there is no breakpoint, so there will be no expressions. So did you understand this point? The main point was you are starting your journey like this. You are starting your journey from minus infinity. That's why everything is written in terms of u of t only. But my question is this the only expression of x1t possible? Can there be other expression of x1t possible as well? So the answer is yes. Other expressions are also possible. This is not the only expression of x1t. Other expressions are also possible. We will see that in this lecture only. In the upcoming part, we will see that. But the conclusion is this is not the only expression of x1t. Right? Now, let's see this one. So here I am saying that I am starting my journey from here, from minus infinity. So how will I write down my x2t? I am starting my journey from minus infinity. That means I am looking like this. I am looking towards here. I am looking towards here. So what I need to write down? I need to write down u of minus t. So what I am writing down? x2 of t. So where is the first jump? The first jump is at plus 4. So jump of 1 is there. So u of minus t plus 4. So there is a jump of plus 4. Right? Then plus. Then what do you see? There is no jump here. There is no breakpoint here. So these two expressions are actually gone. And you can see that u of minus t plus 2 minus u of t plus 2. It will be 0 only, no? This was redundant. U of minus t plus 2 minus u of minus t plus 2. It will be 0 only. This function and this function is same. There is a negative sign. So it is redundant. It should not come here. Right? So forget about this breakpoint because there is no breakpoint here. Next breakpoint you can see at u of minus t. Why u of minus t? Because my breakpoint is at 0. For this one, where is the breakpoint? At 4. And I am correct. U of minus t, but I should not write plus here. I should write minus because I am getting a decrement. From plus 1 to I am going to 0. So u of minus t. Then where is the next breakpoint? The next breakpoint is at minus 3. So what I will write down? U of minus t minus 3. Will there be plus or minus? There will be minus. Why is that so? Because there is a decrement of minus 1. Say yes or no. And is this the same x to t? Yes. This is the same x to t. Say yes or no. Are you getting this point? Okay. So this is how we can write down. Now again my question is this the only possible expression of x to t? So the answer is no. Answer is absolutely no. Okay. If we talk about this waveform, so will you be able to write down xt? Now you will say that, sir, I am starting my journey from here. You are starting your journey from minus infinity. So do you think there is any breakpoint? At minus infinity itself, it is plus 2, no? Are you getting this point? At minus infinity itself, this waveform is plus 2. And at plus infinity itself, this waveform is also plus 2. So it is finite at both of the end. Are you getting this point or not? What I am saying? Here, this was 0. These waveform were 0 here. So I could have started that my first jump is at 4. Here, my first jump was at minus 3. This was the first jump. Can you say here I have my first jump? No. At minus infinity, if I ask you x of minus infinity, what is your answer? Your answer would be, sir, it is plus 2. And if I ask you what is x of plus infinity, what will be your answer? Sir, it is plus 2. Say yes or no. So how can you define your jump? In this question, if I ask you in this waveform, what is your x of plus infinity? x2 of plus infinity. Sir, you will say it is 0. So now I can define my jump that my first jump will be at plus 4. And I am looking at here, I am starting my journey here. So this is how my first jump would be looking like. But if I ask you, what is your x2 of minus infinity? Then you will say that, sir, it is minus 1. And here also we can do the same thing. So how to write down the expression of these kind of functions? So there could be n number of expression possible. What is the first way I can do? That I will treat this much waveform separately. What I'm gonna do is that, look, let me add a page. I hope I have pages left. So what I need to do, I need to write down the expression of this particular waveform. So this waveform is given in the examination and I need to write down that what is your expression of x1t. So what I'm gonna do, I'm gonna break this waveform into two parts. Which two parts? First part is this. First part is this. That is plus 2 and rest everything is 0 till minus 1. This is the first part. Till minus 1. After that everything is 0. Plus what? Plus this same waveform. plus this did to same waveform, but the other part is gone. Which part is gone? The part of between minus infinity to minus 1. Minus infinity to minus 1, it is plus 2, right? Are you able to understand what I am doing here? If I add these two waveform, will I get the same xt? If I add these two waveform, will I get the same xt? Say yes or no. Yes, I will get the same xt. Between minus infinity to minus 1, it is plus 2. Between minus infinity to minus 1, it is plus 2. After that, minus infinity to 0, it is plus 1, 2, 3, 2. Now, if I add both of them, what do I get? Between minus infinity to minus 1, it is plus 2 and this is 0. So, what I will get? Plus 2. Then, minus 1 to 0, it is plus 1 and then this is plus 1. Sorry, between minus infinity to 0, this is plus 1 and this guy is 0. So, 1 plus 0 will be 1 only. Between 0 to 1, this guy is 2, this guy is 0. So, 2 plus 0 will be 0. Why I am writing 2 here? No 2. 2 plus 0 will be 2. 3 plus 0 will be 3. 2 plus 0 will be 2 only, right? So, I have broken down this waveform into two parts. So, if I have broken down this waveform into two parts, what I can do? What is this waveform? Can you let me know what will be the function of this waveform? This is your u of minus t minus 1 into 2. Say yes or no. 2 into u of minus t minus 1. Say yes or no. Do you agree to this point or not? Certainly you agree, right? Minus t minus 1. That means it will be looking towards minus infinity, right? And amplitude is plus 2. Amplitude is plus 2. And breakpoint is at minus 1. Breakpoint is at minus 1. Plus. Now I can write down this expression. How I can write down this expression? That sir, now I can start my journey from minus infinity. Why I can start my journey from minus infinity? Because in this waveform, everything is 0 now. At minus infinity, everything is 0 in this waveform. So now I can start my journey from minus infinity and my first breakpoint will be at minus 1. So what I will write? 1 u of t plus 1. The first breakpoint is coming at, there is an increase of 1. So first breakpoint is at minus 1. Then another breakpoint is at 0. So what I will write down? Plus u of t. Then again there is a breakpoint plus u of t minus 1. Then again there is a breakpoint. Here there is a decrement. So u of t minus 2. Say yes or no. So this is how I can write down my final expression. Are you getting this point? I just broke it down into two parts. Why I broke down into two parts? Because I know that here also it is going towards minus infinity and here also it is going towards plus infinity. So I cannot write down by any single expression. I cannot write down by any single expression that it should not be, it cannot be completely plus t, it cannot be completely minus t. It will be a mixture of both. So what did I do? I broke it down in this manner that u of minus t minus 1, this is separate and then this is separate waveform. So u of t plus 1, then plus 1 u of, here u of t plus 1, then again there is a jump of 1 plus u of t, then again there is a jump of 1 plus u of t minus 1, then there is a decrement of 1. So minus u of t minus 2. So this is how I am getting. Now you will say that sir, no, this was not your xt, this was your xt. So this is what I said, no, there are multiple ways possible. I broke down this waveform into this. Someone would have broke down this waveform into these two parts. It depends how you are breaking down the waveform. If I have broke down the waveform into these two parts, then this is the answer I am getting. And if I have broke down this waveform into these two parts, then I would have got some different answer. So different answers are possible. This is what I was saying. In these ways as well, there are different answers possible. In these waveform as well, there are different answers possible. We will see that how it is possible you are understanding as well. What I will do, I will break this waveform into two parts. One part will be this and another part will be this. What two part I will break down? One part and the another part. So for this I will write down the separate expression, and for this part now I will start my journey from here, because in this part you can start your journey from anywhere. You can start from here as well, you can start from here as well. We will see these kind of examples, it will be more clear to you. But I hope now you are getting the point that what we are doing, how we are writing down the expression, right? So first make these waveform. What you need to make? U of t plus 3 plus 2 u of t plus 1 minus u of t minus 1 minus 2 u of t minus 4. So think how you will start your journey, how you will make this waveform, then draw the other waveform as well, x to t. I will take a break, you do it on your own and then simply check your answer. Okay. So I will take a break now, you can also take a break if you want to, but make these waveforms. And after that we will see that how to write down xt in terms of step function. This we have already seen, but there could be multiple ways possible. So that possible ways we are going to see. Well and good. So same goes for these waveform as well. In these manner we will see it. Okay, yeah. So I will take a break. This lecture will be of like roughly around, I guess, 3 hours, because this will be a bit longer. But yeah, I don't think you are getting bored. Okay, yeah. Yeah, so let's start. X1t is there, which will be u of t plus 3. You see the breakpoints. Breakpoints are at -3, -1, +1 and +4, right? And from where I will start my journey? I will start my journey from -infinity only. Why is that so? Because it is u of t. U of t means till +infinity it will be existing. So at -infinity all will be 0. So I will be starting my journey from -infinity. So now they are given in the increasing order only. So I don't need to change the order. Plus u of t plus 1 minus u of t minus 1 minus 2 u of t minus 4, right? Now you make the waveform. So let's get started. From where I will start? The first breakpoint is at -3, then at -1, then at +1 and then at +4. So before that everything is 0. Then at -3 you are getting +1. Now at -1 you are getting +2. Here you are getting +1, then another +2 you are getting. That means you will be reaching at +3, right? You will be reaching at +3. Then you are getting -1. So already you are already at +3. Now +3 minus 1 will be +2. So you will be reaching at +2. Now 1 plus 2, 3, 3 minus 1 plus 2, you are already at +2. Now another -2 is there. What does that mean? That you will be reaching towards 0. So this is how I have made the waveform. So this is our x1t, x1t versus t. Now guys, I will ask you just one thing. Can there be another kind of x1t, like the same waveform? If this waveform is given and I ask you to write down x1t, can you write down x1t? One way will be this only, that you start your journey from here, you start working from here. So first jump at -3, that means u of t plus 3, jump of 1, then there is a jump of 2. If there is a jump of 2 at -1, so what you will write down? U of t plus 1. Then there is a decrement of +1, from 3 to you are coming to +2, so there is a decrement of +1, so u of t minus 1. And then there is a decrement of -2, there is a decrement of 2, so minus of u of t minus 4. So yeah, that's a way, that's the one way. But what if, sir, I start from here? Can I start from here? Certainly I can start from here. Why I can start from here? Because at -infinity, at +infinity as well, it is 0. And if I am starting like this, if I am working like this, so what I will write down? U of minus t now. So if I am writing down u of minus t, then how will I write down? So u of minus t, here I will write down the jump, because there is a jump of +2. If I start my journey like this, if I am starting from here, so what I see? There is a jump of +2. If I am starting from +infinity, if I am working like this, so there is a jump of +2 at +4. So what I will write down? There is a jump of +2, u of minus t plus 4. So there is a jump of +2. Then there is a jump of +1 as well. So plus u of minus t plus 1. Jump of 2, then jump of +1 as well, right? Then there is a decrement of 2. At which point? At -1. So -2 u of minus t minus 1. Why I am writing down minus t minus 1? Because I need to see the breakpoint. Breakpoint at -1, breakpoint at +1, breakpoint at +4. So breakpoint at +4, jump of 2. Breakpoint at +1, jump of 1. Breakpoint at -1, decrement of -2. And then breakpoint is at -3. Breakpoint is at -3, so there is a decrement of, at breakpoint at -3, there is a decrement of 1. From 1 to 0 you are going, so there is a decrement of 1. So what you are getting? T minus 3. So this is the other way of writing it down. Can you come from here to here directly? Replace plus t with minus t and minus sign with plus sign. Basically, wherever there is positive sign, just replace it to negative sign. What will happen? What about this? Minus u minus t minus 3. minus u minus t minus 3. What about this? Minus 2 u of minus t minus 1, minus 2 u of minus t minus 1. What about this one? Plus u of minus t plus 1, plus u of minus t plus 1. Basically, negative sign is replaced with positive sign. What will happen here? Plus 2 of u of minus t plus 4. So if I have written down the expression for u of plus t, can I write down the expression of u of minus t very easily? Yes. But this trick is applicable only when your function is time bounded. That means if your signal is bounded in the time, then only it is possible. Basically, for these waveforms, let's just say for this waveform, I have written down this expression. Then other expression, if I just replace the minus sign with plus sign, then the other expression would be wrong because this is not bounded. Here also it is open, here also it is open. So it is not bounded. For these expression as well, this trick will not work because these are not bounded. This is open here. For these expression as well, for this expression as well, this trick will not work because these are not bounded. This is open here only. Are you getting this point or not? Say yes or no. So this trick is applicable with which trick? That you write it down for, either you write down for plus t or you write down for minus t. Then you replace plus sign with negative sign. That's it. But this is applicable only when it is bounded. So no need to remember this trick. Basically, I am not going to remember this trick because this trick will be applicable only for a certain function. And there is very high chance that in the examination they will not ask these kind of certain functions. Because they will make this waveform, then they will frame the option that which of the wave options are correct. Then these two options would be correct. And these two are also not the only way of writing down the function. There could be n number of ways. There could be different ways. What I can do, I can take this much function aside. What I will do is that from here to here, I will take this function aside and rest of the function aside. So for this function, I will write down my expression, and then for this function, I will write down my expression, and then I will add them both. So then there will be some different expression. So the conclusion is there is not certain one expression for any function. For any signal, there is not one expression. There could be multiple expressions. So in the examination, if these kind of questions are coming, then we will check by options. But sir, why we are studying all these things? So that we can answer it in a quicker manner. That let's just say in the examination, it is a MCQ only. So in MCQ, you will see that if there is any option which is just giving you plus t. So plus t, plus t, plus t. So very quickly you will be able to write down. Or it might be MSQ as well, but you will see there is one option of plus t, other option of minus t. Then very quickly you will be able to write down. So that's why we are seeing more and more example of these kind of problems. Okay. So what is the next expression? What do you see? x2 of t. What is the next expression? x2 of t. Can you draw the waveform of x2 of t? Yes, the same kind of waveform we will get. Minus u minus t minus 3. Minus 2 u minus t minus 1. Plus u minus t plus 1. Plus 2 u minus t plus 4. Same expression we will get. Are you getting this point? So if this is given in the examination, how will I draw? What is my x2t? If this is given in the examination, x2t is given in the examination. So minus u minus t, I will see that everything is negative. Minus t is there. Everywhere is minus t. So if everywhere is minus t, then it should be coming in my mind that since it is minus t, so I should start my journey from plus infinity. And if I starting my journey from plus infinity, what does that mean? That somewhere in between, if I am starting my journey from plus infinity, then the maximum value of t will be my first breakpoint. So my first breakpoint will be maximum value of t. And if that is my first breakpoint, that means I should replace my function in a manner that the highest breakpoint should come first and then other breakpoint should be coming. So which one is the highest breakpoint in this particular expression? Minus t plus 1 plus 4. So in this particular expression, where are the breakpoints? टेढ़ा आ रहा है ऐसे. Okay, no problem. Where is the breakpoint? Minus 3, minus 1, plus 1 and plus 4. So breakpoints are at 4, 1, minus 1, minus 3. Say yes or no, right? So how should I replace it? I am starting my journey from plus infinity, so I should replace in this manner. U of minus t plus 4 plus u of minus t plus 1 minus 2 u of minus t minus 1 minus u minus t minus 3. Since all are minus, so I am starting my journey something like this. So first breakpoint is at 4, then at 1, then at minus 1 and then at minus 3. So till 4 everything is 0. then at 4 there will be plus 2. At there will be plus 2. Then at 1 there will be plus 2 plus 1, right? Plus 2 plus 1, so you will be reaching at 3. Then at minus 1 there is minus 2, that means you will be reaching at 3 minus 2, that would be plus 1, so you will be reaching at plus 1. Then there is another minus 1, so you will be reaching at 0. So this kind of waveform we will get. So now you should have enough practice that you should be able to make all these waveform on your own. Say yes or no. So this is your x2t. And are we getting the same expression? Yes. We are getting the same kind of waveform. Ditto same waveform we are getting. So I can start my journey from here as well, from here as well. Why is that so? Why I can start my journey from both of the ends? Because at the both of the end I am getting 0. Here if I say that your x2 of infinity or x1 of infinity or x2 of minus infinity or x1 of minus infinity, at both of the end everything is 0. So either you start writing from this end or you start writing from this end, doesn't matter. But in these kind of expressions, here it is not 0, so I need to start from here only. But what I can do, what if I need to start like this? So what I can do, one waveform I will take this one, another waveform I will take this one. Basically I will break down this complete waveform into two parts. One part will be this, another part will be this. So this part I will write down separately, this part I will write down separately. Now the rest of the part can be written in two manner, either from here or from here. Say yes or no, right? So more example we will see, more it will be more clear to you. No need to worry. Now you need to write down xt expression in terms of step function. So what is the basic way? You will see it is 0 here. So that means I will start my journey from here. I am starting my journey from here. That means it is something like this. It is something like this. That means I will write down u of plus t. So what I will see? The first jump of 2 is there. So this is your xt. The first jump of 2 is there. That is 2 u of t plus 2. Jump of 2 is there at minus 2. That means the breakpoint is at minus 2. Then there is a decrement of 1. There is a decrement of 1 at minus 1. Then there is a jump of plus 2. There is a jump of plus 2. Then there is a decrement of 3. Right? From 1 to 3 you are going, that means there is a jump of 2. From 3 to 0 you are going, that means there is a decrement of 3. Then there is a jump of plus 2. There is a decrement, there is an increment of plus 2, and the what is the breakpoint? Breakpoint is at 4, and then there is a decrement of 1. So breakpoint is at 5. So let's check back again. Jump of plus 2, then minus 1 will be 1. 1 plus 2, 3. 3 minus 3, 0. 0 plus 2 plus 2, 2 minus 1, 0. Breakpoint 5, 4, 2.5, 1. No breakpoint at 0. So breakpoint is at minus 1 and then minus 2. There you go. This is the first expression I am writing down. Now I need to write down xt again. So what I can do? Replace plus with minus. Can I do this thing? Basically, can I do this thing that minus 2 u of minus t minus 2 plus u of minus t minus 1. Basically, I am replacing positive sign with negative sign. Minus 2 of u of minus t plus 1 plus 3 u of minus t plus 2.5 minus 2 u of minus t plus 4 plus u of minus t plus 5. Is this expression correct? No, this is wrong. This is wrong. Why it is wrong? Because I told you this trick will be applicable only when your function is bounded. Only when this is bounded. But this is not bounded. It is going towards basically your x of infinity and x of minus infinity both should be 0. If both are 0, then only this trick is applicable. But here you can see x of infinity is 1. So this trick is not applicable. Because in a lot of notes I have seen that directly from here to here you can write down. But no, directly I cannot write down. I need to see the expression as well, that what kind of waveform is there. So this trick is not always applicable. Now the question would be, can I replace this function? Can I write down the expression of xt in terms of u of t only in terms of u of minus t? No, only in terms of u of minus t I cannot write down. Why is that so? Because I know that this function can never be written in u of minus t. Basically, this much function. What is this function? This function is something like this. breakpoint at 5. So there is no way you can write down in terms of u of minus t. You cannot write down this function in u of minus t. There is no way. Why you cannot write down? Because it is looking towards plus infinity only. If the function is of u of minus t plus anything, so that should be looking here, right? That should be looking like this, looking this side. But it is not looking towards this side, it is looking towards this side. So you cannot write down this particular function in terms of u of minus t. So the whole expression can never be in terms of u of minus t. So what could be the other way of representing xt? What could be the other way? So what could be the other way? Other way would be that I will break this waveform into two parts. What I'm gonna do? I will break this waveform into two parts. What kind of two parts I will break this waveform into? So this will be the first part. This will be the first part. So here what I'm gonna do? I'm gonna remove this part. So I have broken down till 5. After that, from 5 to infinity, I know that there is plus 1. So the next waveform would be from 5 to infinity, there is plus 1. From 5 to infinity, there is plus 1. So I know what will be the function of this guy. This will be u of t minus 5. There is no one who can stop it. So if I write down x of t, so u of t minus 5 would come. There is no doubt about that. But now this part can be written from here as well and from here as well. Say yes or no. So I can write down this part from both of the ends. So if I write down this part from this end, if I am going from the left hand side, why I can write down from both of the ends? Because I know that at both of the ends, x of infinity and x of minus infinity both are 0. And if I am walking like this, that means first jump is there. So I will just remove these jumps. So first jump is there, and now u of plus t or minus t? Minus t. Why is that so? Now we are looking towards this. If I am looking like this, that means it is u of minus t. So breakpoint is at plus 5. So plus 2 u of minus t plus 5. Then there is a decrement of 2. So minus 2 u of minus t plus 4 plus 3 u of minus t plus 2.5 minus 2 u of minus t plus 1, and then another jump from 3 to 1 I am going, so minus 2 plus, then there is a jump of 1 plus u of minus t minus 1, and then there is a decrement of 2. So minus 2 u of minus t minus 2. There you go. This is how I can write it down. Are you getting this point? This guy was u of t minus 5. What about these guys? So take the jump, jump of 2, then decrement of 2, then jump of 3, then decrement of 2, then jump of 1, then decrement of 2. Breakpoints are at plus 5, plus 4, plus 2.5, plus 1, minus 1, and minus 2. There you go. This is your xt. Say yes or no. I can write down, I could have written down in this way as well. In this way as well, right? So how I would have written down? If I start from here, so again you see jump of 2, then decrement of 1, then jump of 2, then decrement of 3, then jump of 2, and then decrement of 2, and then plus u of t minus 5. So what this will be? Minus 2 plus 1. So what this will be? Minus 1 only. So here you will be getting minus u of, basically it was minus 2 plus u of t minus 5. Why plus u of t minus 5? This expression. So if I combine both of them, what I'm getting? What is the combination of both of them? Minus u of t plus 5, minus u of t minus 5. So are we getting the same expression? Yes, we were getting the same expression. 2u of t plus 2 minus u of t plus 1 plus 2u of t minus 1 minus 3u t of t minus 2.5 plus 2u of t plus t minus 4 minus u of t minus 5. And this is the other expression. Now in this expression, if I drop this guy, then if you see this particular expression and this particular expression. You see these two particular expression. Just replace minus t with minus sign with plus sign and you will get the same expression. Basically, let's start from here. Minus 2 u plus t minus 5. Minus 2 u plus t minus 5. You see this guy. 3 u minus t plus 2.5. So minus 3 plus u minus t plus 2.5. So here that trick is applicable. For this much expression, that trick is applicable. Why this trick is applicable? Can anyone let me know? This trick is applicable replacing positive sign with negative sign. This trick is applicable because I have broke down my function into one bounded function. What is the meaning of bounded function? That it is there between two certain points. After that it is 0. So one bounded function and another one this function. So this trick is not applicable for this guy, but this trick will be applicable for a bounded function. So for a bounded function, I can write down in this manner and I am able to write down in this manner as well. So if I have just written down this expression, basically if I have just written down this expression, then what I could have done is that, sir, I will just break this part aside. I will just break this part aside. So this particular expression will be gone. Right? Now my function will be bounded. If my function is bounded, so in the rest of the part, what I can do is that replace plus t with minus t, plus 2 with minus 2, and here positive sign with negative sign. So in that manner, I could have written down quickly. So these are all the tricks which is not possible to remember in the examination. Okay, and certainly no one is going to teach you these kind of tricks, because in all of the notes what I have seen is that from here to here you need to go just replace plus sign with minus sign. That's it. Wrong. Absolutely wrong. Okay. So in the examination you are not going to remember any of these tricks. In the examination you just need to know that if function is given, I know that there are multiple ways of writing it down in terms of u of t. If there are multiple ways, what are the multiple ways? Easiest way that you start from minus infinity. Okay. Then you can start from plus infinity as well, but you need to see if my function is bounded or not. Okay. So if I am starting from here, that means it should be 0 from here. If it is not 0, then I will make it 0. I made it 0. Basically, I broke it down into two parts. So this part I wrote down, another part I wrote down. So in that manner, I will be able to write down in the examination. Are you getting this point? Solve this problem. Multiple ways are there. What kind of ways would be there? That once you start from here, because it would be the easiest way. Why is that so? Because at minus infinity it is all 0. And if I am starting my journey like this, that means I will be writing down u of minus t. So first I will see the jump. So if I write down x of t, so there is a jump of 2 minus t plus 5. Then there is a decrement of 2 minus t plus 4. Then there is a jump of 3 minus t plus 2.5. Then there is a decrement of 2 minus t plus 1. Then there is a jump of 1 minus t minus 1. There you go. Okay. So plus 2, then minus 2, then plus 3, then minus 2, then plus 2, then plus 1. Yeah. And breakpoints at 5, 4, 2.5, 1 and minus 1. Yeah, that's it. This is the first way. Is this the only way? No. What could be the other way? You break it down into two parts. One part will be this, the other part would be this. So I broke down into two parts. One part would be this. How I will write down this part? This part would have been 2 of u of minus t minus 1. Say yes or no. I am breaking down my function into two parts. One part is this 2 minus 1. So this is the one part. And the other part is this complete waveform. This complete waveform. The other part is whatever this waveform is there, this complete waveform. So first I have broken down into two parts. So this part would be u of minus t only. So u of minus t minus 1. Now I can start my journey from here. So if I have broken down into two parts, that means at minus 1 I will get the first jump. So plus 1 u of t plus 1. Say yes or no. Because I am starting from here now. If I am starting from here, that means now u of plus t I will write down. So one jump is there, then jump of 2 is there, u of t minus 1. Then decrement of 3 is there, u of t minus 2.5. Then jump of 2 is there, u of t minus 4. And then decrement of 2 is there, u of t minus 5. Okay. Say yes or no. And these kind of trick also you can see. Plus 3 is replaced with minus 3. Minus t is replaced with plus t. Plus 2.5 is replaced with minus 2.5. So this trick also you can see, but this trick you don't need to remember. So what you will see is that this part u of minus t minus 1. Okay, fine. What about this part? First there is a jump of 1, then there is a jump of 2, then there is a decrement of 0, then there is a jump of 2, then there is a decrement of 2. Okay, so minus 1, sorry, yeah, minus 1 plus 1 minus, then at 2.5, then at 4, and then 5. There you go. This is the other answer. So in that manner you can break it down. Now someone will say that, sir, I will break down my function in this manner, that I will break down till this part, and then for this part I will write down the difference expression. So this also you can do. What I mean to say is that someone will write down the expression in this manner, that I will break down this much part. What he is doing, that he is breaking down this much part. So there is a jump. What about this part? Can you write down this part? Breakpoint at 1, breakpoint at minus 1. So u of minus t plus 1, and then there is a jump of, again, jump of 1 to 2. So u of minus t minus 1, right? So this much part is broken down. Then this part is different. So for this part I am starting my journey from here. So if I start my journey from here, so suddenly I will see a jump of 3, because this part is broken down different. So now I will start the journey from 0 only. So I will see the jump of 3. So 3 u of t minus 1 minus 3 u of t minus 2.5, then plus u of t minus 4, and then minus 2 u of t minus 5. There you go. So this is also another way of writing down x of t. So what is the conclusion? The conclusion is there could be n number of ways of writing down x of t. N number of ways are there, right? Someone would be breaking down in some other part, someone would be breaking down in some other part. So n number of ways are there. So in the examination, like, look, this kind of question could be coming, or these kind of questions could be coming. So now in this question you can see that there are options I have mentioned. So if you check all these options, so everything will be correct. Okay, this question you need to do on your own. So these kind of questions could be coming in the examination, that they will break down, they will write down xt can be expressed as, xt can be expressed as. So this is how xt is expressed. So what you need to do in the examination, how will you solve these kind of problems in the examination? So first you will see that this expression cannot be broken into purely u of t or purely u of minus t. Say yes or no. This particular function cannot be broken into purely u of t or purely u of minus t. Why is that so? Because it at x equals to infinity as well, at x equals to minus infinity as well, at both of these values are non-zero. X equals to infinity is plus 2, x equals to minus infinity is plus 2. So values are non-zero, so it cannot be purely broken into u of t or purely u of minus t. So what would be the other way? That, sir, I will broke down this part differently, and then rest of the part I can see. So what I would do, minus 2 u of minus t plus 3 by 2, not minus here, it will be plus only. So plus 2u plus 2u of minus t plus 2 by 3, right? So can I see something like this? Plus 2u of minus t plus 2 by 3. Yes, I have broken down. Then this, from here I will start my journey. So there is a jump of 1, there is a jump of 1, then there is another jump, there is another jump. So this option is correct. In the next way, what I can do, I will break down this part differently. I have broken down this part differently, and then I will start my journey from here. So where is this? Plus 2u of t minus 3 by 2. So this part is broken. Then I am starting my journey from here. So first jump I see at 3 by 2. So minus t plus 3 by 2, there is a jump of 1. Then another jump is there, minus t plus 2 by 3. Yes, there is another jump. So this option is also correct. Same goes for this one as well. Here I am breaking from, here I am breaking somewhere in between. So here you can see that breakpoint is at 2. Breakpoint is at 2. Where is 2? 2 by 3 and 3 by 2. 2 is here. So I am doing some breakpoint at 2 as well. So for this kind of option, what I need to do? I need to draw the waveform. For this kind of option, I need to draw the waveform. So I will draw the waveform for this part. Then I will draw the waveform for this part. And then I will add them up. We have done this kind of analysis, no? Right? If you remember, two kind of waveforms we had to draw. I will draw this part, u of plus t part, u of minus t part. Then I add them up. So same kind of thing we need to do for this option as well. Right? These options we can decode very easily, because here this part is broken ahead and here this part is broken ahead. But here the breakpoint is somewhere in between. Breakpoint is at 2, somewhere in between here. I guess this option could be wrong. Should we try it? Let's make this waveform u of minus 3t. Let's check. I guess this option can be wrong. I'm not sure. I guess this option is wrong only. So let's remove this. So let's check this option. After 36th, I need to add a page. I hope you are enjoying the lecture, and I hope certainly you are learning something new which you might not have studied in step function, because these kind of basics are taught very fastly in signal systems, and then we mess up when we go to the transforms. So all these things should be, all these basics should be clear, right? So what I'm gonna do, u of minus t and u of plus t. So where is the breakpoint? Here the breakpoint is minus 3t plus 2 should be 0. So breakpoint is at 2 by 3. Breakpoint is at 2 by 3. Here the breakpoint is at 2. Here the breakpoint is at 2. And here the breakpoint is at 3 by 2. Okay. So let's start doing. So this is minus t. Minus t. Here there is minus t. Minus t means the upper breakpoint is my priority. Upper breakpoint is my priority. Higher breakpoint is my priority. So breakpoint is at 2 and 2 by 3. So there is an increase of, sorry, previously everything was 0, then there is an increase of 1, then another increase is there, another increase is there. All are positive sign only, no? So another increase is there. This is 1, this is 2. All are positive signs only. All are positive signs. What about this guy? So here I will be starting my journey from minus infinity. That means I will be going somewhat like this. In this direction I will be going. So the lower breakpoint will be my priority. Lower breakpoint will be my priority. Lower breakpoint is at 3 by 2. So there is a jump of 1 at 3 by 2. Then there is a jump of another 1 at 2 as well. So 3 by 2 and 2. This is 1 and this is 2. So if I add both of them, then what do I see? I need to add both of them. So see the breakpoints. Breakpoints will be at 2 by 3, right? So certainly I have done some error here, right? In this expression I have done some error. So breakpoint will be at 2 by 3, and then next breakpoint will be at 3 by 2, and the next breakpoint could be at 2. So between 2 by 3, between minus infinity to 2 by 3, this guy is 0, this guy is 2. So here you will get 2. Then between 2 by 3 to 3 by 2, this guy is 1 and the rest all are 0 only. So 2 and 1. Between 3 by 2 to 2, between 3 by 2 to 2, between 3 by 2 to 2, this guy is 1, this guy is 2. So 1 plus 1 will be 2 only. And between 2 to infinity, this guy is 2 and this guy is 0. So this will be 2 only. Okay, we are getting the same expression actually. 2, 1, 2. So actually 2 is not a breakpoint, right? Because between 3 by 2 to 2, this guy is 1, 3 by 2 to 2, this guy is 1. 1 plus 1 is 2 only. 2 to infinity, this guy is 2, this guy is 0. So it will be 2 only. Between 2 by 3 to 3 by 2, sorry, between 2 by 3 to 3 by 2, 1 plus 0, 1 only. Less than 2 by 3, this guy is 2, sorry, this guy is 2 and this guy is 0. So 2 only. 2 plus 2, 1, 2. So when we add both of them, we are seeing that we are getting the same expression. Between 2 by 3 to 3 by 2, there is 1. Then 2 is there. Yes. So we are getting the same expression. Answer is all. So this kind of expression very easily I can decode. Here I don't need to draw the waveform. Here also I don't need to draw the waveform. Where I will have to draw the waveform only for this part. Here I need to draw the waveform, and this waveform I can easily draw. Right? Here like u of 2t minus 3. Here how did I draw it very quickly? Because I know that breakpoint will be at 3 by 2 and it will be looking towards this. So this is how I can draw it very quickly. Till now we were only seeing t plus something. But even if there is a factor of 2, what you can do, you can take 2 common, no? You can take 2 common, so what you will be left with? T minus 3 by 2. Say yes or no? Right? So common you can take. Same goes here as well. You can take common as 3. So minus t plus 2 by 3. Say yes or no? And then add them up. Okay? In between there was this question. So this you can do on your own, right? So let's do it. X of t I will write down in two parts. So first I am starting from here. I can start from here as well, but first I am starting from here. So first jump of 2, then jump of 1, then jump of 2, sorry, decrement of 2, then jump of again 2. Then how much decrement is there? 3 minus 2. Decrement of 5 is there. 5 u of t minus 2. Then increment of 3 is there. Plus 3 u of t minus 3. Then decrement of 1 is there. Let's check again. Plus 2 plus 1 minus 2 plus 2 minus 5 plus 3 and -1. Breakpoint -2, -1, 0, 1, 2, 3 and 4. There you go. Let's see the next one. So here u of minus t plus 4, u of minus t plus 4, minus 3. Basically what you can do here, you can see both are bounded. So plus sign can be replaced with minus sign, you will get the same answer, right? Because here, from here to here, everything is bounded, no? So plus sign is replaced with minus sign, you will get the same answer, or you can do by the analysis as well. So there is jump of 1, then there is a decrement of 3. There is a decrement of 3 at 3. Then there is a jump of 5. There is a jump of 5. Then there is a decrement of 2. Then there is a jump of 2. Then there is a decrement of 1. And then there is a decrement of 2. There you go. Okay, so you can check between these two options as well. If you replace plus sign with minus sign, both options will be same. So this is how you can do it. This question we have already seen, right? So now this is a different concept. Now you need to draw these waveform. Xt equals to u of t square minus 3t plus 2. So this concept is clear. Okay, this waveform decoding, basically this concept is known as synthesis. Okay, synthesis and decoding. Basically from this I am decoding it, and if I go from here to here, that means synthesis. So you can try making from here to here, you try going. Okay, this also you can do from here. If this expression is given, how will you make the waveform? This you can do, right? And if this expression is given, how will you make this waveform? Okay, so same goes for this one as well. Like if these are given, then how will you make this waveform? That you can try. Like opposite things you can try on your own. Okay, opposite things you can try. Say yes or no, right? So this concept is clear now. Everything related to this concept I have taught. Now I will pause the video. I will take some rest, drink some water. Usually I take 5 minutes break only, because if I am keep speaking again and again, then my efficiency will go low. So that's why I need to take a break. So this is a new concept now. You think about it, that how I will draw this waveform. Think about it. Use your brain here. That xt equals to u of t square minus 3t plus 2. Till now we were seeing only u of t, no? Or u of 3t plus 2, or u of minus 2t plus 3. If this waveform is given, then how will you draw it? U of t square minus 3t plus 2, u of cos t, then how will you draw it? So think about it and try drawing it. I will pause the video, then I will come back, then some simple graphs you will see, and with that this video will be completed. So try doing it on your own. Yeah, so let's start. Xt, first xt is u of t square minus 3t plus 2. So what do we write down? Whenever whatever that is inside, if that is greater than 0, then u will throw 1, otherwise it will throw 0. So now the scene is, if t square minus 3t plus 2 is greater than 0, then it will throw 1, otherwise it will throw 0. So here I am writing otherwise. Okay. So now the scene is, I need to solve this inequality. In mathematics we have seen these kind of inequalities, right? So t square minus 2t minus t plus 2. So from here what I am getting? T minus 2, t minus 1. So I am getting t minus 1 into t minus 2 should be greater than 0. So what do? We make the axis, here there is 1, here there is 0. If my t value is greater than 2, then it will be positive. That means this inequality will be followed. If t is greater than 2, from this inequality what you are getting? If t is greater than 2, then also it will be followed, and if t is less than 1, then also it will be followed. But here there will be negative sign, right? What do I mean by that is that if t is greater than 2, let's just say t is 3. So 3 minus 2, 1, 3 minus 1, 2, positive value. But if t is between 1 to 2, let's just say t is 1.5. So 1.5 minus 1 is 0.5, and 1.5 minus 2 is minus 0.5. So what you are getting? Minus 1 by 4. So minus 1 by 4 is not greater than 0. So in between 1 to 2, this inequality will not be followed. If it is less than 1, then also it is followed. If it is greater than 1, then also it is followed. What do I mean by less than 1? Let's just say t is 0. So 0 minus 1 is minus 1. into 0 minus 2 is minus 2. So minus 1 into minus 2, what we will be getting? 2 only. So 2 is greater than 0, yes, it is followed. So if your t is greater than 1 and if t is greater than 2 and t is less than 1, then this inequality will be followed. So from here what we are getting, that t could be either greater than 2 or t could be less than 1. So if t is less than 1 and greater than 2, then it will be followed. What does that mean? That how the graph will look like? So this is 1 and this is 2. So if t is less than 1, that means it will be 1. For less than 1, it will be 1. Between 1 to 2, it will be 0. And greater than 2, it will be 1. There you go. This is how the graph will look like. This is the graph of xt. There could be other ways of breaking it down. You could have written down in other ways as well. But yeah, this is the graph of xt. This is how the graph will look like. So let's just forget it. From here, we are just solving the inequality. So I will take the graph here. Okay. Do the same for u of cos of t. Do the same for u of cos of t. So u will throw 1 or 0. When it will throw 1? It will throw 1 when cos of t is greater than 0. It will throw 0 when cos of t is less than 0. So can you draw the graph of cos of t? Cos of t. Graph of cos of t. How will the graph of cos of t look like? This is how the graph of cos of t will look like. Right? I hope this much mathematics you know how will the graph of cos of t will look like. So this is the graph of cos of t. Right? So whenever cos of t is greater than 0, that means in this part it will be 1. Whenever it is less than 0, it will be 0. In this part it will be 0. So if I draw the wave cos of t, what will be this value? This will be pi by 2. T equals to pi by 2, right? This will be 3 pi by 2. This will be 5 pi by 2. This will be minus pi by 2. This will be minus 5 pi by, minus 3 pi 2. So basically now you are able to understand that what kind of waveform we will get. Because if it is greater than 0, then it will be plus 1, otherwise it will be 0. So that only I need to make. So between minus pi by 2 to plus pi by 2. Minus pi by 2 plus pi by 2, then 3 pi by 2, then 5 pi by 2, then minus 3 pi by 2, then here minus 5 pi by 2. In that manner the waveforms will keep on going. Yeah, so between minus 3 pi by 2 to plus pi by 2 it is 0, then it is 1, then it is again 0, then it is again 1, then it is again 0, then again 1, again 0. In that manner it will keep on going. Again 1. So whenever your cos is 1, at that time it will be 1, otherwise it will be 0. So in that manner it will keep on going. Okay. So this is the graph of x of t. So in that manner any function could be mentioned. You just need to solve whatever that is inside, and in that manner you will be able to make the waveforms, right? Let's make these waveform. You need to make the waveform of sine of t into u of t. Sine of t into u of t. So what is the graph of u of t? You already know, right? Graph of u of t you already know. Then into sine of t. So how will I make this waveform? So sine of t waveform I can draw. The waveform of sine of t will be somewhat like this. Right? But it is not only spread towards plus infinity only. This is not the complete sine of a t waveform. This is the complete sine of t waveform. This is the complete waveform in that manner. But now it is multiplied with u of t. What is u of t? This is your u of t. Now it is multiplied with u of t. That means this part will be multiplied with 0 and this part will be multiplied with 1. So this part will be there as it is. But if this part is multiplied with 0, then this part will be gone. Anything multiplied with 0 means it will be 0 only. So all these parts will be 0. So the rest of the part which were here, this part will be 0. So now you are getting, this is your x of t. So this waveform is your sine of t into u of t. Say yes or no, right? Sine of t into u of t. Next one is 5t into u of minus 2t plus 3. So what is the graph of 5t? B. What is the graph of 5t? This is the graph of 5t. And then u of minus 2t plus 3. U of minus 2t plus 3. U of minus 2t plus 3. Minus 2t plus 3. So it will be looking towards the left hand side. Where will be the breakpoint? Breakpoint will be at 3 by 2. Yes or no? Minus 2t plus 3. Breakpoint is at 3 by 2. So this graph will be multiplied with this graph. So for less than 3t by 2, basically let's just say here you are having 3t by 2. Sorry, 3 by 2. Here you are having 3 by 2. So at 3 by 2, what will be the value here? 5 into 3 by 2, right? 5 into 3 by 2. So till this point, all this graph will be multiplied with 1, but after that everything will be multiplied with 0. So I need to do the multiplication. So if I do the multiplication, what will be the final answer I will be getting? If I do the multiplication. So if I do the multiplication, then I know that till this point, it will be following only, but after 3 by 2, it will all be 0. This is your t versus x of t. And what will be this value? This value will be 15 by 2. 15 by 2. So yes or no? Very easy, right? So this is how we need to draw the waveform. Now next one, these are interesting. X of t is given as e to the power minus t plus 1 and u of t plus 1. Now can you notice one thing here? Here also there is t plus 1, here also there is t plus 1. So can I define another function y of t, that is e to the power minus t u of t? Then what will be my what will be my x of t? My x of t will simply be y of t plus 1. Say yes or no? I have defined another function y of t. So what will be my x of t? X of t will simply be y of t plus 1. So basically I needed to go from y of t to y of t plus 1. Do I know this process? From y of t to y of t plus 1? Yes. And do I know how to draw this graph? E to the power minus t into ut? Yes. So now it will be easier. Otherwise you will have to pick, you will have to write down the values. So what do I see is that whatever that is here, the same thing is here. So what did I do? I defined another function. And now my x of t will be y of t plus 1. So I already know how to draw this graph. Do I know how to draw this graph? Yes. How will you draw this graph? Do you know how to draw the graph of e to the power minus t? Yes. What is the graph of e to the power minus t? At t equals to 0, it will be 1. E to the power minus infinity is 0. And e to the power, you are drawing e to the power minus t, right? Then multiply with u of t. So at t equals to 0, it will be 1. At t equals to plus infinity, it will be 0. And at t equals to minus infinity, e to the power infinity will be infinity only. So the graph will be starting from here and will be going like this. So basically, the graph of e to the power minus t will be going somewhat like this. Say yes or no? This is the graph of e to the power minus t. But it should be multiplied with u of t. What is the graph of u of t? This is the graph of u of t. That after 0, everything should be multiplied with 1. Rest of the part should be multiplied with 0. So this part should be multiplied with 0. So anything multiplied with 0 will be 0 only. So that is gone. So this part will be gone, only we will be left with this part. So what will be the final waveform? What do you think? What kind of final waveform you will get? What kind of final waveform will be getting? That for the part which is less than 0, it will be 0 only. But after that, at t equals to 0, your value is 1 and then it will be decreasing. So this is the graph of e to the power minus t ut. So at t equals to 0, your value is 1. Then at t equals to infinity, value is 0. And here, whatever the part was there, that is gone. So this is the graph of x of t. This is the graph of, sorry, not x of t, really sorry. This is the graph of y of t. So from here, where I need to go? to x of t, and that is y of t plus 1. So my target is to go from y of t to y of t plus 1. Since there is plus 1, that means there will be a left shift. So I need to do the left shift. So when I do the left shift, this is how my left shift will look like. When I do the left shift, this is how my left shift will look like. This graph is just shifted leftward, right? Nothing else. So this is how the graph is shifted. So this will be your graph of x of t, and x of t is equals to e to the power minus t plus 1 into u of t plus 1. Why is that so? Because this graph was e to the power minus t ut. So plus 1 means simply shifted left side. Say yes or no. All good? And if they ask you what is the value at minus 1, so if you put minus 1 here, minus 1 plus 1 will be 0, e to the power 0 will be 1. So this value is 1. And if they ask you what will be the value at t equals to 0, so at t equals to 0, your value will be e to the power minus 1. This value is e to the power minus 1, or you can say 1 by e. Basically, this value has been shifted here. Complete graph is shifted. So this is your final graph. Now do the same for the final one. E to the power minus t minus 1 into 1 minus u of t minus 1. So this is my x of t in the graph of d. E to the power minus t minus 1 into 1 minus u of t minus 1, right? So what should be my y of t? My y of t should be e to the power minus t 1 minus u of t. Say yes or no. Because my x of t will simply be, after this my x of t will simply be y of t minus 1. Say yes or no. If this is my y of t, e to the power minus t 1 minus u of t, then it will all be easy for me. Now I know how to draw the graph of e to the power minus t. But do I know how to draw the graph of 1 minus ut? Yes, I know how to draw the graph of 1 minus ut. What is the graph of 1? This is the graph of 1. That it will always be 1. The graph of 1 is that it will always be 1. It is 1 for all the time. This is the graph of 1. And what is the graph of ut? Or you can say minus ut. What is the graph of minus ut? That for less than 0 it is 0. But after that it is minus 1. After that it is minus 1. So when I add both of them, I need to add both of them, no? Because this is the graph of 1, this is the graph of minus ut. So what I will get? 1 minus ut. 1 minus ut, whatever that would be. That would be u of minus t, right? Or you can say, or you can simply draw the graph. If I draw the graph, what kind of graph I will be getting? So the graph of, that's why I said lecture 1 is very important. Because this just sets the base of your complete electronics actually, not just a signal system. This is setting the base of electronics, like these waveform and all those things we will be using in communication system as well. Like these waveforms, these two you can see, no? So these are asked in GATE 2022 EC examination. In a problem you need to draw these two waveform. In one question you need to draw these waveform. That was asked in communication system. And that problem was very good. When we study communication system, we will solve it. But if you are not able to make these waveform, then it's all over for you. And in the pressure of examination, I gave my 2022 attempt. In the pressure of examination, I was not able to draw these waveform. Because there I was trying to draw with the t plus 1 or t minus 1. If I just thought that I can make another function and then I just shift it, then it would have been very easy for me. But there I was directly trying to draw this waveform. In the pressure of examination, these kind of things happen. So you should understand how to draw these kind of waveforms, and these are very simple, right? So this is your 1 minus ut, 1 minus ut, 1 minus ut, 1 minus ut. Now this should be multiplied with e to the power minus t, right? E to the power minus t. What is the graph of e to the power minus t? Graph of e to the power minus t. Let's do it on the next page. Graph of e to the power minus t. So this we have already done. This is the graph of e to the power minus t. But this will be multiplied with this function. This function. So this part will be multiplied with 1 and this part will be multiplied with 0. So if it is multiplied with 0, that means it is gone, right? So basically only this much part will be left. How much part will be left? Only this much part will be left. Rest of the part is gone. Rest of the part is gone. So this is the graph of e to the power minus t into 1 minus u of t. Say yes or no, right? And at t equals to 0, your value will be 1, and at infinity it was 0 only. So this is the graph. But what I need to make? I need to make this graph should have been a bit smaller. But this is not the final graph I need to make. Which graph I need to make? This is my y of t, right? Y of t. But I need to go to y of t minus 1. What is the meaning of minus 1? Minus 1 means you will be shifting towards the positive hand side. Here, where did I shift? Yeah. If it was plus 1, so I shifted towards the negative hand side. If it is minus 1, that means I will be shifting towards the positive hand side. So this waveform will be shifted now. This waveform is shifted. This point is 1. Okay. And what is your, this is your xt now, which is equals to y of t minus 1. Say yes or no. Okay. And here what will be the value? This is equals to e to the power minus t minus 1 u of t minus 1. So e to the power 0, this value will be 1 only. So here this value is 1. And here this value will be, if you put t equals to 0 here, so e to the power 1. So this value will be e to the power 1. So this kind of waveform will be getting. Say yes or no. Okay. So this waveform and 1 is this waveform. Here actually I should have made e to the power plus t here, right? Then it would have been good. But here if I have made minus t, then this kind of waveform I am getting. So this kind of waveform I am getting. Okay. Well and good. So you know how to draw these kind of waveforms, right? So next we need to study about rectangular signal. So this is a different signal than a step signal. Now this is the second kind of signal we are studying. About step signal we have studied everything, but it will be again introduced. Are you getting this point? Step signal will be again introduced. As of now, these things are enough, but it will be again introduced when we study ramp signal. In the next video only, I will again introduce step signal. Now we need to study about rectangular signal. Okay. So what is a rectangular signal? Simple definition you need to remember. So this is denoted by rect of t. So usually we denote it by rect of t, or somewhere in some textbook you will find it pi of t as well. So how it is defined? It will be 1 or 0. It will throw only two values. It will be throwing value 1 when your t is between 1 by 2 to, I should not take the equal sign, when your t is between minus 1 by 2 to plus 1 by 2. Otherwise it will be 0. Sir, how will we remember all these things? I will tell you. No need to remember anything as of now. So as of now you just see the graph of rect of t. So what is the graph of rect of t? This is the graph of rect of t. That this is your minus 1 by t, this is the plus 1 by t. You don't need to remember anything, just keep on looking at it, and eventually you will be able to understand that how to remember all these things. Okay, so this is the graph of rect of t. Now the next question is, you need to denote rect of t in terms of u of t. So how will you denote it? Sir, I can start my journey from here. If I am starting from here, then suddenly I see a jump of 1. Then here I see a jump, then I see a decrement. So this is the decrement. Or what could be the other way? Sir, I can start my journey from here as well. If I am starting my journey from here, that means here I see the jump u of minus t plus 1 by 2. I see the jump, and here I see the decrement. So minus u of minus t minus 1 by 2. Say yes or no. Okay, so this is how I can replace my rect of t. Say yes or no. Now I am asking you to draw this diagram. Rect of t minus 3 divided by 2. Basically, you need to draw this thing. Rect of t minus 3 divided by 2. Can I break it down in this manner? Rect of t by 2 minus 3 by 2. So if I know the graph of rect of t, if I know the graph of rect of t, can I go here? How I will reach here? So rect of t minus 3 by 2, then rect of t by 2 minus 3 by 2. Say yes or no. This is how I will be reaching here, right? Just a second. Yeah, fine. So I know the graph of rect of t. Now I need to shift it right by 3 by 2. Say yes or no. I am shifting it right by 3 by 2. This is the graph of rect of t. Shifting it right by 3 by 2, what does that mean? That minus 1 by 2 plus 3 by 2. What that would be? Plus 1. This graph is shifted plus 3 by 2 and plus 3 by 2. So this guy will be 2 and this guy will be 1. Right? So between 1 to 2, it will be 1 only. So this is your x of t and amplitude is 1. Now there could be, one second, t minus, something wrong I am doing, just a second. I need to shift it with, yeah. This graph is not done, really sorry. Only first step we have done, no? We have done only the first step, t minus 3 by 2. Then this time domain is also multiplied with 1 by 2. That means this will be multiplied with 2. Right? Time is divided with 2. So now your time axis will be multiplied with 2. So between 2 to 4. So this will be between 2 to 4. Look, first I have done the shift. Then time domain is multiplied with 1 by 2. That means here time axis will be multiplied with 2. So when I did the shift, it was between 1 to 2. But now it is being expanded. So basically I multiply with 2. So now it is being expanded. So it will be between 2 to 4. It will be between 2 to 4 with the amplitude of 1. What could be the other way of reading it out? How I could have read it? Rect, it was rect t minus 3 by 2, right? This was your xt. I could have read it in this manner. Rect t minus center. Where is the center? Center is at 3. T minus center divided by time width. T minus center divided by time width. What is the time width? Time width is 2. Rect of t can be also read in the same manner. T minus center divided by time width. Center will be at 0. What will be the time width? Minus 1 by 2, 1 by 2. And here you write down the amplitude. If amplitude is 1 here, so it will be 1. If amplitude is a here, then it would be a. So are you getting this point? This is how you can read it. Another thing, if I ask you, what is rect of minus t? Can you draw the graph of rect of minus t? Rect of minus t. What is the meaning of rect of minus t? From rect of t2 you need to go to rect of minus t. So what you will do? You will just take the mirror image, right? If you take the mirror image of this guy, same function you will get, right? This part will be going here and this part will be going here. So if you take the mirror image about y-axis. So if you take the mirror image, you will get the same function. So what does that mean? That your rect of minus t is equals to rect of t. Say yes or no. So rect has the ability of eating up the negative sign. So whenever rect is written, what it will do? It will eat up the negative sign. There you go. Whenever rect is written, it will eat up the negative sign. So rect has the ability of eating up the negative sign as well. So let's try making this function. What you need to draw? 3 rect minus t plus 2 divided by 4. So first I will go with the conventional method that I have the graph of rect. So this can be written as, there could be two ways of writing it down. This can be written as 3 into rect minus t by 4 plus 1 by 2, right? So how I can go? I note the graph of 3 rect of t. Next what I need to do? 3 rect of t plus 1 by 2. Next what I need to do? 3 rect of t by 4 plus 1 by 2. And next what I need to do? 3 rect of minus t by 4 plus 1 by 2. So these are the steps I need to follow. So first let's draw it in this manner. So 3 rect of t will be somewhat like this, between minus 1 by 2 to 1 by 2, and the amplitude will be 3. Now I need to shift it towards the left hand side because there is plus 1 by 2. That means I will be shifting towards the left hand side. So if I shift it towards the left hand side, if I shift it towards the left hand side, then what I will be getting? It will be there between minus 1 to 0, right? It will be there between minus 1 to 0, and amplitude will be 3 between minus 1 to 0, right? Now what is there? Time domain is divided by 4, so time axis will be multiplied with 4. So now it will be there between minus 4 to 0, minus 4 to 0, right? And next step is there is a negative sign, so now you need to take the mirror image. So if I take the mirror image, then plus 4 will become minus 4, sorry, minus 4 will become plus 4. So the final waveform will be like this. The final waveform, this 0 part will come here, everything is 0, and then this will be the final waveform. Between 0 to 4 with an amplitude of 3. So this is my x of t. So this is the first way of drawing it. What could be the other way? How I would have thought of it in the examination? So 3 rect of, I know one thing, that rect has the ability of taking the negative sign. So can I take negative sign common? Yes. So t minus 2 by 4. I have taken negative sign common. So minus t minus 2 divided by 4. So rect has the ability of eating up this negative sign. So what I am left with? 3 rect t minus 2 divided by 4. Now do I know how to draw this waveform? Very easily. Yes. How do I draw this waveform? T minus center. My center will be at 2. And my complete width will be 4. Complete width will be 4. So that means 2 ahead I will go here, 2 back I will go here. Complete width will be 4. T minus center upon time width. Width should be 4. So 2 ahead you need to go, 2 backward you need to come. So there you go. You don't even need to follow this process. Because if you need to follow this process, you need to know how to draw the graph of rect of t. That also you know, but in the examination, what is the best possible point? This is the best possible point and the most important point, that you will remember this thing. T minus center upon time width. Rect t minus center upon time width. That's it. Rect t minus center upon time width. So t, and if there is a negative sign, you take that negative sign out. T minus center upon time width. This is the time width. That is 4. Say yes or no. And this will be the graph of your x of t. So this is the property of rect. Very simple thing. Nothing there is very rare chance that anything will be asked from here. But when we study Fourier transform, so there again and again this rect function will be used again and again. So in Fourier transform it will be used. That's why we are studying it here. Although like there is nothing that directly, there is nothing that can be asked from here. Directly they will not ask anything from here, but it will be used in Fourier transform. And in the Fourier transform I will again and again say rect t minus center upon time width. So you should be habitual there that I will make the waveform somewhat like this. Say yes or no, right? So that's it. That's it about this complete lecture. I hope you enjoyed it. I hope you enjoyed it very much, and certainly you would have understood a lot of new things as well. So yeah, that's it. Let's meet in the next video where there we will start studying about ramp function. Okay, we will study about ramp functions there. Thank you very much. Hi everyone, so welcome back. So in this video we are going to study about ramp signal. In the previous video we studied about unit step signal. So now we need to study about ramp signal. So what is this ramp? So we will multiply two signals now. One signal is t. This is your t. Xt equals to t. This is the graph of xt equals to t, right? And the other one is ut. Other one is ut. And when you multiply both of them, what will be the resultant? When I multiply both of them, what is the resultant? The resultant will be t into ut, right? And the graph would be something like this. For t less than 0, this is 0 multiplied with anything, will be 0 only. For t greater than 0, anything multiplied with 1 will be t only. So this is how the graph you will be getting, right? And this is known as RT. So this is your ramp signal. Okay, what is this? This is your ramp signal. So R of t is equals to TUT. So this is known as your ramp signal. So what is the definition? For t greater than 0, the graph is equals to t only, and for t less than 0, the graph is 0. Say yes or no. And here you can put the equal sign as well, because here there is no discontinuity, right? If I ask you limit t tending to 0 minus and limit t tending to 0 plus r of t, r of t. So if you are tending from here, then near 0, what is the value? 0 only. And if you are tending from here, then near 0, what is the value? 0 only. But in case of ut, this was not the scene, right? In case of ut, if you are tending from here, then the value was 1. If you are tending from here, then the value was 0. So that's why ut was undefined at t equals to 0. But now this is defined at t equals to 0. So anywhere you can put the equal sign. Here also you can put the equal sign, because if you put t equals to 0, it will be 0 only. So what kind of graph you will be getting? This is the graph you will be getting. So this is how you define the ramp function, that for lesser value, for the negative values it is 0, but for the positive values it is simply following the graph, that is the graph of slope 1, right? What is the slope here? Slope is 1, no? What is the slope of the graph t? T is simply a line passing through the origin. So whatever the negative part was there, that is gone. Only this part is left. So this is the graph of r of t. R of t. Well and good. Now you need to make other graphs. R of minus t you need to make, 2r of t you need to make, minus r of t you need to make. So first let's make these three graphs. R of minus t. So what is the graph of r of t? First let me know what is the graph of r of t. So this is the graph of r of t. Right? Just 1 second. Yeah, okay. So this is the graph of r of t. What will be the graph of r of minus t? R of minus t means, if this is r of t, from r of t if I am going to r of minus t, what does that mean? That I need to take the mirror image about y-axis. So what I'm going to do, I'm going to take the mirror image about y-axis. So what will be the mirror image of this graph? Mirror image will be somewhat like this. So this will be the graph of r of minus t. Here what was the slope? Slope was 1. Can you let me know what is the slope of this line? It is plus 1 or minus 1? The slope of this line is plus 1 or minus 1? It is minus 1, right? The slope is minus 1, because I told you, if this is the line, that means the slope is plus 1, and if this is the line, that means slope is minus 1. If the line is like this, then slope is minus 1. If the line is like this, then slope is plus 1. In the first lecture only we have seen this, right? So I hope you know that these kind of lines, that means if the value of t is increasing, then the value is decreasing. If the value of t is increasing, then the value of r of minus t is decreasing. That means slope is negative. So here the slope is negative and here the slope was positive. So this is your r of minus t. Slope is minus 1. Say yes or no. Let's make 2r of t. 2r of t. 2 into r of t. So basically this graph will be multiplied with 2, nothing else. This graph will be multiplied with the 2, nothing else. Magnitude will be multiplied with 2. So now you let me know what is the slope of this graph. What is the slope? What is the slope? Slope is 2 now. Say yes or no, because what will be your 2rt? 2rt can be written as 2. What is rt? Rt is t into ut, right? 2 remains as it is. What is rt? Rt is t into ut. Rt is t into ut. So rt is equals to t into ut. So what you are getting? 2t into ut. What is the graph of 2t? This is the graph of 2t. Sorry. This is the graph of 2t with the slope of 2. Multiply with ut. That means these value will be remaining there and this will become 0. So what kind of graph you will get? This graph I will be getting. This graph I will be getting. So what is the slope? Slope is 2. So basically if I multiply with any factor here, if I multiply with any factor a here, if I multiply with any factor a here, so what I am getting? 80 for t greater than 0. So what will be the slope here now? Slope will be a. Are you getting this point or not? So now I cannot call it unit ramp function. Here when a was not there, I could have called it unit ramp function. But now I cannot call it unit ramp because the factor of a is multiplied. So what does this a represent? This a represents the slope, right? Because art is equals to 80 into ut. And what is the meaning of ut? That it will be there, it will be finite for t greater than 0 and for t less than 0 it will be 0. So here a is the slope. So this, if I am saying this 2rt, that means it is the slope. Now minus of rt. Minus of rt. So this graph multiply with minus. So 0 is multiplied with minus 1. It will be 0 only. 0 is multiplied with minus 1, it will be 0 only. Now this graph is multiplied with minus 1. What does that mean? Positive value will become negative value. And you let me know what is the slope of this thing. What is the slope? Slope is minus 1. Here the slope is minus 1. Here also the slope was minus 1. Here the slope was plus 2. Here the slope was 1. So when I multiplied this graph with minus sign, that means my slope became negative. Why is the slope is negative? Because I have told you that this line will have positive slope and this kind of line will have negative slope. So now you can see if t is increasing, then RT is decreasing. You can say RT is increasing but in the negative direction. So it is decreasing only. So what is the slope now? Slope is minus 1. I hope you know this much basic things. This is a positive slope, this is a negative slope. This we have already studied in the basics, right? Yeah, so slope is minus 1. So here the slope is minus 1, here also the slope is minus 1, here the slope is 2 and here the slope is 1. So what did you understand from here? That in R, if minus t is written, that means this minus t shows that the slope will be negative. Slope is negative. Say yes or no, right? And in the R, if plus is written, but here in front minus 1 is written, that means slope is minus 1. Are you getting this point? Here the slope is minus 1. Here also the slope is minus 1. We will see more examples, it will become more clear to you. Okay? More example we will see, it will become more clear to you. So next we are going to draw, let's draw one more. What I am going to draw? Minus of R minus t. This I am drawing. Okay? Minus R minus t. Try drawing it on your own. So what is your R of t? This is my R of t. What is my R of minus t? This is my R of minus t. Say yes or no. What is my R of minus t? My R of minus t is this. R of minus t is like this. But now R of minus t is multiplied with minus sign. R of minus t is multiplied with minus sign. That means this positive value will become negative. So this will be the graph. And now you let me know what is the slope here. Slope is plus 1. Say yes or no. Are you understanding this point? Here the slope is plus 1. So R of minus t, this guy was saying that your slope should be minus 1. But then you multiplied with minus 1 again. So minus 1 into minus 1. What is the slope? Plus 1. So now you see all these graphs. R of t, slope was positive, that was 1. R of minus t, the slope was minus 1 because of this negative sign. Then 2 R of t, basically this shows the slope. So slope is 2. Minus R of plus t. So if R of plus t is there, that means this guy is saying that slope should be plus 1. But there is a negative sign, so slope became minus 1. Now you see minus R of minus t. So this guy is saying that slope should be minus 1 and this guy is also saying that slope should be minus 1. So minus 1 into minus 1, the slope became plus 1. Are you getting this point? All these points are very important, okay? Because from here we are going to make interesting conclusion. So what we made from here, that your R of minus t is not equals to minus of RT, right? Because the graph of R of minus t is this and the graph of minus R of t is this. Both are having slope same. This will also have the slope of minus 1. This will also have the slope of minus 1. But both graphs are different. How it is different? R of minus t is looking here and R of t is looking here. Although you don't need to remember where it is looking because you will be able to make the graph. But one thing you understood, that you cannot take minus sign outward. Say yes or no. R of minus t is not equals to minus R of t. Are you getting this point? Right? So neither you can take minus sign outward and nor it can eat up the negative sign. Basically these are also not equal, no? And this is not equals to R of t as well. So basically negative sign can neither be eat up nor you can take it outward. So negative sign will remain there as it is. Same goes for ut as well, no? U of t was not equals to u of minus t. So there I told you, you cannot take out negative sign outward. Neither it can eat the negative sign. So negative sign will be remaining there as it is. So same goes for R of t as well. The negative sign will be remaining there as it is. Say yes or no. Okay. So let's make other graph. Now we will make this one and this one. Okay. Let's make these three. So R of t plus 2. So I already know the graph of R of t. What I am drawing? R of t plus 2. So R of t graph I already know. Since there is plus, so there will be left shift. So R of t minus 2. Okay. So there is this left shift. Next what I need to draw? R of t minus 4. R of t minus 4. Since there is a negative sign, that means it will be shifted towards the positive axis. So R of t minus 4. So it will be shifted towards the positive axis. And what about this one? R of minus t plus 3. So there are multiple ways. I told you, if you know the graph of r of t, then what you can do, r of minus t plus 3 I need to draw, right? So how I can draw it, that you go from r of t, then you go to r of t plus 3, then you go to r of minus t plus 3, right? So what is my r of t? This is my r of t. What will be my r of t plus 3? My r of t plus 3 will be this. And what will be my r of minus t plus 3? So simply you need to take the mirror image. So this will be the mirror image. So this is the answer. Or what you can do, I told you one thing. If x of t is given and you need to draw x of minus t plus or minus anything. So what you need to do? I can start from here as well. So two mistakes I will do. So here I need to do two mistakes. What is the first mistake I am doing? I am starting from here. So r of minus t. What will be the graph of r of minus t? This will be the graph of r of minus t. And then plus 3. Plus 3 means I should have shifted towards the negative hand side. But now I will be shifting towards the positive hand side. Because two mistakes I need to do. So the other mistake would be this. So this is how I will be shifting. So this will be the graph. Are you getting this point? Any way you can draw the graph, n number of ways I have taught in the previous lecture. R of t plus 3, then r of minus t plus 3. Or first mistake, r of minus t plus 3. This is how you can shift. Say yes or no. So multiple mistakes, if you do two mistakes, then you will get the correct graph. So this will be the graph. Again, you can see one thing here. What kind of thing you can see here? What is the slope? Minus 1. Here what was the slope? Slope is plus 1 only. Why slope is plus 1? Because you can see the factor is 1 here. The factor is 1 here. Unless the factor is changing. What kind of graph is that? R of minus t plus 3. So unless the factor is changing, the slope is same only. But here the slope is minus 1. Why it is minus 1? First thing you can see the graph. The slope is minus 1. Other thing you can see in the expression as well, right? What you can see in the expression? What is the expression? Expression is r of minus t plus 3. So this guy says that the slope should be minus 1. Here, what was the expression? R of t minus 4. So because of this guy, the slope was plus 1. Here also the slope was plus 1. So you need to see this minus t. So here it was minus sign, so slope is minus 1. If I had connected minus 2 here, then what would have been the slope? Slope would have been plus 2, right? Because this guy is saying that slope should be minus 1 and this guy is saying that slope should be minus 2. So minus 1 into minus 2, the slope would have been plus 2. But as of now, this is not the example. The example is r of minus t plus 3. We will see these kind of examples more. So let's make another one now. R of, now we will make these three. This, and this. Yeah, these three we can make. So r of 2t plus 3, right? R of 2t plus 3. Okay. So let's make r of 2t plus 3. So multiple ways are there. How I can make it? First I can define it. Let's define it first. So how do I define r of t? Whatever that is inside, and that goes inside of u as well. Are you getting this point? Whatever that is inside, that comes outward and goes inside of u as well. So whatever that is inside, that comes outward. Whatever that is inside, that comes outward and goes into u as well. Say yes or no. If you are laughing on this statement, then you are ruined. Okay? अपने आप को सुधार लो. अगर हंस रहे हो तो सुधार लो भाई. अगर नहीं हंस रहे तो you are good. Yeah. U of 2t plus 3. How will I draw u of 2t plus 3? U of 2t plus 3. This is how I will draw u of 2t plus 3. So, sorry, I am losing my concentration. No, this is not how I will draw ut plus 3. Sorry, I lost my concentration here because of that bad joke. Like Ranveer Alawadia, like I will also go to jail now. Yeah, so this will be your u of 2t plus 3, right? U of 2t plus 3, because it can eat up to u of 2t plus 3 will be t plus 3 by 2. So that means breakpoint will be at minus 3 by 2. So this is your u of 2t plus 3. And what will be the graph of 2t plus 3? What will be the graph of 2t plus 3? So the graph of 2t plus 3 will be somewhat like this, right? With the slope of, what will be the slope? I hope you know how to draw the graph of 2t plus 3. Slope will be 2, and at y-axis it will be cutting at minus 3, and at minus 3 by 2 it will be 0. Say yes or no. At minus 3 by 2, if you put minus 3 by 2 here, it will be 0. Now you need to multiply both of them. If I multiply both of them, then what will happen? All these values will be going towards 0, and these values will be multiplied with plus 1, and anything multiplied with plus 1 will be the same waveform, and anything multiplied with 0 will be 0 only. So what kind of waveform you will be getting? So this I have drawn by the definition, but always I am not gonna draw by the definition, right? How I am gonna draw? Later on, how I am gonna draw. As of now, let's draw it by the definition. So here I can see that breakpoint is at minus 3 by 2, slope is of 2, and this is the graph of r of 2t plus 3. Say yes or no, right? But this is not how I am gonna draw it. R of 2t plus 3. So what I know? I know the graph of r of t, right? What could be the procedure? That I start from r of t, then I go to r of t plus 3, then my time domain is multiplied with 2. Say yes or no. This is how also I can draw. Okay. So first I am drawing r of t. This is my r of t. Then r of t plus 3. R of t plus 3 means you are going backward. Here what is the slope r of t? Slope is 1. Here the slope is 1. Okay. Just hold on to this. This is very, very interesting. Slope is 1. What does that mean? That at t equals to 1. At t equals to 1, your value should be 1 only. At t equals to 1, value should be 1 only. Now what you are doing? T plus 3. That means you are shifting backward. You are shifting backward by 3. So this graph will be shifted backward. This graph will be shifted backward. This graph is shifted backward. What is the slope still? Still the slope is 1 only. Say yes or no. Still the slope is 1 only. So let's just say at minus 3, you are having 0 value. So at 0, how much value you will have? Slope is still 1, right? At minus 3, you are having 0 value. So at 0, how much value you will have? Plus 3, say yes or no. Right? Because I need to make slope to be 1. So if my x changes by 3, then my y is changing by 3. So 3 divided by 3, that is 1. So at minus 3, if I am having 0, so at 0, I will have plus 3, right? So slope is still 1. Now what you are doing? You are multiplying time with 2. That means time axis will be divided by 2. So what is the next step? The next step is from here to here. What is the next step? You are multiplying time domain with 2. So here it will be divided by 2. So it has become minus 3 by 2. But is there any change in y-axis? Basically, is there any change in these values? No. If this was 3, then this will be 3 only. Are you getting this point or not? Here only my time axis got divided by 2. Nothing got changed with this guy. This is 3, then this will be remaining 3 only. Now what is the slope of this line? Change in y, what is the slope? Change in y-axis is 3. And what is the change in x-axis? That is 3 by 2. So what is the slope now? The slope is 2. So the slope got changed here. Say yes or no. Are you able to understand this point? R of 2t plus 3. The slope is 2 here. R of 2t plus 3. R of 2t plus 3. So what you will see, what is in the multiplication of t? That is 2. So that means slope is 2 here. Say yes or no. Are you getting this point? Right? And breakpoint is at minus 3 by 2. Now my next task is draw the waveform of 2r of t plus 3 by 2. Draw this waveform. How will you draw this waveform? I know r of t waveform, right? I know the waveform of r of t. R of t waveform is somewhat like this. Now r of t plus 3 by 2. R of t plus 3 by 2. That means I need to shift backward by 3 by 2. So I am shifting backward now. So if I shift backward, so this is how I have shifted backward. So this I have drawn r of t plus 3 by 2. But what I need to do, I need to multiply with 2. So initially my slope was 1. Now my slope has become 2. And this is equals to minus 3 by 2. Slope is 2 because of this value. Slope is 2. Right? The slope is 2 because I am multiplying with the function with 2. So everything will be multiplied with 2. So the slope will also be doubled. Are you getting this point or not? This was my r of t. So at 0, if this is your r of t, so at 1 what you are getting? 1 only. But if you draw 2 r of t, what does that mean? That amplitude will be multiplied with 2. Time domain will remain there as it is. Now amplitude is multiplied with 2. So at 1 what you are getting? At 1 you are getting 2. So what is the slope now? Slope is 2 now. Say yes or no. So if I am doing 2 r of t, that means slope is doubled. R of t means slope is 1. 2 r of t means slope is doubled. So same thing is happening here. I have drawn the graph of r of t plus 3 by 2. If I multiply with 2, that means slope is doubled. So now the slope is 2. So now just can we see one interesting thing, that r of 2t plus 3 is ditto same as 2r of t plus 3 by 2. Here which graph did I draw? R of 2t plus 3. This was the graph of r of 2t plus 3. By multiple ways I have drawn the graph. Always I am getting the same graph, that it is starting from minus 3 by 2 with the slope of plus 2. Starting from minus 3 by 2 with the slope of plus 2. Say yes or no. Right? We are getting the same thing. So what did we understand here? What you used to do? What you used to do? You used to eat up these 2. So this was equals to t plus 3 by 2. Now what this r is doing? For this r, what you can do is that you can take 2 common. You can take 2 common. But now this r will not eat up this 2. This r will say that this is my slope. So I will take it outward. So I will take it outward. So this is the conclusion that we have made. Say yes or no. Okay, you understood the conclusion? So usually people remember all these things, that okay, 2 will be coming out, you will be eating it up, and in the delta what will happen? It will be coming out by 1 by mod of a factor. So people usually mug it up, but are you going to mug it up? Absolutely no. Right? You are not going to mug up, you will just remember the things. Okay, this guy shows the slope, because here I have given the explanation that this guy is showing the slope. Here also I told the same thing previously. This guy is showing the slope minus 1, plus 1. This guy is showing the slope, and this guy also shows the slope. Whatever that is the factor. So what we can do here, if I take it outward, if I take this 2 outward, so what this guy is saying? That slope is 1. And what this guy is saying? The slope is 2. So 2 into 1, total slope is 2 only. Right? So from here I can say that the slope is 2. From here I can say the slope is 2. And from here I can say the slope is 2. Let's just say if this was the function r of 2t plus 3 into 2. So if I ask you what is the slope, what is your answer? What is the slope? And just do another thing. Let's keep it positive. And here what I'm gonna do, I'm gonna keep this as negative and this as positive. So what this guy is saying? That slope should be minus 2. What this guy is saying? The slope should be plus 2. So what is the total slope? What is the actual slope? This guy is saying 2 into minus 2. So actual slope will be minus 4. So for this line, the slope will be minus 4. Are you able to understand this point? Are you able to understand this point? That from here also I need to pick one slope, here also I need to pick one slope, and then multiply both of them. And the same thing we are doing in all the graphs. Here also we are doing the same thing. Minus 1 into minus 1, slope became plus 1. Plus 1 into 1, slope is 1. Minus 1 into 1, slope is minus 1. Plus 1 into 1, slope is plus 1. Say yes or no. Here also the same thing. Minus 1 into 1, plus 1. Plus 1 into minus 1, minus 1. Sorry, minus 1 into 1, minus 1 only. Plus 1 into minus 1, minus 1. Plus 1 into 2, 2. And plus 1 into 1, slope is 1. Are you getting this point or not? Very interesting point. So we have drawn this one, we have drawn this one. R of t plus 3 by 2 also we can draw, right? This also we can draw very easily. What will be the slope here? The slope will be 1. And from where it will be starting? It will be starting from minus 3 by 2. So it will be starting from minus 3 by 2, and this is how it will be going with the slope of 1. So this graph is very easy. I have drawn here only. F is done. Now these 3 are remaining. So let's draw these 3. Okay. R of minus 2t minus 3. Let's draw R of minus 2t minus 3. So again from here as well we need to make conclusion. So all we are doing, all these things we are doing to make the conclusion, so that in the examination we draw it very quickly. In the examination all these things will not take time. But here if we don't learn, if we just keep it for the final examination, then in the final examination it will take some time. R of minus 2t minus 3. So what I can do, how I can start from here? R of t, then R of t minus 3, then R of 2t minus 3 and then r of minus 2t minus 3. Have I reached here already? Yes, I have reached here already, right? I already know what is the graph of this thing, r of 2t minus 3. R of 2t minus 3 is somewhat like this. Slope of 2, right? And the breakpoint is at, okay. Sorry. Breakpoint is at plus 3 by 2, no? Where will be the breakpoint of this guy? Basically, R of t I started. This is R of t. Then what will be R of t minus 3? R of t minus 3 will be this. And then divided by 2. And what will be the slope here? Slope is 2. So this is your R of 2t minus 3. Now I am multiplying time domain with minus 1. So what will happen? Mirror image. So this guy will become here. So this guy will simply be like this. This guy will simply be like this. So this will be the final graph. Okay, this will be the final graph. This will be the final graph, R of minus 2t minus 3. But in the examination, I will not be following this process. In the examination, what I will be doing? So R of minus, and what is the slope here now? The graph is like this. The graph is like this. So slope is minus 2. Here the slope was supposed to be, in this graph the slope was plus 2. But now it got inverted. So slope also became negative. Previously this was the scene. The slope was plus 2. But now it got inverted. Mirror image you took. The slope became minus 2. Right? So R of minus 2t minus 3. So what I am going to do is that I know one thing, that sir I can take 2 common. What I can do, sir? I can take 2 common. So minus t minus 3 by 2. And this guy will not eat up this 2. So 2r of minus t minus 3 by 2. Now I know that my slope will be minus 2. Why I know my slope will be minus 2? So here the guy is 2, here the guy is 1. So I know that my slope will be minus 2. Okay, the slope is minus 2. Now minus t minus 3 by 2. So I have the graph of r of t in my mind. Say yes or no. Then I told you, you can start from here and you can do 2 mistakes. First mistake is that you are starting from here. R of minus t. What will be the graph of r of minus t? Graph of r of minus t will be somewhat like this. And then minus 3 by 2. So minus 3 by 2 means you should have shifted towards the positive hand side. But you are doing the mistake. So you are shifting towards the negative hand side. So r of minus t minus 3 by 2. What does that mean? That I will be shifting towards the negative hand side. So there you go. This is how I am going to shift. This will be minus 3 by 2. So this will be the graph. And here also you can verify that my slope is minus 2. Say yes or no. Are you able to understand these points? Okay. Should I tell another point? Another point I will tell. If you are able to keep these points in mind, then it is fine. Otherwise, anyway, I am telling you 10 number of ways to draw one graph. So there are 10 number of ways in the examination you can draw any graph. So any way you can draw the graph. I will tell you another point here. What another point I will be telling? First thing I will see, here my slope is minus 2. Okay. What is my slope? Slope is minus 2. Here I can see there is minus t, no? Here minus 2t. What is the meaning of minus t? Meaning of minus t is that it should be looking towards minus infinity. It should be looking towards minus infinity. And where is the breakpoint? The breakpoint is at minus 3 by 2. And it should be looking here. So now it can look towards this side in two manner, either like this or like this. Are you getting this point? What did I say? That first thing I saw that my slope is minus 2. Second thing I saw that there is minus sign. U of minus t was there. That means it was looking towards this side, no? So now my graph will be looking here, either like this or like this. If I say my graph is like this, that means my slope will be negative. And if I say my graph is like this, that means my slope will be positive. If the graph is like this, that means slope is positive. And if the graph is like this, that means slope is negative. So either your slope is positive or negative. M is equals to minus 2. That means slope is negative. So negative graph means this should be the slope. This is how the graph should go. Negative slope means this should be the graph. If positive slope was there, then this would have been the graph. But if negative slope is there, then this is the graph. Say yes or no. So first thing I saw that there is minus t. Minus t means it will be looking towards minus infinity. Then I saw the slope. Slope is minus 2. That means the slope should be minus 2. So graph cannot be like this. Graph has to be like this. So there you go, directly I can draw the graph. How I can draw the graph? So first what I'm gonna do is that I'm gonna make the axis. Then I notice that my slope is -2. Then I notice my breakpoint. Breakpoint is -3/2. Now my slope is -2. Okay. And other thing where my graph will be looking, my graph will be looking here because of this -t. Because here there is -t is there, so graph will be looking towards this side. Now the point is that how it should go. For greater than -3/2, it will all be 0. Now the point is whether it should go like this or like this. So I know that my slope is negative. So for this waveform, my slope is positive. So it has to be negative. So this is how I can draw the graph. Although as an educator, it is easy for me to remember all these things because I teach this again and again. I study this again and again. But in the examination, you might not be able to remember all these things. But at least I would expect that you will be doing this step. That it goes outward, then slope is 2, then r of -t -3/2. So quickly you will be able to make it. If you are not able to remember, if you cannot remember these things, then at least the first step that I told you, that you take this 2 outward. So that means now I know that my slope is 2 minus 1, my slope is -2. This I already know. Now I remember my graph of RT. Then what will be the graph of R of -t? This will be the graph of R of -t. Then -3/2, that means I need to shift 3/2 here. So 2 mistakes I am doing, and this is how I am drawing the graph with the slope of -2. There you go. So multiple ways I have taught. This way also you can go. So the thing is, you need to save your time here. These kind of things are very important when we study. Okay, when we study, these kind of things are very important because this will eventually help you in the examination in a lot of problems. So my target has already been that always my target would be whenever I teach, my always target would be that in the examination, how you can reduce your calculation. So like a lot of people will be going like this, but let's just say in one question, there are 10 functions like this. So there will you be making these waveform? No. There your intuition would be working. So slowly we will build up those intuition in this lecture only. And certainly you will see that in one problem only I will introduce a lot of r of -t, r of +t, these kind of things. So there confusion will be made if you don't study this much thoroughly. But now we are studying thoroughly. So everything is clear to you, right? Okay. Now the first function we have made. Now we need to make this one. 2r of -t -3/2. 2r of, it was -2t -3, what we made, -2t -3. So now they are asking 2r of -t -3/2. The same waveform I will get, no? Next they are asking here, what they are asking next? Next they are asking 2 of r of -t -3/2. So same function I am getting. Next what they are asking, -2r of -t -3/2. -2r of -t -3/2. So in the examination, what I will be doing? In the examination, suddenly someone is saying that you need to make this waveform. So first I will see, okay, what will be my slope? -1 into -2. Slope will be 2. Okay, slope is 2. Where is the breakpoint? Breakpoint is at 3/2. Sorry, -3/2. Sorry. Breakpoint is at -3/2. Okay. Okay, sir. Breakpoint is at -3/2. What I can see here, r of -t. R of -t means my graph will be looking towards this side. Graph is looking towards this side. What does that mean? That means for t greater than -3/2, everything will be 0. Now what is the slope? Slope is +2. So either I can make my graph like this or like this. How will I make it? Like this only. Because my slope has to be positive. So graph should be like this. Slope has to be positive. The slope is 2 here. There you go. This is the graph of -2 r of -t -3/2. Or at least in the examination, first step that you need to tell slope is -2. Then you will draw, sorry, slope is +2. Then you will draw this graph, r of -t -3/2. So this is the graph of r of t. R of -t will be somewhat like this. Then you need to do another shift. So another shift I have done. So r of -t -3/2 you have already drawn. Now what is the scene? You need to multiply this graph with -2. So if I am multiplying this graph with -2, that means this positive value will become negative value. So this is how I can draw the graph. So multiple ways are there. Or what is the basic way? Basic way would be r of t, then start from here. R of t -3/2, then r of -t -3/2, and then multiply it with 2. -2, sorry. -t -3/2. So this is the most basic way. This is the advanced way that directly in the examination, okay, slope is +2. Breakpoint is at -3/2. And since there is a negative sign, that means it will be looking towards -infinity. So for -3/2, for greater than -3/2, it will all be 0. Now the scene is the slope is plus 2. So whether it should be looking upward or downward. So it should be actually looking downward. Why is that so? Because the slope is plus 2. That's it. So these are the ways in that manner you can draw the graphs. And certainly we have already made the conclusions out of it. What all are the conclusion? You would have already understood that the ability of R is that it can just take out any constant value. That's it. Nothing else. So if I take out from here, I can take out 2. Say yes or no. Or how I can understand this? Let's take another way. So R of 2t plus 3 can be replaced somewhat like this. In the worst possible way, if you are forgetting in the examination, then what you are going to do? Say yes or no. Right? 2t plus 3 into, can I replace your u as t plus 3 by 2? Why is that so? Because you just eated up these 2. So this 2 came common and you have eaten it up. So t plus 3 by 2. Same goes for this one. Can I take 2 outward? 2t plus 3 was there, no? So can I take 2 outward from here? Yes. Now what is this? This is equals to 2. Sorry, 2 is common. 2 is outward. Now what is this equivalent to? R of t plus 3 by 2. Say yes or no. This is another way of proving it. Once we proved with the waveforms, right? Once we proved with the waveform. Now by simple mathematics, I can also prove it. R of 2t plus 3 is equals to 2t plus 3, u of 2t plus 3. Here, from here I can take 2 common. Okay. From here as well I can take 2 common, but u will eat it up. So u has eaten it up. And now what is this equivalent to? This equivalent to R of t plus 3 by 2. And 2 remains there as it is. There you go. Or directly I have told you that slope will be 2. Slope will be 2. Breakpoint will be at 3 by 2. There you go. Sorry, minus 3 by 2. Here what you will do? Take 2 outward. 2 R of t minus 3 by 2. Here what you will do? Take 2 outward or minus 2 outward? 2 outward, not minus 2 outward. Right? Minus t plus 3 by 2. Breakpoint will be at 3 by 2. What kind of graph I will get here? Breakpoint will be at 3 by 2. Okay. Minus t is there. That means it should be looking towards this side. That means this will be 0. And what is the slope? Slope is plus 2 or minus 2? Slope is minus 2. If slope is minus 2, that means it should be looking like this or should be looking downward. It should be looking like this. Or what you can think? Okay, sir, I know the graph of R of minus t. So graph of R of minus t will be like this. Then R of minus t plus 3 by 2. R of minus t plus 3 by 2. Then slope should be 2. Slope should be 2. Multiple ways are there. In that manner, you can draw the graphs as well. I hope you are following the lectures. Right? 2R of minus t minus 3 by 2. Right? Because only the common thing I can take is that is 2. I cannot take minus 2 common. I can only take 2 common. So this is how I can reduce my functions. And was it same for u? No. How this u of 2t minus 3 will be replaced? It will be equals to t minus 3 by 2. Because u will just eat up this common. How this will be replaced? Can this u eat up this plus 2? Can this u eat up this minus sign? No. But you can eat up this plus 2. So what it will do? U will just eat up that 2. And here also u will eat up that 2. There you go. Well and good. Okay. Next, the same thing. Now we need to add up the graphs. What we need to do? We need to add the graphs. So try doing it on your own. Okay. Once give your hand onto it. Try it. Try it once. And then certainly I will tell. So now I need to take a break because it's been 40 minutes. I am continuously speaking. So I will take a break and then we will see it. So, but you try it on your own. You can add up these graphs. Yeah. So let's get started. So what I need to do? R of t. So first I will draw the waveform of R of t. So this is the waveform of R of t. What will be the waveform of R of t minus 2? So R of t minus 2 waveform will be somewhat like this, right? Then R of t plus 2. So R, here the slope are plus 1 only, no? So I should make in a better way. Slope is plus 1 only. What is the slope? Slope is plus 1. Here the slope is 1. Here also the slope is 1. Here where is the breakpoint? Breakpoint is at 2. In the next one, breakpoint will be at minus 2, right? Breakpoint will be at minus 2. The slope is again 1 only. The slope is again 1. Breakpoint is at minus 2. Next one. How will you draw minus r of 2t plus 3? So there are multiple ways. You know the graph of r of t. Then r of t plus 3. That means you go here. So this will be minus 3 then divided by 2. And the slope is minus 1. So sorry, slope is minus 2 actually. So it goes down like this. And what is the slope? 2 into minus 1. So slope will be minus 2. So this is the one way. What is the other way? What do you see? What will be the slope? Slope is minus 2. This is the first thing you see. Then where is the breakpoint? Breakpoint is at minus 3 by 2. Breakpoint is at minus 3 by 2. Now, what is this? This is plus t. Plus t means your graph should be looking towards plus infinity. So graph should be looking towards plus infinity. And here you are having plus t. So graph will be looking towards plus infinity with the slope of minus 2. And so till minus infinity it will be 0. So till this point it will be 0. Now the slope of minus 2 is there. So this will be plus 2 and this will be minus 2. So this is how also you can make it. So in the examination, whatever that clicks to you, whatever that is comfortable, you draw it by that matter. Okay. For me, I usually prefer like, because I will see the waveform. What I am going to do is that I am going to see the function. The function is 2t minus 3. So I know my slope is minus 2. And then I know my breakpoint as well. So very quickly I can see, okay, this is my breakpoint. Then my slope is minus 2. And at infinity it should be 0, plus infinity. At minus infinity it should be 0. At plus infinity it should be existing with the slope of minus 2. So it cannot go like this. It can go like this only. So now the slope is minus 2. Slope is minus 2. Okay. For the next one, the breakpoint is at 3, right? The breakpoint is at 3 and the slope, how much slope is there? Slope is minus 1. Slope is minus 1 and it will be looking towards plus infinity because there is plus t here. If there is plus t, that means it will be looking towards plus infinity and the slope is minus 1. Slope is minus 1. Slope is minus 1. Okay. So now I need to add all of them. And you remember one thing from first lecture. What is that? That slopes are always added, right? If I add all of them, so one thing I have already told from the first lecture itself, that slopes will be always added. So you see the breakpoint. Before minus 2 everything is 0, right? Before minus 2 everything is 0. So from where I will start? I will start from minus 2. Then at minus 3 by 2 something is changing. At minus 3 by 2 something is changing. Then next one is changing at 0. Next one is changing at 0. So let's make it better. Minus 2, minus 3 by 2. The next one is changing at 0. Next one is changing at 2. Next one is changing at 3. After that there is no breakpoint. Certainly we will learn some method as well. As of now we are not learning any method. As of now we are just studying it. So till minus 2 everything is 0. After minus 2 the slope is 1. So between minus 2 to minus 3 by 2 slope is 1 only. Between minus 2 to minus 3 by 2 the slope is 1 only. After that what is happening? Now between minus 3 by 2 to 0. Between minus 3 by 2 to 0. So this guy is 0 only. Slope is 0. Here also the slope is 0. Here the slope is 1. Between minus 3 by 2 to 0. Here the slope is minus 2. Right? Here the slope is minus 2. And here the slope is 0. So what will be the total slope? 0, 0, plus 1, minus 2 and 0. So plus 1 minus 2, that means slope will be minus 1 now. So this was your slope plus 1. Here the slope was plus 1. Now what will be your slope? Your slope will be minus 1. Now your slope will be minus 1. So if your slope was plus 1, then what would have been this point? What will be the value of x of t here? Slope was plus 1. That means if you are increasing the value by half, if the value of x increases by half, then value of y should also increase by half. That means this point would have been plus 1 by 2. Now the slope is minus 1. Now you can see the slope is plus 1 minus 2. That means now the slope is minus 1. So now your x is increasing by 3 by 2. That means your y should decrease by minus 3 by 2. Say yes or no. This is the meaning of slope. I have taught all these things in the first lecture with good amount of patience. Here now slopes are added. Now between minus 3 by 2 to 0, my slope has become minus 1. But I need to see how my curve will go. I know that my curve will go something like this. But where it will cut on y-axis, that I need to see. So how will I see that? Because I know that my x need to cover a distance of 3 by 2. And the slope being minus 1, that means my y will be covering a distance of minus 3 by 2. So from plus 1 by 2, it will cover the distance of minus 3 by 2. That means it will come to minus 1. Are you getting this point? So this point will be minus 1. Are you able to understand how did we write that? Certainly you are able to understand. There is no doubt about that. So just one second. Yeah. So covering a distance of 3 by 2 with the slope of minus 1. Covering a distance of 3 by 2 with the slope of minus 1. That means you are going down by minus 3 by 2. And 1 minus 3 by 2. That would be minus 1. So this point would be minus 1. This point would be minus 1. Okay, now let's get started between 0 to 2. So between 0 to 2, this guy is giving 1 slope, this guy is giving 0 slope, this guy is giving 1 slope. Between 0 to 2 I am talking about. This guy is giving 1 slope, this guy is giving minus 2 slope, and this guy is giving 0 slope. So what is the total slope between 0 to 2? Between 0 to 2, what is the total slope? Between 0 to 2, the total slope is 0, because 1 plus 0 plus 1, 2. 2 minus 2, 0. So now the slope has become 0. So this is the 0 slope. Say yes or no? Right? This is the 0 slope. Between 2 to 3, between 2 to 3, 2 to 3, this guy is giving plus 1 slope, this guy is also giving plus 1 slope, this guy is also giving plus 1 slope, because this is spread till infinity, right? So this guy is also giving plus 1 slope, this guy is giving minus 2 slope, and this guy is giving 0 slope. So now what is the slope? 1 plus 1 plus 1 minus 2, 0. So slope is plus 1 now. Slope is plus 1. So now you are at minus 1. You are at minus 1. Now your x increases by 1. X increases by 1. Or you can say your tx is increases by 1. So how much your xt will increase? By 1 only, because slope is plus 1. Slope is plus 1. So it will also increase by 1 only. From minus 1 to it will go to 0. So here also the slope is 1. Here what was the slope? Slope was 0. And here what was the slope? Here the slope was minus 1. Here the slope was plus 1. So this is how we are going. Say yes or no. I hope you are able to understand everything. We are just adding up the slope, nothing else. Right? Now after 3 what is the scene? After 3 what is the scene is that this is giving plus 1 slope, this is also giving plus 1 slope, this guy is also giving plus 1 slope, this guy is giving minus 2 slope, and this guy is also giving minus 1 slope. So now what is the total slope? 1 plus 1 plus 1, 3, minus 2, minus 1. So now the total slope is 0. That means from here the slope is 0. So 0 slope. So this is the waveform we will be getting. In the examination will we do like that? No. In the examination what we are going to do? The same thing, whatever that we have done in UT, the same kind of analysis here we are doing. In the examination we will be given this waveform. We know that here everything is plus t. R of plus t is there. And if everything is plus t, what does that mean? That your waveform would be looking towards plus infinity. Everything is plus t, that means your waveform would be looking towards plus infinity. That means at minus infinity, everything will be 0. So I will start my journey from minus infinity. Then I need to see the breakpoints. Where are the breakpoint? 0, 2, minus 2, minus 3 by 2, and plus 3. So how should I adjust my xt? How should I adjust my xt? I will adjust my xt in a manner that first the minimum breakpoint should come. Why is that so? Because I am starting my journey from minus infinity. So the minimum breakpoint is r of t plus 2, right? Then r of 2t plus 3, or can I write down in this manner? Yes, I can write down in this manner. And why I am writing down in this manner? Because here I can directly see the slope. Slope is 2. That's why I am writing down in this manner. Then next one would be at 0. So plus r of t. यार इसको हो क्या गया, ये लैग कर रही है स्क्रीन. Plus r of t. Then the next one at plus r of t minus 2, and then minus r of t minus 3. Okay. So now I will draw the waveform. I need to restart my PC now, I guess, because the screen is lagging. कुछ अलग से तो कनेक्टेड नहीं है यार, माइक ही कनेक्टेड है. Yeah, so before minus 2 everything is 0. Before minus 2 everything is 0. Before minus 2 everything is 0. At minus 2 I am having my first breakpoint. At minus 2 I am having my first breakpoint with the slope of plus 1. With the slope of plus 1. So first I can draw my breakpoints only. Breakpoint minus 2, minus 3 by 2, 0, plus 2, and plus 3. These are my breakpoints, right? Now at minus 2 I am having the slope of plus 1. I am having the slope of plus 1. If this slope is plus 1, then I know that my x is increasing by 1 by 2. So my y will also increase by 1 by 2. So that means this guy will be 1 by 2 only. There you go. Okay. After that, at minus 3 by 2, here the slope was plus 1. Now the slope is 1 minus 2. Now the slope will become minus 1. Slope will become minus 1 now. Okay. Slopes are added. In the previous diagram, what we were doing, 2u of t plus 3u of t minus 2. So this is how we were drawing, right? U of t. Then after that, another one is added. So 2 plus 1, slope is added. So same thing is happening here. 1 minus 2, slopes are being added. So now the slope will be minus 1. So slopes will be keep on adding. So slope will be minus 1 now. So slope will be minus 1, and I know that if slope is minus 1, then where I will reach, because x is increasing by 3 by 2, so y will decrease by 3 by 2. That means it will decrease by minus 3 by 2, so it will reach at minus 1, right? So this is how it will be reaching. Now next, here the slope is 1, so total slope will become plus 1 minus 2. Total slope will be 0 now. So total slope is 0. Now after that again there is plus 1 slope. So till this point total slope was 0. Now the slope is plus 1. So I will be reaching till this point. And after that the slope is minus 1. So till this point the slope was plus 1. Here the slope was plus 1. Till this point my total slope is plus 1. So now plus 1 minus 1 total slope will become 0. So there you go. In the examination I will be making the waveform like this. Since we have seen a lot of examples of u of t, then these examples are not that difficult for us, because we have seen all the examples with a good amount of patience, right? So yeah, this is how we are going to draw the waveform. Try the same for this particular function as well. Meanwhile, I will restart my PC and then I will come back to this particular waveform. So try doing it with this particular waveform and try making your conclusion as well, that what kind of conclusion you can make out of it. Okay, and here everything is minus t, right? Everything is minus t, everything is minus t, everything is minus t. So try making your conclusion out of it and draw the waveforms. Okay, so let's get started. So r of minus t plus 2. So r of minus t plus 2 should not be very difficult for you. The slope will be minus 1, and I already know the graph of r of minus t, then I just need to shift it by 2. R of minus t plus 2. R of minus t plus 2. Next, what will be the slope? Next, the slope will be plus 1, right? Sorry, plus 2. Sorry. Basically, next is minus r of minus 2t minus 3. So what I can do? I can take 2 common. If I take 2 common, so minus 2r minus t minus 3 by 2. So the slope is plus 2 here, right? Because this guy is saying minus 1, this guy is saying minus 2. So slope is plus 2. Where is the breakpoint? Breakpoint is at minus 3 by 2. The breakpoint is at minus 3 by 2. Breakpoint is at minus 3 by 2. Say yes or no? Because breakpoint is at minus 3 by 2, and then the sign is minus t here as well. Since sign is minus t, that means it will be looking here. If it is looking here with the slope of 2, with the slope of plus 2. So slope of plus 2. So this will be your minus 2, this will be your plus 2 slope. So this is how the graph should go. You can make waveform on your own with any method you want to. So what else you could have done? R of minus t minus 3 by 2. R of minus t minus 3 by 2. So minus 3 by 2. So this point will be minus 3 by 2. And then you need to take negative. So this is how the negative would go. So this is actually easier way. The way I am drawing, that is actually a tougher way. So r of minus t minus 3 by 2. R of minus t minus 3 by 2 shifted this side and then multiply with minus 2. So this is how I will get. So just important part is here the slope was minus 1. What is the slope here? Plus 2. Here the slope was minus 1 from here. Here the slope is minus 2 into minus 1. So slope is plus 2 here. And the breakpoint also you know. And then the final one, minus t minus 3. Minus t minus 3. So where will be the breakpoint? Breakpoint will be at minus 3 actually. So breakpoint will be at minus 3. And now where the waveform will be looking? The waveform will be looking towards minus infinity with the slope of minus 1. With the slope of minus 1. With the slope of minus 1. So what is the slope of minus 1? That means this will be the slope of minus 1. So r of minus t minus 3. So this is how the waveform will go. R of minus t minus 3. So these are the waveforms we are drawing. So all the waveforms we have drawn, what I need to do now? I just need to add them up. So where I will start adding from? I will start adding from minus infinity. Why? Sorry, plus infinity. Why is that so? Because here everything is 0. Everything is absolutely 0 here. So everything is 0, and where are the breakpoints? Breakpoints are at 2, at minus 3 by 2, at minus 3. These are my breakpoints, and at minus 3. So for greater than 2, everything is 0. For greater than 2, everything is 0. between 2 to minus 3 by 2. This guy is saying that slope should be minus 1. This guy is saying that slope should be minus 1. This guy is saying that slope is 0. And this guy is also saying that slope is 0. So total slope will be minus 1. Total slope will be minus 1. At what point it will reach? What do you think? Slope is minus 1. What do you think? What will be this point? So 2 plus 3 by 2. What that would be? 2 plus 3 by 2. 2 plus 3 by 2, that means 3.5. 2 plus 3 by 2, that means 3.5. And the slope is minus 1. Slope is minus 1. So x is decreasing by 3.5. That means y should increase by 3.5. So here the value will be 3.5 with the slope of minus 1, because the slope was minus 1. Say yes or no. In that manner you can see 3.5 divided by 3.5, the slope is minus 1 only. Okay. After that, minus 3 by 2 to 3. After that, minus 3 by 2 to 3. Here the slope is minus 1. Here the slope is plus 2. Minus 1 plus 2. So the slope will be now plus 1, right? The slope will be plus 1. Slope will be plus 1. Between minus 3 by 2 to 3. Between minus 3 by 2 to 3, the slope will be plus 1, right? Slope is plus 1. Already you are at 3.5. Already you are at 3.5 and the slope is plus 1 now. So how much will be this point? Basically, your x is decreasing by, this t-axis is decreasing by 1.5. So this guy should also decrease by 1.5, right? So this guy should also decrease by 1.5. That means 3.5 minus 1.5. What that would be? 2. 3.5 minus 1.5. What that would be? That would be 2. I don't know what this point will be. This point will also be 2 only actually. This point will be 2 only, no? Say yes or no? Because the slope is minus 1 here. So 2 divided by 2, the slope will be minus 1. So this point will be 2 only. So till this point it will reach. Between minus 3 by 2 to minus 3, the slope is minus 1. Sorry, the slope is plus 1. So minus 1 plus 2, the slope is plus 1. Now you are saying that your x is increasing, sorry, x is decreasing by 1.5. That means y should also decrease by 1.5. So 3.5 minus 1.5, it will reach at 2. So this is how it has reached. After minus 3, what is the scene? After minus 3, the scene is that this guy is saying that my slope should be minus 1. So this guy is saying that slope should be minus 1, this guy is saying that slope should be 2, and this guy is saying that slope should be minus 1. So minus 1 plus 2, the slope should be 0. So after that, the slope will be 0. There you go. This is the final waveform we are getting. Okay. So this is the final waveform we will get in that manner. In the examination, are we going to follow this process? No. In the examination, what we are going to do? We will just see that everything is minus t. If everything is minus t, what does that mean? That means that if everything is minus t, that means all the slope will be looking towards minus infinity. That means everything is minus t. That means all the slope will be looking towards minus infinity. That means at infinity, all will be 0. So I will start my journey from infinity. If I am starting my journey from infinity, so which breakpoint matters for me? The highest breakpoint. So this breakpoint is 2. This breakpoint is minus 3 by 2. And this breakpoint is minus 3. So which breakpoint matters to me? The highest breakpoint. And the highest breakpoint is plus 2. Okay, and we will write down the slope as well. This gives me a slope of minus 1. This gives me a slope of plus 2. And this gives me a slope of minus 1. Right? Right? And then breakpoint 2 minus 3 by 2. And then minus 3. Right? Okay. So till 2, everything is 0. After 2, between 2 to, at 2, what is the slope? Minus 1. So at 2, the slope is minus 1. So this slope will be plus 1, this slope will be minus 1. Till this point, till which point it will be minus 1? Till this point it will be minus 1. So this is the point, till this point the slope is minus 1. So here you can see the increment is 1.5, or you can say, so decrement is 1.5. So here the increment will be, sorry, not 1.5, 2 plus 1.5. So total decrement is 3.5. So here also increment will be 3.5. So this 3.5 I have written. Now what will happen? Another breakpoint that is minus 3 by 2. So the already it was having the slope of minus 1. Already it was having a slope of minus 1. Now the slope is plus 2. So minus 1 plus 2, the slope will become plus 1 now. Slope will become plus 1. So with the slope of plus 1, if it is decreasing by 1 by 2, if it is decreasing by 3 by 2, sorry, not 1 by 2. If it is decreasing by 3 by 2, so this should also decrease by 3 by 2. What does that mean? So it should reach to plus 2. And this point is also plus 2. and this point is also plus 2. So it should decrease till plus 2. Say yes or no. Okay, and after that, at another breakpoint, the slope is minus 1. So already the slope was plus 1 here. Here the slope was plus 1. Here the slope was minus 1. So already the slope was plus 1. Now plus 1 is added with minus 1. The slope will become 0 now. Slope will become 0 now. There you go. So this is how the waveform will go. Okay. Now the next task would be, the waveform is given. How would you write down x of t? So here it is bounded function, right? Bounded means x of infinity and x of minus infinity, both are 0. So in this waveform, actually you could have started from anywhere. You could have started from here as well. You could have started from here as well. Let's start from here. Let's start from here. So how I will write down x of t? I am starting from here. Okay, that means my waveform will be looking towards plus infinity. So now I am going to write down r of plus t. So all will be r of plus t. So at this point, what is the breakpoint? Breakpoint is at minus 2. So at this breakpoint, I am having a slope of plus 1. I am having a slope of plus 1. Then after that, what slope I am having? So I can calculate the slope. What will be the slope? Decrement of 3 by 2. Here also 3 by 2. The slope is minus 1 now. Here the slope is minus 1. What is the slope here? Here the slope is 0 and here the slope is 1. So initially my slope was 1. Now the slope has become minus 1. That means there would have been a decrement of 2 slope, no? Let's just say if this waveform is given. If this waveform was given, let's just say this point is 1, this point is 2 and this point is also 2. So how would I write down? U of t plus, let's call it 3. Okay. So here increment of 2 was there. So I would have write down 2u of t minus 2. Similarly here the slope is 1, 2, minus 1. That means there would have been decrement of 2. So decrement of 2. There is a decrement of 2. So 2 at which breakpoint? At minus 3 by 2. That means r of t plus 3 by 2. Then now the slope has become 0. The slope has become 0. Till this point, what is the slope? Till this point the slope is minus 1. Now the slope has become 0. That means there would have been an increase of 1. No? There would have been increase of 1 slope at t equals to 0. Then the slope has become plus 1. That means there would have been an increase of 1 slope. There would have been an increase of 1 slope. And then it is becoming 0. That means there would have been a decrease of 1 slope. So this is how it should go. First increase of 1 slope, then decrease of minus 2 slope, or you can say decrease of 2 slope. So 1 minus 2 slope would become minus 1. Now the slope would become 0. That means 1 slope would have been added. Then the slope would become plus 1. That means another 1 slope would have been added. After that the slope would have become 0. That means 1 slope should have been subtracted. Right? So this would have been your x of t. Say yes or no. You could have started your journey from here as well. But it would be actually very tough to write down. We will learn it because in the next example we need to start the journey from here only. Okay. In this example we need to start our journey from here only. Can I start my journey from here? No, it would be very difficult. Why is that so? Because it is spread till minus infinity. So from here I will start. So how I will write down my r of, x of t. X of t. Yeah, so what should be your x of t? You are starting your journey from plus infinity because at minus infinity it is completely spread. At minus infinity the value is plus 2. So you will start your journey from plus infinity, right? So first you are getting a slope of minus 1. At breakpoint of plus 2 you are getting the slope of minus 1. And another thing you know that if I am going from plus infinity to minus infinity, then I need to write down r of minus t, right? R of minus t. Breakpoint is at 2, so r of minus t plus 2. So from here breakpoint is at 2. Now what is the slope? Slope is minus 1. So do I need to multiply minus 1 here? No. Why is that so? Because this function is already saying that your slope is minus 1. So you don't need to multiply anything here. Are you getting this point? Next, add 3 by 2. At minus 3 by 2, what is the slope? Initially the slope was minus 1. Now the slope has become plus 1. That means plus 2 slope would have been added. Plus 2 slope would have been added. What is the breakpoint? Breakpoint is minus 3 by 2. Is that correct? Yes. Breakpoint is minus 3 by 2. From minus 1 to you are going to slope plus 1. That means 2 slope would have been added. But it would have been added. Here, if you see this waveform, then this waveform will say that the slope is minus 2. If I need to make it plus 2, then I need to add a negative sign here, because minus 1 into minus 2, then slope will be plus 2. So initially the slope was minus 1, then plus 2 slope was added, so slope became plus 1. Say yes or no? So here the slope became plus 1. After that the slope should be becoming 0. Slope should be becoming 0. What does that mean? Slope should be becoming 0. So r of t, minus t minus 3, because the breakpoint is at minus 3, breakpoint is at minus 3, minus 1, here the slope was plus 2, so total slope would have been here already minus 1. Now, total slope would have been here plus 1, minus 1 plus 2, the slope would have been plus 1. Now plus 1 and this slope is minus 1. So plus 1 minus 1, total slope would have become 0. Why I added positive sign here? Did you understand? Because I needed minus 1 slope, because already my slope is 1 and I need to make the slope to be 0. So I need my slope to be minus 1. If I need this slope to be minus 1, so I need to add a positive sign here, because r of minus t is already giving me minus 1 slope. Say yes or no? Right? So minus 1 plus 2 minus 1, total slope in the end should be 0. Yes, I am getting 0 only, and this is the expression I was expecting. Yes, this is the expression I was expecting. So the same expression we are getting, r of minus t plus 2. Here this 2 can come outward, so only the same expression you will get, or you can say that 2 can go inside as well. So same expression you are going to get, and here also the same expression you are getting, right? So this is how you can replace your x of t. But is this the only way of writing down x of t? Certainly no. There are multiple ways possible. So that certainly we will see. Like, only this is not the only way of writing x of t. And one more thing, these questions are very rare. Okay, till now in the examination these kind of problems are not asked. That no one in, like, nowhere in the notes as well, in like in any coaching's notes you can see, you will never find that they are writing down these expressions with respect to minus t as well. Like, they will teach this kind of thing and that's it. That's the complete your ramp function. But we are writing down in r of minus t as well, because that is the worst possible case they can ask in the examination. Okay, so you should be knowing that how you read the slope of this particular function. Right, the slope will be minus 1 into minus 2, slope will be plus 2. So IIT's professor may think about it, because these kind of things are not even given in the textbook as well. You can read OpenM. So these kind of waveforms are not given, that you need to write down with respect to r of minus t. With respect to r of t we write down, but with respect to r of minus t, that is very rare. But what if some IIT professor is thinking in the same manner that we are thinking, so he can also frame the problem from there. Okay, so that's why we are looking at the worst possible case, and that's why our speed is a little bit high in this lecture, because we have spent good enough time, good enough patience as well in u of t. If we are studying about r of t, then making the function should not be that difficult, right? Now if these kind of questions are coming in your examination, that you need to draw x1t and x2t, how will you draw it? So first function, you can see x1 of t, you can see everything is plus t. If everything is plus t, what does that mean? My waveforms will be looking towards plus infinity. So where should I start my journey from? From minus infinity, because at minus infinity everything would be 0. So I will be starting my journey from minus infinity. So which breakpoint I should care about? I should care about the minimum breakpoint, right? Because if I am starting from minus infinity, then first I will encounter the minimum breakpoint. So then I will see the breakpoints 3, minus 2, plus 1 and 0. So what is the minimum breakpoint? Minimum breakpoint is minus 2. So now I will replace my x1t in this manner. 2r of t plus 2. Then next breakpoint will be at 0. Then next breakpoint will be at 1. And then next breakpoint will be at 3. So this is how I will replace it. Slope 2, slope minus 2, slope minus 1, 2 minus 2, minus 1, and then slope will be plus 1. So this is how the slopes are going. So now I can draw the waveform. This is how the slopes are going. So breakpoint is at minus 2, 0, plus 1 and 3. Okay, t x1 of t. So before this everything is 0. Before this everything is 0. Now at minus 2, what is the slope? Plus 2 slope is there. So two kind of waveforms are possible, either this or this. Which waveform you will go with? This waveform, because the slope is plus 2, right? Slope is plus 2. That means increasing value of x should increase the value in y as well. Increasing value of t should increase the value of x of t as well. Right? So if x is increasing, what is the slope? Slope is 2. So if x is increasing by 2, then y should increase by 4. X increases by 1, y should increase by 2. That's the meaning of slope. If x is increasing by 2, then y should increase by 4. So this point will be 4. After that, the slope would become 0, because plus 2 minus 2, the slope will become 0 till the point of 1. So slope will be 0 till the point of 1. After this, here, what will happen? Between 1 to 3, what is the slope? Plus 2 minus 2, already the slope is 0 here. Here the slope is 2, here already the slope is 0. After that, the slope is minus 1. So plus 2 minus 2 slope is 0. Now minus 1 is added, so slope will be minus 1 now. Till what point? Till the point of 3. That means your x is increasing by 2, or you can say your t is increasing by 2. So your y should decrease by 2 only. Your y should decrease by 2 only. So it should decrease by 2 only, because the slope is minus 1. Slope is minus 1. So whatever the increase is there, the same decrease is there. Slope is minus 1, not minus 2. So it should decrease by 2. That means from 4 to it will come to 2. From 4 to it will come to 2. From 4 to it will come to 2. And after that, here the slope is minus 1. Then another one slope is added, so slope will become 0 now. So what will be the slope? Slope will become 0 now. There you go. So now the slope will become 0. Say yes or no, right? Now if this function was given and I asked you to write down your x1 of t, can you write down? Yes. That's why I will start my journey from here, because from here I can see that at infinity there are functions possible. So I will start from here. So first the slope is, breakpoint is at minus 2, slope is plus 2, right? Then the slope became 0, that means minus 2 slope would have been added at r of t. Next the breakpoint is at plus 1, breakpoint is at plus 1 and the slope is minus 1, that means minus 1 slope would have been added at the breakpoint of plus 1, minus 1. Now the slope is 0, that means plus 1 slope would have been added, plus 1 slope would have been added at the breakpoint of 3. So this is how I can write down the function as well. So draw the function and write it down here. Okay. Let's see the next one. This will be a bit on tougher side, but have the confidence and try drawing it directly without even drawing the waveforms. Directly one waveform I need to draw. I'm not going to draw the waveform of minus r of minus t plus 3, minus 2 r of minus t minus 2, plus r of t minus t plus 1, or 2 r of separately. I'm not going to draw. So what I can think here, everything is minus t. Everything is minus t. That means all the waveforms should be looking towards minus infinity. That means at plus infinity, everything would be 0. So I will start my journey from plus infinity. So what should matter to me? What should matter to me? The maximum breakpoint, right? So maximum breakpoint should matter. Here the breakpoint is 0, here the breakpoint is 1, here the breakpoint is minus 2, and here the breakpoint is 3. So maximum breakpoint matters first. So how sorry, this should not have been erased. Only this would be erased. So how would I write down my x2 of t? So first minus r minus t plus 3. Okay. Then this would come plus r of minus t plus 1. Then what will come? Then 2r of minus t would come, and after that what would come? Minus 2r of minus t minus 2 would come. Let's see the slope. What is the slope here? Tell me correctly, what will be the slope here? Plus 1 or minus 1? Plus 1. Because this guy is saying that minus 1 and this guy is saying that minus 1. So slope will be plus 1. What is the slope here? Minus 1. What is the slope here? Minus 1. And what is the slope here? Plus 2. Say yes or no. Minus 1 plus 2. Oh, sorry, here the slope is minus 2. Really sorry. Here the slope is minus 2. I should see this factor as well. One factor is there. Here also one factor is there. So slope is 1. Here it is minus 1. Here the slope is minus 2. And here the slope is plus 2. Okay. So let's get started. First I will make my breakpoints. So where are my breakpoints? 3, 1, 0 and minus 2. These are my breakpoints. So before 3 everything is 0. Then after that, what is the slope? Slope is plus 1. So this slope is minus 1 actually. This slope is plus 1. So this is how the waveform will go. Are you getting this point? The slope is plus 1, no? The slope is plus 1. So this is how the waveform should go. Slope is plus 1. Now if t decreases by 2, then y should also decrease by 2. Basically, if your t is decreasing by 2, then x2 of t should also decrease by 2. So this should also decrease by 2. So here it is decreasing by 2. It has decreased by 2. So it is decreasing by 2. This also should have decreased by 2. So from 0 to it should come to minus 2. Then only the slope will be 1, right? Slope is 1. Then at 1, what is happening? Here what is happening? At breakpoint of 1, the slope is plus 1 minus 1. So slope will become 0. What will happen? The slope will become 0. The slope is becoming 0 here, right? Plus 1 minus 1, slope is becoming 0. Now the slope is becoming minus 2. Slope is becoming minus 2. Till what point? Till this point. Till what point? Till the breakpoint of plus 2. Sorry, till the breakpoint of minus 2. Till the breakpoint of minus 2, the slope will become minus 2 here. Because plus 1 minus 1, the slope has become 0. 0 minus 2, the slope is becoming minus 2 now. The slope is becoming minus 2. So this slope is minus 2. This slope is plus 2 actually. The slope is becoming minus 2. So now your t is decreasing by, here your t is decreasing by 2. So your x2 of t should increase by 4 because the slope is minus 2. This slope is minus 2. So if it is decreasing by 2, if it is decreasing by 2, then this waveform should increase by 4. This 2, that means it should increase by 4. So from minus 2 plus 4, it should reach to plus 2, right? It should reach to plus 2. So here it has reached to plus 2. So yes or no, right? Now this slope is already minus 2, then plus 2, slope will become 0. Minus 2 plus 2, slope will become 0. So now the slope will become 0. Are you able to understand this particular waveform? Started slope of 1, then slope of 0, then slope of minus 2, then slope of 0. 1, then slope became 0. That means minus 1 would have been added. Yes, minus 1 would have been added. Then slope became minus 2. That means minus 2 would have been added. Yes. Then slope became 0. That means plus 2 would have been added. Yes, plus 2 is added. Breakpoints you can see at minus 2, 0, plus 1, plus 3. Breakpoints you can see plus 3, plus 1, 0 and minus 2. So this is the waveform of x2t, right? So like good analysis it is, but very rare for your examination. Okay, so that's why we are moving a bit faster here. Now find x1, xt. You need to find xt. So I can either start from here or I can start from here. Which one will be easier for you? Sir, both will be easier. Okay, but actually going from minus infinity is easier, right? Because there will not be any minus t. You are going with plus t. So there you will have to think lesser. Because what is the slope here? First you let me know the slope. Negative slope would be there. This is 3 and this is 2. So slope will be 3 by 2. That means slope is minus 1.5. Say yes or no. Slope is minus 1.5. 3 divided by 2. Here what is the slope? Slope is 0. Here what is the slope? So minus 3 plus 6, 9. 9 divided, slope is plus 9 here. Right? Because in the x it is changing only 1. But in the y, how much it is changing? By 9. So 9 divided by 1, the slope is plus 9 here. Right? And what is the slope here? Here the slope is minus 6. Why minus 6? Because in y it is changing by 6 and in x it is changing by 1. So the slope is minus 6 here. So these are the slopes. Now let's get started from here. From this side I am starting. So breakpoint is at minus 2 with the slope of minus 1.5. Then breakpoint is at r of t. The slope became 0. That means 3 by 2 slope would have been added. right? Then the slope became 9. The slope became 9. That means 9 slope would have been added at the breakpoint of 2. Then slope became minus 6. That means 15 slope would have been subtracted. Here the slope was minus 3 by 2, then plus 3 by 2, slope became 0. 0 plus 9, 9. Now the total slope is 9. So 9 minus 15, I need the slope to be minus 6. So 9 minus 15. So that would have happened at t minus 3. Is that it? This is complete? No. At 4 as well, there is a change in slope. Here the slope is minus 6. Now the slope has become 0. So till this point my slope is minus 6. So here plus 6 slope would have been added, right? Then it would have become 0. Started with minus 3 by 2, then minus 3 by 2 plus 3 by 2, slope became 0. 0 plus 9, slope became 9. 9 minus 15, slope became minus 6. Minus 6 plus 6, the slope became 0. So finally the slope became 0. So this is how you can write it down. This is the first way of writing it down. What could be the other way? Let's see the other way. Where I will start from? Now I will start my journey from here. So first breakpoint, where do I see? I see my first breakpoint at plus 4. So r of minus t plus 4. That means my breakpoint is at plus 4. What is the slope? Slope is of minus 6. So should I multiply minus 6 here or plus 6 here? Plus 6. I should multiply plus 6. Why I am multiplying plus 6? Because this is already giving me minus 1 slope. So this is what I am getting. 6 r minus t plus 4. Next, my slope became plus 9. My slope became plus 9. Initially my slope was minus 6. Now my slope became plus 9. But let's see, where is my breakpoint? My breakpoint is at 3. So minus 6 to plus 9. That means 15 slope would have been added, right? 15 slope would have been added. So here I need to write down minus 15. Say yes or no. Why I am writing down minus 15? Because plus minus 6 plus 15 would make plus 9, right? And here this minus sign is saying the slope is minus 1. This minus 15 is saying that slope is minus 15. So minus 15 into minus 1 would be plus 15. Now the slope is becoming 0. Already my slope is plus 9. The slope is becoming 0. That means minus 9 slope would have been subtracted. And at the breakpoint of 2. At the breakpoint of 2. And how much slope would have been added? Minus 9 slope would have been added. So already this is saying that minus 1 slope is there. So I need to multiply with the factor of 9. So this is showing that minus 9 slope is there. So here I need to put positive sign. Why I am putting positive sign? Because minus 9 slope would have been subtracted, right? Now next, slope is minus 1.5. That means another slope should be subtracted. 1.5 slope should be subtracted at 0. Breakpoint is at 0 and minus 1.5 slope should be subtracted. So the slope here is minus 1.5 only. Till this point the slope is 0. Till this point the slope is 0. Now 1.5 slope is minus 1.5 slope is added. So minus 1.5 slope is added. At this point here the slope became 0. At which breakpoint? The breakpoint of r of minus t minus 2. That means at this breakpoint the slope became 0. That means plus 1.5 slope would have been added. Plus 1.5 slope would have been added, right? So here I need to multiply with the plus sign. I need to multiply with the minus sign, because minus 1 into minus 3 by 2, that would become plus 3 by 2. So here plus 1.5 slope would have been added. So this is the other expression. Are you able to understand? I hope you are able to understand, because I have spent, I guess, good enough time. Now you need to have good enough patience, then you will be able to understand all these things. Slope, just you need to see the slope. Here the slope is minus 6 plus 15 minus 9. Minus 6 plus 15, that means plus 9. Plus 9 minus 9, that means slope is 0. Then 0 plus 1.5, 0 minus 1.5, the slope is minus 1.5. Now minus 1.5 plus 1.5, the slope is 0. So there you go. This is the expression we are getting. One expression and two expression. Both of the expressions are there. Say yes or no. So these kind of questions are very rare in the examination, but if they ask, a lot of aspirant will struggle. In these kind of problems, a lot of students will struggle, because they learn only from one side. We can study from the other side as well. Say yes or no. Try doing it for this waveform. This is a bit different waveform. Okay. Slopes you can write down. Certainly, what is the slope here? Slope is plus 1. What is the slope here? Slope is 0. What is the slope here? Slope is again plus 1. What is the slope here? Again it is plus 1. What is the slope here? It is 0. What is the slope here? Minus 2, because minus 1 by 2, right? In the decrement of y is decreased by 1, but x is increased by 2. So slope is minus 1 by 2. And here what is the slope? Minus 2, right? But notice these points. There is a sudden jump. Is there sudden jump? No. Is there any sudden jump? Yes. At this point, what is there? There is a sudden drop, right? There is no sudden drop, but here at this point there is a sudden drop, and here there is a sudden jump. So if there is a sudden jump or sudden drop, then what should come? U of t should come. Say yes or no, right? So try writing it down, then let's see if we are getting it correct or not. Okay, I need to take a pause. Then you try writing it down, then we will check whether you get it correct or not. So use your brain here. How I will write down my x of t? Use your brain. How will you write down your x of t? Okay. Yeah, hi guys, welcome back. So did you write down the expression of x of t? Let's write down the expression of x of t. So I will start my journey from minus infinity. Why is that so? Because at minus infinity everything is 0. I can start from plus infinity as well, but it will be very tough. You need to write down in terms of minus t. If you are starting from here, I will write down in terms of t. So that is on the easier side. So we will start our journey from minus infinity. So I am starting my journey from minus infinity, and at t equals to minus 3, what do I see? That there is a slope of 1. Initially the slope was 0, everything was 0. Now the slope of 1 has been introduced. That means r of t plus 3. Breakpoint is at minus 3, slope of 1 has been introduced. Now let's talk about at point minus 2. At t equals to minus 2, there is a breakpoint. What is happening here? Here amplitude is also increasing and the slope is also changing. Slope is going from 1 to 0. Slope is going from 1 to 0. What does that mean? That there is a decrement of slope 1. So there is a decrement of slope 1. Along with that, there is a increase in amplitude 1. Along with that, there is increase in amplitude 1. Say yes or no. Increase of amplitude 1 at t equals to minus 2. Now at t equals to minus 1, what is happening? Is there any sudden jump? No. There is no sudden jump or there is no sudden decay. But there is a change in slope. From 0 to plus 1 you are going. So that means there is an increase of plus 1. There is an increase of slope plus 1. Now at 0 what is happening? At t equals to 0, let me know at t equals to 0 what is happening. There is certainly a decay, right? There is a sudden decay. From 3 to 1 you are coming. There is a sudden decay. So at 0 there is a decay of 2. From 3 to 1 you are coming. That means there is a decay of 2. There is a sudden decay, right? But is there any slope change at t equals to 0? No, there is no slope change. Previously it was 1, again it is 1 only. So no term of r would be coming here. Are you getting this point? No term of r would be coming here. There is no slope change. Next you need to check at t equals to 1. So is there any slope change? Yes. One slope is being reduced. Here the slope was 1. Now the slope has become 0. So yes, there is a slope change. Next at this point, at point 2. So is there any slope change? Yes. Also there is a sudden decay as well. So there is a decay of 1. There is a decay of 1. Also there is a slope change. From 0 to you are coming to minus 1 by 2. So minus 1 by 2 r of t minus 2. Now at point 4, what do you see? There is a sudden jump. Right? Here I have written down both of these things. No? Yeah. One is the sudden decay and there is a slope change. Yeah. At 4, what do you see? There is a sudden jump of 2. There is a sudden jump of 2. Along with that, at 4 only there is a slope change as well. From minus 1 by 2 you are coming to minus 2. So minus 3 by 2 r of t minus 4. Now at 5 what is happening? From minus 1 by 2 the slope became minus 2. Right? So minus 1 by 2 slope was already there. From 0 to minus 1 by 2 slope was already there. You just need to add minus 3 by 2 to get the minus 2 slope. And at 5 what is happening? There is only the slope change. Here your slope became 0. There is no sudden jump or there is no sudden decay. So only the slope change is there. From minus 2 to you are coming to 0. From minus 2 to you are coming to 0. There you go. This is how you write down. So at each point you see Slope change, okay. Sudden jump and slope change. 1 minus 1 slope became 0 and then there is a sudden jump of 1. Then at this point, only slope change. So, one slope change is there, so RT plus 1. At this point, there is a sudden jump, sudden decay and no slope change. At this point, there is a slope change. From 1 to 0 it is going, so there is a slope change. Then there is a sudden decay. At point 2, there is a sudden decay and slope change as well. There is a slope change as well. Then at point 4, there is a sudden jump. There is a sudden jump and there is a slope change as well. From minus 1 by 2 to minus 2 you are going. So that means minus 3 by 2 r of t minus 4. And at point 5, there is a slope change. So there is a slope change. So this is how you write down the expression of x of t. Say yes or no. It is good, right? Try drawing this waveform. I will post the video. You try drawing this waveform on your own. There is R as well, there is UT as well, there is everything. You can do it on your own. In the same manner you think, whatever that we have done here, just the previous thing you need to do here. So in the same manner you try to think it and try drawing it on your own. Yeah, so let's get started. So here the breakpoint is at minus 2, here the breakpoint is at 1, breakpoint is at 0, breakpoint is at 2, breakpoint is at 2 and breakpoint is at 3. All are plus t. What does that mean? I should start my journey from minus infinity, right? All are plus t, that means I will start my journey from minus infinity. So if I am starting from minus infinity, then in between what will matter? The least breakpoint will matter to me. So I should adjust in the increasing order. I should adjust my xt in the increasing order of breakpoints. So this is the first one, r of t plus 2. Then the breakpoint will be at 0, 3 ut. Then breakpoint will be at 1, so minus 2 r of t minus 1. Then breakpoint is at 2 plus 2, sorry not 2, plus r of t minus 2 and minus 2 u of t minus 2. Then breakpoint is at 3 minus u of t minus 3. So total 6, there you go. So let's get started. So breakpoint is at minus 2, then directly at 0. So minus 2 I can make somewhere here, then directly at 0, then at 1, then at 2 and then at 3. So previously everything was 0. Then here the slope became 1. Slope became 1 and it remained there till 0. So now the slope is 1. This is the slope 1. So if x is increasing, then y is also increasing. X is increasing by 2, so y should also increase by 2 only. That is the meaning of slope 1, right? At 0 what is happening? Okay, I should make it a bit downward, because at 0 what is happening is that your amplitude increases by 3, right? So let's just say this point is 2, this point is 2. The slope is 1, here the slope is 1. So here your amplitude increases by 3. At t equals to 0, your amplitude is increasing. Here only ut term is there, that means it is increasing by 3. So here it has increased by 3, that means 2 plus 3 it would have reached to 5. 2 plus 3 it would have reached to 5. Slope is not changing. Slope is not changing. Slope remains the same. Slope is 1, so again slope remains the same only. Slope will change at t equals to 1. So here also the slope remains the same. Slope is still 1 only. Slope is still 1. So here for the increase of 1, here what is the slope? Slope is again 1. So in t value if 1 increases, then in y value else also 1 will increase. So this point will be 6. This point is 6, right? Now at 1 what is happening? At 1 what is happening? The slope is decreased by 2. The slope is decreased by 2. Previously your slope was 1. Now 1 minus 2, slope will become minus 1. So now the slope is minus 1. Till what point? Till the point of 2. So till the point of 2 the slope is minus 1. 1 minus 2 the slope is minus 1. Slope is minus 1. What does that mean? That if your t increases by 1, then x of t will be decreasing by 1. So from 6 to 5 you are reaching. Again you are reaching till 5. Now at 2 what is happening? At 2 there are two things. Amplitude decreases by 2 and slope is increased by 1. Here the slope is minus 1, no? Here the slope is minus 1. So amplitude is decreased by 2. amplitude is decreased by 2. So from 5 to it will come down to 3. 5 to it will come down to 3. So amplitude is decreased by 2. Along with that, amplitude is decreased by 2. Along with that, in the slope 1 is also added. So minus 1 plus 1. In the slope 1 is also added. So slope was minus 1 plus 1. So slope will become 0 now. Slope will become 0. Say yes or no. And at 3 what is happening? At 3 what is happening? Only the amplitude is being decreased. So only the amplitude is being decreased. Right? So we are reaching to the point 2. So this is the graph. So each one by one we need to see. Here the slope is 1. Then at 0 what is happening? Amplitude is being increased. The slope remains the same. At 1 what is happening? Slope is decreased by 2. So slope is decreased by 2. So slope was initially 1. Now it has become minus 1. At 2 what is happening? At 2 the slope is increased by 1. That means slope would have become 0. Slope would have become 0 and amplitude is also decreased. Amplitude is also decreased by 2. Then at 3 what is happening? Only the amplitude is decreased by 1. So amplitude has become 2. So there you go. This is the final graph. It will go there till infinity. So this is the final graph. This is how we draw the final graph. Well and good. Now let's understand the concept of area. Okay. So there is this graph is given. What they are calling it? X of t they are calling it. What is the meaning of area? Simply you need to integrate. The meaning of integration is area, or you can say the area is integration. Basically, if I ask you to find minus infinity to minus 4 x of t dt, what does that mean? That you start your journey from minus infinity and reach till point minus 4, and whatever the function you get, try finding the area of that particular function. So minus infinity to minus 4 I need to go. So from minus infinity to minus 4 everything is 0. Say yes or no. So what will be the area? Area will also be 0. Say yes or no. Minus infinity to minus 4 everything is 0. So area will also be 0. Next you need to go from minus infinity to minus 2. Minus infinity to minus 2. So till minus infinity to minus 3 everything is 0. If I ask you what is the value? Minus infinity to minus 3 xt dt. So from minus infinity to minus 3 everything is 0. Now what they are asking? Minus infinity to minus 2. So this point till this point everything is 0. But between minus 3 to minus 2 this much area is there, no? So what is this much area? Height is 1, this height is 1 and this is also 1. So this much area will be 1 only. So minus infinity to minus 2, that means this much area will come into action. So minus infinity to minus 2 area will be 1. Area is 1. What about minus 2 to 2? Minus 2 to 2. This is your minus 2, this is your plus 2. So this much area you need to find. So try finding this area. Try finding this much area. How will you find this much area? So this structure you can see, right? Right. What is the area of this structure? 1 by 2. 1 by 2. Addition of parallel lines. 1 plus this height is 1 and this height is 2. Addition of parallel lines into the height. This height is 1. So this area is 3 by 2. Or what you can see, there are two type of structure. One is this structure, other one is the triangle. So what is the area of this particular structure? That is 1. And what is the area of the triangle? Half into base into height. So from here as well you are getting 3 by 2. Simple area of your square and triangle that you can add. Right? Or it is known as paralleloid. So for that your area is half into addition of parallel lines into height. So addition of parallel line 1 plus 2 3 into height is 1. So basically this area is 3 by 2. So this much area is 3 by 2. What about this area? This area is 2 into 1. This area is 2. What about this area? The same kind of area would be there. Half into addition of parallel lines. Addition of parallel lines 2 plus 1 3 into height. Height is 1. So this area is also 3 by 2. What about this area? This area is also 2. So from minus 2 to 2, what is the complete area? From minus 2 to 2, the complete area is 3 by 2 plus 2 plus 3 by 2 plus 2. So 7. Right? Now 2 to 3. 2 to 3. How much is this area? Again you can see 1 by 2, addition of parallel side 2 plus 1, 3 into height. So this area will be 3 by 2. Right? And now next what they are asking, from 2 to 4. From 2 to 4. So this area plus this area. How much is this area? You can see this point is minus 1. You can see this point is minus 1. So how much is this area? 1 by 2 into base into height minus 1. So this area is minus 1 by 2. So in this area, this much area would be added. So what will be the total area? 3 by 2 minus 1 by 2. Because here the area is negative, no? So 3 by 2 minus 1 by 2. So total area would be 1. So there you go. This is the concept of area only, because if I am saying you need to integrate, that means you just need to take the area. So minus infinity to minus 4, there was nothing. Minus infinity to minus 2. So this particular structure was coming. Then between minus 2 to 2. Between minus 2 to 2, this much structure was coming. So all the area we calculated. Then 2 to 3. 2 to 3, this area was coming. And then 2 to 4. 2 to 4. So answer would be 3 by 2. Okay. So this was the concept of area. Very, very simple concepts we are going to see. Why did we see it? Because now we need to see the concept of running integration. What we need to see? Concept of running integration. What do I mean by running integration? You already know what is the integration, but what do I mean by running integration? So let's just say I am defining a function which is x of tau. If I am writing x of tau here, that means I need to define it with respect to tau. X of tau versus tau. That means if the value of tau changes, then x of tau will also change. So this is how I am defining it. So how will I define my running integration? So that I will define minus infinity to t x of tau d tau. You are differentiating this function. Sorry, you are integrating this function, and the limit is from minus infinity to t. So you let me know. Let's just say my answer is y of something. So this y will be a function of t or tau. This y will be a function of t or tau. Here I should write t or I should write tau. What should I write here? Let's just say my x of tau was tau square plus tau. Because if I am saying x of tau, that means it has to be a function of tau only, no? So tau square plus tau, right? Then dot d tau minus infinity to t. If I integrate t cube by 3 plus t square by 2 minus infinity to t. Now this limit I will put here. So what I will be getting? T cube by 3 plus t square by 2, and here there is minus infinity. So minus infinity doesn't actually make sense. So let's just make it some real value, that is 2. Some real value we are making it. Let's just say that value is 2 here. So here I will put the limit of 2. So something 2 would come. So now eventually the function is becoming of t only, no? Because the limit is of t. Basically this limit t will be put here. So limit is of t. That means this function will be of the function of t only. Are you getting this point? Now this limit t could be any value. T could be 1, t could be 3, t could be 4, t could be minus 5, t could be minus 10, t could be minus 11, t could be anything. So basically on this axis, I will take different values of t. I will be starting from minus infinity. If I take t equals to minus infinity, here also I put minus infinity. And then I will take the value of t. Now t is my variable. I can take value of t anything. If I take t equals to minus infinity. So from minus infinity to minus infinity, that means value should be 0. If you integrate anything from minus infinity to minus infinity only, there is anything. So limit is the same only. If the limit is same, that means the integration will become 0. Let's just say here I put minus infinity to 2. This I can put. Then I will integrate from minus infinity to till 2. So all the area I need to find between minus infinity to 2. So this is how we are going to define it. You will understand it. So first point was, the only point here, the major point was to understand that this will be a function of t. Why this will be a function of t? Because this is a function of tau. And in the tau, if I am putting any value t, that means eventually it is going to be a function of t. Now this t is variable. This t I can put anything. I can try putting it 0, 1, anything I can put. So t I will be sweeping. I will be sweeping the value of t from anywhere. From minus infinity to till plus infinity, I will sweep the value. So now we need to do the running integration of ut. Here what is your x of tau? It is u of tau. So we need to do the running integration of u of tau. from minus infinity to t u of tau d tau. So I'm saying that after the running integration, I'm getting the function to be x of t. So what I can do, first let t equals to minus infinity only. I am thinking that my t is minus infinity. So what I will say, x of minus infinity is equals to minus infinity to minus infinity u of tau d tau. What will be the answer? 0 only. Now I am saying let t equals to minus 10. So what will be my x of minus 10? What will be my x of minus 10? So minus infinity to minus 10 u of tau d tau. You just let me know one thing, minus infinity to minus 10. What is the area between all these things? Everything is 0. Area is again 0. C. Let t is equals to minus 0.01. T equals to minus 0.01. So what will be the value of x minus 0.01? So minus 0.01. Here will be your minus 0.01. So minus infinity to minus 0.01. Everything is again 0. So what will be the answer? Everything will be again 0. Just 1 second, guys. Yeah, so from here, what conclusion you can make? If the value of t is negative, or you can say if the value of t is less than 0, the point is, if value of t is less than 0, then x for every t less than 0, for every t less than 0, it will be 0 only. Because if you put t to be less than 0, that means here if you do the integration, everything will be 0 only. Say yes or no. Are you able to understand this point? Right? Because t value I can sweep. T is on my hand. I can put minus infinity, minus 10, minus 0.01, and in that manner I was sweeping. So I started my journey from here. I kept on seeing and I got to know that everything is 0, 0, 0, 0, 0 only. Now I will sweep more. Right? Now I will start putting the positive values. So I need to add a page. Okay, I am having the page already. Yeah, so let t is equals to 0.5 now. So what you are going to do? In place of t, I am putting 0.5. So what will be my x of 0.5? Minus infinity to 0.5 u of tau d tau. What will be the answer? I need to come from minus infinity to 0.5. Let's just say this is my 0.5. So how much is this area? How much is this area? This area is 0.5 only, right? 1 into 0.5, this area is 0.5. So x of 0.5 is coming to be 0.5. Let t is equals to 1. So x of 1, what will be the value? Minus infinity to 1 u of tau d tau, right? X is equals to 1. So minus infinity to 1 you need to come. That means this much area you need to calculate. This much area. What will be this much area? This much area will be 1 only, right? Let t equals to 1000. T equals to 1000. So what will be your x of 1000? Minus infinity to 1000 u of tau d tau, right? So minus infinity to 1000. Let's just say this place is 1000. This place is 1000. So if this place is 1000, how much area I need to calculate? This much complete area I need to calculate. So 1 into 1000, the area would be 1000 only. So what you are seeing here, whatever the value that you are putting here, that is coming out. That is coming out. That is coming out. So for t greater than 0, for t greater than 0, what you are getting? X of t for t greater than 0 is equals to t. So here what is the conclusion you can make if I need to define x of t? So how will I define it? It is equals to t for t greater than 0 and it is equals to 0 for t less than 0. Have you seen this kind of function anywhere? Have you seen this kind of function anywhere? Anywhere in your complete journey, have you seen this kind of function? Yes. For t greater than or equals to 0, it is t. For t less than 0, it is equals to 0. Say yes or no. And what is this? This is your ramp function. So whenever you integrate a step function, what you are getting? You are getting a ramp function, right? So from here, what is the conclusion you can make? That I am taking the running integration of u of tau. Why I am writing tau here? Why I did not write t? I cannot write like this, minus infinity to t u of t dt. Why is that so? Because this function is of t only and you are taking the limit of t as well. Is that possible? Basically, if I say t square by 2 dot dt and 2 to t, this does not make any sense. This integration does not make any sense because your function is also of t and your limit is also of t. No, that's why I introduced another variable, that is u of 2. Now I am taking the limit to t, so this t will be put here and your final answer would be becoming r of t. You need to remember it. So the running integration, people will say that integration of step function is ramp function. That is wrong. Running integration with respect to t, running integration of a step function with respect to t is your ramp function. Are you getting this point? Okay. Running integration of a step function with respect to t is your ramp function. So from step to ramp, if we need to go, that means I need to do the integration. So this is what is written. So in the waveform, how I will do the integration? In the waveform, how I will do the integration? So here, this point is 0. So I will start my journey. Whenever I need to do the integration, I will start my journey from minus infinity only. So I started from here, everything was 0, 0 only. So when I was doing the integration, everything is 0, 0, 0 only. Then what did I see? There is a jump of 1. There is a jump of 1, that means now the slope will be 1. Integration means slope. Basically, if I integrate 1 dot dt, if I integrate 1 from 0 to t, what I will be getting? T only. Same thing is happening here. If you integrate 1 from 0 to t, what you are getting? T only. So here the slope is of 1. Let's just say if this value was 2, if this value was 2, then what would have been the slope? 2, right? Here you would have put 2. So what you have got? 2t. So you just need to see this jump. Here if the value is 2, then the slope will be 2 only, right? We will see this kind of example, but as of now, only you need to see the simple step, and from step you are getting ramp. Okay, we will see all those examples. We will build up the problem solving ability as well. From step 2 we are going to ramp. Here the jump was of 1, so the slope became 1. Well and good. Let's integrate this particular function. Try doing it on your own. You can do it. Let's integrate this particular function. U of tau plus 2 d tau. Either you can make the diagram. What will be the diagram of u of tau plus 2? U of tau plus 2 will be somewhat like this. U of tau plus 2. This will be your u of tau plus 2. Say yes or no, right? And then you need to integrate. So if I integrate, what will happen? I will start my journey from minus infinity only. Everything is 0, 0, 0. Till this point, everything is 0, 0, 0. So everything will be 0, 0, 0 only. Everything will be 0, 0 only. At minus 2, what do you see? There is a jump of 1, right? There is a jump of 1. Let's make it interesting. Here I put 5. Okay. If I am putting 5 here, so there is a jump of 5. So now what will happen? There will be a ramp of slope 5. There will be a ramp of slope 5. Right? There is a jump of 5, that means there is a ramp of slope 5. So this will be your x of t. X of t, because you are doing the running integration, right? Slope 5. So what I am getting? This point is minus 2 only. So can you define your x of t? Yes. Slope of 5 starting from minus 2. So 5 r of t plus 2. So simply, if you just put this t here, there you go. Your answer is done. You just need to put this t here and you need to replace this u with r. How will I remember? Whatever the limit is there, I just need to put this t here and I just need to replace u with r. My answer will be done. I don't even need to make this waveform. Or what I could have done other way. I need to calculate this thing, right? Minus infinity to t u of tau plus dot d tau. Can I assume tau plus 2 as k? Okay, I am assuming tau plus 2 as k. So how my limit will go? If tau is equals to minus infinity, then your k will also be equals to minus infinity. And if tau is equals to t, then your k will be equals to t plus 2. Right? And from here what I can see, d of tau is equals to dk. So u of k, d of k from minus infinity to t plus 2 is equals to x of t. What will be the answer for this one? In the previous channel, here what did we do? U of tau d tau. Whatever the limit was there, we put it here, replaced u with r. What we are going to do here, whatever the limit is there, u of k dk is there, whatever the limit is there, that we need to put here, and u will be replaced with r. So r of t plus 2. This could be the other way. Basically, I know the answer of u of something, d of something. This answer I know with the limit of minus infinity to anything. So this here I need to put, and u should be replaced with r. So what will be the answer? R of t. So this here I need to put, t plus 2 I need to put here, u will be replaced with r. Or directly you could have done that this t you can put here and u will be replaced with r. But there is a catch in this method. That catch we will find out. Okay. Certainly there is a catch in this method that t is put here and u is replaced with r. There is certainly a catch, and that catch we will find out. So don't worry about that. Okay. Because we will solve more example. This was just one of the example. Solve this question. This is very straightforward. This you need to put here and you will be getting the answer. So what will be the answer? T minus 2, r of t minus 2. Or you can draw by the diagram as well. That my function is u of tau. My function is u of tau. This is my u of tau. But now I am not integrating. My limit is not of t. My limit is t minus 2. My limit is t minus 2. Are you getting this point? My limit is t minus 2 this time. What does that mean? That if I put the value of t equals to 2, let's just say if I put the value of t equals to 1. So what will be the value of t equals to 1? So here t equals to 1 I need to put minus infinity to 1 minus 2 will be minus 1 only, u of tau d tau. So minus infinity to minus 1, everything is 0 only. So that is equals to 0. So at t equals to 1 what we are getting? 0 only. X of 1 is coming out to be 0. Are you getting this point? Here the limit is t minus 2. That means this limit is going backward. If I put t equals to 1.99, so what will be the value of x? 1.99. So here what we are going to put? Minus infinity, put 1.99 minus 2. So here what will be the value? 0.01, u of tau d tau. So from minus infinity to minus 0.01. So what will be the total integration? 0 only. So till 1.11 value is 0 only. If I put t equals to 3, so x of 3, so minus infinity to 1, u of tau d tau. So minus infinity to 1. So in this part, how much this integration? That is 1 only. So x of 3 is equals to 1. What will be x of 4? X of 4. Put 4 here, it will come out to be 2. Put 4 here, that means the limit will be from minus infinity to 2. So this value will be 2. So it will come out to be 2 into 1, it will come out to be 2 only. So x of 4 will be 2. X of 3 is coming out to be 1. And before that everything would be 0. So what do you think, what is this? X of t is equals to r of t minus 2. It is your r of t minus 2. Why is that so? Because if you draw the graph of r of t minus 2, that means it will be starting from 2. R of t minus 2. It will be starting from 2. And after that, it will be rising with the slope of 1. So here the slope is 1. This point is 2. So at 3, how much you will be getting? At 3 value you will be getting 1. So at 3 the value is 1. At 4 what will be the value? 4 value will be 2. Because if the increase is 2, then here also the increase will be 2. So at 4 you are getting value 2. At 3 you are getting value 1. So in that manner this is r of t minus 2. So by that diagram as well we have verified it. Simply I need to take the values of t and then I need to see the running integration. Or I just told you the method that whatever that is there, just put it here. That's it. Say yes or no. Okay. Try doing both of them on your own. Try doing this one as well. This is very simple actually. Whatever that is there, just put it here. That's it. So r of t minus 3 plus 5. So r of t plus 2. Now try doing this one. Here you will find something interesting. If you directly put it here, then the answer will be wrong. So first draw the diagram for this one. Okay. First draw the diagram. Then take the value of t. Take the limit t. Take the limit t to be, first take the value to be minus 1, or take the value to be minus 3, take the value to be plus 1. Then see something different you will see here. Okay. Solve it using the diagram. Okay. Try solving it using the diagram. I will pause the video. You try it on your own. solve this video using the diagram. Solve this particular problem with the diagram. Don't directly put it here. If you directly put it here, you will get something wrong. Are you getting this point? So solve it using the diagram. You will see something good, interesting point. Yeah, so let's get started. Let's draw the diagram of u of 2 tau plus 3. U of 2 tau plus 3. So 2 tau plus 3 are here. The breakpoint will be at minus 3 by 2, right? So here will be the breakpoint. Breakpoint is at minus 3 by 2. And this is 1. This is your u of 2 tau plus 3. And this is your infinity only. This axis is t. So you need to integrate t plus 2 is written here, right? T plus 2 is written. So let's start. Let's just take x2 equals to, let's take t to be minus 3. Not minus 3. Let's take t to be minus 4. I am taking t to be minus 4. So what will happen here? Minus infinity to minus 2. Whatever that is there, minus infinity to minus 2. Minus infinity to minus 2. Minus 2 will be somewhere here. Answer would be 0. What about x2 of just before minus 3 by 2? I take something. So let's take minus 1.5111. Okay, minus 1.51. This is your minus 1.5. So minus 1.51 would be somewhere here. So what will be the answer? 0 only. x2 of, let's take 1.6. Minus 1.6, sorry. Minus 1. Oh, sorry. Really sorry. Here t plus 2 is written. No, really sorry. T plus 2 is written. T plus 2 is written. So what value I should take? T plus 2 is equals to minus 3 by 2. So t is equals to minus 3.5. So let's take the value to be, and this should be less than minus 3 by 2. So t should be less than minus 3.5. So let's take the value to be minus 3.51. So if I take the value to be minus 3.51, then here what will come? Minus 3.51 plus 2. So it will be minus 1.51. Minus 1.51. So whatever that is there, it will be equals to 0 only, right? Because minus 1.51 will be somewhere here. Because your this value is minus 1.5. This value is minus 1.5. So till minus 1.51, everything will be 0. Now let's take x2 to be minus 3.49. Minus 3.49. So minus 3.49 plus 2, it will be minus 1.49. Minus 1.49 d2. So now minus 1.49 would be somewhere here. So the gap is 0.01. So this value will be 0.01. Let's take more example. x2 of, let's take t equals to 3. So if I take t equals to 3, what I am getting? Minus infinity to 5 dot d2. So here what will be the value? 5. Basically minus infinity to 5 you need to integrate. So between 5 to minus 3 by 2, how much value is this one? This is 7.5, right? So 7.5 into 1, this much area I need to calculate. 7.5 into 1, the answer is coming out to be 7.5. Let's take the example of x2 of 0. What will be the value of x2 of 0? So what will be x2 of 0? x2 of 0 I am talking about. So your x2 of 0, so minus infinity to 2. Minus infinity to 2. So 2 plus 3 by 2, it would be 3.5. So value will be 3.5 here. Are you getting this point? X of 0 is 3.5. You are able to understand this, right? X of 3 is 7.5. So what do you think? What is your x of t? X of t. What do you think? What is your x of t? Let's add another page. Or what I can do, I can just take this down. So from here what I can see is that till 3.5, if t is less than minus 3.5, if your x is t is less than minus 3.5, it is coming out to be 0 only. And for greater than minus 3.5, what is happening? It is coming out to be, if t is greater than minus 3.5, so it is coming out to be t plus 3.5. Say yes or no? T plus 3.5. Because at 0, x of 0 it is 3.5. X of 3 it is 3 plus 3.5. Can I write down it as 3 plus 3.5? No, it will be 6.5. Yeah, it is actually 6.5 only. This is actually 6.5 only. Really sorry. Because 5 plus 1.5 will be 6.5. So this is actually 6.5 only. Yeah, so it is coming out to be t plus 3.5. So for t greater than minus 3.5, it is coming out to be t plus 3.5. So how will the diagram look like? So before minus 3.5, everything is 0. Before minus 3.5, everything is 0. After that, there is a slope of 1. After that, there is a slope of 1. Slope of 1 is there. At minus 3.5, this will be 0 only. After that, the slope of 1 is there. Slope of 1 is there. So what is the answer? Your x of t is equals to r of t plus 3.5. This is the answer, right? This is the answer. Now this we have solved by the complete method. We have taken all kind of integration and all these kind of things. But actually how we could have done it? If I could have done it directly, so my x2 of t was actually minus infinity to t plus 2, t plus 2, u of 2t plus 2 plus 3 d2. Now if I had directly put this t plus 2 here, then what I would have got? R of 2 t plus 2 plus 3. So the answer would be R of 2t plus 7, and that is equivalent to 2r of t plus 3.5, right? Because 2 I can take outside. So this is wrong actually. This is your wrong answer. So how will you get the correct answer? For getting the correct answer, what you need to do? For getting the correct answer, the thing is, what you need to do is that minus infinity to t plus 2. Now you need to reduce it to the least possible form. Reduce this particular expression to the least possible form. So how I will reduce it? U of tau plus 3 by 2. How did I reduce it? Because I know that u can eat up this 2. So this is how I have reduced it. Now once I have reduced it, now I can put this value. Basically this tau should be alone. This tau guy should be alone. If you are putting this value directly here, then this tau guy should be alone. This tau should not be having anything with it. This factor of 2 should not be there. Now I can directly put this t by 2 here. T plus 2 here. So what I will get? R of t plus 2 plus 3 by 2. So the answer is R of R of t plus 3.5. Yeah, now this answer is correct. So what is the method? Are you able to understand? What is the method? The method is this toe should be alone. My target would be to make this toe alone. That's it. If my toe is alone, then whatever the limit is there, I can directly put it here. Now what about this question? What about this particular problem? In this particular problem, toe is alone, no? Toe is alone. So directly I can put this limit here. So what I will be getting? R of 2t minus 3. And I can replace this as 2r of t minus 3 by 2. So if I see my toe alone, then my job is done. If I don't see this toe alone, then I need to make it alone, and then I can directly put the limit. Are you getting this point or not? Okay. Let's see next examples. Is your toe alone? No. So first target would be to make this toe alone. So minus infinity to 2t plus 1. How can I make this toe alone? Basically take this 2 outward. So what you are getting? Toe minus 3 by 2 d2. Now what I can do? I can directly put the limit. So what will be the answer? R of 2t plus 1 minus 3 by 2. So what you are getting? 1 minus 3 by 2 will be minus 1 by 2. So R of 2t minus 1 by 2. 2r of t minus 1 by 4. That is your x4t. Okay. So what did I do? I just made it alone. 2 goes out, so I just made it alone. So R of 2t plus 1 minus 3 by 2, R of 2t minus 1 by 2, then this 2 goes outward, this 2 can also go outward, or this option can also be mentioned. Basically, both of the options can be mentioned. This can also be mentioned. Both are your final answer. Right? I just took this outward and this is the final answer. Okay. So that's why we studied about the reduced form. Like I was again and again saying that you can eat up this 2. So why I was again and again saying it? Because here I knew that it will be used. Okay. Otherwise, you will have to do this process. This process is not tough, but you make the diagram, then you think about it. Okay, t plus 2. Okay, t value this much I am putting, then this value I am putting. How did I thought of these values? I thought of these values with respect to this minus 1.5, because I know that if this limit is less than minus 1.5, then the value will be 0. If this limit is greater than minus 1.5, then the value will be something else. So that's why this is how I thought of it. Say yes or no. So the x2 of 0, x2 of 3, then I thought of it, then I got to know that if t is less than minus 3.5, everything is 0. If it is greater than 3.5, then the answer is coming out to be t plus 3.5. Then I got this expression. Then I show you that how to see the reduced form. So directly I cannot put, I need to make it to the least possible form, then I can put it. Say yes or no, right? Yeah, so let's solve this problem now, x5 of t. So let's solve it with the diagram first, and we have the method as well. But here the interesting point is now u of minus tau is there. So just for your satisfaction, I will solve it with respect to diagram as well. So this diagram I can draw, right? And you will also understand that why this limit is plus infinity now. Because in the previous problem, the limit was always minus infinity to anything, minus infinity to anything, minus infinity to anything. Everywhere the limit was minus infinity to some value. But now the limit is from plus infinity. You will also understand why it is from plus infinity. So this is the graph of u of minus 2. U of minus 2 versus 2. U of minus 2 versus 2. Now if I put the limit from minus infinity to anything, will that make any sense? Let's just say minus infinity to 100, or you can say minus 100. So where will be your minus 100? Minus 100 would be somewhere here. So what would be this area? Minus infinity to 100. The area would be infinity only. The area would be infinity only. So in between the complete area is infinity only. So that doesn't make any sense. You should start your journey from infinity now. Infinity to any value. Yes, now you can calculate the area. Say yes or no, right? So that's why the limit will be, I will start my journey from infinity. Basically, if I put, let's just say if I am putting x of 1, x5 of 1, that means infinity to 1 I am going. Infinity to 1, where will be 1? Here. Infinity to 1 I am going, whatever that is there I don't care. Infinity to 1, what is the area? 0, right? If I put x5 of 0.00001, so infinity to 0.00001, where will be 0.001? Somewhere here. What is the complete area? 0 only. So can I write down one thing? In x of 5, is if t is greater than 0, then it is equals to 0 only. Or you can see by the diagram as well. No, you will integrate, so everything is 0 here. It will be 0. Then you will integrate this part. Here, what is the amplitude? 1. Right? You will integrate this part. Amplitude is 1. So now this kind of integration you will get. Say yes or no. Or we can see from here as well. x5 of, let's check at minus 2. So infinity to minus 2. Where will be minus 2? This will be your minus 2. Infinity to minus 2. How much will be this area? This area will be 2. Right? This area will be 2. x5 of minus 10. What will be the answer? Minus 10 would be somewhere here. How much will be this area? This area will be 10 only. Right? So what you can write down here? If x of 5, if t is less than 0, then it is coming out to be whatever that is written inside, just the negative of that. Whatever that is written inside, just the negative of that. That is coming out. Say yes or no. Right? So can I write down my x of 5t is equals to r of minus t? Because what is the graph of r of minus t? Let's take this downward. Or I could have defined in this manner, that x of 5t is equals to 0 for t greater than 0, and it is equals to minus t for t less than 0. So what kind of graph you will get for x5 of t? x5 of t. Slope of minus 1. For greater than it is 0, slope of minus 1. Slope of minus 1. Slope of minus 1. So what is this? R of minus t. So what is the answer? x5 of t is equals to r of minus t. There you go. So from here, what kind of method we have built up? Just you put this value here. So what will be the answer? U of minus t. There you go. Just you put this value here, nothing else. In this, you will directly put the value here. No. Make your toe alone. Make your toe alone. If you make this toe alone, then only you can put the value, right? So I can do it on the next page. So minus infinity to minus infinity, not minus infinity. Sorry. Here it should be plus infinity. No? Why it should be minus infinity? Because the graph will be looking towards minus infinity already. So you need to start your journey from plus infinity. So it should be plus infinity here. So x6 of t is plus infinity to t u of minus 2 tau plus 3 d tau. So 2 comes common. So what you are getting? Minus infinity to t u of minus tau plus 3 by 2 d tau, right? 2 comes common, minus tau plus 3 by 2. Then this t comes here. So what we are getting? R of minus t plus 3 by 2. This is your x6 of t. This is the answer. Say yes or no. 2 comes here, minus tau plus 3 by 2. Thus now you can put the limit. T I put here, r of minus t plus 3 by 2. And you can do it on your own as well. You will certainly realize what kind of waveform we will get. Breakpoint is at 3 by 2, right? Breakpoint is at 3 by 2. Yeah. Now you will integrate it. Limit was from t only. Yeah. So now if I integrate it, so this is how the integration would come out to be. And what I can write down? R of minus t plus 3 by 2. Because here the slope is minus 1. The slope will be minus 1. So r of minus t plus 3 by 2. So this kind of, oh, with the waveform as well you can see. If I start integrating from here, everything will be 0. Then after that, it will be rising up. Why it is rising up like this? Because the area will keep on adding, right? Area will keep on increasing. So here, this will keep on increasing. And the slope is minus 1. R of minus t plus 3 by 2. What is the slope here? Minus 1 only. And where is the breakpoint? Breakpoint is at 3 by 2 only. So yes, this is the waveform. So in this manner, you can verify in the examination as well. Because in the examination, there will be one question, right? So even if you forget the method, even if you forget anything, that's why I always focus on method, right? Not on the final expression, that not on the final result. I always focus on method as well, that even in the examination, in the worst case, if a very good question is coming and you are forgetting the rules, like whatever that rules that we have built up, then you can go by the conventional method, because in the examination there will be only one question and you can spend time on that. So even if you go by conventional method, you will be able to solve it in the examination. Are you getting this point? So both things are important. The direct results are also important and conventional method are also important, so that you get confident enough in your examination. Let's solve x7 of t. So here what I need to do, this remains as it is. I'm not gonna solve by conventional method. I'm gonna just apply that trick here. What is the trick? That you make this toe alone. So if I'm making this toe alone, what I'm getting? This thing I am getting, right? And then t minus 2 will be put here. So r of minus t plus 2 it will become. Basically t minus 2 you need to put in place of toe. What I am doing, in place of toe I am putting t minus 2. This is what I am doing. So r of minus t plus 2 minus 3 by 2. So what I am getting? R of minus t plus 1 by 2. So that's the answer. Okay. Or you can solve by that method as well. You can draw the diagram and then you can put the limit of t. You can put the values, like these kind of conventional method also you can use. These method also you can use, and you will get the same kind of waveform. Okay. But I have given you a good enough approach that how to get to the final answer. So your x7 of t is r of minus t plus 1 by 2. And you can solve by the conventional method as well. You should try solving it with the conventional method. You will get the same answer with the slope of minus 1 and the breakpoint at 1 by 2. Well and good. Okay. So let's see the next question. You need to integrate, you need to find yt, and then you need to draw xt and yt both. So what I need to integrate, what is my yt? My yt is minus infinity to t x of tau d tau. What is your x of tau? X of tau is u of tau plus 2 minus u of tau minus u of tau minus 2 plus u of tau minus 4 into d tau, right? Yeah, minus infinity. It will work. For this limit should be minus infinity only. Why it is working? because my waveform is looking towards plus infinity this time. This is how my waveform would be looking. So here the limit from minus infinity to t would be good enough, right? Now this is how I can break it down. No, like for every function, I can break down the limit for every function. Say yes or no. For every function, I can break down the limit. What is the answer for this one? R of t plus 2. This t directly goes here. What is the answer for this one? R of t. Then R of t minus 2. And then R of t minus 4. So that's your y of t. This is my y of t. So now let's first draw the x of t and then draw the y of t. And from there we can see that with the help of waveform only I can directly do the integration. With the help of waveform, how I will do the integration, that I am learning now. Okay, so first I am drawing x of t. So this I have already taught you how to draw x of t, and y of t also I have already taught you. So here where are the breakpoints? Minus 2, 0, plus 2 and plus 4. So getting started with minus 2. Getting started with minus 2. Minus 2, 0, plus 2 and plus 4. Plus 2 and plus 4. So at minus 2 it is 1. Then it is 0. And at 2, look, there was amplitude of 1, then 1 minus 1, 0, then another minus 1. That means here now the amplitude will become minus 1. On all these we have spent enough time, so I don't think there should be any doubt. Basically, initially there was a jump of 1, then there was a decrement of 1, then another decrement of 1. Now again there is a jump of 1. So from minus 1 to 0 you will go. So this is my final waveform. Right? This is my final waveform. This is 1, 0 and 1. So let's draw your y of t now. So y of t I will draw, but for now I will draw y of t from the expression that I got. From here, from this expression that I got, now I will draw y of t. So where are the breakpoints? Breakpoints are same only. Minus 2, 0, 2 and 4. Starting with minus 2. First you get the slope of 1. First you get the slope of 1. Before this everything was 0. Then you get the slope of 1. After this, plus 1 minus 1, the slope becomes 0. After this, plus 1 minus 1 minus 1, the slope becomes minus 1. And why it is reaching till 0, that also I will tell you. Here what is the slope? Slope is plus 1. Here what is the slope? 0. Here what is the slope? Minus 1. And now in minus 1, plus 1 will be added, plus 1 slope will be added, so it will become 0. So this will be your y of t, right? This will be your y of t versus t. So minus 2, 0, 2 and 4. If slope was 1, so this point would have been 2. Right? 2 and 2. And this point would have been 0 only. So this is the waveform. But what you are understanding from here, this y of t, first I integrated it and then I made the expression. But what you are actually understanding here, if x of t is given, can I directly draw the y of t without even writing down any expression? Yes. I will start my journey from here. Then I see there is a sudden jump of 1. That means there is increase in the slope by 1. There is increase in the slope by 1. Then I will see that there is a drop of 1. That means the slope would have been decreased by 1. So initially the slope was 1. The slope would have been decreased by 1. That means slope would have become 0. Are you getting this point? What I am doing? From here I am starting. I saw there is a jump of 1. There is a jump of 1. That means slope will be increased by 1. Now there is a decrement of 1. That means slope will be decreased by 1. So slope would become 0. Then there is another decrement of 1. That means slope would have decremented by another 1. So slope would have become minus 1. Then there is an increment of 1. That means slope would have become from minus 1 to increment of 1. That means slope would have become 0. Are you getting this point? So let's solve a lot of example. After that you will be comfortable with this particular analysis. So if I need to integrate this, how will I integrate this? How will I do the integration? -2, -1, 0. Then 1, 2, and 3. Okay. So let's get started. Before -2, everything is 0. Then there is a increase of 1. If there is an increase of 1, that means slope would have increased by 1. Then there is a decrease of 1. So here the slope is 1, right? Here the slope is 1. Here the slope is 1. So now there is a decrement of slope. Slope would become 0 now. Say yes or no. Then again there is a increase of slope. Again there is an increase of slope. From 0 to the slope will increase. So slope will become again 1. Again the slope is 1. Are you getting this point or not? You just need to get started from here. There is an increment of 1, that means slope will become 1. There is a decrement of 1, so now the total slope will become 0. 1 minus 1, 0. Now again there is an increment of 1, then again the slope will become 1. Now there is again a decrement of 1, then again the slope will become 0. Then again there is an increment of 1, again increment of 1. After that, again there is a decrement of 1, then again the slope will become 0. So slope will become 1, 0, 1, 0, 1, 0. In that manner, the waveform will go. So this is how we do the integration. Are you able to understand these parts or not? Increase, constant, increase, constant, increase, constant. Why it is happening? Because here the slope is becoming 0. That means there is a decrement of slope. What about this one? How this waveform will go? What do you think? So have the patience and draw the final waveform. This point is -2. This point is -1. This point is 0. This point is 1. This point is 2. And after that there is no breakpoint. So let's get started. Initially, what do I see? I started from here. There is a jump of 1. That means the slope will be 1. No doubt about that. Slope will be 1. Here there is a jump of 1, so slope will be 1. And this point will be 1 only. Right? Because x value increased by 1, so y value will also increase by 1 only. Now there is a decrement of 2. Initially there was an increase of 1. Now there is a decrement of 2. That means, what does that mean? The slope would have become -1. So now the slope is -1. So where it will reach? Till 0 it will reach. Why it is reaching till 0? Because the slope is -1. Slope is -1. So if x increases by 1, then y should decrease by 1. The slope is -1. After that, again the slope is +1. Because again there is a decrement of 2. So now the slope is -1. There is a increment of 2. So slope will become +1. So slope again became +1. Now again there is a decrement of 2. So now slope is +1, decrement of 2, that means slope will become -1. Slope will become -1. Now again there is a increment of 2. So currently the slope is -1, increment of 2. What does that mean? The slope will become 1. So this is how it is going. +1, -1, +1, -1. And are you able to understand why this is happening? Yes, you are able to understand it. Say yes or no. Right? Can you do for this one? Try doing it on your own for this particular waveform. Try doing it on your own. I will post the video. You try it on your own. Yeah, so let's get started. Yeah. So -3. This point is -2. Then there is 0. Then there is 2. And then there is 3. Right? Okay. So now I will start my journey from backward side. Everything was 0 here. Then there was a sudden jump. That means slope would become +1. Slope has become +1. So in the increment of 1, this point will be 1 only. Because if this is increasing by 1, then y should also increase by 1. Slope became +1. So here the slope is +1 now. Here the slope is +1. Now what will be the slope? +1 -2. Because sorry, +1, then there is a decrement of -3. From here there is a decrement of -3. So +1 -3. Slope will be -2 now. Slope will be -2. So that means if there is a decrement of 2, then if there is increase of 2 in x by 2, then y should be decreased by minus 4. So from 1 minus 4, you will reach at minus 3. You will reach at minus 3. Right? 4 divided by 2, you will reach at 4 divided by 2, that means the slope is minus 2. Okay. Now there is an increment of 2. There is an increment of 2. So already the slope is minus 2. Already the slope is minus 2. So minus 2 plus 2, the slope will be 0. Or you can directly see that here, what is the value? Value is 0, that means slope will be 0. Next, at 2, what is the value? Value is 2, that means slope will be 2. So if there is an increment of 1, here in the x there is an increment of 1. So what will be the increment here? That will also be 1. So you will be reaching towards minus 2. And after that the slope will be 0. So this is how you can make the waveform. So this will be the waveform. This point will be minus 2 only. How did I make it? First I see the jump of 1, or you can see the value as well. 1 minus 2 0 2. So slope will be 1, then minus 2, then 0, and then again it is, the slope is 2, sorry, the slope is 2. Slope is 2. Really sorry, here the slope should be 2. Between 2 to 3, the slope should be 2. If the slope is 2, that means for the increment of 1, y should increase by 2. So it will reach till this point. And then slope is 0. So here what will be the slope? Slope will be 2. Here the slope is 0. And here also the slope is 0. Right? So what is this point? This point is minus 2. This point is minus 2. Well and good. Are you able to understand? So in the same manner, there is a jump of 1, slope is 1. There is a decrement of 3. So 1 minus 3, the slope will be minus 2. Then there is a jump of 2. There is a jump of 2. So already the slope is minus 2. Minus 2 plus 2, the slope will be 0. Then again there is a jump of 2. Already the slope is 0. So 0 plus 2, slope will be 2. And then there is a decrement of 2. So already the slope is 2. So 2 minus 2, slope will be 0. In that manner you can remember. Or anyway, in the worst case, if you forget this method, like even I will forget this method in the examination. So in the examination, what I'm going to do? I'm going to take a random example. This example I am taking, u of t plus u of t minus 2. I know how I will make the waveform. This is how I will make the waveform. U of t plus u of t minus 2, or here I can take 2. So 1, 3, this will be the waveform. And I know that what will be the integration r of t plus r 2r of t minus 2. What does that mean? The slopes are being added. Initially the slope was 1. Then if there was an increase of 1, that means now the slope will be 3. So initially the slope was 1, then the slope is becoming 3. So I will make this waveform on my own, then I will make this waveform on my own. From here I will make the conclusion. What is the conclusion I am making? The slopes are added. So here amplitude was 1, slope was 1. Here amplitude is 3, the slope is 3. So this kind of conclusion I can make in the examination. Then any big waveform I can make it. So amplitude is 1, slope will be 1. Amplitude is minus 2, slope will be minus 2. Amplitude is 0, slope will be 0. Amplitude is 2, slope will be 2. Amplitude is 0, slope will be 0. In that manner. Say yes or no. Okay. So in the examination, worst case could be that you forget every method and don't remember any method. Till this point, I am not asking you to remember anything in the complete course of signal system. You just need to see it and forget it. That's it. When you come back, when you revise it, it will take minimum of time. You will see that, okay, this kind of method we used. We need to see the slope. Then in that manner, we need to proceed. That's why I say in signal system, you don't need to remember anything till this point. Whenever, like, there would be certain things which I will ask you to remember so that your problem solving skills would be increased. But in signal system, I don't think there is anything that you should keep in mind or you should remember. Okay. These kind of method you don't need to remember. There you can take a random example and you will get to know that whatever the amplitude is there, that is the slope. So slope is 1, minus 2, 0, plus 2 and then 0. Okay. Let's do the differentiation. So if I already know my integration is, if you integrate u of t, you will get r of t. So if you differentiate, so from here what do I get to know? That if I differentiate my ramp function, so what I will get? Step, right? So from r of t to, if I am going to u of t, that means I need to differentiate. And from u of t I need to go to r of t, that means I need to integrate with respect to 2. Say yes or no, right? How will you do the differentiation? So differentiation simply means slope. Okay. What is the meaning of differentiation? Differentiation simply means slope. So this is your r of t. So till this point the slope was 0. Then what was the slope? Slope became 1. There you go. So differentiation, meaning of differentiation is simply the slope, nothing else. What is the meaning of differentiation? Differentiation meaning the slope. That's it. Okay. Let's take an examples. What will be the differentiation of this guy? R of t differentiation I know that is u of t. R of minus t will be differentiated as u of minus t, but minus t will also be differentiated, so minus 1 will also be added here. Basically, what is the differentiation of x of minus t? What is the differentiation of x of minus t? So that will be x dash of minus t, and then internal thing will also be differentiated, no? So minus sign will come here. Say yes or no? You have seen it, right? So same thing is happening here. R of minus t. Differentiation of R of minus t is minus u of t. R of minus t is minus u of t, and this will also be differentiated. So minus sign will also come. So what will be the total answer? Total answer will be minus of u of minus t. Right? And you can see by the waveform as well that this is my waveform of R of minus t. R of minus t. And one more thing I would like to add is that whenever we do the differentiation, we will always move from minus infinity. Minus infinity. You can move from infinity as well, but we will move from minus infinity. So when I was standing at minus infinity, how much slope did I see? When I was standing at minus infinity, how much slope did I see? I saw the slope to be minus 1. And till this point, till 0, always the slope was minus 1 only. Always the slope was minus 1. After 0, how much the slope became? Slope became 0. After 0, the slope became 0. So what is this function? What is this function? This is function is u of minus t. Say yes or no. So what is the answer we are getting? The same answer we are getting. So either you can solve by the simple differentiation method, or you can solve by the waveform as well. What about this one? Differentiation of r of 2t plus 3. What is the graph of r of 2t plus 3? Breakpoint is at minus 3 by 2. So this will be the graph of r of 2t plus 3. If you differentiate, what you will say? That sir, till minus 3 by 2, I saw the slope to be 0. But after that, the slope is 2. After that, the slope is 2. So what you are getting? 2u of t plus 3 by 2. Here, this what is the slope of this graph? 2, no? 2t plus 3. The slope of this graph is 2. So till minus 3 by 2, so the slope was 0. After that, the slope became 2. So how you can solve it? So u of 2t plus 3. But this inside function should also be differentiated. So what is the differentiation of basically d by dt? What is the differentiation of 2t plus 3? So inside function is also being differentiated. So what answer you are getting? 2u of 2t plus 3. And what could be the reduced form of this? 2u of t plus 3 by 2. So this is the reduced form. Okay. Or by the diagram as well you can see, or any method you can see. What about this one? You need to differentiate it. So what you are getting? u of minus 2t plus 3, and then differentiated the inner one, so it would be minus 2. What about this one? U of minus 3t minus 4, then differentiated the inner one, you will get minus 3. And by the diagram as well you can see it. So enough method I have taught. In that manner you can see. Let's solve some questions. So again, xt is given, you need to find yt and you need to draw xt and yt. And from there we will make the conclusions. Okay, so first you need to differentiate. So what will be your yt? Differentiation of this guy, that would be u of t plus 2. What will be differentiation of this guy? U of t. What will be differentiation of the next guy? U of t minus 2. And what will be the differentiation of next guy? U of t minus 3. Can I draw my y of t here only? Yes, I can draw my y of t here only. I need to see the breakpoints. Breakpoint as minus 2, 0, 2 and 3. I need them in increasing order only, and they are already placed in increasing order only. Okay. So this is your minus 2, this is your 0, this is your 2, and this is your 3. At minus 2, there is an increment of 1. Then there is a decrement of 1. So I will come to 0. Then again there is an increment of 1. And then again there is a decrement of 1. So 1, 0, 1 and 0. This is my yt I am getting. But how will I make it directly from the waveform? Let's see that. So first I will make the waveform of x of t. Okay, I need to add a page. I need to add a page. I am adding a page. I need to draw the waveform of x of t. And then on below only I will draw the waveform of y of t as well. minus 2, 0, plus 2, plus 3. Minus 2, 0, plus 2, and plus 3. So slope is 1, then minus 1. First the slope is 1. 1 minus 1, the slope becomes 0. The slope is 1. Then another minus 1 is there, so slope becomes 0. After that, what is the scene? Another plus 1 is there, so slope became again plus 1. And then another minus 1 is there, so slope became 0. Slope is 1, and here the slope is 0. Say yes or no. Okay. And what did I tell you? What is the meaning of differentiation? Differentiation simply means slope, nothing else. What is the meaning of differentiation? Differentiation meaning slope, nothing else. Okay. So you just need to see the slope. So started at minus 2. At minus 2, how much slope I see? Plus 1. So it would be plus 1. Then from 0 to 2, how much slope I see? 0. 0. So the meaning of differentiation is only the slope, nothing else. In the next lecture, I will change the meaning of differentiation. There I will say that the meaning of differentiation is slope along with sudden change. The meaning of differentiation is differentiation equals to differentiation is nothing slope plus sudden change. But as of now in this lecture, we are not seeing the sudden change, right? In this waveform, do you see any sudden change here? No, there is no sudden change. 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 So in the next lecture, we will study about impulse function. And after that, we will see the sudden change as well. And then we will do the differentiation. So differentiation only means two things, slope and sudden change. That's it. So here the slope is 0. Then next, what is the slope? Slope is 1. Then next, what is the slope? Slope is 0. There you go. This is your waveform. Okay. This is your minus 2. This is your 0. This is your 2. This is your 3. 1, 0, 1 and 0. There you go. This is your YT. Say yes or no. Well and good. Do this differentiation. You can do it directly. You can do it very easily. You can do it. How will you do it? What did I tell you? The meaning of differentiation is just the slope. In integration, you might need to think a bit, but in differentiation, you don't need to think even a single thing. Just you need to say the slope. What is the slope here, sir? 1 by 1. Slope is 1. Basically, this value is 1, this value is also 1, slope is 1. What is the slope here, sir? Slope is 0. What is the slope here, sir? The slope is, the amplitude decreases by 1.5. This also increases by 1.5. The slope is minus 1. What is the slope here? The slope is plus 1. And what is the slope here? 1 divided by 0.5. The slope is plus 2. And what is the slope here? Slope is 0. Right? 1 divided by 0.5, slope is 2, 0. So let's get started. So minus 2 is not a breakpoint. Minus 2 is not a breakpoint. Breakpoint is minus 1. Because at minus 1, slope is changing. At minus 2, no slope is changing. Here also the slope is 1 only. So always the slope was 1. Till the point minus 1, always the slope was 1. Then slope became 0. Till which point? Till the point of 1. Slope became 0. Then slope became minus 1. Till what point? Till 2.5. Till 2.5, the slope became minus 1. Then slope became plus 1. Then slope became plus 1. Till the point of 3. Then slope became plus 2. Then slope became plus 2. And after that, it all became 0. It all became 0. So this was 1, then 0, slope became minus 1, then slope became 1 here, the slope became 2, and then slope became 0. What was this point? This point was 3, and what was this point? This point was 3.5. And there you go. This is how you draw the waveform. This was your x of t, we can say, and now differentiation y of t. So from this lecture, you are understanding that differentiation means nothing but slope. That's it. So that's it about our ramp function. We have seen integration, differentiation. We have seen how to synthesize the waveform. We have seen everything regarding our ramp function. These kind of integration we have seen. In the integration, what is the final conclusion? In the final waveform, here we made a conclusion that whatever the amplitude is there, that would be the slope. Slope of 1, then slope of minus 2, then slope of 0, then slope of 2, then slope of 0. Okay, that increase decrease you don't need to see. Increase decrease you don't need to see, you just need to see the amplitude. Amplitude is 1, then slope is 1. Amplitude is minus 2, then slope is minus 2. Amplitude is 0, the slope is 0. Amplitude is 2, the slope is 2. And amplitude is 0, then slope is 0. Right? So this is how you can integrate and differentiate. Now we need to study about triangular function. Okay, what we need to study about triangular signal. So in the last lecture we studied about step and then we studied about a rectangular. So now there is a triangular signal. So that is given by 1 minus mod of 2 divided by 1 for the value of t being between minus 1 to 1, otherwise it is 0. You are not able to understand this. Can you draw the graph of this one? 1 minus mod of 2, mod of t, sorry, 1 minus mod of t. What is the graph of mod of t? This is the graph of mod of t. What is the graph of minus mod of t? This is the graph of minus mod of t. And then it should be shifted by 1. So if it is shifted by 1, but it is there till the limit of minus 1 to 1 only, rest of the time it is 0. So this is how you draw the graph. Right? Or what you can see, at t equals to 0, what will be the value? 1. At t equals to minus 1, what will be the value? At t equals to minus 1, the value will be 0. And at t equals to plus 1 as well, the value will be 0 only. Are you getting this point? At t equals to 0, this is your t. And this is your triangle tri-t, rect t or tri-t. So if you put t equals to minus 1, what will be the value? Tri-t value will be 0. If you put t equals to 1, tri-t value will be 0. If you put t equals to 0, then tri-t value will be 1. So this is how we can make our diagram, right? So this is our tri-t. How I can denote it? Previously for rectangular, what did I do? Rect t minus center upon time width, right? So what do you think what I will do for tri now? Tri t minus center time width of one side, t minus center, t minus 0. What is this? This is equivalent to tri t minus 0 divided by 1. So what is 1? 1 is the time width but of one side only. So t minus center divided by time width of one side. So yes or no? Are you getting this point? And another point what do I see is that from tri of minus t, that is equals to tri of t as well. Why is that so? Tri of minus t is equals to tri of t as well. Why is that so? You can see in the waveform as well. What will be your tri of minus t? That means mirror image about y-axis. If you take the mirror image, you are getting the same thing. Tri of minus t, that means mirror image about y-axis. So you are getting the same thing only. So tri of minus t is equals to tri of t. So that means it has also ability to eat up this negative sign. Same was with rect as well. Rect of minus t was also equals to rect of t. So rect was also having the ability of eat up the negative sign. So now if I ask you 3 into triangle minus t minus 4 divided by 3, can you draw the waveform of this one? What I need to draw? 3 tri minus t minus 4 divided by 3. So I know one thing, it has the ability of taking up the negative sign. So 3 tri minus t plus 4 divided by 3. So it has the ability of taking the negative sign. So what you will be left with? 3 tri t plus 4 divided by 3. Okay. And what did I tell you? T minus center. T minus center. Where will be the center? Center will be at minus 4. T minus center divided by the width of one side. So center will be at minus 4. Minus 4. Then width. Width of one side is 3. So minus 4 plus 3, that will be minus 1. And minus 4 minus 3, that will be minus 7. Width of one side. And center will be at 4. Okay. So amplitude is 3. So this is your x of t versus t. T minus center. Center is at minus 4 and time width. time width of one side. So one side width would be this 3. So either you could have gone by this way, that sir 3 try minus t by 3 minus 4 by 3. So first you start from here, 3 try minus 4 by 3 you do, then time domain which should be multiplied with 3, and then you take the inversion. So this thing you could have done, or you already know t minus center upon time width of one side, time width of one side, time width of one side. So time width of one side will be 3 only. So this 3 and another 3. So total width will be 6, right? And center will be at 4. And what did I do? It can eat up the negative sign. So it has eaten up the negative sign as well. So 3 try t plus 4 by 3 it was, center at minus 4 with the time width of 6. Well and good. And magnitude is also 3. So this is how I am doing the final answer. So let's keep it there as it is and let's remove it. So that's it about the triangular function. We will be using all these things in our, where we will be using it? In Fourier transform. That's why we are studying it here. Okay. In Fourier transform, I will use my triangular function again and again, and rectangular function as well. So yeah, that's it. So I hope you enjoyed this lecture. Although the lectures are pretty big, I know, but these are very simple actually. You just need to see it and then solve it. That's it. I don't think there is too much to understand here. This is simply mathematics. So with me also you are doing the same things and you are learning certainly something new. Even if you have already studied signal system, I know there are 10 new things you are at least learning from these lectures. Okay. Thank you very much. The same kind of thrill we will use in our transform as well. We will use in our Fourier series, Fourier transform, Laplace transform, jet transform, everywhere we will use it. Okay. Thank you very much. Hi everyone, welcome back. So till now we have studied about step signal and we have studied about ramp signal. We also studied about rectangular pulse and triangular pulse as well, right? Now we are going to study about impulse signal, a very important signal. So first we will just define it, okay? Just hold on to next 25 to 30 minutes. After that you will have a very clear idea of impulse signal, that what does it actually represent. So have the patience here. So first I am just gonna define it. How do I define it? How do I define it? So step signal is given by delta t. Okay, delta t. It has the infinite amplitude at t equals to 0 and otherwise it is 0. The other thing, when you do the integration of delta t from minus infinity to infinity, your answer would be 1. So basically the area of impulse signal is 1. What I mean to say is that area of unit impulse. Unit impulse means here I am not multiplying anything. So that's why it is known as unit impulse. Basically I have multiplied 1 here. So that's why I am saying that unit impulse it is. So area of unit impulse is 1. So slowly you will understand everything about this particular impulse signal. Okay, so have the patience. So this is how I am representing my delta t. Now there is infinite amplitude. So how do I show the infinite amplitude? So I will show the infinite amplitude by somewhat like this arrow. Okay, I am showing it by this arrow. So at t equals to 0, I am having infinite amplitude, but the area is 1. So usually when we define impulse signal, we always write down the area, but this is not the amplitude. You will not say that this impulse is having amplitude 1. No, this is having amplitude infinity, but the area 1. So you will show this 1, and this 1 will tell that it is the area, not the amplitude. You are certainly going to understand the meaning of this impulse signal. Certainly you will understand that, but have the patience. Are you able to understand the definition? That at t equals to 0, it will be infinity. At rest of the points, it will all be 0. Here everything is 0. Only it is defined at t equals to 0. So at t equals to 0, it is having infinite amplitude and the area is 1. Here I have written minus infinity to infinity delta t dt is equals to 1. If I write down 0 minus to 0 plus delta t dt, what would be the value? What do you think? I have said that from minus infinity to plus infinity, you take the complete area, that area would be 1. Why it is 1, we will understand this. Okay, don't worry about it. But I am saying that from minus infinity to infinity, complete area is 1. If I ask you from 0 minus to 0 plus, what will be the area? Your impulse signal is defined between 0 minus to 0 plus only, no? Say yes or no. So even if you take the area from minus infinity to infinity, or you take the area from 0 minus to 0 plus, it will still be 1 only, no? Say yes or no. Are you able to understand this point? Right? Because it is defined between 0 minus to 0 plus only. Now if I ask you from 0 plus to infinity delta t dt, what will be the answer? From 0 plus to infinity. From 0 plus to infinity. Is there anything? No, everything is 0 only, no? From 0 plus to infinity. It is strictly defined at t equals to 0 only. It is strictly defined at t equals to 0. So from 0 minus to 0 plus, that means t equals to 0 is there in this window. If I am saying 0 minus to 0 plus, that means t equals to 0 will be existing in this window. But if I am saying 0 plus to infinity, 0 plus to infinity, that means t equals to 0 does not exist in this window. So what will be the answer here? 0. Are you getting this point? Okay. So we will see all these points again and again. Don't worry about that. But I was just telling what is the meaning of area here. Either you can define from minus infinity to infinity. In some textbook you will find that it is defined from 0 minus to 0 plus. Both are the same thing only. Well and good. I can define it from 2 minus to 2 plus as well. Like basically I can say that minus 2 to plus 2 delta t dt. What do you think? What will be the answer? Here is your minus 2, right? Here is your plus 2. In between there is an impulse. So what will be the answer? 1 only, right? So anyway I can define it. But you will remember this definition, that what is your impulse signal? What is your impulse signal? This is the definition of impulse signal. That's it. That at t equals to 0 it is giving you infinite amplitude, otherwise it is all 0, and the area of the impulse signal is 1. Let's understand the meaning of impulse signal by an example. So if you have studied network analysis, then you would know that what is the meaning of charge. So charge is given as, in your basic elementary classes as well, in class 11, 12 as well, you would have seen it. Basically you would have seen it, it equals to dq by dt. Have you studied it? Right? So if I need to write down qt from here, basically I need to write down the charge, then what will be the equation of charge? I tau d tau, and then integration I need to do from minus infinity to t. This will be the equation of charge. So equation of charge is given by this. This you would see in network analysis as well, and you would have studied it in your elementary classes as well. Now I am saying that from this source IT current is getting out. I know the equation of current. I know the waveform of current. These are the waveform of the current. I know the waveform of the current. I need to find the total charge supplied by this source. What I need to find? Total charge supplied by this source. So what is your charge? Integration of current. And what is the meaning of integration? Meaning of integration is the area. So you need to find the total charge. That means you need to take that total area. Because what is your Q? What will be your Q total? Q total will be from minus infinity to infinity it dt, right? Whatever the area it is enclosing, that will be the total charge supplied by the source. So here how much area it is enclosing? 1 multiplied with this window is also 1. So 1 multiplied with 1. So how much area it is enclosing? 1 coulomb. So the charge supplied will be 1 coulomb here. Say yes or no. What about this one? What will be the charge supplied here? What is the area enclosed here? 2 into this window is 1 by 2. 2 into 1 by 2. So here also the charge supplied will be 1 coulomb only. What about this? What is the area enclosed here? 4 into 1 by 4. 4 into this window is 1 by 4. So what is the charge supplied here? 1 coulomb. What about this one? Now the time window is delta. Time window is delta and minus delta. So what is the time window here? 1 by 2 delta. And what is the amplitude? Sorry. The time window is 2 delta. Really sorry. The time window is 2 delta. And what is the amplitude? 1 by 2 delta. So what is the charge supplied here? 1 coulomb only. So here also the charge supplied is 1 coulomb. So what do you think what I am doing? Here you are giving 1 ampere current. Here you are giving 1 ampere current for 1 second of time. I was giving 1 ampere current for 1 second of time. And my charge supplied was 1 coulomb. So what I can say, to supply a charge of 1 coulomb, I need to give 1 ampere of current for 1 second. To supply a charge of 1 coulomb, I need to give 2 ampere of current for half second. That means if I am decreasing my time window, if the time window is decreased, here it was 1 second, here it was half second. So if the time window is decreased, now to supply the same amount of charge, I need to give more current. Here I needed to give 1 ampere, here I needed to give 2 ampere. Now what I am doing, I am shrinking my time window more. So how much time window I have? How much time window I am having now? I am having the time window of 1 by 4 second only. So now I am having the time window of 1 by 4 second only. So now my value of current got increased more. In all the cases, we are applying the same amount of charge. 1 coulomb, 1 coulomb, 1 coulomb and 1 coulomb. In all the cases, we are applying same amount of charge. That is 1 coulomb only. But if I am shrinking the time window, that means the amplitude of my current is increasing. Here I needed to give 1 ampere current, here I needed to give 2 ampere current, here I needed to give 4 ampere current, here I needed to give 1 by 2 delta current, here delta value I don't know. Now what if I make the delta value to be 0? I am making delta to be 0. That means this point will be coming towards 0 only, and this point will also be coming towards 0. 0 minus 0 and 0 both are same thing only, no? And where this point will go? 1 by 2 into 0. This point will go to infinity. That means you need to give very large amount of current. To supply the same charge, you need to give very large amount of current now, because your time window is 0. Your time window is 0. So you need to give very large amount of current, and that current is having an amplitude of infinity, but the area is 1. Area is 1. Area is 1 only. So here the area is 1, but the amplitude of the current is infinity. Are you getting this point? Slowly, more point you will understand here. More point you will understand. Have the patience. Okay. Here what we were doing, here we were supplying 1 coulomb of charge, but in the time window of 1 second. So your current was 1 ampere. Here we were supplying 1 coulomb of charge. Basically, what is your IT? IT is dq by dt, right? IT is dq by dt, right? So if I write down the current value here, so I was supplying 1 coulomb of charge. dq value is 1 coulomb in the time window of 1 second divided by 1 second. So what was my current? 1 ampere. So yes, here my current was 1 ampere. In this case, what I was doing, I am supplying 1 coulomb of charge. 1 coulomb of charge means previously the charge was 0. Now I am supplying 1 coulomb of charge. So the change in charge is 1 coulomb divided by how much time I took? 1 by 2 second. So what was my current? 2 ampere, right? Here I am supplying 1 coulomb of charge, but how much time I took? I took the time of 1 by 4 second. So what was the current here? 4 ampere. Here I was supplying 1 coulomb of charge. dq is 1 coulomb. dt, how much time I took? 1 by 2 delta. So what was my current? 1 by 2 delta. Say yes or no, right? But in the next case, here I am just removing it off because this is not useful. Here in this case, current, I am supplying 1 coulomb of charge. Current is equals to dq by dt, right? Current is equals to dqt by dt. I am supplying 1 coulomb of charge, but in the 0 time, the time window is 0 now. At that moment only I am supplying 1 coulomb of charge. So how much current is flowing? Infinity. And this infinity amplitude means delta t. Wherever you get infinity amplitude, that means delta t is there. Are you getting this point or not? So this is the meaning of impulse. Impulse means right at a moment only you are supplying something. That's it. At that particular moment you are applying something, and that's it. So if I do this thing, that what is the value of it dt from minus infinity to infinity? That will be 1 only, because here you can see the value of integration in all these cases, minus infinity to infinity, it dt is 1 only. In all these cases, the integration value is 1 only. Say yes or no. So I did nothing. First I was applying 1 ampere current for the window of 1 second. Then I had to increase the current. If I shrink the time window, if I am giving the current for half second only, to apply the same amount of charge, I need to give more current. Now, if I am shrinking the time window more, so if I am giving the charge for only 1 by 4 seconds, so I need to apply more current. Now, if I am giving the current for 0 time, that means now I need to give infinite current. So that means I need to apply delta t current. If I am applying the delta t current, then my charge would have been 1 coulomb. Are you getting this point or not? Okay. So we will understand it more. We will understand more depth about it. No need to worry about it. Okay. So this thing you have seen, and also you have seen here the current is delta t. And this is how we are defining our impulse, that we are completely shrinking it, and when I make it 0, at that time it goes to infinity. Okay. So this is the definition of your impulse with delta t tending to 0. Sorry, not delta t, delta tending to 0, or delta t also you can say, delta tending to 0. Okay. Now can you tell me one thing? Delta of minus t is equals to delta t or not? Say yes or no. Delta of minus t is equals to delta t. Because if you take the mirror image of this, what will be delta of minus t? What do we do when xt is given and we need to make x of minus t? We take the mirror image. So what will be the mirror image of this guy? The same guy, right? Mirror image of this impulse will be, because it is at 0 only, no? So the mirror image will be the same only. At 0 only it will be the mirror image. So mirror image will be the same. So delta of minus t is equals to delta of t. Say yes or no, right? So delta has the ability of eating up the negative sign. Delta has the ability of eating up the negative sign. Okay, so we will see more about it. Let's understand by more example. Now what they are saying, you need to deliver 5 coulomb of charge in no time at t equals to 0. Let's just say I give 5 coulomb of charge. Let's just say I give 5 coulomb of charge in 1 second. What I am saying, I am giving 5 coulomb of charge in 1 second window. 5 coulomb of charge in 1 second window. That means it is minus half second. This is plus half second. So how much current I need to give? Basically, this area has to be 5 coulomb, right? This area has to be 5 coulomb. So what is this area? X into 1 should be equals to 5. So here x value should be 5 ampere. So you need to give 5 ampere current. You need to give 5 ampere current. 5 ampere into 1. So you need to give 5 ampere current. If you give 5 ampere current for a window of 1 second, then you are supplying 5 coulomb charge. Say yes or no. Then you are supplying 5 coulomb charge. Say yes or no. Now if I am shrinking down all these things, if I am shrinking down this time, if I take this time to 0, so how much current I need to apply? Infinity. That you already know. But what will be the area? Area will still be 5 coulomb only, no? What I mean to say is that, what should be the area? Minus infinity to infinity, it dt. What should be the area? Area should be 5 only, no? Are you getting this point? Minus infinity to infinity, it dt. That should be 5 only. In this case, the area was 1. Because I was supplying 1 coulomb of charge. But now I am supplying 5 coulomb of charge. So now area has to be 5. Or what you can say, what should be my it? What is it? dqt by dt. So your charge is changing by 5 coulomb. Basically, initially your charge was 0. Now your charge is 5 coulomb. And how much time you took? 0 second. So what you are getting? 5 by 0. So it is coming out to be 5 by 0. Or can I write down 5 into 1 by 0? What is this 1 by 0? 1 by 0 is delta t. 1 by 0 is delta t. So what I am getting? 5 into delta t. So what is the current? Current is 5 into delta t. So it is 5 into delta t. And if I do the integration, minus infinity to infinity, it dt. So what I will get? Minus infinity to infinity, 5 into delta t dt. So what I can do? I can take this 5 outside, because 5 is constant. And what is the value of minus infinity to infinity delta t? That is 1. So what I am getting? 5 only. So what is the value of integration I am getting? 5 only. So are you able to understand? If I was applying 1 coulomb of charge, that means I need to give delta t current. But if I am applying 5 coulomb of charge, so I need to give 5 into delta t current. So that is the meaning of area now. Are you able to understand the meaning of area now? So if I had a window of 1 second, then I need to give 5 ampere current. That means the area is 5 coulomb. Similarly, if I have the window of half second, that means I need to give 10 ampere current. If I have the window of 1 by 4 second, that means I need to give 20 ampere of current. If I have a window of 1 by 8 second, that means I need to give 40 ampere of current. But if I have a window of 0 second, that means I need to give infinite current. But in all these cases, the area would be 5 only. So my current has to be 5 into delta t. Or you can understand by this example that 5 coulomb charge is being changed in 0 time. That means your current has to be 5 delta t. Say yes or no. Well and good. Understood? Okay. A very good concept. Like, I hope now you are actually understanding the meaning of impulse. And when we study network analysis, there more concept about impulse current will be, or impulse function as well, it will be cleared. Okay, about impulse current or impulse function, a lot of concept will be cleared there, because in the capacitor, impulse current is very important. And at a lot of places, you might have already studied, but a lot of places they do not discuss impulse current in a good manner. They will just say that amplitude is infinity. But what is the meaning of infinite amplitude? So you should understand the meaning of infinite amplitude. Why there is infinite current? Because in no time I need to apply something. So in no time, in zero time, I need to apply something. That means it has to be infinity. Like, have you heard the word impulsive thought? Impulsive thought or impulsive decisions. Like taking electronics engineering was an impulsive decision from my side. It was an impulsive decision. Was it an impulsive decision? It might be an impulsive decision because you just saw that I got this rank and I am getting EC there, so just go for it. So that decision you took in zero time. You just thought that I should go for EC and that's it. That was an impulsive decision. So there was one thought. There was one thought for zero time. So the area was 1, but the impact is infinity, right? Now you are preparing for gate. The impact is infinity, but the area was 1, and in zero time you took that particular thought. The same thing is happening here. The area is 5 coulomb. In zero time, you need to give infinite amount of current, but the area is 5 coulomb only, right? Yeah, so that's the meaning of impulse. Let's see more things about impulse. So the relation between EMF and flux is given by EMF equals to d phi by dt. Now what they are saying, if flux is increasing by 4 unit in no time at t equals to 0, then find the EMF. So EMF would be, flux is changing by 4 unit. Flux is changing by 4 unit in no time at t equals to 0. So increases by 4 unit. That means initially the flux was 0. Let's just say I am saying that initially the flux was 0. Let's make the waveform. Let's make the waveform of the flux. So at t equals to 0, what they are saying? At t equals to 0, what they are saying? Initially, I am assuming they did not give what was the flux initially. I don't know. So I am saying that initially my flux was 0. Now at t equals to 0, what happened? Initially the flux became 4 unit. Suddenly the flux became 4 unit. Here previously it was 0. Now suddenly the flux became 4 unit. So this has happened in this particular scenario. Now what is your EMF? So it was changed from 0 to 4. 4 minus 0. In how much time? In 0 second only. In 0 second only. So what will be your EMF? 4 divided by 0. So EMF will be 4 delta t. Say yes or no. EMF is simply d phi by dt. So if you differentiate this particular function, what you will be getting? What did I tell you? Differentiation means simply slope, right? What I need to do? D phi by dt I need to do, right? And what is the meaning of differentiation? I told you differentiation meaning the slope. So what is the slope here? 0. Slope is 0. Slope is 0. What is the slope here? Here also the slope is 0. But what is the slope at t equals to 0? At this window, what is the slope? What is the meaning of slope? dy by dx. So the change in y is 4 and the change in x is 0 only. So what is the slope here? Infinity. So slope here is infinity. And what is the meaning of infinity? Infinity means impulse. The slope after t equals to 0, it is 0 only. Before t equals to 0, it is 0 only. But at t equals to 0, at t equals to 0, what is the line? At t equals to 0, you are having this kind of line. Sudden jump is there. At t equals to 0, you are having a sudden jump. At t equals to 0, you are having a sudden jump. So at t equals to 0, what really happened? Previously you were having 0. After that you are having 4. Right? So sudden jump from 0 to you went to 4 in 0 time only. So that means what should be the amplitude? Infinity amplitude should be there, no? So here we are having infinite slope. At t equals to 0, I am having infinite slope. This slope is infinity. What is the meaning of differentiation? Differentiation simply means slope. So here the slope is 0. Here also the slope is 0. But here the slope is infinity. At t equals to 0, the slope is infinity. And what is the meaning of infinity? Wherever you see infinity, that means it is delta t. And what will be the area? Since it is going from 0 to 4, the area would be 4 only. So 4 delta t. Are you getting this point? Let's just say it would have gone from 2 to 6. This could have also been the case, no? They just have mentioned that flux is increasing by 4 unit. This could have also been the case that initially it was 2, now it became 4. So what was the slope here? Constant value, slope is 0. What was the slope here? Constant value, slope is 0. But at t equals to 0, okay, it is changing by 4 unit, that means it has to be 6, right? So constant value, slope 0, constant value, slope 0. But at t equals to 0, there is a jump of 4 unit in no time. That means infinity. So it has to be impulse. What is the area? What is the jump there? Jump of 4 is there. So it has to be 4 delta t. So this function is 4 delta t. So more points you will understand. Slowly you will understand more point about impulse, right? So have the patience, because here I could have simply given you the definition of the impulse and then I would have proceeded in the video. But this is not something I want. Okay, I want you to give the actual concept of impulse, because that is a very important part. Even if you become a VLSI engineer or wherever you go in your complete electronics, the importance of impulse is very, very, very important, because these impulses change our complete circuitry. Now the same question is there, but now the flux is decreasing by 4 unit. So what do you think? What will be your EMF? So what do you think? What would be your EMF? So let's just say initially my flux was 0. Finally, how much flux I am getting? It is decreased by 4 unit. That means now I am getting minus 4 flux. Say yes or no. Are you getting this point? We can draw the waveform. Initially it was 0. Then it became minus 4. From 0 to it became to minus 4. This was your flux. If you do the differentiation, slope 0, right? But from 0 to minus 4 it is going. That means it is decreasing. From 0 to minus 4 it is going. In how much time? 0. So what you are getting? Minus 4 by 0. So your EMF is minus 4 by 0. So minus 4 into 1 by 0. What is 1 by 0? Delta t. So minus 4 delta t. So what is your EMF? EMF is minus 4 delta t. And how will you show this minus 4? So now the area is minus 4. Basically the area is minus 4 now. So if the area is minus 4, so this is how I will show it. Area is minus 4. So negative impulse I am showing. This simply means the area is negative. The amplitude is infinity only. You can say amplitude is infinity or minus infinity. But negative impulse simply shows that something is decreasing. Something is decreasing. Okay. So flux is decreasing by 4 unit. Then what will be your EMF? Minus 4 delta t. Okay. So here the area is minus 4. In that manner I can show it. So this will be my EMF. EMF as a function of t. So EMF t. No, it is not EMF t. EMF t. EMF t course is available completely for free on YouTube. You can cover it in a very good manner. I am just doing the promotion. You can cover it in a very good manner and you will just love the content. Okay. EMF t completely you can study. Okay. Oblique incidence, transmission line, a very different kind of analysis you will get. A very, very different kind of approach you will get if you study EMF from YouTube itself. You can study from there if you want to. Yeah. So let's get back to our topic. So your EMF is minus 4 delta t, because here the flux is decreasing by 4 unit. Okay. So let's get back to our mathematics now. So now there is a very good idea of impulse signal. This is not the end of impulse signal. We will see it in Fourier transform as well. We will see it everywhere. A lot of time it will be introduced in network analysis. It will be introduced everywhere. Even in EMFT, I have tried to introduce impulse at least once. Okay, I will try to introduce impulse in certainly it will be introduced in communication system as well. I will introduce it certainly in analog electronics. A lot of places I will introduce the impulse. In digital electronics as well, somewhere I will try to introduce the impulse function. Okay, so it will be again and again used. I hope now you have a actually clear idea that what is the meaning of impulse. What is the actual meaning of impulse? In no time you are applying something pretty big. In 0 time you are applying something pretty big. That is known as impulse. Well and good. Okay. So just answer me this thing. Xt is equals to 5 delta t. So what is the area of minus infinity to infinity xt dt? What do you think? What is the area? 5 dt. Okay. So 5 I can take common. This we have already seen actually. Right? Delta t dt. And what is the area of this? The area is 1. So what you are getting? 5. That's the answer. And what will be the answer of this guy? Minus 5 will come. Same approach, you know. Did to the same approach. Minus infinity to infinity. Minus 5 delta t dt. So here what will come out? Minus 5 will come out. Delta t dt. And what is the area of minus infinity to infinity delta t dt? That is 1 only. So what will be the answer? Minus 5 will be the answer. So basically here it tells that the area is minus 5. Here it tells that the area is 5. So if you see A delta t and I ask you what is the amplitude of xt? What is the amplitude of xt? A? No. Amplitude of xt is infinity only, but the area is a. Say yes or no. If in the, just I will ask you one more question. If you have already studied network analysis, then you can tell. If I say it dt, and here I have made an impulse. Okay, impulse I have made. बन जा भाई. Impulse I have made, and here I have written 4. Okay, on the impulse I have written 4. What is the unit of this 4? What is the unit of this 4? I want you to answer this. What is the unit of this 4? Here what do you write? This is the area. What is the meaning of area? This 4 is actually minus infinity to infinity it dt. So this 4 has a unit of ampere into second. Say yes or no. 4 is the area, right? 4 is the area. It into dt. Let's just say my current was something x and my time window was something y. So my it into dt, this particular thing would have been x into y, and that is equals to 4. So x is having a unit of ampere and y is having a unit of second. So what is the unit of 4? That is ampere into second. The unit of 4 is not ampere, because 4 is not the amplitude. Amplitude is infinity here. 4 is the area. So if I ask you what is the unit of this 4, so that would be ampere into second, because this shows the area. So what is the meaning of ampere into second? That is coulomb. Say yes or no. The unit of this 4 is coulomb. Are you getting this point? Okay. So unit of this 4 is coulomb. Although all these points I have completely taught in network analysis course. Okay. If I apply a impulse voltage, if I apply a impulse current, then what will happen to the capacitor? In RC circuit, in transient analysis, we don't discuss impulse very often, but it is very, very, very important. Next year, IIT Madras is going to frame the question paper. Okay. And today I am telling there would be a lot of questions simply from the concept of impulse. So if you are studying from any other resource, you can study from any other resource. All teachers are good, but at least cover transient analysis that has been uploaded on YouTube itself from PrepFusion. At least transient analysis you can cover, because like I can tell you 100 different things are there, at least 100. So try covering it from there, because it will be very helpful for your examination. And not only for the examination, it will be very helpful for your masters as well. It will be very helpful everywhere you go. In the industry, even if you go, these kind of concepts will be highly used. So when I teach, my target is never to teach mathematics. Okay, because we are engineers, not mathematicians. So we are not going to learn the mathematics, we are going to learn the actual concept behind that, right? So yeah, certainly problem solving skills are important, but understanding the concept is also very important, because in the examination only the mathematics will not work. And this is what happens with a lot of students. They feel like examination came difficult and all those kind of things, but actually it will all be based on simple mathematics. Yeah, you need to define delta of 2t. So first, can you answer this thing? What will be the value of this? Just answer me this. Try doing it on your own. I will take a pause. If you want to take a pause, you can also take a pause. But answer me this. Minus infinity to infinity delta 2t dt. What will be the answer of this thing? Try doing it on your own. Have patience. Use your brain and then answer. Okay. I will take a pause. You can also take a pause if you want to. Yeah. So do you get the answer? Answer will be 1 by 2. Right. So multiple ways are there. We can solve it. You need to define delta 2t. Basically, this is what I need to define. So I know one thing, that if there is delta, that means amplitude will be infinity. At t equals to 0, amplitude will be infinity, and otherwise it will be 0. This I already know. But this is not the complete definition. The complete definition comes with the integration as well, no? Because I told you, whenever you define impulse function, you need to define the integration as well. So you need to get this data. So what is your answer for this particular data? That is more important now. So multiple ways are there. One, how we can solve. So from where to where I need to go? I need to go from delta t to delta 2t, right? And how do I define delta t? I define delta t in this manner, that its area is 1. If I say this is minus delta, this is plus delta, so this amplitude has to be 1 by 2 delta. Its area is 1. This is how I define my delta t. But if I am saying delta 2t, that means your time domain is multiplied with 2. That means time axis will be divided by 2. And there will be no change in the amplitude. So this will be your delta 2t. Surely your delta tending to 0. There is no doubt about that. Whenever you define delta t, delta tending to 0, that is fine. Now I am defining delta 2t. So what will happen? This will be divided by 2. Because time domain is multiplied with 2, so time axis will be divided by 2. Say yes or no. Now what is the area? What is the area? What is the height? 1 by 2 delta. And what is the width? Delta. So what is the area now? Area is half. So what is the area here? Area will be half. There you go. By simple understanding, we have got to know that our area will be half. So this is the complete definition. Actually, I should not keep it in a box. This is how I should define it completely. That this is the complete definition. Or what I could have done, I need to define this thing, right? Now I will go with the basic mathematics. So can I do one thing, that I can take 2t equals to k, right? I am taking 2t equals to k. So from here I can get to know that 2 dt equals to dk. Now the limit of t is from minus infinity to infinity. Limit of t is from minus infinity to infinity. So if t is minus infinity, then your k will also be minus infinity, because 2 into minus infinity will be minus infinity only. And if t is infinity, then your k will also be infinity only, because 2 into infinity will be infinity only. So limit is not changing. So minus infinity to infinity, delta of, in place of 2t what you will put? K. In place of dt what you are going to put? Dk by 2, right? Because dt is equal, 2 dt is equal to dk. So dt will be equal to dk by 2. So what you are going to get here? 1 by 2, then integrate minus infinity to infinity. This you are getting, right? So what is the value of this thing? 1. So what is the final answer? Half. So by the mathematics also you have proved that answer is coming out to be half. And here also by the diagram, simply by the diagram also you have proved that answer is coming out to be half only. So can I write down one thing, that your delta of 2t is equals to 1 by 2 of delta t, because both will have infinite amplitude. This guy will also have infinite amplitude, this guy will also have infinite amplitude, but this guy will have half area and this guy will have one area, but this complete guy will have half area only. Are you getting this point? The area of this guy is half, right? The area of this guy is half, that I already know. And what about this thing? What will be the value of this particular integration? What will be the value of this particular integration? Tell me. The value of this particular integration is also half only, because half can come common, and then delta t dt minus infinity to infinity is 1. So this value integration is half. And if you define half delta t, that means amplitude will be infinity only. So can I write down delta 2t in this manner? Yes. So this is one very good conclusion I have made, that I have taken out this 2, but this 2 is coming out to be in reciprocal. In place of u of 2t, this 2 will be eaten up. In place of r, this 2 will be directly coming out. But in place of delta, this 2 is coming out to be but in reciprocal. Say yes or no. And is it tough to remember? No, it is not tough to remember, because you would see that, okay, there is scaling in time domain. That means your time domain is multiplied with 2. So your time axis will be divided by 2. So area will be half. So delta of 2t can be replaced by 1 by 2 delta t. Both definition will be same, because in the definition amplitude will be infinity only and the area will be half only. Okay, very interesting point I have made out from here. So these are the interesting point. By mathematics we have seen, by the diagram we have seen, by every single thing we have seen. Now let's go to the next one, delta of minus 2t. Try doing it with the diagram itself. You can do with anything. One thing I told you, delta has the ability of eating up the negative sign. So xt equals to delta of minus 2t. And I told you delta has the ability of eating up the negative sign. So what it will be left with, and what this would be equals to. Or let's go by the diagram. I know how to define my delta t, right? I know how to define my delta t. From where to where I need to go? I need to go from delta t, then I will go to delta 2t, and then I will go to delta of minus 2t, right? This is how I will proceed. I told you always start from here. So let's start. This was my delta t, minus delta here, plus delta here, amplitude of 1 by 2 delta. This was your delta t. Now I am doing delta 2t. Time axis is, sorry, time domain is multiplied with 2, so time axis will be divided by 2. And then there is a negative sign, so I need to take the mirror image. Mirror image will be same only, no? Mirror image will be same, right? If you take the mirror image will be same. So this is your delta 2t. And what you can see from here, that if you take the integration, delta of minus 2t, sorry, because you have taken the negative sign as well. So what do you see from here? If you take the integration, what you are getting? It will be plus half or minus half? It will be plus half, right? Not minus half. Minus sign will not come. Minus sign is not coming into action. Minus sign in time simply means that you just need to take the mirror image. So if you are taking the mirror image, area is not changing, even the graph is not changing. Everything remains the same only. So from here also, what did you get to know? That your delta of minus 2t is equivalent to 1 by mod of minus 2 delta t. Kind of you can say in this manner. So it would be equals to 1 by 2 delta t. So first thing is that first it will eat up the negative sign, and then it will take out the 2 in the reciprocal. There you go. Are you able to understand this point? Certainly you are able to understand. By the mathematics also you can prove it. You assume minus 2t as k, and then limit will be changing, right? You will assume minus 2t as k, then minus 2 delta t will be equals to dk. So minus sign would also be coming. Along with that, limit will also change. Basically, when t is equals to minus infinity, k will be equals to infinity, and when t is equals to infinity, k will be equals to minus infinity. So limit will also change, then there is a negative sign as well, then the same thing will come out. So by the mathematics as well you can prove it, the same answer you are going to get. Okay, so mathematics I am leaving it up to you. Well and good. So let's make the conclusion. U of minus t, is it equals to u of t? Absolutely no. This don't have the ability of eating up the negative sign. Is it equals to r of t, or is it equals to minus r of t? Absolutely not. It is also not equals to u of minus of ut. Basically there is no relation. Minus sign will remain there as it is. That's it. In place of u as well, in case of r as well. But in case of delta, it will eat up the negative sign. In case of rect as well, it was eating up the negative sign. In case of triangular as well, in case of triangular pulse as well, it was eating up the negative sign. Because we have seen the structure, right? This was the structure of rect. This was the structure of triangular. This was the structure of step, and this was the structure of ramp. And this is your delta. So it is eating up the negative sign, right? And what about delta of at? So a could be negative as well, a could be positive as well. So I will write down in this manner, 1 by mod of a delta t. Because let us say delta minus 2t. What that was? 1 by mod of minus 2 delta t. Or delta could be plus as well. So what that was? 1 by 2 delta t. So plus minus anything could be possible. That's why I have written mod of. But you will not be remembering this thing in the examination. What you will see? Okay, there is no negative sign. This 3 can come out. Basically, the area will be 1 by 3rd. Here, it will eat up the negative sign. First, it will eat up the negative sign. Now, this 4 will come out. So, area will be 1/4. There you go. Say yes or no. Well and good. Understood? Yeah. So, now let's define this particular xt. Okay. So, multiple ways are there. What I could have done, simply by some method if I go. So, what I can do, I can take the negative sign common. Along with that, I can take 4 common as well. Why I am doing so? Because I know that it can eat up the negative sign and 4 can go outside, right? Can I do in this manner? Is there any doubt? I took minus 4 common, so t minus 3 by 4 will be left. Now I know that this negative sign will be eaten up and 4 can go outside. It will go outside in the reciprocal. So this is what I can get. Say yes or no. Right? And I already know that what is my delta t. How do I define my delta t? This is how I define my delta t. This is how I define my delta t. With the area of 1, this is your delta t. If I need to make delta t minus 3 by 4, delta t minus 3 by 4, minus 3 by 4 means it should be shifted towards the negative hand side. T minus 3 by 4 means it should be shifted towards the positive hand side. Sorry, there is negative sign, no? So it should be shifted towards the positive hand side. So here it should come at 3 by 4 with the area of 1 by 4 this time. So this is your xt. This is how you can define it. This is your xt. Are you getting this point? Here the area is 1 by 4 now, and the impulse is at 3 by 4. Basically, if you see this equation, what should come into your mind? That's our area will be 1 by 4, and the impulse will be where this thing becomes 0. In delta t, where was the impulse? It was at t equals to 0, right? The impulse was at t equals to 0. Why is that so? Because at what point this t becomes 0? So at t equals to 0. So now t minus 3 by 4. So where will be the break point? Kind of break point you can say. It will be equals to at 3 by 4 only. So that means the impulse will be at 3 by 4. So yes or no? Are you able to understand this point? And you can go by that method as well. Which method? That first you start from here, delta t. Then you go to delta t plus 3. Basically, you start working from this direction. Then you go to delta of 4t plus 3. And then you go to delta of minus 4t plus 3. In that manner you can start. So what is your delta t actually? This is my delta t. That from minus delta to delta with the amplitude of 1 by 2 delta. Then what will be delta t plus 3? Delta t plus 3, that means it should be shifted towards the negative hand side. So what I will be getting? Shifted towards the negative hand side. So minus delta minus 3 minus delta, oh sorry, plus delta minus 3 with the amplitude of 1 by 2 delta only. Then there is a scaling in time domain. That means time axis is multiplied with 4. That means, sorry, time domain is multiplied with 4. That means time axis should be divided by 4. So time axis is divided by 4. Time axis is divided by 4. So this thing is divided by 4. And then you take the mirror image. So if I take the mirror image, what I will be getting? If I take the mirror image, so this will become what I need to do, although it will be tougher. Basically here I need to take the mirror image. So this point will be here. So this point will be minus delta plus 3 by 4, and this point will be delta plus 3 by 4, and the amplitude is 1 by 2 delta. Say yes or no? So what will be the area of this impulse? Obviously, when we are defining all these things, delta tending to 0. This is how we define our pulse, right? Sorry, this is how we define our impulse. How do I define our impulse? That we will make this waveform and we will say that delta is tending to 0. So here also the same thing is happening, but area you need to check. What is the area you are getting? Area you are getting is that 1 by 2 delta, that is the amplitude, into how much is this width? How much is this width? How much is this width? So this width is delta plus 3 divided by 4 minus delta plus 3 divided by 4. So delta by 4 plus 3 by 4 plus delta by 4 minus 3 by 4. So what we are getting? Delta by 2, right? So this width is delta by 2. So this width is delta by 2. So what is the area? Delta get cancelled. Area will be 1 by 4. So yeah, area is 1 by 4 only. So by this basic definition also we can define it, or by our whatever the concept that we have studied, that minus sign will be eaten up by delta and 4 will be coming out in the reciprocal. So by that as well we can define it, and it will be very easy. Otherwise by the basic definition also you can define it, or by mathematics as well you can define it. By mathematics how? I need to do this thing, right? Minus 4t plus 3 dt. This I need to find. So what I can do? Minus 4t plus 3 is equals to k. Then minus dt would be equals to dk. What would be the limit? Limit you put, sorry, minus 4 dt will be equals to dk, not minus dt. Minus 4 into dt would be equals to dk. Then you put the limit. Limit will be interchanged and there will be a negative sign. So same thing you will be getting. Basically after that what you will be getting is that minus infinity to infinity delta k dk by 4. Where did this negative sign go? This negative sign went into making this limit minus infinity to infinity, because if your k is, sorry, if your t is minus infinity, then your k would be infinity. Basically limit of k would go from plus infinity to minus infinity, because if t is minus infinity then k would be plus infinity, and if t is plus infinity then k would be minus infinity, but there would be a negative sign, so that negative sign will interchange the limit. So this will be the answer you will be getting, and the final answer would be 1 by 4 only. So mathematics as well you can define, by basic definition also you can define, and whatever the method we have studied, from that also you can define it. There are n number of ways of every single thing. Say, like the sound for last 6 minutes the sound would have been a bit irritating. Now the sound would be fine, right? Now the sound is pretty good. Are you getting this point? Yeah. So define this thing now. How will you define it? So needlessly this could have gone to previous page as well. क्या बात है भाई? Okay, let's solve it here only. So what do I know? 3 is being multiplied. How I can solve this thing? So what I can do? I can take 2 common, t plus 3 by 2. Then this 2 goes downward. So 3 by 2 delta t plus 3 by 2. So this is your xt. If someone asks you what is this value, then what you will say? This value is equals to minus infinity to infinity 3 by 2 delta t plus 3 by 2 dt. Then 3 by 2 come outward, and I know that if it's an impulse, then its area will be 1 only. So the answer is 3 by 2. So the area is 3 by 2. And how will you make it? You know that the area is 3 by 2, and where will be the impulse? The impulse will be existing at minus 3 by 2. Say yes or no? Impulse will be existing at minus 3 by 2. Because when this becomes 0 at minus 3 by 2, so the impulse will be existing at minus 3 by 2 with the area of 3 by 2. With the area of 3 by 2. Very simple definition. Everything is pretty simple. You could have solved it with the mathematics as well, or you could have solved it with this particular analysis as well. Right? The analysis that I have shown here. Area will come out to be 3 by 2 only. Say yes or no? Okay. So let's write down the final conclusion. What was the ability of u to eat up this 2? So if I take the 2 common, u will be eating it up. So u into t plus 3 by 2. Can I take minus common? No. U of minus t plus 3 by 2. Here can I take minus common? Absolutely no. So there is no meaning of taking the minus sign out, because you cannot eat up the minus sign. Here I can take common, but it will not eat it up, it will just throw it outside. It will just throw it outside. So it is just throwing it outside. Can I take up the negative sign common? Absolutely no. So I can only take 2 common, which will be thrown outside. I can only take 2 common, which will be thrown outside. Say yes or no. What about this one? It will be thrown outside, but in the reciprocal. It will be thrown outside, but in the reciprocal. Now I can take minus common as well, because it has the ability of taking the minus sign. It has the ability of eating up the minus sign. So what you will be getting? 1 by 2 delta of t minus 3 by 2. Here 1 by 2 delta of t minus 3 by 2. And here 1 by 2 delta of t plus 3 by 2. Are you able to understand all these points? Are you able to follow all these points? Certainly you are able to follow all the points, because we have spent enough time on these particular analysis. So better than remembering r of at plus b, a is positive or negative, in that manner a lot of students remember. But better than remembering all these things, what should be in your mind? That I cannot do anything with u of minus t, I cannot do anything with r of minus t. I can do delta of minus t will be equals to delta of t. This is one thing you will remember. Then you will remember that u of 2t, I will just eat it up, ut. R of 2t, the slope will be 2, so that I can just take it out. And for delta of 2t, I will just take it out, because area will be half. So if you remember this, just only these things, then you will be able to answer all these kind of problems. And these are very, very helpful for you. Okay. A good question can be framed from these particular analysis. Say yes or no. Let's move to the next concept, that is we will multiply a particular signal. Xt could be a random signal with a with the impulse signal. What I need to do? I need to multiply a random signal with impulse signal. So this is my random signal. At t equals to 0, it is having the value of x of 0. What I am saying? The signal x at t equals to 0 is having the value that is x of 0. This is what I am saying. And how do I define my impulse? Let's define my impulse with the basic definition. Minus delta to delta with the amplitude of 1 by 2 delta, and delta being minus delta to delta with the amplitude of 1 by 2 delta, with delta being to 0. Say yes or no. This is how I define it. Now if I multiply, so this particular before minus delta, everything is 0. After plus delta, everything is 0. Say yes or no. Basically this particular value will be multiplied with this particular function. So only at 0 the value will be multiplied, no, because this delta is tending to 0. This delta is tending to 0. right? So this particular box, this value 1 by 2 delta will be multiplied with x of 0. Say yes or no. And rest all values, these values, all these will be multiplied with 0 only. So after the multiplication, what you are going to get? After the multiplication, what you are going to get? This is what I am going to get. The delta was nearly equals to 0 only. So 1 by 2 delta, this 1 by 2 delta, 1 by 2 delta got multiplied with x of 0 only. And rest all the values, rest all these values are multiplied with 0. And this point is minus delta, this point is plus delta. All are tending towards 0. All are tending towards 0. So t versus x of t. Now can you just let me know the area of this particular graph? Can you just tell me that it is an impulse only? Yes, it is an impulse only because delta is tending to 0 here. If delta tends to 0, what will happen? This amplitude will be infinite. So amplitude will be infinite. But what is the area here? What is the area? Area will be this width, that is 1 by 2 delta, 2 delta into the height. What is the height now? 1 by 2 delta into x of 0. So what is the area now? X of 0. So your area is x of 0. Now the area has become x of 0. So what will be the multiplication? Xt into delta t. So multiplication is resulting into impulse signal only. But now the area of impulse signal is not 1, it is x of 0. Say yes or no. Are you able to follow this conclusion? What we are doing here? The impulse function was multiplied with your xt. Impulse was 0 for values other than 0. Basically at t equals to 0 only your impulse is defined. For other values it is 0 only. So these values will be multiplied with 0. Now x of 0 will be multiplied with the impulse function. So x of 0 is multiplied with the impulse function. There you go. That's it. This is how it is explained, that x of 0 is multiplied with the impulse function. But this is not the actual reality. The actual reality is x of 0 is multiplied with the impulse function. Now the area of this particular final answer, this is not xt, this is xt into delta t. Xt into delta t. The area of this particular multiplication is coming out to be x of 0. That means it is an impulse only because delta is tending to 0. So amplitude, if I talk about amplitude, so amplitude is still infinity. That means it is an impulse. Infinity amplitude means it is an impulse. But what is the area? Area is x of 0. That's why I have put an x of 0 here. So are you able to understand this point? X of t into delta t is x of 0 x of 0 into delta t. So the point is I can write it down in this manner: x of t into delta of t minus 0. X of t into delta of t minus 0. So this 0 can come here. So it will be becoming x of 0 into delta t. Now same thing if I ask you x of t into delta of t minus 2. So where will be your delta of t minus 2? Your delta of t minus 2 will be defined somewhere here. Because where will be the breakpoint? Breakpoint you can say, or where will be the impulse? Impulse will be at t minus 2 is equals to 0. So impulse will be at t equals to 2. So impulse will be at t equals to 2. And what is the area? Area is 1. Now this impulse will be multiplied with x of 2. Say yes or no. This value will be x of 2. So impulse will be multiplied with x of 2. So if I do the multiplication, what I will be getting? This particular impulse is being multiplied with x of 2, nothing else. So now the area, new area will be 1 into x of 2. The new area would be 1 into x of 2. And that impulse is defined at 2 only. This is my multiplication. Multiplication is x of t into delta of t minus 2. So what I am getting? This impulse is defined at 2 only with the area of x of 2. So what you are getting is x of 2 delta of t minus 2. So this is the final answer of xt into delta of t minus 2. The area being x of 2 and defined, the impulse is defined at t equals to 2. So if impulse is defined at t equals to 2, can I write it down in this manner? Delta of t minus 2. If I draw the graph of delta of t minus 2, will I get the same graph? Yes. So impulse is defined at t equals to 2. So delta of t minus 2. And that is being multiplied with x of 2. That means area is x of 2 now. So this is how I can define it. Right? So basically this was your scene, x of t into delta of t minus 2. So what will happen? This 2 will go here because delta of t minus 2. So this 2 will go here. You will be getting the answer of x of 2 into delta of t minus 2. So are you able to make any conclusion out of it? What is the conclusion? X of t into delta t minus t naught, that would be equals to x of t naught into delta of t minus t naught. Say yes or no. Say yes or no. Are you able to follow this conclusion? So wherever the impulse is existing, wherever the impulse exists, that value will be put in x of t. Are you getting this point? Okay. So this is the conclusion into delta of t minus t naught. So answer me this thing. What it will be equals to? This impulse exists at t equals to 2. So x of 2 delta of t minus 2. What will be the answer here? X of 3? No. This impulse is existing at minus 3, right? Here minus 2 was there, so I wrote plus 2. This impulse will exist if I draw the graph of delta of t plus 3. So delta of t plus 3 will be somewhat like this. Delta of t plus 3 will be somewhat like this. The impulse will exist at minus 3. So this minus 3 will be put here. So x of minus 3 into delta of t plus 3. Say yes or no. This is the graph of delta of t plus 3. Certainly the amplitude is 1 only. Sorry, not amplitude, really sorry, area is 1, amplitude is infinity. Now simplify this thing, x of t into minus delta 2t plus 3. So what I am going to do first, x of t into, either you can make the diagram of this one, or what I will do, delta of, can I take minus 2 as common? Yes, certainly you can take, right? I am taking minus 2 as common. So what I will be left with, x of t into, this will be 1 by 2 delta of t minus 3 by 2, right? Minus 2 I took a common, t minus 3 by 2. Now this minus 2 delta will eat up the negative sign and 2 will come out as 1 by reciprocal. So 1 by 2 delta of t minus 3 by 2. So 1 by 2 is simply a constant value. Can I took it down in this manner? So 1 by 2 xt delta of t minus 3 by 2. Where this impulse is existing? This impulse is existing at 3 by 2. So what will be the answer? 1 by 2 x of 3 by 2 into delta of t minus 3 by 2. So this is how it can be defined. So basically if I write down, so I will see that 2 I can take common, that will be coming out. So 1 by 2 x of t, then impulse will be defined at 3 by 2. So 3 by 2 into delta of t minus 3 by 2. So this is how I can define it. So that's the answer. Okay, this is the answer. So it is nothing but simple mathematics, but you just need to take care of all the things that you have studied. Or you can make the diagram as well. That you make the diagram of this impulse. Then you simply need to multiply it with random xt. Right? Solve these integrations. Make the diagram of delta t. Make the diagram of delta t. So where will be your impulse? Sorry, delta t we need to make, no? So impulse will be somewhere here. This is your delta t. This is the graph of delta t. What is this? Here if I write 1, that means it is the area, right? Area is 1. So from minus infinity to infinity, if I integrate from minus infinity to infinity, I will get 1. If I integrate from minus infinity to minus 2, here will be minus 2. So minus infinity to minus 2, there is nothing. So value will be 0. Are you getting this point? From minus infinity to minus 2, there is no function. Everything is 0 only. So if everything is 0, so integration will also be 0. 2 to infinity. From 2 to infinity, there is nothing. Everything is 0. From 0 minus to infinity. From 0 minus to infinity, where will be 0 minus? Here will be your 0 minus. From 0 minus to infinity, that means this impulse is coming. In between, if this impulse is coming, so answer will be 1. From 0 plus to infinity, where will be your 0 plus? Here will be your 0 plus. So from 0 plus to infinity, this impulse is not coming. So answer will be 0. And from 0 minus to 0 plus, yes, the impulse is coming. So answer will be 1. So if the impulse is there in the limit, then answer will be 1. Otherwise, it will be 0. Say yes or no. If the impulse is there within the limit, then answer will be 1. Otherwise, it will be 0. Well and good. So let's get started and solve these kind of problems. So first, I will solve this particular thing. What this would be? I am not solving the integration. I am only solving whatever that is inside. So can I write it down in this manner? X of 2 into delta of t minus 2. And can I write it down in this manner as well? That x of 2, this will be a constant value. Because on xt, let's just say this is my xt. So at 2, what value I will have? X of 2, which is a constant value. So x of 2 is the constant value that I can take out. So x of 2 minus infinity to infinity delta of t minus 2. So now where will be the impulse? Impulse will be at 2, right? Impulse will be at 2. Impulse will be at 2. Just a minute, guys. I am having some issue in my eyes. Okay, just a second. I need to pause the video. Although you can see that impulse will be at 2 only, no? Impulse will be at 2, and you are taking the integration from minus infinity to infinity. You are taking the integration from minus infinity to infinity. That means impulse is coming into action. And what is the area of this impulse? That is 1 only. So area of this impulse is 1. So this integration is coming out to be 1. So x of 2 into 1, what is the answer? X of 2 only. So for this integration, the answer is x of 2. What about this one? Here the same thing will happen. X of 2, 3 to infinity, delta of t minus 2 dt. Right? This is what we are doing. This x of 2 was the answer of the previous question. So here I should write x of 2. But here you let me know what will be the answer of this integration. The impulse exists. Where does the impulse exist? If I make the diagram of this impulse, delta of t minus 2, delta of t minus 2. So where does the impulse exist? Impulse exists at 2. And now you are taking the integration from 3 to infinity. From 3 to infinity. So there is no impulse there. That means the area will be 0. So what will be the final answer? Final answer will be 0 only. Basically, this particular function is giving you 0 value. So x of 2 into 0. X of 2 into 0. What will be the final answer? 0 only. So the answer for the second one is 0. Answer for the first one is x of 2. In the similar manner, you try all these questions. This one, more questions will be there. Try this one as well. Okay. Try this one as well. And then we will see the differentiation. So try these questions. In between, I will look into my eyes. Okay. Yeah. So did you try this one? In this one, how you will do it? So let xt remain there as it is. What you can do with this one, minus 2 I can take common, then it will come out to be 1 by 2 delta of t minus 2. So yes or no, right? Minus 2 will come out, minus will be eaten up, it will come out as 1 by 2, then t minus 2 will be remaining there. What do you see? 1 by 2 minus infinity to infinity. Now delta of t minus 2, impulse is at 2, so that 2 can be replaced in x. So x of 2 into delta of t minus 2. The impulse will be at 2, you are taking the integration from minus infinity to infinity. So certainly it will be 1 only. So what will be the answer? X of 2 divided by 2. So that will be the final answer. So what is the final answer here? X of 2 divided by 2. That is the final answer. What about this one? Here also minus can come out. So if minus will come out, then it will come out as 1 by 2. Right? Minus 2 will come out, it will come out as 1 by 2. The integration is from minus 2 to infinity. X of t will remain there as it is, and this will be delta of t plus 3 by 2. Right, delta of t plus 3 by 2 dot dt. So where is the impulse? Impulse is at minus 3 by 2. The impulse is at minus 3 by 2. And you are integrating from minus 2 to infinity. Minus 2 to infinity. You are integrating from minus 2 to infinity. The impulse is at minus 3 by 2. So what will be the answer? This minus 3 by 2 will be replaced here. So the answer, what will be the answer? Answer will be 1 by 2 into x of minus 3 by 2. So that will be the answer. Okay, 1 by 2 into x of minus 3 by 2. Say yes or no. So x of minus 3 by 2 will be existing, but the integration minus 2 to infinity, that means impulse will be existing at minus 3 by 2. So that is there in the limit. So if that is there in the limit, then the integration would be 1 only. So 1 by 2 into x of minus 3 by 2 would be the answer. Let's try this one. So first I will solve this particular equation. So let's solve this particular equation. So I is equals to t1 to t2. Then in two questions, different values are given. T1 is 1, the limit is from 1 to 4 and the limit is from 3 to 6. So let's check that out. 5 rect t minus 2 divided by 3. How I can solve this one? Minus 2 I will take common, so it will come out to be 1 by 2 delta of t minus 2 dt. Right? So now 5 by 2 can come out, right? Because 5 is also constant, 1 by 2 is also constant. So 5 by 2 can come out. T1 to T2. The impulse is at 2. The impulse is at 2. So 2 you can put here. 2 you can put in the rect. So in the rect I can put 2. In place of t I can put 2. So 2 minus 2 divided by 3 into delta of t minus 2 dt. Right? what did I do? 1 by 2 I took common from here. 1 by 2 I took common from here. Basically minus 2 was coming common, so 1 by 2 will come out. So delta of t minus 2. The impulse is at 2, so that 2 I am putting here. That 2 I am putting here. Or delta of t minus 2 is there. Delta of t minus 2 is there. What is the value of this thing? This will be 2 minus 2, 0, no? So this will be rect of 0. Do you remember the graph of rect of t? Do you remember the graph of rect of t? Look, either you could have made the graph of this particular function. This you can make. But what is my target? My target is to find rect of 0. So what I'm going to do, I'm going to make the graph of rect of t. Are you getting this point? I could have made this graph. Then what I would have done, I would have find the value at t equals to 2. That I would have done. Or what I can do, I can make the graph of rect of t and put t equals to 0. Are you getting this point or not? Basically, if I make this graph, rect of t minus 2 divided by 3. So how the graph will be made? Rect of t minus center, center will be at 2, divided by the width. It is the complete width. The complete width, the complete time width has to be 3. So what will be this point? This point will be 3.5. And what will be this point? This point will be 0.5. So this is how this graph I will be making, right? Now, if I need to find rect of 0, rect of, because it is 2 minus 2 divided by 3. That means in place of t, I need to put 2. So in place of t, I need to put 2. That means this value I need to find. And what is this value? 1. So this is the one way I could have done. After solving it, what I am getting? Rect 2 minus 2 divided by 3. I am getting rect of 0. What I am getting here? What is this? This is your rect of 0. So if I make the graph of rect of t, what is the graph of rect of t? This is the graph of rect of t. So minus 1 by 2, 2, plus 1 by 2 with the amplitude of 1. So this is the graph of rect of t with respect to t. And if I put t equals to 0 here, rect of, I put t equals to 0 here. So what is the value here? At t equals to 0, that value is 1. So basically rect of 0 is equals to 1. I just needed to find the value of rect of 0, that is equals to 1. Here also it is coming out to be 1 only in this particular graph. T minus center, center at 2, this point at 3.5, this point at 0.5. So here also it is coming out to be 1, or I can find from here as well. Rect of 0 will be 1 only. There is no doubt about that. Say yes or no. Right? Okay. So this value is 1. So what we are left with? We are left with 5 by 2. This value is 1 only. T1 to T2. T1 to T2. And the impulse is at 2. So in the first one, you are taking the integration from 1 to 4. Basically, your impulse is at 2. Impulse is at 2. Now in the first one, you are taking the integration from 1 to 4. So when you take the integration from here, that means impulse is coming into action. So answer would be 1. So for the first question, answer will be 5 by 2. Because this integration, for option A, this integration will be 1. For option B, you are taking the limit from 3 to 6. You are taking the limit from 3 to 6. You are taking the limit from 3 to 6. So in between 3 to 6, is there any impulse? No. If there is no impulse, that means what will be the value of this integration? That would be 0. So for the option B, the value of this integration is 0. So 5 by 2 into 0, what will be the answer? 0. So these two are the final answer. There you go. These two are your final answers. Did you understand how did we do it? First, my target was to make this into the least possible form. So that I did 1 by 2 delta of t minus 2. Now 5 by 2 is coming out to be common. Now I need to solve this integration. So this 2 will be put in place of t. So this is becoming out to be rect of 0. I need to find the value of rect of 0, and that is 1. That I have find out. In any way I can find out these values. Then I go to know t1 to t2 del of t minus 2. Now I know this thing that if my impulse is into the action, then the value of integration would be 1, otherwise it would be 0. So if the impulse is coming into action, then a value is 1, otherwise it is 0. So 5 by 2 into 1 will be 5 by 2, otherwise it will be 0 only. Very simple question. Let's solve this particular problem. So e to the power minus t square sin pi by 2, and then this is your delta t. So let's solve it. Minus infinity to infinity. First task would be what? First task would be to get common out of it. So what is coming out to be common? 1 by 2 again. Sorry, minus 2 is coming out to be common. Minus will be eaten up, and then 2 will be coming out as 1 by 2. So delta of t minus 2 pi. Say yes or no. Dot dt. Right? So 1 by 2 is coming out as common. Then this 2 pi can be put at all these places. 2 pi can be put at all these places. Minus 2 pi whole square into sine pi by 2 into 2 pi into delta of t minus 2 pi into dt. So what we are left with, e to the power minus 4 pi square into sine pi square divided by 2. Then integration minus infinity to infinity delta of t minus 2 pi. The impulse is at 2 pi, but the limit is from minus infinity to infinity. So certainly the impulse will be coming into action. So what will be the value of this integration? 1. So what will be your final answer? This will be your final answer. This is your final answer. Say yes or no. Are you getting this point? How did we get this final answer? Basically 2 pi I just need to put here. Then I put the, so here I am getting sine pi square and here I am getting e to the power minus 4 pi square. Okay, and 1 by 2 is coming out to be there. So this particular answer we are getting. For this particular integration, my integration is 1 only. Say yes or no, right? Now we need to see the differentiation of a step function. So what do you think, what will be the differentiation of step function? We have seen the differentiation of a ramp function. What was that? It was step. Because what did I tell you? Differentiation simply means slope. So here the slope was 1. So when I did the differentiation, I got the slope is 1. Here the slope was 0. Here the slope is 1. So I wrote down that slope is 1. Similarly, you just let me know one thing. What is the slope in this region? 0 only. 0. And what is the slope in this region? This is also constant value. Slope is 0 only. But what is the slope at t equals to 0? What is the slope at t equals to 0? It is infinity. The slope at t equals to 0 is infinity because you are changing the value from 0 to 1. You are changing the value from 0 to 1 in 0 time. So the slope is infinity. And you are getting 1 by 0. What does that mean? This means it is delta t. So if the change is 1, then you will have the impulse of area 1. If the change is 1, then you are having the impulse of area 1. Say yes or no. So d by dt ut is delta t. Say yes or no. Are you able to understand this point? Differentiation of a step function is impulse function. Here slope is 0, here also slope is 0, but only at t equals to 0 there is a sudden jump, and if there is a sudden jump, that means the differentiation would give you an impulse. Impulse of area 1. Why area 1? Because there was a change of 1 amplitude. If there was a change of 5, let's just say here 5 was written, then also it would have been impulse, but here the area would have been 5. We will see these kind of examples. Okay, let's see this question. You need to find d by dt 3u of 2t minus 3. So first thing, by simple differentiation you can find out. 3 will be common. What will be the differentiation of u 2t minus 3? So u will be replaced with delta. Then you need to differentiate whatever that is inside. Whatever that is inside? What is inside? That is 2t minus 3. So 3 delta of 2t minus 3 into the differentiation. What it will give you? 2. So what you are seeing? 6 into, can I take 2 outside? Yes. So it will come out to be delta t minus 3 by 2. So what we are left with? 3 delta of t minus 3 by 2. So this is what we are getting. This is the differentiation. Now I will solve it with the graph, or with the diagram you can say, or with the simply the graph of this particular function. What is that? What is this? 3ut 3u of 2t minus 3. This can be replaced as 3u of t minus 3 by 2. So you are having a step. At 3 by 2, right? At 3 by 2 of amplitude 3. Now if I do the differentiation, so what I will get? This point was 3 by 2. Okay. So here the slope is 0, here also the slope is 0. At 3 by 2 only there is a sudden jump. So at 3 by 2 I will get an impulse. And what will be the area of that impulse? The area of that impulse will be equals to the jump. Jump of 3 is there. So there you go. So what is this? This is your 3 delta of t minus 3 by 2. Are we getting the same answer? Yes, we are getting the same answer. Are you able to relate now? With the diagram as well I can see the same thing. With the mathematics as well I can see the same thing. Are you getting this point or not? Right? Let's solve this one. So in this one what I'm gonna do, first I'm gonna reduce it. You can keep it as it is and then also you can solve it, or you can reduce it. How you can reduce this one? Can you take minus common? No, I cannot take minus common. I can take only 2 common. So if I take 2 common, what I will be left with? This is what I will be left with. So now what I need to do? I need to differentiate. So what I am getting? This is what I am getting, and then I need to differentiate inner thing as well. So minus t plus 3 by 2. What will be the differentiation? There will be a minus sign. So this is the final answer. Or what you can do? What kind of graph I will get here? Here the breakpoint will be again at 3 by minus 2t plus 3. So where will be the breakpoint? So breakpoint will be again at 3 by 2 only. So breakpoint will be at 3 by 2, but the graph will be looking towards minus infinity. So that's where the graph will be looking. Now this is a very interesting point here. What is the interesting point here? So I always told you one thing, whenever you differentiate, always differentiate from minus infinity. So if I am differentiating, I will always differentiate from minus infinity. So I started my journey from here. Slope was 0, 0, 0, 0 only. This is your u of minus 2t plus 3. Do you agree to this point? With the breakpoint at 3 by 2. Say yes or no. Right? Now I need to differentiate this curve. So I will start my journey from minus infinity only. Here also I was starting my journey from minus infinity. Slope is 0, 0, 0, 0. Suddenly there is a jump. So impulse came. Then after again slope is 0. So after again everything is 0. So here also I started. What is the value here? Constant value is there. That means slope is 0. What I am going to do is that I am going to do d by dt. Right? So I am doing d by dt. So I started like this. From here I started. Slope is 0 because constant value is there. That means slope is 0. Here also slope is 0. Suddenly there is a decrement. Right? You are going the amplitude from 1 to 0. So there is a decrement. There is a decrement. So impulse will be negative this time. So there will be an impulse at 3 by 2. There will be an impulse at 3 by 2 with the area of 1. But that impulse will be negative. The area will be here minus 1. Are you getting this point? And after that again the slope is 0. So here there was a decrement. And always whenever you differentiate, you start from minus infinity. Okay? Whenever you differentiate, you always start from minus infinity. So if someone would have started from plus infinity, then what he would have done? Okay, slope is 0. Then there is a jump. So he would have made a positive impulse, right? He would have made a positive area. But no, whenever I differentiate, I will always start from minus infinity. So here the slope was 0. Then there was a decrement. If there was a decrement, so there was a decrement of 1. That means the area of the impulse will be minus 1. So what will be the answer from here? Here I can see minus delta t minus 3 by 2. So there you go. The same answer we are getting. Yeah, same answer it is. Basically, it can eat up minus sign. No, delta can eat up the minus sign. So what I will be left with? T minus 3 by 2. So the same answer here we are getting. Basically, this minus I can take common. Delta of minus t plus 3 by 2. So I am taking the minus sign common and delta will eat up the minus sign. So what I will be left with? Minus delta t minus 3 by 2. So the same answer we are getting here. This answer and this answer. Both answers are same. Are you getting this point? Now let's do the same kind of thing with the waveform. So where I will start my journey from? I need to differentiate. So how I will start my journey from? Very simple it is. Very, very simple. I need to differentiate. So from here I will start. Slope is 0, 0 only. Suddenly there is a decrement of 3. From 0 to minus 3 you are going. Here you are 0 and 0 to minus 3 you are going. At which point? At minus 3. So there will be a negative impulse. Negative impulse of the area of minus 3. Then here also constant value, that means slope is 0 only. Suddenly there is a jump. Jump of how much? From minus 3 to plus 2 you are going. That means there is a jump of 5. So at minus 2 there is a jump of 5. And you are increasing the amplitude. That means the area will be here 5. Although the slope is infinity only, but the area is important. Here the area is 5. Here the area was minus 3. Now at 1 there is a jump. From 2 to 3 you are going. That means the jump is of 1 only. So at minus 1 there is a jump of only 1. So the area is 1. Here there is a decrement of 3. So at t equals to 0 there is a decrement of 3. Minus 3. Right? There is a decrement of 3. Between 0 to 1 the slope is 0. Again at 1 there is a decrement of 3. Again there is a decrement of 3. Then at 2 there is a jump from -3 to +3. That means there is a jump of 6. -3 to +3. At 2, there is a jump of 6. So I will have the impulse of 6. Right? And after that, everything is 0. Now, what is this? Let's just say after differentiating, I am getting yt. What I am saying? d by dt of xt is yt. So can you just write down yt in terms of impulses? Yes, I can write down. How will you write down? At -3, there is an impulse of area -3. So can I write down in this manner? -3 delta of t plus 3. Say yes or no? Because delta of t plus 3 would, how will you make this graph? This is how I will make this graph, no? That impulse will be at -3 with the area of -3. So -3 into delta of t plus 3 plus there is another impulse. So this is simply the addition of impulses plus area is 5 and the impulse is there at -2 plus the area is 1, the impulse is there at 1, right? Plus here the area is -3 and the impulse is at 0 plus the area is again -3, the impulse is at 1 plus the area is 6 now and the impulse is at 2. So this is how I can define my yt. Say yes or no. And can you write down your xt? Yes, I can write down my xt. How will I write down? I will start my journey from here. Then how will I write down? I will say that, okay, suddenly there is a jump. So -3 u of t plus 3. Then there is a jump of 5. So plus 5 u of t plus 2. Then there is a jump of 1. So u of t plus 1. In that manner I will write down and then I will just differentiate it. So what I will get? -3 delta t plus 3, -3 delta t plus 3, plus 5 delta t plus 2, plus 5 delta t plus 2, plus delta t plus 2, plus delta t plus 1, plus delta t plus 1. In the same manner here, -3 delta, what I will write down after that? -3 delta. So what I will, sorry, -3 ut, sorry, I am writing down the expression of xt. So -3 ut. So what will be the differentiation? -3 delta t. In that manner, I will keep on going. With respect to graph as well, with respect to the signal as well, you can do every single thing, right? You can write down the expression of xt and then you can differentiate, or you can simply do by the graph as well. After differentiating, you can write down the expression of yt as well. Every single thing you can do because we have spent good enough time on all these kind of concept. Say yes or no, right? So all these things are clear now. So let's make a conclusion out of it. So if I need to differentiate this particular waveform, then how I will differentiate it? So what I will see first? What I will see? What is the meaning of differentiation? Differentiation means simply the slope. So here what is the slope? This is a constant graph, so slope is 0. Slope is 0, so slope is 0. Then what is the slope? Slope is m1. What is the slope? The slope is m1. So, and always the slope is remaining m1 only. So this is how the graph will go. What about the second one? What about the second one? So in the second one, what will happen? Initially, here, the slope is again 0 because alpha 1 is a constant value. If it is a constant value, then slope is again 0. But at t equals to t1, what is happening? There is an increase from alpha 1 to alpha 2. So what you will have? You will have an impulse. Increasing impulse you will have. And what will be the area of this impulse? There is an increase from alpha 1 to alpha 2. That means the area will be alpha 2 minus alpha 1. And after that, again, everything will be 0. Like usually 0 is not shown here. I can make the graph like this as well. Like slope is 0, no? Between -2 to -1, the slope is 0. So here I could have made 0 as well. But it is like you already know that at all these points it will be 0 only. This will be 0, this will be 0. So I don't need to show the 0. Okay? Only I need to show one impulse. That's it. And the area of that impulse is alpha 2 minus alpha 1. What about this one? What about this one? So initially here, what is the slope? Slope is m1. If the slope is m1, that means till this particular point, the differentiation will be m1 only. And after this point, let's just say this point is t equals to t1. This point is t equals to t1. And after this point, what is the slope? Again, the slope is m1 only. Again, the slope is m1 only, right? But at t equals to t1, look, here also the slope was m1, here also the slope was m1, but at t equals to t1 there was a sudden jump, and if there is a sudden jump, that means at this particular point there is an impulse. Are you getting this point? There is an impulse of how much amplitude? Alpha 2 minus alpha 1. Say yes or no, right? Let's do the same for this as well. So previously what was my slope? My slope was m1. Previously my slope was m1. Then after a certain point, what was my slope? Slope became minus m2. Slope became minus m2. Here my slope was m1, then the slope became minus m2. But at this particular point, there is a sudden jump as well. There is a sudden jump. And if there is a sudden jump, what does that mean? That there will be an impulse as well. And this would be the impulse. This impulse will have a magnitude of alpha 2 minus alpha 1. So while differentiating, always remember that you will start your journey from minus infinity. Okay, from minus infinity always you will be starting. So slope of m1, then slope became minus m2, but at this particular point, there was an impulse as well. Say yes or no, right? So very famous signal all these are. So do the differentiation. First you write down xt, okay, write down xt in terms of ramp. So how will I write down? What is the slope here? 1. And what is the slope? Minus 1. Because if t is increasing, your value is decreasing, right? So slope is minus 1, slope is plus 1. So how will I write down the xt? So I started from here, suddenly I saw the slope of 1. Then the slope became minus 1. What does that mean? That there would have been a minus 2 of RT. Basically at this particular point, the slope became minus 1. Initially it was 0, then it became 1. So this is coming. Then at t equals to 0, the slope became minus 1. So already it is plus 1. So there would have been some minus 2 slope. That's why it became minus 1. Now the slope became 0. So at t equals to 1, the slope became 0. So now already your slope is minus 1. So you need to make it 0. What does that mean? That I need to add something. So r of t minus 1. So this is how it will go. Slope is 1, then minus 1, that means 2 would be subtracted, and then again it became 0. So slope 1 will be added. Okay. So this is your xt. Now what will be your dxt by dt from here? That would be u of t plus 1 minus 2u of t plus u of t minus 1. Very simple. And what will be the double differentiation? It would be delta of t plus 1 minus 2 delta t plus delta of t minus 1, right? But let's do it with respect to graph only. With respect to directly graph without even writing down any expression, how I would have differentiated it. So how I would have differentiated? One thing I already know, the meaning of differentiation is nothing but slope. So I would have started from minus infinity till minus 1, the slope is 0. At minus 1, the slope became plus 1. The slope became plus 1. After that, the slope became minus 1. At t equals to 0, the slope became minus 1. Then at t equals to 1, the slope again became 0. There you go. So this is how I would have got the answer. Differentiation simply means slope and nothing else. That's it. Okay. So 1 was there, then slope became minus 1. This was the point of 0. It happened at minus 1. It happened at plus 1. This is your dxt by dt with respect to t. Okay. Now again I need to differentiate. From here again I need to differentiate. I already know what is the meaning of differentiation. Differentiation simply means the slope and nothing else, right? So I will get started from minus infinity only. I will get started. So at minus 1, what do I see? There is a sudden jump, right? There is a sudden jump of amplitude 1. So there will be an impulse of amplitude, impulse of area 1. Then I saw the slope is 0. But at t equals to 0, what do I see? I am going from 1 to minus 1. I am going 1 to minus 1. That means there is a decrement of 2. There is a decrement of 2. There is a decrement of 2. So again at 0 as well, I will have a impulse with the area of minus 2. Then at 1, what is happening here? At 1, again there is a jump. There is a jump of 1. So again there is a jump. So again there is a jump. That means again there will be one more impulse. There is a jump of -1 to 0 you are going. So again there will be one more impulse. So this will be your d square xt by dt square. Say yes or no. Right? And can you write down the expression of this guy? Yes. How I will start? U of t plus 1. Then directly the decrement minus 2 u of t. Then again at t equals to 1, there is again an increment plus u of t minus 1. Okay. What about this one? Sorry. We start from here. Delta of t plus 1. Then there is an impulse at 0 minus 2 delta t. Then there is an impulse at 1 as well. So plus delta t minus 1. Because this area is 1, this area is 1, this area is minus 2. So area 1, minus 2 and 1. Impulses are there at -1, 0 and 1. So -1, 0 and 1. Are we getting the same expression? Yes. U of t plus 1 minus 2 ut, u of t minus 1. Delta of t plus 1 minus 2 delta t plus delta of t minus 1. So n number of ways are there. By every single method we are solving it. I know there is a bit of speed in solving all these kind of problem, but these are just the mathematics that you have already studied it. So I don't think I should spend much time here. Slope you just need to see there is a change of 1, change of 2, change of 1. There you go. Increasing or decreasing that you can see. Here decreasing, then area is -2. So it is very simple. You just need to see it and then just solve it. Differentiation, integration, all these are very simple. Okay, but the thing is, a lot of people mess it up here. Like a lot of guys mess up in differentiation and integration. In these simple kind of problems only. And you will mess up here. Okay, try doing this question on your own. I hope no one will be messing up if you have studied it in a good manner. So what is the slope here? 1. And what is the slope here? Again it is +1 only, no? The slope is 1 only. It is not -1. In this case it was -1. Here the slope is 1 only. Okay, so how will you differentiate? I just need to find dxt by dt. Okay. So here the slope was 0, but at -1, initially the slope was 0, but at -1 the slope became +1. At t equals to 0, what happened? At t equals to 0, your amplitude went down from +1 to -1. That means there is a decrement of 2. There is a decrement of 2. There is a decrement of 2. +1 to -1 it went down. Decrement of 2. So this area will be -2. So there will be an impulse of area -2. After that, what is the slope? Again the slope is 1. So again the slope is 1 only. So again here the slope is 1. Till which point? Till the point of 1, because again here after the slope became 0. Here the slope was 0. Slope was 0. Before -1 slope was 0. After +1 the slope is 0. Between 0 to 1 the slope is 1. Between -1 to 0 the slope is 1. So slope is 1. But at t equals to 0 the slope is infinity. But the area of that particular slope is from 1 to -1 it is going. That means it is decreasing by the factor of 2. So area is 2. -2 you can say. Area is -2. Slope is infinity but the area is -2. So this is how I am gonna do. So this is my differentiation of xt. Say yes or no. So this was about our differentiation. Try differentiating this particular function. Don't do any mistake. You can differentiate it very easily. So let's see the slope here. What is the slope? 0. Again, what is the slope here? Again, it is 0 because it is a constant value. What is the slope here? This value is 2. The increment is also 2. So what is the slope? 1. What is the slope? 0. What is the slope? Increment is 1. X increment is 1. Y increment is also 1. Slope is 1. What is the slope? 0. And what about this? What is the slope here? Decrement 2. Increment 1. So slope is -2. Say yes or no. Y is decreasing by 2. But X is increasing by 1. X is increasing by 1. Y is decreasing by 2. So slope is -2. Right? And certainly here there is a jump. No jump here. Suddenly there is a decrement here. Suddenly there is a decrement here. So 3 impulses you will get. Rest all are just simply the slopes. Right? So let's get started. How will I draw my differentiation? Slope is 0. Then after that as well the slope is 0 only. But at -3 what I will see? Till minus 2 the slope is 0 0 only, but at minus 3 you can see that there is a jump of amplitude 2. So if there is a jump of amplitude 2, that means the slope will be infinity, but the area will be 2. Now here at minus 2 what happened? The slope became 1. The slope became 1. At minus 2 what happened? That slope became 1. Slope became 1. Now at 0 what happened? The slope became 0. There is no sudden change. At 0 there is no sudden change. If there is no sudden change, that means slope directly became from 1 to 0 it became. 1 to 0 it became. Now at 2 what is happening? After 2 what is happening? The slope is becoming 1. After 2 the slope is again becoming 1. And it will remain 1 till the point of 3. But along with that, at 2 there is a sudden drop as well. From 4 to 2 you are coming. From 4 to 2 you are coming. If there is sudden drop, that means at 2 there will be an impulse. Certainly there will be an impulse, and the magnitude of and the area of that impulse will be minus 2. So at 2 there is an infinity slope. There is an infinite slope, so the differentiation will be infinity, but the area of that differentiation will be minus 2. Right? From 2 to 3 the slope is 1. Now at 3 as well there is a drop. Drop of how much amplitude? Drop of amplitude 1. That means the area of the impulse will be minus 1. Area of that impulse will be minus 1 because there is a drop. From 3 to 2 you are coming. So there is a drop. So between 2 to 3 the slope is 1. Then from 3 to 4 the slope will be 0. From 3 to 4 the slope will be 0. Now between 4 to 5 what is the slope? At 4 is there any sudden jump? No. At 5 is there any sudden jump? There is no sudden jump. The sudden jump was at 3. Sudden decrement was there at 3. Sudden decrement was there at 2. Sudden increment was there at minus 3. Rest all the places there are no sudden decrement, only the slope changes are there. So between 3 to 4 the slope is 0. Between 4 to 5 the slope is minus 2. Between 4 to 5 the slope is minus 2. And from 5 to ahead, after 5 the slope is 0. The slope is minus 2. After 5 the slope is 0. So dxt by dt. Okay, so there you go. This amplitude was 1, this amplitude was minus 2. Here the impulse amplitude also I have seen. So this will be the differentiation of the given function. Very simple, very straightforward, right? Now the running integration of impulse. So try thinking about it. What should be the running integration of impulse? It should be step only, right? But let's try it. Let's do it by complete mathematics. Okay. So I will draw the diagram of impulse. This is how the diagram of impulse will look like. This is your delta tau versus tau. This point is 0. This point is minus infinity. This point will be infinity, right? If I take t equals to minus 1, so x of minus 1, what that would be? Minus infinity to minus 1, delta of tau d tau. You need to integrate from minus infinity to minus 1. Where will be minus 1? Minus 1 will be somewhere here. Minus infinity to minus 1. Is there any impulse? No. Answer would be 0. What would be t equals to minus 2? What will be the value of x of minus 2? Minus 2 will be somewhere here. Again the answer would be 0. So x for t less than 0, answer would be 0 only. Say yes or no. And if x is t greater than 0, let's just say if t is equals to 1. So x of 1 minus infinity to 1 delta of tau d tau. What will be the answer? 1 only. Minus infinity to 1. So impulse minus infinity to 1. That means impulse is coming into action. Answer would be 1. If I put t equals to 2, t equals to 2 would be somewhere here. Minus infinity to 2. Impulse is again coming into action. The answer would be 1 only. So x of 2 integration will be from minus infinity to 2 del of tau d tau. What will be the answer? 1. So what you are getting from here? That for t greater than 0 you are getting the answer to be 1. So what kind of function is that? So from here what did I understand? That I can define my x of t in this manner, that it is 1 for t greater than 0 and it is 0 for t less than 0. What does that mean? X of t is your ut, right? Although we already know it because we have seen the differentiation. So running integration of impulse is your step. Say yes or no. Right? Very easily we have proved it. And also we have already seen that differentiation, so already we know that integration would be step only. So if I need to integrate this, what I will do, I will start from here, everything is 0 0 0 only. Just I integrated, I got to know that there is a jump of 1. What does this represent? That there would be a jump of 1. So there you go, there would be a jump of 1. That's it. Okay, there is a jump of 1. So integrate would be ut. Okay, and minus infinity to tau, it would be u of t. Well and good. Okay. Here, okay, on integration, we could have framed good question as well. In the next lecture, we can see more questions on integration, because here I don't think there are much question on from integration in these slides. So in the next video, we will see more questions on integration. Okay. In this video, only this much questions we are going to see. In the next video, we can see more questions on integration. Yeah. So in this particular lecture, only these many questions we will see. So let's solve this particular problem now. Y of t. What will be your y of t? So y of t will be, simply you need to integrate. So integration will be done one by one. All those will be integrated. So u of t plus 2 plus u of t plus u of t minus 1 minus u of t minus 3. So what I'm going to do is that now I'm going to make xt as well, and then I will make yt as well. So what is your xt? What do you think? There are impulses at these points. Which point? Impulses at minus 2, impulse at 0, impulse at 1, impulse at 3. So this is your xt versus t. Okay. So there is an impulse area 1, then area 1, then again area 1, and then area is minus 1. 1, 1, 1, area is minus 1. Okay. Now if I do the integration, what I am getting? Minus 2, 0, 1, 3. So here there would be a jump of 1. At minus 2 there would be a jump of 1. Then at 0 as well there would be a jump of 1. And at 1 as well there would be a jump of 1. But at 3 there will be a decrement of 1. This is how the curve will go. Okay, 1 we will reach at 2, we will reach at 3, then we will reach at 2. So this will be your y of t, right? Now can you write down y of t? Yes. So first I have the jump at 2, then I have the jump at 0, then I have the jump at t minus 1, then I have an decrement at t minus 3. Are we getting the same thing? This and this expression both are same, right? So by the curve as well you can solve, or by simply the expression as well you can solve. But there is very high chance that in the examination, what will be coming? These expression will not be coming in the examination. These kind of a curve will be coming, and then you need to differentiate. Then you need to integrate. So there you just need to see minus 3 means there will be decrement of 3. Plus 3 means there will be increment of 3. Plus 2 means there will be increment of 2. Minus 5 means there will be decrement of 5. But before that we need to solve more problems. So let's solve this particular question. You need to do the integration. Okay. So first what I can do, I can reduce it to the best possible form. So 2 will come out. So delta of t plus 1 by 2. From here 3 will come out. So delta of t minus 1 by 3. And from here 3 will come out. So 2 by 3 delta of t plus 1. Say yes or no. So can I draw the diagram? Minus 1, minus 1 by 2, and then plus 1 by 3. So impulse at minus 1, that would be of amplitude 2 by 3. Sorry, not amplitude, area of 2 by 3. Impulse at minus 1 by 2, that is of area 1. and impulse had 1 by 3, that is of area minus 1, right? Okay, so how will I integrate it? How will I integrate? Starting from here, at minus 1, what do I see? There will be an increment of 2 by 3. At 1 by 2, what do I see? Increment of 1. So 2 by 3 plus 1. 2 by 3 plus 1. Basically, 2 by 3 plus 1. So here there is an increment of 2 by 3. So this value will become 2 by 3. Now 2 by 3 plus 1. 2 by 3 plus 1. What that would be? This value will become 2 by 3 plus 1, 5 by 3. Right? Because there will be increment of 1. Then there will be a decrement of again 1. There will be a decrement of again 1. So again you will reach at 2 by 3. So this is how your waveform will go, and this point is actually 1 by 3. Right? So here the slope will be 2 by 3 delta t. Here the slope will be, what is the increment? 1 delta t, and here the slope will be minus 1 delta t. Are we getting the same thing? Yes. This point is actually 1 by 3. And this point was minus 1 by 2. And this point was minus 1. This is your t. This was your xt. And your integration would be yt. Okay. Well and good. This was your xt. Very simple thing these are. Now if these kind of waveforms are given, then can you draw it? Yes. What I will do, I exactly need to do that ditto same thing. I will start my journey from minus infinity to t. I need to go. So I started. Before that everything was 0. At minus 3, what did I see? There is a jump of minus 3. Then at 2, what was there? What I will do, first I will make the points minus 3, minus 2, minus 1, 0, and then here 2. Then at 2, minus 3 plus 3, it will become 0. Then at minus 1, there is a jump of 2. At minus 1, there is a jump of 2. Then there is a decrement of 5. That means from 2 to you will reach to minus 3. 2 to you will reach to minus 3. Then at 2, there is a jump of 2. That means you will reach to minus 1. And after that, you will reach to, yeah, after that everything remains as it is. The slope becomes 0 only. Right? So here we went to minus 3, then there was an increment of 3, so we went to 0. Then there was an increment of 2, so we went to 2. Then there was a decrement of 5, that means we went to minus 3 again. Then there was an increment of 2, so we went to minus 1. Right? From minus 3 to increment was 2, so we went to minus 1. And after that the slope became 0 only. So there is nothing, so slope became 0 only. So simple constant line is there. Say yes or no. So this is how I can integrate. Okay. So this is my integration yt. Right? Okay. So what is the conclusion in the integration? So when we studied about the integration of step, what did we study? Integration of step minus infinity to t, u of tau d tau. That was r of t. And now minus infinity to t, delta tau d tau, that is equals to ut. Right? So here it was all about slope. Right? Starting slope is 0. Now the slope will become 2. After that there is an increment in 2, that means slope will become 4 now. After that there is a decrement, that means now the slope will become 3. Right? Basically these means simply slope. Here the slope will be 2. Here, after that the slope will be 4, and after that slope will be 3. Say yes or no. Right? And what about these? These simply shows the jump. So first there will be a jump of 4, then there will be a jump of another 2, and after that there will be a decrement of another 2. So jump of 4, then jump of another 2, 6, then decrement of another 2, again 4. There you go. Right? Well and good. What about this one now? How will you integrate this particular function? So think about it, do it on your own, and then match the final answer. Okay, I am not pausing the video this time. You can do it, you can pause the video and then match the final answer. So breakpoints are at -2, 0 and 1. Okay, so starting before that everything was 0 only. Before that everything was 0. Now at -2 the slope is not changing. Slope is still 0. Previously the slope was 0. Now also the slope is 0. After -2 the slope is 0. But there is a jump of 2. So there is a jump of 2. The slope is still 0. The slope is still 0. There is only a jump of 2. So here also the slope is 0. Here also the slope is 0. We have reached to this point. Jump of 2. Now here. Now the slope will become 1. So at 0 the slope will become 1. But at 0 there is a, here there was a slope 0. Basically this slope was, previously the amplitude was 0. What we are doing? We are doing the integration, not the differentiation, right? We are doing the integration. So when we integrate a step function, what do we get? We get ramp. And when we integrate a impulse, what do we get? We get a step. So here there was an impulse. So we are getting a step of 2. Now there is no impulse. Here there is only step function. So I will get a ramp. That means I will get a slope of 1. So slope of 1 I am getting. Till which point? Till the point of 1. Till the point of 1 I am getting a slope of 1. So where I would have reached? If this window is 1, so the increment will also be 1, right? So I would have reached till the point of 3. So this point would have been 3. After that at 1, what do you see? The slope is also changing. After that the slope is becoming 3. Along with that there is a jump of 4 as well. So basically at this particular point there is a jump of 4. That means you are reaching to the point 7. And along with that now the slope is also becoming 3. So slope will also become 3 now. So this particular slope is also 3. This particular slope is also 3. Now in the examination what they can do, they will give you this particular diagram and what they can ask is that what will be the value of yt? Let's just say this is yt. What will be the value of y at 1.5? So what do you think, what will be your answer? Value of yt at 1.5. So you already know that at 1 it is 7. At 1 it is 7. Now the slope is 3. So if the value of t increases by 0.5, then the value of y will increase by 3 into 0.5. So it will become 8.5. So that will be the answer. So these kind of question could be coming in the examination. So for that you always need to make the waveform. What did we do? Impulse will give you just a step. Here value is 0. Here value is 0. That means slope is 0. Slope is 0. After 2 as well, the slope will be 0 only. If there is an impulse, that means there will be a step. Step of 2. Step of 2 we are getting. Then the value is 1. What does that mean? The slope will be 1. So here the slope is 1. The slope will be 1. So till from 0 to 1 the slope will be 1 and we are rising like this. Now at 1 what is happening? There is an impulse as well and there is a slope change as well. So slope is becoming from 1 to 3. Slope is becoming from 1 to 3. And also there will be a sudden jump of 4 as well. There will be a sudden jump of 4 as well. So you are reaching to the point 7. And then there is a slope change as well. So this slope will be m equals to 3. Now we are asking what will be the value of y at 1.5, t equals to 1.5. So at 1 it was 7. After that the slope is 3. So if this increases by 0.5, then y will increase by 3 into 0.5, that means 1.5. So 7 plus 1.5, answer will be 8.5. So this will be the answer. So these kind of good question can be coming in your examination. So this is a good question. Okay. Let's define delta of ft now. So this is a pure new concept, right? You know how to define delta t, you know how to define these things. From there we will build up the formula and we will see how to define these kind of things. In delta, if I am giving a exponential function I can give or any kind of function I can give a quadratic function. So these kind of function if I can give, then how will you define your delta? So that we are going to see, but after a break. So I will take a break. You can also revise whatever that we have studied previously and then we will start this particular topic. Very simple topic it is. You just need to remember certain things and after that it will be completed. Okay. Yeah, so let's get started again. So what we need to do, we need to define these kind of functions, the delta t square minus 3t plus 2. So how I will define these kind of function, how I will make the diagram of these kind of functions. So that I need to see. So before that, let's see this example. Do I know how to define this particular function, delta of minus 3t minus 2? Yes, I know what will be the answer. Minus I can take common. minus I am taking common, minus 3 I am taking common. So this will come out as 1 by mod of minus 3 delta of t plus 2 by 3. And from here I will get my answer to be 1 by 3 delta of t plus 2 by 3. But let's try defining it with something else. What I'm gonna do is that I'm gonna make this function as ft. So I'm saying that this is my ft. This is my ft. So what will be my first step? That first I will find the roots. I will put ft equals to 0. So from here what I am getting? My t is coming out to be minus 2 by 3. So my t is coming out to be minus 2 by 3. So that is the root. So that means my xt would be, that means my impulse would be at minus 2 by 3. That means impulse has to be delta of t plus 2 by 3. Say yes or no? My impulse will be at 2 by 3. Impulse will be at minus 2 by 3. That means my impulse has to be delta t plus 2 by 3. Say yes or no? This is just another way I am saying. Now here I need to multiply by the area. So what will be the area that I don't know? So what I am gonna do now in the next step, what I am gonna do, this is just a method, okay? Just a method that how to find your impulses. What I am gonna do, I am gonna differentiate my f dash t. So what I will get? Minus 3. So what will be my area? 1 by mode of this differentiation, but mode of this differentiation but at the root only, at minus 2 by 3. So mode of, what is the differentiation of ft? That is minus 3 only at any value of t. So answer is minus 3 only. So here you will write that your impulse will be existing at minus 2 by 3, but you need to divide it with mode of your differentiation. Mode of your differentiation. What differentiation did you get? Minus 3. So mode you need to take. So your x of t is equals to 1 by 3 delta of t plus 2 by 3. Sir, why you are doing this process? You already told us this process, no? Why I am doing this process? For these kind of questions. So here what you need to do, again the same process you need to follow. What you will find? F of t. What will be my f of t? T square minus 3t plus 2. Right? So what is the first task? Find the roots. Ft equals to 0. What does that mean? That your t square minus 3t plus 2 should be equals to 0. So from here what you will get? T equals to 1 and t equals to 2. These two values you will be getting. That means your xt would be, there will be two impulses, one at 1, other one at 2. So one impulse will be at 1, other impulse will be at 2. But we need to multiply the area. We need to multiply the area. So I need to see the area now. So f dash t. How I will find the area? So first I will do f dash t. So what I am getting? 2t minus 3. So 2t minus 3 at root of 1. So 2t minus 3 at root of 1 and 2t minus 3 at the other root, that is equals to 2. So what I will get? 2 minus 3, that is equals to minus 1. And here what I will get? 4 minus 3, that is equals to 1. So here I will write, if I put t equals to 1, then what I am getting? Mode of minus 1. And here I will write mode of 1. If I put t equals to 2, what I am getting? Mode of 1. So my xt is equals to actually delta of t minus 1 plus delta of t minus 2. So this can be defined in this manner. Basically there will be two kind of impulses. There will be two impulses, one at 1, one at 2. Although this has never been asked in the examination, but still it's there in the textbook, so it might be asked any day. So that's why we are learning it, and both are having a area of 1. Are you able to understand this point? How we are defining it? So can you define the same for this particular function? So now this is non-linear, right? If it was linear, if it was like this, then I would have already taken the common. Minus 3 I take common, 1 by 3 delta of 2 t plus 2 by 3. Right? If it would have been like this, what I would have done? I would have taken 3 as common. So what I would have got? 1 by 3 delta of t minus 2 by 3. Very easy to define. Right? This would have been my xt. Or what I could have done? I would have taken, first step is, I would take ft equals to 3t minus 2. Then what I need to find? I need to find the root. So from here I will get the root to be 2 by 3. So that means my impulse will be at 2 by 3. So delta of t minus 2 by 3. Now I need to find the area. So for that area what I need to do? Second step is f dash t. That would be 3. But this 3 at Where? At the root. Root is at 2 by 3. So it will be 3 only. The differentiation is always 3. It is not a function of t. So it will always be 3. So divided by mod of 3. That means it would be equal to 1 by 3 delta of t minus 2 by 3. So this method you don't need to follow here. But if the function is non-linear, then you need to follow it here. So first what you are going to do, ft 3t square minus 5t plus 2, right? So what you are going to do, ft equals to 0. That means 3t square minus 3t minus 2t plus 2 is equals to 0. So 3t t minus 1 minus 2 t minus 1. So from here t equals to 2 by 3 I am getting and t equals to 1 I am getting. So I am getting two roots. T equals to 2 by 3 and t equals to 1. These two roots I am getting. But now I need to see the area. How do I see the area? Second step, f dash t. What will be our f dash t? 60 minus 5. F dash t will be 60 minus 5. So 60 minus 5 at what value I will check? At t equals to 2 by 3 I will check. So 6 into 2 by 3 minus 5. So what we are getting? 4 minus 5. Minus 1 we are getting here. And at t equals to 1. ये फिर minus 1 आ गया यार. Minus 1. Actually we are not getting anything else here. So mod of minus 1 for 2 by 3. Yeah, for 2 by 3. And next we need to check for 1 as well. Let's check for t equals to 1. For t equals to 1 if I check, so 6 minus 5, it would be 1. So here what I need to divide by? Here I am dividing, okay, not multiplying. So here what did you do? Here you divided by mod of 3. So you need to divide. Whatever the value after putting here, whatever the value that you are getting, mod of minus 1 you are dividing. Here also you are dividing. So what you are getting? xt is equals to delta of t minus 2 by 3 plus delta of t minus 1. This is your xt. Okay. So these are just two impulses at 2 by 3 and 1. So this can be reduced in this particular manner. In this particular manner. Say yes or no. Right? So one impulse is at 2 by 3, other impulse is at 1. Okay, so this is your x of t. Sir, how this formula came? That mathematics you don't need to know, okay? Because this is not at all important for your examination. These are mentioned in some textbook, that's why we are studying it. That's it. And everyone teaches it, that's why we are studying it. These are not at all important for your examination. Just in the worst case, if these kind of questions are coming, in these kind of questions can be coming in ESC prelims examination. So if these kind of questions are coming, you should know the process. First put that equals to 0, get the two roots, then do the differentiation. Add the two roots, find the values, and then just put the mod value, and this is how you can define it. There you go. That's it. This is one example. This is the other example. These examples we have seen. Like looking for these examples, it is not important. Like right, this example is not important. So let's just remove it off. Let's just remove it off. Okay. So let's see a question now. This question we can see. Yeah, that's the final problem. So let's solve a problem. Integration from minus pi to pi sin t, delta of cos t is there this time. Delta of cos t. So first let's define delta of cos t. How will I define delta of cos t? So what is my ft here? Ft is equals to cos t here. Right? So what is the first task? To find the roots. Ft equals to 0. That means cos t should be equals to 0. What could be the value of cos? Basically, if you see the graph of cos, this is the graph of cos. Right? This is the graph of cos. So this value is pi by 2, this value is 3 pi by 2, this value is 5 pi by 2. In the same manner it will keep on going. This value will be minus pi by 2, this value will be minus 3 pi by 2, and in the same manner it will keep on going. So t is coming out to be like pi by 2, 3 pi by 2, 5 pi by 2, and so on. Similarly minus pi by 2, minus 3 pi by 2, and minus 5 pi by 2, and so on. So basically that means that your xt if I call this as xt, I'm calling this as xt, okay, del of cos t, I'm calling this as xt. So you will have the impulses at pi by 2 plus 3 pi by 2 plus 5 pi by 2 in the same manner, right? Along with that, you will have the pulses at minus pi by 2 as well, minus 3 pi by 2 as well. In that manner, you will have these pulses. So these kind of pulses would be there. But here something will be divided. Something of mode will be divided here. That you cannot forget, right? Because this is not the complete answer. Here something of mode will be divided. So what mode will be divided? How can we find that? So for that, what is the next step? You find f dash of t. So what is the differentiation of cos? Differentiation of cos is minus sign. Differentiation of cos is minus sin t. So now you need to find value of minus sin t at all these roots. That means at pi by 2 you need to find value of minus sin t, you need to find at 3 pi by 2 as well. Then you need to find same thing, you need to do value of minus sin t at minus pi by 2 as well. I hope you are able to understand what we are doing. Same thing you need to find at minus 3 pi by 2 as well. So these kind of steps you need to do. And then you will be taking the mode as well, right? You will be taking the mode as well. After that, you will be taking the mode as well. Because eventually we need to divide by the mode. Eventually we need to divide by the mode. So just let me know one thing. At pi by 2 or at 3 pi by 2, what will be the value of sine? If you draw the graph of sine, if you draw the graph of sine, this is the graph of sine. So whether it is pi by 2 or minus pi by 2 or anything, this point is minus pi by 2, this point is pi by 2, this point is 3 pi by 2. At pi by 2 value is 1. So 1 into minus 1, it would have been minus 1, but there is a mode, value will be 1 only. Here also at 3 pi by 2, minus 1 is there, minus 1 into minus 1, it would have been plus 1, then mode would be, it would be plus 1 only. So at all these points, value will be plus. Let's just say I take the point of minus sin t at t equals to minus 5 pi by 2. At minus 5 pi by 2 as well, the value will be 1 only. This will be your 5 pi by 2. So there will be mode always, no? So value will be 1. So all these mode value, all these values will be 1 only. Are you getting this point? All these values will be 1 only. Here I cannot put, basically here it could be plus 1 or minus 1, that I don't care. But after the mode, the value will be coming 1 only. So from here what you are understanding, that your delta of cos t is nothing but the impulses. What kind of impulses would be there? Delta of cos t is nothing but impulses, and impulses will be there at certain points. Those certain points would be pi by 2, 3 pi by 2, 5 pi by 2 and so on. Minus pi by 2, minus 3 pi by 2, minus 5 pi by 2 and so on. So here we will be having the impulses. Impulses of all are of area 1. All are of area 1. All these impulses are of area 1. So what is this? This is the graph of del of cos t. Are you able to understand how did we draw the graph? Just took this as ft and then do the operation on this particular ft. This ft is there, first I need to find the roots. Then I found the root. Roots are coming out to be pi by 2, 3 pi by 2, 5 by 2 in that manner. Then I got to know that I will be having the impulses. Now I need to find the area. For that what I need to do? I need to do the differentiation. And at the differentiation, at all the roots, I need to put the value and see the magnitude there. So did the differentiation, then add all these values, pi by 2, 3 pi by 2, minus 5 by 2, what all values I am getting? 1 I am getting. So I need to divide by 1 here. And if I am dividing by 1, so this kind of waveform I am getting. So this is your del of cos t. So can I write it down in this manner? Let's try generalizing it. T minus, how will I generalize it? Let's try it. 2n plus 1 pi by 2, right? And n equals to minus infinity to infinity. Is that correct? Because if I put n equals to 0, fine. If I put n equals to 1, fine. If I put n equals to minus 1, then it would be, if I put n equals to minus 1 here, then it would be minus pi by 2 delta of t plus pi by 2. Yeah, if I put minus 2, yeah, this is correct. This is how I can define it. Delta of t minus 2n plus 1 pi by 2. Okay, how I am defining it? Delta of t minus 2n plus 1 pi by 2. So this is how I can define it. But this is not important for us. What is important for us? What they are saying? You need to find this value. So I have defined it. I have defined my delta of cos t. Now what is my target? My target is to find from minus pi to pi sin t into delta of cos t. The limit is from minus pi to pi only. Where will be minus pi? This will be your minus pi. Where will be your plus pi? This will be your plus pi. And that will be multiplied with sin t. So this delta of cos t I can open up. I can open up this delta of cos t, but my matter of concern will be between minus pi to pi only. And between minus pi to pi, how many impulses are there? Only these two impulses are there. In the graph of delta of cos t, between minus pi to pi, only these two impulses are there, no? So these only are my matter of concern. These impulses will also be existing, but these are not my matter of concern. My matter of concern is only these two impulses. Are you getting this point or not? So I will break it down in this manner, that my integration is from minus pi to pi sin t into then one impulse I am having at pi by 2 and other impulse I am having at minus pi by 2. Sorry, this is at pi by 2 and this was at minus pi by 2. That's it. Other impulses also I am having, but these are not lying between minus pi to pi. Are you getting this point? Dot dt. The next step, what will be the next step? Minus pi to pi. So once I will multiply my sin t with this impulse, sin t is being multiplied with the impulse at pi by 2, and then again my sin t will be multiplied with the impulse at minus pi by 2. Then what will be the procedure? This pi by 2 goes here, this pi by 2 goes here, and this minus pi by 2 goes here. So what you will be left with? Sine of minus pi by 2 minus pi to pi delta of t plus pi by 2 dt. What will be the value of this guy? That would be 1 only. And similarly here, sine of pi by 2 minus pi to pi delta of t minus pi by 2 dt. What will be the value of this guy? This guy will also be 1. What is the value of sine of minus pi by 2? You can see the graph of sine. Sine of minus pi by 2 is minus 1 and sine of plus pi by 2 is plus 1. So what we will get here? This value is minus 1. This value is plus 1. So minus 1 into plus 1, minus 1, plus 1 into 1, plus 1. So what is the answer? 0. So all this process just to get the answer to be 0. Okay. If the limit was from 0 to pi, let's just say if this limit was from 0 to pi, then what would have been the answer? If it was from 0 to pi, then only this impulse would come into action. Then answer would have been 1. Only this impulse would have come into action. T minus pi by 2. So only this impulse would have come into action. Then answer would have been 1. If the limit was from 0 to pi. But the limit is from minus pi to pi. So this impulse is also into action. So this guy is giving minus 1. This guy is giving plus 1. So answer is 0. Right. So are you able to understand? Like a very rarely discussed topic might be asked in the examination. In ESE, these kind of questions are famous, but in GATE, they did not ask these kind of questions ever. Okay. Always they will give the linear function. Whenever they introduce del, they always give the linear function. Okay. Always they give the linear function. Always they give this kind of linear function. So for that, I don't need to apply this process. Not required. This process is not required, right? For that, what I need to do, I already know that I can take minus 3 common. It will come out by like this. This we have spent a lot of time. So here also I already know this process that directly it will come out like this. So there I don't need to spend time. But if there is anything non-linear, then I will define ft. I will find the roots. If I have find out the root, then I know that where will be my impulses. Then next task would be to find the area. So for that, what I need to do, it will be divided by something of mode. Something of mode. How will I find that something of mode? I will do the differentiation. I will get the value 2t minus 3. Now I need to put all these roots. So t equals to 1 I put, t equals to 2 I put. So what value I am getting? Minus 1 and 1. So it should be divided by mode of minus 1, mode of 1. So at 1 I am putting the root of 1 only, and at 2 I am putting the root of 2 only. So this root I am putting. So this is how I got my impulses. Same goes for this particular question and same goes for cos t problem as well. So wherever cos is becoming 0, all these impulses are there, it will be divided by something. For that I need to do the differentiation, and then I go to know that if I put the value of pi by 2, 3 pi by 2, 5 pi by 2, or minus pi by 2, minus 3 by 2, minus pi by 2, always the value will be, always the mode will be 1 only. So everything will be divided by 1. So these kind of impulses I will be getting. So all are having area of 1. All are having the area of 1. All are having the area of 1. Say yes or no, right? Then it is being multiplied with sin t. So you can do the multiplication with sin t. These two impulses I am taking into action because the limit is from minus pi to pi only. If the limit is from minus pi to pi only, then I can see these kind of integration I am getting, answer is 0. This is not the end of impulse signal. For this video, this is the end. In next video, we will see more questions on impulse. Okay, integration problem we can see more. Like when we studied about integration of step signal, we introduced these kind of questions, no? U of 2t plus 3, then the limit was going from minus infinity to, it was actually 2t plus 3. So these kind of questions we did not see for the impulse signal. Like the same kind of questions can be asked for impulse signal as well, no? The limit can go from minus infinity to, let's just say, t plus 2. So how will you do? Will you directly put it here, or you will do something else? So these kind of questions we can see for impulse as well. I forgot to write those kind of questions in this slide. So in the next slide, I will be writing down these kind of problems. And in the next slide, we can see the problem on integration. And then we will study about doublet signal. Okay. What is doublet signal? Differentiation of delta t. Okay. So now we will differentiate this delta t. So then we will study about doublet signal. Well and good. So let's meet in the next lecture. I hope you are enjoying the lectures on a very good level. Thank you very much. Yeah, hi guys. So actually there was a small concept left, that was this concept of integration. So I just saw the length of the video. It is roughly around 2 hours 20 minutes only. So I thought I can extend this particular video. So we have seen these kind of problems, right? U of tau plus 2 d tau. Then what did I tell you? This t comes here and u replaced with r. So r of t plus 2 will be the answer. So there I told you a trick that using this trick we can solve the problems. But can we apply the same trick in case of delta function as well? Can we apply the same trick for impulse function as well? So let's see what is different in case of impulse function. So now we are going to see the integrations. Okay. So now we are going to integrate this impulse. So first I will solve with the help of waveform, right? So this is the waveform I am having. I will draw the waveform of delta of tau plus 2. So that means you are having an impulse at minus 2. You are having an impulse at minus 2 of area 1. Okay. And from where you are integrating from minus infinity to t. So t is variable here, minus infinity to t. So I know one thing, that if my t is less than minus 2, let's just say my t is minus 3. So what will be the area? In between, what is the area? What is the meaning of integration? Meaning of integration is area. So if my t is less than minus 2, then what is my area? 0 only. So for t less than minus 2, your xt is equals to 0, because this integration is equals to xt. And for t greater than minus 2, if your t is greater than minus 2, that means this impulse will be into action. And if this impulse is into the action, then what will be your xt? Xt will be 1, because the area of this impulse is 1. So if your t is less than minus 2, then xt is equals to 0. If it is greater than minus 2, then your xt is equals to 1. So what do you think, what kind of graph you are getting? What kind of graph we are getting here? So if I draw the graph, I can see that for less than minus 2, it is equals to 0. And for greater than minus 2, it is equals to 1, right? So this is the graph of xt I am getting. So what do you think, what is your xt now? So here you can see that your xt is u of t plus 2, right? So from here what you are understanding, that you will see that, sir, you replace this t here and replace this delta by u. Your job is done. But can we actually do it? No. Luckily we got the correct answer here, that you place the t here and replace your delta with 2. Sorry, you replace your delta with u, and you are luckily getting the correct answer. That would be u of t plus 2. But this trick is always not applicable. Why is that so? The reason is, for this particular waveform, I can take my integration from plus infinity to t as well. What I mean to say is that, when, let's just say I have this integration, u of tau plus 2 d tau. What is my u of tau plus 2? This kind of waveform will be there, right? From minus 2 it will start and it will going towards infinity. So can you just let me know, can I put the limit to infinity to t? No, I told you cannot put the limit from infinity to t. Why you cannot put it? Because if you start from infinity, then you already know that area will be always infinity. So infinity to t, let's just say I took the value of t to be 100. So what is the length between infinity to 100? It will be infinity only. So what will be the area? Area will be infinity only. So this integration doesn't make any sense. There I told you, here it has to be left-sided signal. Like it's the face of this signal should be left-sided. If you take the limit from infinity to t, that means the face of the signal should be left-sided. You should be looking towards here. Now it is applicable that you can start from infinity and you come to t. These kind of example we have already seen. But in case of impulse, for the same function, for this particular function, I can take my limit from infinity to t as well. There would be no doubt about that. Say yes or no. For this particular function, I can take my limit from infinity to t as well. Right? Why is that so? Because there is no face of the impulse, no. Impulse is just at a certain point. There is no face of the impulse. So what will be the answer you will be getting? So let's check that out. What I'm gonna do, I'm gonna just change the limit now. And how I will change the limit? In changing the limit, I will just put this minus infinity to plus infinity. That's it. So this is the question now. You are going from plus infinity to t. So what kind of impulse I am having? This is the impulse I am having. Impulse I am having at t equals to minus 2. So here I am having my impulse, which has an area of 1. This is your minus 2. Delta of tau plus 2 versus tau. Now you need to get started from infinity to t. Infinity to t. One thing I already know, that if my t is greater than minus 2, then my xt will be equals to 0. Let's call it xt. If my t is greater than minus 2, what do I mean by that? T is greater than minus 2. Let's just say my t is 1. So infinity to 1, is there any impulse? No, area would be 0. Let's just say my t is minus 1. Infinity to minus 1, is there any impulse? No, area will be again 0. So if t is greater than minus 2, then your xt would be 0. But if t is less than minus 2, let's just say t is minus 3. So from infinity to 3, impulse is there? Yes, it is there. From infinity to 3, sorry, infinity to minus 3. So from infinity to minus 3, is there any impulse? Yes, it is there. That means the area would be 1. Let's just say your t is minus 4. So from infinity to minus 4, is there any impulse? Yes, it is there. That means your area would be 1 only. So for t less than minus 2, value is 1. For t greater than minus 2, value is 0. So what kind of waveform you will get? What do you think? What kind of waveform you will get? So what kind of waveform you are getting for x of t? So here no trick will be working. Here you need to solve by the conventional method. Okay. Here you will apply the conventional method, not any trick. So for t less than minus 2, it is 1. Otherwise, it is 0. Okay. So what kind of waveform you are getting? And here the area is 1. So what is this? U of minus t minus 2. Say yes or no. This is your xt. I hope you know how to write down this u of minus t minus 2, right? Because I told you two kind of mistake you can do. First you start from here, u of minus t, and then minus 2. Actually you should have shifted towards the right, but you will shift towards the left now. So u of minus t minus 2. So this kind of waveform is u of minus t minus 2. So what did you understand from here? That if you directly put this t here, and you would have done that, sir, I will replace this delta with u, and this put directly I will put it here. So u of t plus 2, that would have been wrong. Are you getting this point? So always you need to see that whenever there is a impulse function that is being integrated, so I will solve it using the diagram, not by any trick. In all the question, I will make the diagram and then I will solve it. I will not apply any trick there. Say yes or no. Okay. The trick will be applicable for step function, but not for the impulse function. Right? Let's go with this one. You need to integrate from minus infinity to t plus 2. So again, I told you one thing. Make the diagram. Make the diagram. So this is the diagram of delta of tau versus tau. Where is the impulse? Impulse is at origin. Area 1. From where you are starting? You are starting from minus infinity and you are going till t plus 2. Right? So just let me know one thing. If your t plus 2 is less than 0, if this limit, if this upper limit is less than 0, then what will happen? Let's just say t plus 2 is minus 1. I am saying that your t plus 2 is equals to minus 1. So between minus infinity to minus 1, is there an impulse? No. What will be the area? 0. So if t plus 2 is less than 0, that means your xt will be 0. If t plus 2 is less than 0, that means t plus 2 is less than this particular value. Then your xt will be 0 only, because there will be no impulse. And if there is no impulse, that means area would be 0. So you can say that if your t is less than minus 2, then your xt is 0. But if your t is greater than minus 2, then your xt would be 1. Or you can say that if your t plus 2 is greater than 0, what is the meaning of t plus 2 greater than 0? That means let's just say t plus 2 is equals to 1. If t plus 2 is equals to 1, that means this would be somewhere here. Limit will be from minus infinity to 1. X del of tau d tau. So if t plus 2 is equals to minus 1, sorry, t plus 2 is equals to 1, where it has gone? Yeah, t plus 2 is equals to 1. That means t is equals to minus 1. So if your t is equals to minus 1, that means the limit will be from minus infinity to 1. And in this limit, the impulse is coming. And if the impulse is coming, then area would be 1. So are you understanding this point? What you are understanding from here? Are you able to get this point? So what kind of waveform you are getting? That for t less than minus 2, everything is 0. But for t greater than minus 2, everything is 1. So what is your xt here? Xt is simply a step. This is your xt versus t. So what is your xt? Xt is simply a step. Here the trick is actually working. Replace your delta with u and then just replace this here. So u of t plus 2 you are getting. Trick is working here, but luckily, if I change the limit, then the trick will not work. Are you getting this point? So better than remembering any trick in the examination, I will have the confidence on myself and I will go by my conventional method. What is the conventional method? If the limit is less than 0, that means if your t plus 2 is less than 0, that means there will be no impulse. And if there is no impulse, then area would be 0. And if it is greater than 0, that means there would be the area 1. So this is how the waveform I will be getting, and from here I can write down this u of t plus 2 very easily. Let's solve this one. So my first target would be to make the waveform of this guy. Can I make the waveform of this guy? Yes. First way is that I can reduce it. I can take minus 2 common. So how it will come out? 1 by 2 delta of t plus 2. That means now there will be an impulse. There will be an impulse at minus 2 only, but the area of that impulse, there will be an impulse at minus 2 only, but the area of that impulse is 1 by 2. Say yes or no. So this is your delta of minus 2 tau minus 4 versus tau. And you need to get started from minus infinity to t plus 2. So if your t plus 2 is less than minus 2, if your t plus 2 is, if this upper limit is less than minus 2, that means there will be no impulse here. And if there is no impulse, what does that mean? That your xt would be equals to 0. So that means if your t is less than minus 4, then your xt is equals to 0. If t is greater than minus 4, then your xt would be equals to what? Equals to 1? No, it would be equals to half. Basically, if your t plus 2 is greater than minus 2, let's just say your t plus 2 is equals to 0. That means your t is equals to minus 2. So if you put t equals to minus 2 here, so from minus infinity to 0, from minus infinity to this point, 0, you need to integrate. That means this area would be coming into action because impulse is coming into action. And what is the area of the impulse? That is half. So from minus infinity to 0, it is giving us half. So if t is greater than minus 4, then the value is half. If t is less than minus 4, then the value is 0. Say yes or no. So very simple thing. If you are just following the lecture, if you are just listening to my words, then you are certainly able to understand all these kind of points. Say yes or no. Right? So this is your x of t versus t. So before minus 4, everything is 0. I know I am moving a bit faster, but we have done enough practice on all these kind of things. When I wanted to move slow, I moved slowly there. But now you already know all these kind of things, how to do the integration. If t plus 2 is less than minus 2, that means no impulse will be there, area would be 0. If t plus 2 is greater than minus 2, that means certainly impulse will be coming into action. So what will be the area? Area will be half. So from here you got to know the breakpoint as well, right? So area would be half here. So what kind of xt you are getting here? Xt is 1 by 2 u of t plus 4. No short trick, nothing. Okay, I am not going to apply any short trick or anything like that. I will just solve by my conventional method. Well and good. Let's solve this question. Is this the same? Okay, yeah, this is the same, but limit is interchanged. No, now you are going from plus infinity to t. So try doing it on your own. First, what is my target? That reduce it off. How will I reduce it? I can take 1 by 2 common. The same function is there, just the limit is interchanged. I will take 1 by 2 common. I will take 2 common, minus 2 common. Then what I will be left with? This. Then the ditto same diagram. So instead of I can directly copy it here. because I will be getting the same diagram. Okay, the same function is there, so there will be an impulse at -2 with the area of 1/2. But now from where to where I am integrating? I am integrating from infinity to t. So one thing you know, if your t is greater than -2, if your t is greater than -2, let's just say if your t is 1, so is there an impulse? No. That means the area would be 0. And if your t is less than -2, let's just say if t is -3, so is there an impulse? Yes, there is an impulse. That means the area would be half, right? So what we are getting here, okay, let it be here. So if we make the waveform, what do we see? What is the waveform of xt? Waveform of xt versus t. So -2 is the breakpoint. For less than -2, it is equals to half. For less than -2, it is equals to half. And for greater than -2, it is equals to 0. So what we are getting? X of t is equals to half of u of minus t minus 2. Say yes or no, right? So this is the answer. If you apply any trick, then there would be some issues. But if you don't apply any trick, then certainly you will be getting it correct, right? So don't apply any trick if it is about impulses. Well and good. Let's go to the next question. You can also do it on your own as well. Delta of -2 to -3. So what I will do? Again, I can take -2 common. So now where I will be getting the impulse? This time I will be getting the impulse at -3/2, right? The area is same. The impulse will be at -3/2. Area is half only. Impulse is at -3/2. Delta of -2 to -3. In the examination, all these things will not take time. Now, what is the limit? T plus 2. So, if your t plus 2 is greater than -3/2, that means your area would be 0, right? If it is greater than -3/2, that means it could be here, here, or here, or here. Then you are starting your journey from infinity to t plus 2. You are starting your journey from infinity to t plus 2. So if you are reaching till this point only, so there is no impulse, so area will be 0. But after that, the area would be half. So what we are getting from here, minus 1.5 minus 2, that would be minus 3.5. That means if t is greater than -7/2, then your xt is equals to 0. And if t is less than -7/2, then your xt is equals to half, right? So simply make the waveform, make the diagram, and there you go. Okay, -7/2, then it is half. So this is your actually xt, and this value is half. So what is your xt? Xt is amplitude is half, u of, it is looking towards minus infinity, so u of minus t, where is the breakpoint? Breakpoint is at -7/2. There you go. So this is your xt. Okay, well and good. Very simple, very straightforward, right? Do this example. 2t plus 1 is the limit, and these are the scenes here. So again the same example is -2 to plus 3. So basically delta of -2 to plus 3. So what I can do, I can take -2 common again. So the area would be half, but now the impulse will be at +3/2, right? Impulse will be at +3/2. So I need to make the impulse at +3/2 with the area being, impulse at +3/2 with the area being half. Okay, and this is -2 to plus 3 versus 2, right? From where to where you are integrating? You are integrating from infinity to 2t plus 1. You are starting your journey from infinity to 2t plus 1. Okay, so you know that if your 2t plus 1 is greater than 3/2, if your 2t plus 1 is greater than 3/2, it could be here, it could be here, it could be here, it could be here, then your answer would be 0. Then your x of t would be equals to 0. So 1/2, 1/4. So if t is greater than 1/4, then your xt would be equals to 0. If t is less than 1/4, then what would be your xt? It would be equals to half, right? And did I do the calculation correctly? 2t plus 1. So 1/2, 1/4. Yeah. So at 1/4, 1 by 2. Yeah, okay, fine. So what kind of waveform I will be getting? Where is the breakpoint? Breakpoint is at 1 by 4. So for greater than 1 by 4 it is 0, after that it is half. So breakpoint is at 1 by 4. Breakpoint is at 1 by 4, right? And this is your x of t. And here what you are getting? Half. So can you explain what is this xt? Your xt is u of minus t plus 1 by 4. And the amplitude is being half. Minus t plus 1 by 4, right? Minus t will be looking here. What is the breakpoint? Breakpoint is 1 by 4. So minus t plus 1 by 4 with the amplitude of half. So that's the x of t, right? So no trick, nothing. If I had applied the trick here, then there would have been an issue, right? Delta minus 3 by 2. So this I would have reduced. Then I would have simply put 1 by 2 u of 2t plus 1 if I had put 2t plus 1 minus 3 by 2. What I would have been getting? U of t plus 2t. It would be here, and this would have been minus 1 by 2. This would have been minus 1 by 2. So this would have been minus 1 by 2. Then I can take 2 common. So I will be left with 1 by 2 u of t minus 1 by 4. This answer I would have got, but that answer is incorrect. Actual answer is 1 by 2 u of minus t plus 1 by 4. So no trick is applicable here. Okay. So don't apply any trick if you see the integration of impulse. In the examination, if you see the integration of impulse, then just tell to your mind that I have the confidence on my concept, and with the help of concept I will be solving it, not by any trick. But trick is applicable in case of step function. Okay. So can I solve it using the trick? Yes. Here in case of step function the trick is applicable. So what we used to do, first I can say that I can eat up this 2 inside. It cannot eat up the negative sign, but it can eat up the 2. So what I will be left with? Minus tau plus 3 by 2 d tau. Then what I can do? This upper limit can be put in place of tau, and this u will be replaced with r. So what I will be getting? R of minus 2t minus 1, because in place of tau what I am putting 2t plus 1. So minus 2t minus 1 plus 3 by 2, right? So and u is replaced with r. That's it. Okay. So what I am getting? Minus 2t plus half. And one more thing I know that I can take this 2 outside. So 2r minus t plus 1 by 4. So this is what I am getting. This is your xt. And can you draw the waveform of this one? Certainly I can draw the waveform of this one as well. That where will my breakpoint? Breakpoint will be at 1 by 4. Breakpoint will be at 1 by 4. And it is looking towards minus infinity with the slope of minus 2. So all these things we have already seen. That's why I am doing it very quickly. So this is your actual xt. So here your trick is applicable, right, with the slope of minus 2. But let's just say there is some guy who thought that I am an engineer, I will solve it using the conventional method. So let's try doing it using the conventional method. Okay, the same question I'm gonna do using the conventional method, but you will see there we will do one error there. Okay, this question I will solve using the conventional method, and we will end up doing some error, and you will not even realize that we are doing the error. What I'm saying, we will end up doing some error and you will not even realize it. So let's solve it using the conventional method. So can you draw the waveform of u of minus 2t plus 3? U of minus 2 tau plus 3. That would have been u of minus tau plus 3 by 2. That means this kind of waveform I would be getting. Now in these waveform and all those things you should not be taking time, because there have been n number of questions that we have seen. So just even if you just see the expression, then the waveform should be coming into your mind, right? But we will do a mistake in the conventional method, I am telling you, and we will not even realize that we are doing the mistake. Okay. Now from where to where I need to integrate? I need to get started my journey from infinity, because if I had given the limit from minus infinity, then it would not make any sense. If I had given the limit from minus infinity, then it would not make any sense. Why is that so? Because from minus infinity you can see that it is unbounded only. Basically here the area will be infinity only. So in the examination, if these kind of questions are coming, if your function is looking towards the left hand side, then you will be starting your journey from infinity only. So now you are starting from infinity. But in case of impulse, you can start your journey from infinity as well, you can start your journey from minus infinity as well. From anywhere you can start your journey. But in case of step, it is certain that if your function is looking towards the left hand side, then 100% here the limit will be plus infinity only. So you are going from plus infinity to 2t plus 1, right? And here what is the step? Step is 1. So you are going from plus infinity to 2t plus 1. What do you know? That if 2t plus 1 is less than 3 by 2, if 2t plus 1 is less than 3 by 2, or sorry, greater than 3 by 2, if 2t plus 1 is greater than 3 by 2, that means if it is here or here, then everything is 0. What is the meaning of integration? I told you meaning of integration is simply the slope, right? Sorry, not meaning of the meaning of integration is not the slope. Basically, meaning of integration is the area. So there is no area here, no? Everything is 0. Meaning of integration is simply the area. So I have started my journey from infinity to 2t plus 1. Now if I am saying that if 2t plus 1 is greater than 3 by 2, so till this point the area would be 0. So you would say that my xt would be 0, right? So what will be my breakpoint? My breakpoint would be 1 by 4. So if your t is greater than 1 by 4, if your t is greater than 1 by 4, then your xt would be 0. But if your t is less than 1 by 4, then your xt would be ramp, right? You would say that my xt would be ramp. So my breakpoint is coming out to be 1 by 4. How did I get my breakpoint to be 1 by 4? Are you able to understand? If your 2t plus 1 is less than 3 by 2, sorry, if 2t plus 1 is greater than 3 by 2, that means your points are here. Your points are here. And if you integrate, there is no area, so answer would be 0. So till 1 by 4, if t is till your 1 by 4, everything would be 0. Everything would be 0. Everything is 0. Right? Now after that, if t is greater than 1 by 4, let's just say your t is 1. T is 1. So you are taking the integration for infinity to 3. I am saying that if my t is 1, then integration will be taken from infinity to 3. Where will be my 3? Wait a second. If t is equals to 1. Okay, t should be less than 1 by 4. No, really sorry. T should be less than 1 by 4. So let's just say my t is equals to 0. So infinity to 1. I am taking my integration from infinity to 1. So how much area I am enclosing? I am enclosing some area. I don't know. If your limit goes from infinity to 2, sorry, infinity to 0, that means if you reach here, then more area I will enclose. If the limit goes from infinity to minus 3, then I will reach here, then more area it will enclose. So the area is increasing only. Area keeps on increasing. Are you getting this point? If my limit goes from infinity to minus 5 would be somewhere here. So area will keep on increasing. That means here, if the value of t is decreasing, then the amplitude should keep on increasing. Say yes or no. Are you getting this point? Because if I am moving with the value of t, if my value of t is decreasing, then my area is actually increasing, right? So this is how it should go. So this kind of ramp I will get. What would be the slope of my ramp? What would be the slope of my ramp? You understood, right? Why the ramp is going upward? Why the ramp is going upward? Are you able to understand this point? Certainly you are able to understand, because the area will keep on increasing. If the value of t increases, sorry, if the value of t decreases, then the area keeps on increasing. And if the area keeps on increasing, then it should go like this. What would be the slope? It feels like that, sir, there is a jump of 1. So the slope should be, sir, equals to minus 1 here. Because this slope has to be negative only, and there is a jump of 1 only, so slope has to be minus 1. But was that the case here? Slope was actually minus 2. So we are getting the wrong answer here. And we can verify as well this answer is wrong. Like you will say that, sir, you applied a particular method here, but here you are solving with the conventional one. Let's check if your answer is correct or not. You might be feeling that, sir, here I solved with the conventional one and I am saying that my slope should be minus 1. So is your actual answer is this is the correct answer or this is the correct answer? So can we check it? Yes, certainly we can check it. How I will check? Let's find the value of x of 0. What I am finding? I am finding the value of x of 0. So if I put in place of t equals to 0, then what I will do? Infinity to, if I put t equals to 0 here, infinity to 1, u of minus 2 tau plus 3 d tau. That means I need to integrate from infinity to 1. From infinity to 1 I need to integrate. So how much area I will be enclosing? This much area I will be enclosing, right? how much area I will be enclosing. This much area I will be enclosing, this much area. And what is this much area? What is this width? This width is half. And what is the upper width? Upper width is 1. So what will be the area? Half. So what should be your answer? Half. This is our waveform, no? X of t. This is our x of t waveform. If I am saying that this answer is correct, if I am saying that this answer is correct, I am saying that my slope is -1. This is what I am saying. At 1/4, you are having the value to be 0. If you reach at x of 0, according to this waveform, if I reach at x of 0, if my t decreases by 1/4 and slope is -1, that means my x of t should increase by 1/4. So here x of 0 is coming out to be 1/4. And here it is coming out to be, this was your x of 0, that is coming out to be 1/2. So is it correct? No, this is wrong. So that means somewhere you got wrong. Try thinking about it, where did I go wrong? Try thinking about it, where did I go wrong? I solved that by the conventional method. The only doubt was about the slope. This will be the waveform. Breakpoint will be at 1/4, breakpoint will be at 1/4. This is how the curve will go, this is how the curve will go. The concern is about the slope. Here it looks like that there is a jump of 1, so slope has to be -1. But the slope is coming out to be actually -2. And we can check it here as well. How we will check? If your t is increasing, if your t is decreasing by 1/4, then how much your xt should increase? 1/4 into 2. 1/4 into 2. So how much it should increase? By half. So what is the value of x of 0 here? Half. So here the value of x of 0 is half. And what is the actual value of x of 0? That is also half. So this guy and this guy is matching. So what is this? This answer is correct. And this answer is wrong. Here, whatever the analysis we did, all these analysis is wrong. Where did we go wrong? Here did we go wrong. If t was not having any multiple, like if it was t plus 1 directly, then there would be no change in the slope. But if it is having a multiple, then the slope will be changing by that factor only. So now the slope will be 2. Okay. And in the examination, you cannot do all these kind of things and again check that whether I am going correct or not. Are you getting this point or not? Because here in the previous videos, when we study about step signal, when we study about ramp signal, in the previous videos, I did not take any multiple here. It was like t minus 2 or t plus 3 or t plus 4, but there was no multiple. But now if I take multiple and I try solving using the conventional method, using the waveform, if I try solving, then my answer is being wrong because of that particular multiple. So what did you understand from this particular discussion? That if there is an impulse, no matter even if there is a multiple or not, no matter whatever the limit is, if you solve by the conventional method, if you solve by the graph, there is no chance that your answer would be wrong. Here this answer is correct only. You can verify it as well. How you will verify? Take a random value. Let's take x of 0. Here also you take x of 0. So if I find from actual thing like x of 0, what that would be? Infinity to 1, delta of minus 2 to plus 3 d to. What should be the answer? Infinity to 1. Here would be your 1. Infinity to 1. In this range, certainly there is an impulse. So what would be the answer? 1/2. So this is the correct answer. Are we getting the same answer here? If I ask you x of 0 here, what is the value of x of 0 here? Half. So this answer and this answer, both are matching. So in case of impulse, I don't remember any trick. But in case of step, rather than solving by the conventional method, I will go by the trick. Are you getting this point or not? A very interesting conclusion. If they want to frame a good question from basics of signal, then from here they will frame the problem. A very good discussion. I hope you are able to follow up. So what is the conclusion? I will write down. Where is the conclusion, yaar? Kahan rahe conclusion? Yeah. For step, follow the trick. Okay. And for impulse, go by the conventional method. So that would be the best possible approach in the examination. Okay. Because here you will not be able to see there is 2t plus 1. So you will not be able to see that if I am getting the correct slope or not. Because here you would be thinking that your slope is correct. But actually this slope is wrong here. The slope will be 2. Slope will be minus 2, not plus 2. Are you getting this point? Well and good. And we verified it using a random value of t. If I put t equals to 0, then my limit is going from infinity to 1. When I integrate this particular graph, infinity to 1, I get to know that my value should be equals to half. Value should be equals to half. But in this graph, the value is coming out to be 1 by 4, which is absolutely wrong. But in the previous one, when we did the trick analysis, when we did by the trick, we got the correct answer. But this trick is only applicable for the step 1. If you are following for impulse, then you will be doing the conventional method. This is a very good conclusion out of it. Well and good. Solve this problem. You need to find x of minus 2. Multiple method could be there. One method, what I will do, first I will draw the graph of u of minus 3 to minus 4. So I will take minus 3 common, to plus 4 by 3. Oh, sorry, not minus 3 common, blunder I am doing. These kind of blunders should not happen in the examination, okay? Minus I cannot take common, no? These kind of blunder I usually do. Right? So it should not happen. Breakpoint will be at minus 4 by 3. Breakpoint will be at minus 4 by 3 and graph will be looking towards minus infinity. U of minus 3 to minus 4. Right? So what they are asking, x of minus 2 they are asking. So what will be your x of minus 2? X of minus 2 would be infinity, put x of minus 2 here, put minus 2 here, 3 into minus 2, that would be minus 6 plus 2, so it would be minus 4. So infinity to minus 4, x of minus 2 only they are asking, no? Yeah, so minus 6 plus 2, yeah. So infinity to minus 4, you just need to integrate this particular function. So from infinity to minus 4 would be somewhere here. So you need to integrate. What is the meaning of integration? You just need to find this particular area. You just need to find this particular area. What is the magnitude here? Magnitude here is 1. Magnitude here is 1. So what will be this area? What is this gap? Can you tell me what is this gap? This gap is minus 4 plus 4 by 3. Or otherwise you can say, because we just need the length. So that would have been minus 4 by 3 plus 4. So this would be 12, 8 by 3. So this gap would be 8 by 3. This particular gap is 8 by 3. 8 by 3 is multiplied with 1. So what you are getting? Answer is 8 by 3. There you go. This is the answer. Right? Or what I could have done? That forget about these things, sir. First I will find my function. So what will be my x of t? I know that first I need to reduce it to the best possible form. So infinity to 3t plus 2. Reducing it to best possible form. So 3 goes outward. Minus 2 minus 4 by 3. D2. Now what I need to do? 3t plus 2 will be put here. U will be replaced with r. So minus 3t minus 2 minus 4 by 3. So what we are getting? R of minus 3t minus 10 by 3. Right? So from here I can take 3 common. R of minus t minus 10 by 9. So this will be your x of t. Now if I want to ask x of minus 2, x of minus 2. So what this would be? So this will be my final graph. You can make this graph. From there also you can find x of minus 2, or directly from here also I can find x of minus 2. So 3 into r of, I will put x of minus 2. So 2 minus 10 by 9. What I am getting? 3 of r in r 8 by 9. What is the value of r 8 by 9? What is the graph of r of t? This is the graph of r of t with the slope of 1. This is the graph of r of t. If I put t equals to 8 by 9, what value I will be getting? 8 by 9 only, no? T equals to 8 by 9. At t equals to 8 by 9, what will be the value? 8 by 9 only. So what will be the value? 3 into 8 by 9. What is the answer? 8 by 3. So this was your method 2. So here also you are getting the answer to be 8 by 3. So this was your method 2 and this was your method 1. So rather than by going for conventional method, what I am preferring here, rather than by going for the conventional method, I am preferring here the trick, because with the trick I am getting the correct answer. Or if they are asking at a random value, then I will just make the graph, put the values, and then I will get the final answer. Say yes or no. Are you agreeing to this point? Well and good. So yeah, I guess that's the end, or we can see something more. Let's try something more. In the next video, we can see a few more concepts. Like some miscellaneous concept would be there, so that we can see in the next video. As of now, yeah, that's it. That's it about the discussion of our impulse signal. I hope you would have understood a lot of new things even if you have already studied. And if it is new, then I guess you are understanding every single thing about step signal. Next, we need to study about doublet function. And what is the doublet function? Doublet function is simply the differentiation of your impulse signal. Okay, differentiation of impulse. So you would have already studied about impulse, step, and ramp. Now I will differentiate my impulse signal. Well and good. Okay. So one conclusion we can write down that I was here, then I did the integration, I got ut. Then I did the integration, I got rt. I went from here to here, I did the differentiation. From here to here, I did the differentiation. Right? This thing we can write down. Very simple thing, very basic thing. Okay. Yeah. Thank you.